Hi there, welcome to the complete AWS full course. Today we bring you the AWS full course, a comprehensive program designed to help you master cloud computing using Amazon Web Services, the world's leading cloud platform. Cloud computing has transformed how organizations build, deploy, and scale applications. Businesses across the industries rely on AWS to manage the infrastructure, store data, run applications, and deliver services efficiently without investing heavily in physical hardware. In this course, we will begin with the fundamentals of cloud computing and AWS Core Services. Gradually, we'll move into the compute services, storage, networking, databases, security monitoring, automation, and architecture best practices. You'll not only learn how AWS services work, but also understand when to use them, how to design scalable cloud solutions, and how to align cloud architecture with business requirements. By the end of this course, you'll have a strong understanding of AWS concepts, hands-on knowledge of deploying cloud resources, and confidence to pursue cloud computing or DevOps career opportunities. Having said that, let's take a look at the agenda for this course. We'll start off with Module 1, which is Introduction to Cloud Computing and AWS, followed by Module 2, which is AWS Core Service Overview. Module 3 is Compute Services. Module 4 is Storage Services. Module 5 is Networking in AWS. Module 6 is Databases in AWS. Module 7 is Identity and Security. Module 8 is Monitoring and Management. Module 9 is Automation and Infrastructure as Code. Module 10 is Serverless Application Integration. Module 11 is Architecture and Real-World Use Cases. And finally, we have Module 12, which is Interview Questions and Answers. Hope I made myself clear with this agenda. That said, if these are the type of videos you would like to watch, then hit the subscribe button with the bell icon to get notified whenever we host. Also, just so that you know, if you want to upskill yourself, master cloud computing and DevOps skills, and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various cloud computing and DevOps programs. Simplilearn offers a variety of master's certifications and postgraduate programs in collaboration with world's leading universities. Through our courses, you will gain knowledge and work-ready expertise in skills like application migration, autoscaling, continuous integration, BI, microservices, database management, and over a dozen others. And that's not all, you'll also get the opportunity to work on multiple projects led by industry experts working in top-tier data and product companies. After completing these courses, thousands of learners have transitioned into cloud computing and DevOps roles as a fresher or moved on to high-paying job and profile. If you're passionate about making your career in this field, then make sure to check out the link in the pinned comments and in the description box to find DevOps and cloud computing program that fits your experience and areas of interest. So let's get started with our Amazon AWS full course with a small quiz. Which AWS service is primarily used to create and manage virtual servers in the cloud? Your option A is Amazon S3, B Amazon EC2, C is AWS Lambda, D is Amazon RDS. Please let us know your answers in the comment section below. Now over to our training experts.
AWS or Amazon Web Services is something of a king when it comes to cloud computing services. Now, have you ever stopped and wondered why it takes that position? I'm Rahul from Simplilearn, and these are the top 10 reasons to choose AWS for your work requirements. We'll be going through each of these reasons one by one in detail. At number 10, we have ease of use. Now, one of the main reasons for AWS to become this famous is because how easy it is to use. Anyone can set up an account on AWS and start deploying their services without having any advanced programming language skills. Now, it's so easy to use that even a baby can use it. Don't take our word for it though. AWS puts their customers' understanding of their services first and foremost. AWS maintains a document for each service under developer resources, listing how to use the AWS dashboard to deploy and maintain any service. Now here you can see the Amazon EC2 developer resources, which contains a vast array of information that the users can use. Now say you wanted to access EC2 Autoscaling. You'll go to the EC2 page, you'll click on developer resources, find the Amazon EC2 Autoscaling, and get the required information that you need. Number 9. Third-party APIs. Now, AWS API means that you can manage your cloud-based infrastructure through various third-party softwares. Now, these third-party softwares include Cloud Ranger, Quintly, and Tango Card. These help you utilize all the time and cost-saving features that AWS has to offer. Now, for example, Cloud Ranger helps companies understand the cloud with visual representation. Tango Card that events rewards programs for businesses and their customers worldwide, and Quintly, which provides social media analytics for brands on a single dashboard. Number 8. Scheduling. Scheduling means that you can start or stop an AWS service at predetermined times. That is, you can schedule a service to run at a particular time or on a particular day or even when a certain event takes place. Now you'll be able to sleep a whole lot better knowing that the services that you want will be able to function on their own without any supervision of yours. That is, as long as you've scheduled them to work in a particular manner. Now, if you've noticed, AWS is all about customers' experience. So AWS offers a multitude of customization options to ensure that the user's experiences are made easier and according to their requirements. Customization options such as customer-defined tagging allows users to easily monitor and manage their specific resources. It can be used to implement cross-tracking, security, and automation. Number 6. A full stack of services. AWS provides a wide range of services covering all your cloud computing requirements. Now, AWS didn't become the cloud computing giant that it is now without having such an expansive array of services. It covers domains such as compute, storage, database, migration, and so on. Now, if you do find a domain that AWS doesn't cover at the moment, it's probably because AWS is working on creating services on it as we speak. Here, we can see the array of services that AWS provides. These account to at least 100 services at the moment. Number 5. Data privacy. In today's world, there's nothing more important than privacy, and that's something that AWS understands very well. Data privacy is offered to each and every AWS customer, regardless of their business size. AWS ensures data privacy through physical security, fine-grained access, and data locality control. There's also no additional cost for IAM. IAM, or Identity and Access Management, helps users control who is authenticated and authorized to use the resources. Number 4. Availability. AWS services are also well known for their availability zones. The AWS cloud spans over 54 availability zones and 18 geographic regions and 1 local region around the world. These multiple availability zones ensure that your data can be stored in a multitude of locations that are of your choosing. Now, as you can look at the map here, each AWS region has multiple availability zones and data centers. Number 3. Reliability and recovery. Reliability is also a very important selling point of AWS, which is achieved through multiple backups of servers at multiple physical locations. Now, without backup, in case of some disaster, when data is lost, it cannot be retrieved as there's no backup available. Now, in the case of AWS, there's multiple backups available that the data that one of the servers has lost can be reobtained, making it very reliable to use. Flexibility and scalability. Now, AWS services are well known for their flexibility and how they can auto-scale themselves as per our requirements. Businesses don't have to deal with the constraints of physical computing infrastructure and can have access to servers and storage on demand, which means scalability or auto-scaling allows automatic increase or decrease of resources as per the needs. And the flexibility in services means that you can start or stop a service at any time. Number 1. Pricing. Now, AWS has a pay-as-you-go approach for pricing. It's about 100 cloud services. Now, with AWS, you only pay for the individual services that you need and for as long as you use them without having to pay for a long-term contract or complex licensing. Now, if you can see the images below, in an on-premises approach, once we have bought a physical infrastructure, the cost will always increase even if the demand decreases. The area in the pink shaded region is what we have to pay even if our resources are underutilized. In the case of AWS, the only cost is based on how much we use. So at some point you use more, you end up paying more. It also has a pay less by using more approach to promote higher usage. As you can see in the images below, the more storage you require for S3, the lesser you pay per unit per month.
Very good morning all. I welcome you to Simplilearn World's #1 Bootcamp, and even I welcome you to AWS Certified Solution Architect Associate course. Myself, Muzammil Dakhni, I'll be your trainer for this AWS Solution Architect Associate course. So total, I have 10.5 years of experience in teaching and training. Right now, I have a 3 certification: AWS Certified Solution Architect Associate level, Professional level, and AWS SysOps Administrator. 3 certification in AWS. Introduction to AWS. So before that, what is cloud computing? Folks, cloud computing is an on-demand remote availability of resources such as computing power, storage, and networking, that too without direct user management. Even if I take one more simple definition, cloud computing is nothing but on-demand delivering IT resources over the internet. So what kind of a resources? Now, power, storage, what you're doing in on-premises environment, that same thing you're going to use in cloud environment. And that too, user is going to not manage that. User is going to access the resources like virtual servers or a storage, networking thing. So user is not responsible to manage. Someone is there, behalf of you, they are managing. Just being a client or a user, you are going to utilize the resources. Now let me take one simple example for cloud concept. Everyone is familiar with the electricity board, right? Electricity board, just being a user, you are consuming the electricity in your houses or offices. And what you are consuming, based on that, you are going to pay for it. You are not going to maintain your infrastructure of this electricity board. Behalf of you, someone is there to manage this. But just you are using the service of that electricity board. So like that, cloud computing also, you are using the service, but someone is there to manage that. So now folks, do you have any idea what benefits I'll get if I'm using cloud computing? Cost optimization, cost saving, no upfront cost for resources. Scalability is also one of the benefits. No need to think about the capacity also. And the very important, pay as you go model. And no need to think about the capacity. Automatically scale up and scale down when it is required. Many services are available, ready to use. Dynamic hosting as per the requirement. Less time to start an application. So these are the some important benefits for cloud computing. Now, the companies that provide these services are called cloud providers. So folks, as per my knowledge, I know one of the cloud provider, AWS. Do you know any other cloud providers in the market? GCP, Azure. GCP is a product of Google. Azure is a product of Microsoft, IBM, Oracle, Alibaba. These all are cloud providers in the market. Now, these services are accessible to the user over the internet. So always how you are using this cloud computing services by using the internet connectivity. So cloud provider ensure the large scale management of these services. So now this cloud provider, they can deal with the large, like a tier one company. They can provide a solution for beginners, that to what you call startup. Even cloud providers, they provide a solution to individuals also. Now, what is AWS? AWS stands for Amazon Web Services. It's a leading cloud provider which offers over 200 on-demand cloud services. These services are extended to individuals, companies, government based on a pay-per-use model. So now folks, in AWS, it provides more than 200 services. Now, what are the features I'll get in AWS? Why should I go for AWS? What is the reason behind that? The first one is reliability. Folks, even if you have a huge amount of a data or a low amount of a data, always the performance will be consistent, and that too accurate also. Now, scalability. No need to think about the capacity, because when I'm getting high traffic application, automatically the resources will be increased. When I'm getting a low traffic, automatically the resources will be decreased. That is the power of scalability in AWS environment. Now, security. Let us consider this is my AWS environment now. And here we have different level. Let us consider this is level 1, this is level 2, and this is level 3. Now, I am providing some security group at level 1. I'm providing some NACL at level 2. I'm providing some VPC flow log at level 3. So now if I want to make sure that my AWS environment should be secure, at that time I'm providing a different level of a security within the environment. Cost effectiveness. As you know that pay as you go model. How much you are consuming, based on that you are going to pay for it. Now, what about the market trend? If you talk about the market trend, so average salary of AWS professional is like $1,60,000, and there is a huge demand of AWS professional. That to 60% of a cloud computing jobs which require the AWS related skill. Even in the market, you can see there are a lot of opportunities are available. Lot of opportunities are available. There is only one condition: a person should be skillful. If you are obtaining a solution architect course, solution architect certification, that means once you complete this course, you are able to decide which particular service should be used in which situation, which option should be used in which situation. So being a solution architect, you know that. So once you'll get the grip on these services, 100% you will be hired in the market. Now, what are the skills we are going to cover in this particular certification? Virtual private cloud, storage services, AWS security and IAM, identity and access management, and finally container services. So now, why should I go for this AWS Solution Architect course? All the organizations are migrating from on-premises to cloud environment. Not only AWS, I'm talking about the cloud environment. So in every organization, solution architect is required. In the organization, some of the people have the knowledge. Sir, and I know that. I know about the storage service. I know about the database service. I know about the compute service. So I can design the solution. No, that is not possible. If that person, he or she is not certified architect, then it's not possible. See, until and unless if you don't have that much of a depth knowledge about the designing, then you can't. Because being a solution architect, you should know that in which situation you are going to use bus table class, in which situation you are going to use standard class, in which situation you are going to use general purpose. So that you should understand. There is one more option in memory. That is also one of the strategy. So being a solution architect, you should know that when should I use which particular option. Might be you have the knowledge, but do you think I can provide the optimized result? No. So the task of solution architect is providing optimal solution, that to secure high performance cost optimized architecture. And no doubt, being a solution architect, you are going to meet the requirements of current and future business needs. What they are expecting today and even what they are expecting in future. By considering that requirements, you are going to design the architecture. And solution architect is not responsible to only review the new infrastructure, new solutions. Even being a solution architect, let us consider the organization is already migrated to AWS. Now you can review that and provide the solution, like how I can improve the architecture. For example, I'm using one of the EC2 instance T2.micro, but you are working with a huge amount of load. So I can suggest, being a solution architect, instead of T2.micro, I can use T4.large to handle that much of a traffic. This kind of a task can be identified by only solution architects. Oh, now let's move on to the AWS overview. So folks, in every module, you will get this scenario, a day in the life of cloud architect. So now you are a cloud architect in an organization and have been asked to implement a solution in the AWS cloud. As a beginner in AWS, focusing on core services such as computing, storage, database, and networking services, and even more. So now you must set up an AWS account and use the AWS CLI command line interface to interact with the AWS services and resources. Additionally, learn how to securely regulate access to AWS resources using AWS Identity and Access Management Service. To achieve this, you will learn a few concepts in this lesson that will help you to find the solution for given scenario. Now, what are the learning objectives? By the end of this lesson, you will be able to set up AWS setup and AWS account, enabling access to the and utilization of AWS services. Configuring billing alerts to monitor AWS charges for cost control and budget management. Then delegate access using IAM roles to enhance the security and permission management. Then finally, set up and work with the AWS CLI for efficient interaction with AWS services. These are the learning objectives, or even you can call it as outcomes. Once you complete the lessons, you are able to answer the questions based on these topics. Now, how you will define the infrastructure term? Infrastructure is nothing but a combination of software and hardware components. So now in AWS infrastructure, if I talk, the region is first point. So what is region? Region is nothing but a geographical area where your AWS services are available. So this is one region now. Do you know how many regions we have in AWS? It's 38. Like recently AWS is updated one more region. And do you know how many regions we have in India? There are two regions are available. The first one is Mumbai and the second one is Hyderabad. So as you know that regions are nothing but a geographical area where AWS services are available. Now, one more definition. Region is nothing but collection of two or more availability zones. Why it is two or more? What is the reason? Why not one or more? See, if one goes down, if one fails, like disaster occur for this, so second and third is ready to provide the service. So in simple terms, for high availability, for fault tolerance, for make sure that your data is highly available. So if I talk about the availability zones now, what is availability zones? Availability zones are nothing but collection of one or more data centers. Then what is data center now? Collection of thousands of servers. How many number of availability zones we have? Earlier, before September 1st, it was 117. Now, if I talk about the infrastructure, 120 availability zones we have. So recently launched region name is New Zealand. And let me tell you folks, minimum 2 or more availability zones are always available, and maximum 6 availability zone in North Virginia we have. So what is the distance between these two availability zones? It's 60 miles or 100 kilometer or more. So why they are keeping 100 kilometer or more? To avoid any natural disaster. See, if one of the availability zone affects, if you keep within a 5 kilometers, even that affect to the second also, then there is no use to maintaining the edges within the range. So that is the reason AWS has decided to keep this different availability zone 60 mile or more than 100 kilometers. Always they maintain the distance. Now, in the next slide, you are going to see what I discussed just now here. AWS infrastructure. As you know that it's a global cloud infrastructure that offers the unmatched security, broad reach, and reliability. As a cloud platform, it features over 200 services supported by data centers worldwide. Now, what is a region? A region is correspondent to geographical area housing the multiple availability zones. Each availability zone comprises one or more separate data centers. As I discussed in the first slide itself, availability zones are nothing but the collection of a data center, each equipped with the sufficient power, network setup, reliable connection within the distinct zones. Right? That is the reason they are maintaining the distance between the two availability zone to maintain these data centers. Now, what benefits I'll get if I'm using this particular AWS infrastructure? AWS will provide a ability to quickly increase or decrease the resources to your application as their requirement, as their need. And even it enables your organization to manage the cost effectively while managing and maintaining the performance and efficiency. This particular feature is beneficial for the organization. They experience a variable workload. Sometimes the traffic is high, sometimes the traffic is low. In that situation, scalability will support more. Now, reliability. AWS has a strong track record. That too, if I talk about the architecture itself designed in a way that to deal with the disruptions, and even it ensures the high availability and continuous functionality. What exactly it means? It means that AWS can provide uninterrupted services even in the event of network failure or any natural disaster. Now, security. In security, you can say that it delivers the high level security through its firewall. Firewalls are nothing but filters which filters your incoming and outgoing traffic. The next, encryption. If I talk about the technical definition for the encryption, encryption is a process where I'm going to convert from plain text to ciphertext. Now, encryption is nothing but doing the encoding and decoding. Encryption is a process from readable form to non-readable form. Readable form to non-readable form. So there are different definition. Finally, the goal is same, but I'm using more simple terms to understand clearly. Now, IAM capabilities. So folks, identity and access management by using the IAM, where you can decide who can access what, that you are going to design by using IAM services. Now, next is performance efficiency. So let me tell you, performance efficiency is one of the key attribute of AWS. It has the ability to run your services efficiently in a cloud platform. It can scale according to the need of your traffic. It can handle a high volume of a traffic without declining a performance. And even it ensures the smoother operation and user can get a best experience. Now, flexibility. So AWS allows the selection of your preferred operating system, programming language, and databases. So now AWS is given this authority to you people. So you can select your operating system. If you want a Windows operating system, you can go for it. Mac, Ubuntu, then Fedora. Which operating system do you want? You can select that. Then programming language. You can go for .NET, Java, Python, Ruby, Rails, and even more different runtime engines are available for us. Now, cost optimization. Cost optimization is all about a pay-as-you-go model. How much you are consuming, based on that, you are going to pay for it. Now, here you can see in AWS infrastructure, we are increasing the agility and decreasing the complexity and risk. Accelerate time to market. Now you can see that right now in the market, there is a trend. Everyone is talking about only one technology in the market. right now. AI/ML, artificial intelligence and machine learning, NLP, natural language processing. So now AWS is also provided some machine learning services, artificial intelligence services, like we have Sega Maker, Bedrock. These are the services what we are using. So as for the market, what market is expecting, and that too what clients are expecting, AWS is providing a solution to them. Now they are talking about the AI/ML. Now they are talking about the NLP, natural language processing. Now they are talking about the different kind of things. So as per the market trends and as per the client's request, even AWS is providing a solution. Every day AWS is updating. What I got the information just now. Every day AWS is updating itself. Like last week, it was 117 availability zone. Now, September 1st, AWS was released a new region called New Zealand, along with the 3 availability zone, total 120. Now, let me tell you folks, the upcoming region, Saudi Arabia, KSA, and the Germany, KSA, Saudi Arabia, they are planning within 2026, they are going to launch the new 2 regions. So every day AWS is updating the infrastructure. AWS is providing a solution to all the customers, not only restricted to particular domain. As per your requirements, now everyone is talking about the AI/ML. We have the services called Bedrock, Sega Maker. So even they are providing a solution in the AWS environment. Now, increase innovation. When someone is managing your infrastructure behalf of you, then you will get the sufficient time to think something innovative. Like what your client is given the requirement. Based on that, you are satisfying the condition as per your client. But what I can add something new where I can make my client happy. So these are the features what I added from my end. So you will get some sufficient time to think something innovative things, because your infrastructure will be managed by someone else. And now being a developer, you can think, then scale seamlessly. What it means, as I clearly specified in the benefits, no need to think about the capacity. When you are expecting high traffic, automatically it will be increased. When you are getting low traffic, automatically it will be decreased. Now, how we are reducing the complexity and risk? First, optimizing cost. As you know that pay as you go model, how much we are consuming, based on that we are going to pay for it. Then minimizing security vulnerabilities by providing a security at different layer. For example, this is at EC2 layer. Now I'll give the security at EC2 level. I'll give the security at subnet level. I'll give the security at VPC level. So there are different layers we have, right? So just for your understanding purpose, just you can take level 1, level 2, level 3. So you can give a security at different layers where you can minimize the vulnerabilities. The final, reduce management complexity. How we are reducing management complexity? As I clearly specified in the first slide itself, there is no user direct involvement. Someone is there to manage your infrastructure behalf of you. So because of that reason, you are going to reduce the management complexity. The management headache will be totally taken by AWS. Let's move on to the next topic called core services. So here we have the variety of services like compute, storage, database, developer tools, IoT, and even analytics, security, networking, management, mobile, enterprise application. First, we have compute. So what exactly the meaning of compute here? So compute service which offer the secure and resizable computing capacity in the cloud, simplifying the web scale computing for developers. So folks, here AWS is provided a secure and resizable computing capacity. That means resizable. How much you want, as per your requirement, you can do the compute task. You can process your data. So this is very much helpful for the developers. Folks, in AWS environment, we are using the term called instance. Some people will call it as VM, virtual machine. Instance, virtual machine, servers, everything is a compute resources. Now, let us consider this is my on-premises server. Okay, and this is my EC2. Let me give one scenario to you people now. You all 52 participants are my network engineers, right? And I don't know anything. I'm your client. I want to design one server. So how you will take up this task? I'm your client. When you go for any of the project, which is the first task? See, the first thing is requirement. What your client is expecting. First, you have to understand. Then you can select, oh yes, hardware, whatever you want. Okay, let me consider requirement first. Then next, what is the next step? For how many user you want, which operating system you want, like what are the things, like what are the which operating system. Okay, can I call this entire configuration part? First is Okay, requirement, then configuration, then how much time you want. Let's take 1 week. Okay, let us consider my server is ready for 500 people. Now, suddenly there is a huge hike in the traffic. Suddenly I'm getting 1,000 as the users. So what will happen to this particular web server? So the server will crash or slow down or a low latency. So what is the solution? If I take the EC2, launch the instance, select the operating system, select the security, then create an instance. And here you can launch the instance. This is my EC2. So my EC2 is ready within 2 minutes. And folks, when I'm getting the high amount of a traffic, automatically the resources are increased. When I'm getting low traffic, automatically the resources are decreased. So this is totally pay as you go model. How much you are consuming, you are going to pay for this. Elastic Compute Cloud. This is one of the compute service. So now just you create an instance. Here you'll provide the operating system, softwares, EBS, security, everything. Now EC2 is ready, right? When I'm getting a huge traffic, automatically the resources are increased. When I'm getting low traffic, automatically the resources are decreased. So which one is the best fit? So what are the key features? It empowers user to control their computing resources. They operate under pay-as-you-go model. How much you're consuming, based on that, you're going to pay for it. It allows the user to the boot new server instances within a minute. You can launch your servers within 1 or 2 minutes of a time. They enable quick scaling to meet the changing computing requirements with quick and easy configuration of the service. To meet the quick change of a traffic, there is a concept called Autoscaling group, where multiple EC2 instances are available with the single group. So as per the demand, it deals with the traffic. So what are the different compute services we have? You can see EC2, Elastic Compute Cloud, ECR, Elastic Container Registry, ECS, Elastic Compute Service, Elastic Kubernetes Service, Lightsail, Serverless Application Repository, Lambda, Fargate, and even Batch, Elastic, Beanstalk. So these all are the AWS Compute Services. Now, okay. So folks, these are the compute related services. Now let me take to the next service called storage services. So folks, what is storage? Can I say that it's a place where I'm going to store the data? So this storage offers a secure, reliable, scalable storage solution for a data in AWS cloud. And that will provide the high efficiency, availability, durability, and performance. So let me tell you folks, there are different types of, and that two popular storage types we have. The first one is object storage. Then second one is file storage. And the third one is block storage. So there is a popular service in object storage called S3, where you are going to create some buckets. S3 is a popular object level storage. So here you can store any kind of a data, and that too unlimited, where you can store images, video, audio, photo, anything, and that too it's a unlimited storage. So what is the main use case here? Especially we are using for backup purpose, log storing purpose, where I can store unlimited data. So this S3 is integrated with many other AWS services, where you can store and retrieve the huge amount of data. Now, if I talk about the a single use case, now file storage. So folks, file storage, here there is a popular service called EFS, Elastic File System, which is scalable shared file storage. So now let me tell you folks, what is EFS? This is EFS, and these all are EC2 instances. So now EFS is shared file storage that can be accessed concurrently from multiple EC2 instances. Because of this reason, this is well suited for the applications which required a shared storage. If you are familiar, let me take where I'm using. For example, I'm using in content management system. Let me take the example of development, right? Let us consider here developer 1, developer 2, developer 3, developer 4 are working for the same software. But this first developer is working on first module, he is working on second module, and he's working on third, and he's working on fourth. And finally, the data will be stored in this shared file system. This is the example for EFS. Now, block storage. Block storage, here the popular service is called EBS, Elastic Block Storage, right? Folks, it's a persistent block level storage value. So now you can attach this EBS volume to EC2 instance. This EBS is suitable for the application, for example, database, data intensive application, or let us consider if I want to install the operating system. So at that time, I'll install in EBS value. Why? Because here I'll get the low latency, high IO operations, input output operations. So that is the reason I'm going to install my operating system in EBS. Now you can ask, why we can't use with the EFS? See, in this we are not attaching with the EC2, but here we are attaching this elastic block storage. Once I create the EBS, I'm going to attach with this EC2. That is the reason it provides the low latency, high IO performance. So your installation of operating system, database, or what you call some of the low latency applications, at that time you can go with the EBS. What is block? All the data, let us consider this is my storage. So in EBS, all the data will be stored in terms of blocks and no need to modify the entire document. If it is a particular part is there, then you have to modify only that block. AWS will take care about that one. Now, when I'm using this EBS, what are the use cases? Let us consider if I want to install my databases or if I want to install my operating system, at that time, I'll go with EBS, Elastic Block Storage. It allows the user to store, access, and analyze the data to reduce the cost, increase the agility, and accelerate the innovations. Right? So it can be broadly categorized into object storage, file storage, block storage, and even backup and data migration. These are also types, but whenever you want, you can take a backup into the backup services and data migration. If you want to migrate from on-premises to AWS, at that time, you can use the data migration services also. Now, so what are the major services in storage? ES3, EFS, Elastic File System, FSX for Windows, Lustre, Elastic Block Storage, then backup, Snow family, transfer family, then data sync, storage gateway. So these are the services which are related to storage now. Next is database, any kind of a data, images, audio, video, photos, anything. Yes, what is database? Place where store the data. Then what is the difference between database and storage now? Now let me give the definition for a database. Database is nothing but collection of related data. It offers the comprehensive selection of purpose to build the database suit for various applications. So AWS is provided a solution for the different requirements. As per your requirement, you can select your databases. Okay. So what is the difference between storage and database? Storage is nothing but a raw place to keep your data, where you are going to keep your data like files, object blocks. But database, organized storage management system with querying capability. So here, the nature of database is you can store structured, unstructured, semi-structured data, right? You can use the schema. You can define the queries, right? You can define the relationship among the objects. That is database. Now, storage is all about just you have to keep the data safe and retrievable. So here, we don't provide any query, relationships, indexes, nothing. So now, folks, these database services are fully managed. So when the term comes fully managed, everything will be taken care by AWS. Even updating, patching, provisioning, everything will be taken care by AWS. No need to worry about these databases. Fully managed in the sense, updating, patching, provisioning, everything will be taken care by only AWS. And this is scalable and highly efficient also. Now, database services, some features. So here it provides the different databases like key value database, in-memory database, graph database, time series database, ledger database. There are different types of databases are available. They support a multi-region. That means more than one region in all the 38 regions. Multi-master replication. That means in all the 38 regions, you can perform read-write operation. That is the replication. And even which offers the control over the data. Now, complete control will be user is managed. User will be taken care by the entire complete infrastructure of a database. And what are the services are available? RDS, Redshift. Ledger is also one of the type of database. DynamoDB, Elastic Cache, QLDB, Neptune, Keyspace, DocumentDB. So these are the different database services which are available in AWS environment. What is networking? Networking is the concept where I am going to establish the connection between two or more devices to share the resources. So now it offers a broad set of networking services that provide the essential security features and robust network solutions. In that, these services isolate the resources. There is a service called VPC, Virtual Private Cloud, which isolate the resources. Let us consider this is Gopinath VPC, this is Santosh VPC, this is Deepthi VPC, and this is Karan VPC. Now, see, no one without Gopinath permission, no one can enter to this VPC. Without Santosh permission, no one can enter to this VPC. Without Deepthi permission, no one can enter to this VPC. Without Karan permission, no one can to this VPC. That is the reason we are calling it as a isolated area. VPC is nothing but it's an isolated area. No one can enter without owner permission. Every services will be deployed in the VPC only. So being a owner of that VPC, you are going to decide who can enter, who can not enter. Then encrypting data. So in AWS, folks, AWS supports advanced encryption standard 256 algorithm to encrypt your data. And there is a one more service called KMS, Key Management Service. It's a centralized repository which maintains a cryptographic keys for encryption as well as decryption. Now, AWS provides the private connection to AWS global network. So what kind of a private connections, like which connections you are going to call it as a private connection? Is this VPC establishment between the regions? If you want, you can do that. But if you want, you can do that. There is a concept called VPC peering. Like if you want to peer the two VPCs, that is possible. Now, if I want to provide the private connectivity, which connections you are going to call it as a private connection? Can I consider VPN? Can I consider direct connections? Direct connections, then we have site-to-site connections, VPN, direct connect, site-to-site, all are the examples of a private connections. Now, what are the features? It offers the highest network availability with very few downtime hours due to networking issues. And it provides the global coverage of how many regions? 38. And how many availability zones? 120. Now, these are the services in a networking: VPC, gateway, CloudFront, Route 53, Mesh, Cloud Map. Then we have direct connect and VPN connections. So these all are the networking services which are available for us. So there is a page called AWS Infrastructure where you can see all the regions, If you see here, these are the available region: US region, North Virginia, and here Europe span, Zurich, London, Europe. So these dark circles are already available regions, and these are upcoming regions. Now you can see Europe upcoming region, Kingdom of Saudi Arabia upcoming region. And here if I talk about the India, there are two regions. First one is Mumbai and the second one is Hyderabad. Okay, 38 like regions, 120 availability zones, 700 plus point of presence, 43 local zones and wavelength zones. So local zones are nothing but a single digit, which provide the single digit latency to the customer. So local zones are not available in all the availability zone. Only selected local zones are available. In every region, we don't have a local zone, and wavelength zones are specially designed for 5G purpose. Let's move on to the next topic called account setup. So now, folks, if you want to access the AWS services, first thing is required account. How to access the Gmail account? First, we have to register. For that, first username, first name, middle name, last name, recovery password, mobile number, everything, personal details you will fill. Then you will get the username and password. Now sign up process is only one time. Then you have to log in. So like that, in AWS also, there are two types of account we have. First is root account, and the second one is IAM user account. By default, root account have the access to all the AWS services. Now, IAM user have the access only what you specify the policy. For example, S3, that means you can work with only S3. If you attach IAM policy, then this person can work with only IAM. If you specify RDS, that means this person can specify only RDS. So here you will get a complete control, a more granular permissions you can assign here if it is required. How to create a root account? Same procedure like our Gmail. first name, middle name, last name, password recovery, mobile number, alternate email ID, everything. The only difference is here you have to put debit or credit card details. Now AWS will debit one token amount from your account. So once your account is verified successfully after 24 hours, again that token amount will be credited to your account. If you go to the AWS console, you can create a root account. So within the root account, you are going to create a IAM users. AWS is also given clear input. Don't use your root accounts for day-to-day activity. Why? If something went wrong, if the credentials are compromised, then you are gone. So that is the reason for a day-to-day work, create IAM users, provide the more granular permissions. They can work on that and don't share the credentials with others. Now, like how we are going to perform this creating account. AWS console, just type www.aws console, then here click on create account, then continue, whether it is personal or business account, provide the personal or company information, accept the agreement and create account and continue. So here it asks for billing information, verified, provide the PIN number, mobile number. Then by default, one basic support plan will be available. It's like a customer care. Now, if you want some advanced plan, you have to pay for that. Once everything done, your account will be activated. If you create an account in AWS console, the account what you create is called free tier account. Free tier account is valid for 12 months. And within this 12 months, you have some services with this free credits like EC2 instance, 750 hours, S3 bucket, 5 GB. After 5 GB, 750 hours, you have to pay the extra amount what you have. This is free tier account. There are three types of account we have. The first one is 12 months free tier, always free. There is no restriction, but even we don't get any services here for a free, like what we are getting in 750 hours, 5 GB in free tier, right? Now, the next one is short-term trials. So let us consider Pradeep is one of the developer for one organization called ABC. Now, AWS is released a new service called Bedrock. Pradeep is very interested to see this service, Bedrock. Now, he'll request to AWS, can you give me access to the Bedrock service? I'm a developer. I want to know and understand this service. Okay. AWS will give a response. You can use this Bedrock service for 7 days. So understand the service and let me know if you face any difficulty. So we are calling it as a short-term trial. So for 1 week, Bedrock service will be provided to the customer. Now, let's move on to the AWS Management Console, our lab environment. So now here, once your lab is successfully loaded, you can see sign in link, username and password. Let me tell you the one important thing. So once you enter to your AWS console, you can see some access denied option and all, right? So no need to worry, because here in this console, only the services which are related to AWS Solution Architect Associate, these services are enabled. You can't access the other services apart from what we have for our courses, right? And once you enter to your AWS console, the first thing is you have to check in which region you are working. Right now, you can go for North Virginia. Let me tell you the reason why we are selecting North Virginia region. Folks, the reason is this is pre-cooked environment for you people. Only North Virginia region is enabled. Here you can see in this AWS console, all the AWS services. Now let us consider compute. So here EC2, Image Builder, Elastic Beanstalk, Global View, Lambda, Lightsail, all the services are available. Now let me take database, SQL, RDS, the DocumentDB, DynamoDB, Elastic Cache, Keyspaces, MemoryDB. Then networking, gateway, app mesh, cloud map, CloudFront, data transfer, direct connect, global accelerator. Then, okay, networking, storage, backup, EFS, disaster recovery, FSX, recycle bin, S3 Glacier, and even more. So these all are services what we are going to use in AWS environment. So now here you can see search option. If I want to search this specific service called ES3, just type that service name. And here you have to, here you are able to see the services. If you want to bookmark this, just click on this. Now the service is available. If you want to remove from the bookmark list, you can remove this. Okay. Now, after search, here we have Cloud Shell. Cloud Shell is nothing but built-in command line interface. If I want to interact with the AWS services by using CLI, at that time, I'll go with Cloud Shell. Okay. Now, Next, notification, help, support, then settings. This is for regions. And now here you can see. So here you will get the account details for this account. Then organization. If you want to go for multi-account environment, then there is an option called organization. Service quota. That means every services has some limit. For example, IAM users. Within the single root account, you can create up to 5,000 IAM users. So like that, for every service, we have some quota. That is limit. Okay. Then billing and cost management. So let me show you a very important part. Let me tell you, billing is one of the crucial service in every organization. That is the reason no one will get a billing access. Only the respective person who is working on the billing, they'll get the access. But let me explain what are the fields are available in the billing. Now you can see cost summary, month to date cost here, and last month details. Like a current month, here you will get the detailed breakdown for that particular month, how many services are active, in which region, when it was started, when it was end, and how much it was charged. Everything you will get a detailed information. Now, if you see here, there are different tabs are available. Let me take which are very important. Bills. If you click on bills, you are able to see, like if I want to view the bill of last 6 months, 1 year, 2 year, you have to select the year and particular month, then a bill will be generated for that particular month now. Then payments. Let us consider you want to do the AWS account, like AWS account, you have to pay. Now you have the account code 123 and you want to pay for this. So you can add the payment method here like credit card, debit card, and UPI payment using the Google Pay, Phone Pay also you can pay your AWS bills. Then credits. So folks, credits are nothing but which is provided by AWS. Like for a free tier account, 750 hours for EC2 and 5 GB for ES3. So how much it is remaining, everything you'll get the details in a credit option. And whenever you're using any of the services, you will get the purchase order. Cost Explorer. When you click on Cost Explorer, you will get the detailed information. If you want to optimize the cost, then Cost Explorer is a tool where you can go for it. So this is for total cost, average monthly cost, service count, how many services you are using. And here, it's like a dashboard. It's like a dashboard, a systematic graphical representation will be provided, which if you select any of the particular month service, here a detailed graph will be provided for which service, how much it is utilized, in which duration, everything you will get the detailed information. And here cost and usage breakdown. And even you can download this as a CSV file, Excel file. Now, when which service, in which region, when it was started, when it was end, and what are the charges. Even you can download the Excel sheet. So this is all about the Cost Explorer, folks, and this is all about the billing part. So why we want billing? So billing is the tool where you are going to pay your AWS bills. So where you can organize and report your cost and usage by using AWS Cost Explorer. Then you can manage the consolidated billing for the member of AWS organization. There is a service called AWS Organization where you can manage a multi-account environment. Here you can manage a consolidated billing. Let us consider this is ABC account. Here we have a different employees and you will get a consolidated billing within the ABC. So these are the accounts and these are the charges. I'm not sure, but there is a one telecommunication industry which provides one plan, one family. I think it's Airtel, right? Only one bill will be provided for entire family. So like that here also for ABC organization, I can do the consolidated billing where every users along with the cost you can see here. So as I discussed just now, all the tabs, these are the features which just now what I discussed in the console. Managing AWS account where you can view the bills, you can manage the payments, Google Pay, cards, everything. You can manage the purchasing orders. Then you can manage the cost by using the cost categories. Then you can manage the payment profile. Then a consolidating, like consolidating billing organization. Let us consider this is ABC and here are the employees. In an organization, there are multiple employees we have and every account is charged and you will get the consolidated bill for that. Now, there is something called AWS Support. Do you think these support people are like a customer care people? It's a technical support. These people are technical people. That too, they are well qualified well-trained who is going to provide a solution to you people. So now AWS supports provide the variety of plans to access the tools, right? And even expertise to support the success and operational health of AWS resources. So always 24/7 access to the customer service. If customer is not ready to accept the answer, they'll provide some documentation, technical paper, and even support forms. Now, here we can see there are different plans. We have developer, business, enterprise, on-ramp, enterprise. And these are the scenario, like what are the advisory best practices to check, like technical support, then case severity, then programmatic case management, then proactive programs and self-services, like AWS managed services, training, pricing. So pricing is also different in every model. So here the different plans are given based on your workload, how you are going to understand. Like if I consider our Geo mobiles, once you complete 50% of a data, you will get the notification. Once you complete 90% of a data, you will get a notification. You are completed this much of a data. Now here in AWS also, you can set. Let us consider this is my EC2. This is my EC2, a compute service, putting the threshold value. If my EC2 crosses $200, then it should be notified to the Kiran. Kiran is a user. So once my EC2 crosses $200, I'm going to set the alert. The EC2 CPU utilization this. Now when it is crosses, a user will be informed by using email. So now you can see here AWS Billing Alerts, which allows user to monitor the charges on their bills. So now user can set up an alert to receive email notification when the estimated charges reaches to the specific threshold value. Once it crosses the $200, your EC2 instance. So through email, it will be informed to Kiran. Hey Kiran, your EC2 is successfully crosses $200. Take some proper action. You can specify the action. If you want to do the automation, once it crosses the $200, whether my EC2 should be stopped or terminated, you can do that one also. So how to set these billing alerts? Go to AWS Billing Console here. And once you'll get the billing dashboard. So at the left side here, we have the billing preferences. So click on receiving billing alerts and save the preferences. Once you add this email ID, you will get the notification. So this is all about the billing alerts. So now how you will define delegate. Let me take one simple example. Now the class is a live session is going on. So I'm a trainer. I'm taking this session. Right. So what I'll do now, I'll inform to Vishwanathan. Okay. So being a trainer, I'm busy in taking the session. I'm continuously busy in taking the session. What I'll do now, I'll delegate my authority to Vishwanathan. Hey, Vishwanathan, can you take attendance for today's session? I'm busy. Can you take the attendance? So Vishwanath is ready. Sir, sure, I'll take the attendance. So what I did just now, I delegated my authority to Vishwanathan. Suddenly, Shane will come into the picture. I'll take the attendance. Do you think Shane is the right person to take the attendance now in this scenario? No, because I have not delegated the authority to Shane. I have given the authority to only Vishwanathan. Now, delegate access to the billing console. So now you know that AWS account owners can delegate access to specific IAM user that need to access or manage the AWS billing and cost management data for AWS accounts. So now, as I discussed, billing is one of the crucial service, right? So now everyone don't have that billing access. So now you are going to delegate this billing access to IAM user. Let us consider this is your ABC organization. Here we have admin. Preeti is admin. So now folks, in this company, we have 100 people. Do you think this 100 employee work can be performed by only one employee, that is Preeti? Is it possible? No. That is the reason we have delegation. Even every user have the responsibility. So that is the reason here we have Vishwanathan. Then we have Jignesh. Then we have Nupur. Okay, next we have Kiran. So now Preeti is administrator. Now being a administrative account, or let us consider she is having access of root account. And now she is delegating authority to others. Vishwanath can perform S3. Jidesh can perform KMS. Nupur can perform EC2 task, and Kiran can perform billing task. So here we are attaching some policies, like we are giving the authority to Vishwanathan. Preeti can access all the AWS services because it's a root account. Now Vishwanathan can access S3. Vishwanath can't access KMS or EC2 or billing, only S3. Same thing, Jidesh can't access S3, EC2 or billing, right? So even Kiran can't access S3, KMS or EC2. Kiran is responsible for only billing. So domain, what they are provided to this employee, they can work on only that place. How to delegate the authority to this Kiran user? So there are 4 steps. The first one is you have to enable the access. Enable in the sense, for billing, IAM user and role should be accessed. First, you have to enable. Then create a policy. Now, no need to create a policy. Already, policy is defined by AWS. We are calling it as a managed policies. Already policies available. Now, who is user? Kiran. Just attach this policy to Kiran. Now check by using the IAM user credentials. You can check. You can test the access by using the separate username and password. You can access the resources. Let me show you. Okay, just you have to go to the IAM user. IAM. So this is my IAM dashboard. So now let me create a IAM user. So who is responsible for billing now in our scenario in ABC organization? Vishwanathan, Preeti, Nupur, Jignesh, Kiran. Okay, let me consider as Kiran. Okay, now folks, it asks, do you want to provide access to AWS console? Yes. And do you want to use auto-generated password? No, I want to use custom password. Let me give the name called Kiran at 123. Now, user must create a new password in next sign in. Do you want to give the authority to Kiran to change the password? No. Let's click on next. Attach a policy directly. So folks, which policy do you want to attach? Billing. Just type billing. So folks, no need to create. It's already available. Select this and click on next. Right. So now review it. And once I'll create a user, you will get the error. Like here, user is created, but with few errors. Let me show you. Kiran user is created with few errors. See, if I don't have authority to access the billing information, then how I can assign this policy to someone else? See, user is created, but with few errors. You don't have authorized permission to attach the policy. So here you can see Kiran user and password. Just now the user is created. Let me open another browser. So let me copy the password. So now you can see this is account ID and the username is Kiran and the password is Kiran at 123. Once I click on sign in, the user successfully signed into the account. Can you see this? The username. Now I successfully logged in by using the Kiran as a user. And if you go for billing service, even Kiran is also not able to access the information. Let me show you that one. First, if you want to enable, first step is here, account section. Here, IAM users roles. Access the billing information, you have to enable. Once you enable, then create a user, attach a policy, then access, check it out. Just now what we are completed, 4 steps. Activated billing access, we are not created. We are using the managed policies which is defined by AWS. Then attached to the Kiran, then tested access by using the username and credentials, password. So now there is a concept called IAM roles. Just now I discussed with you people regarding IAM users. Now there is a concept called roles. How we are delegating authority using roles. Let me tell you folks, these roles are temporary in a nature. Sure. Why we are calling it as temporary? What is the reason? Because these roles are active from 1 hour to up to maximum 12 hours. Not more than that. Now, AWS account owner can use a role to delegate access to the resources in a different account called production and development. So one of the best use case of role is cross account access. Now let me explain what exactly the role by taking one simple analogy. I hope everyone is familiar with the Spider-Man. Actually, Spider-Man is a normal person. When the problem occurs, he'll become a Spider-Man. Once the problem is rectified, again he's going to become a normal person. Like he is not going to work as Spider-Man for 24/7. So can I say that the Spider-Man is a temporary role, folks? Let us consider production and development. Now I have production environment in 1, 2, 3 account, and there is another account called 4, 5, 6 in development. Here in production, we have Prem is working. Prem is working in production. In development environment, Pradeep is working. Prem and Pradeep are very good friends. And now here we have an RDS database where in development environment. Now Prem suddenly asked to Pradeep, hey Pradeep, can you share your credentials? I want to access the RDS of development environment. No, it's against the policies, right? So what I'll do, Pradeep will inform, hey Prem, instead of that, I can do one thing. I can create a role for you. And what you want, which access you want, I'll provide a RDS full access. And this role should be assumed to Prem. And that too, this is for 2 hours. Now, after assuming this role to Prem, Prem can access the RDS database. This role is active for only 2 hours. Once the task is completed, again, he is going to work as a production employee. Now, here you can see the steps. First, you have to create a role, grant the access, and test the access. Let me show you the same thing in the console, how we are delegating authority. Now, if you see here, there is an option called create a role. Let me create a role. Now, see, you can create a role for account also. You can create a role for service also. Now, let me create a role for EC2. And now, click on next. So, which permission do you want to provide? Okay, let me give the scenario. Here, this is my EC2 and this is my S3 bucket. If I want to access this EC2 should access S3 bucket, at that time, I have to create a role. So role is S3 full access. And this should be assumed to EC2. Then only EC2 can access the S3 bucket. So now, folks, I am using EC2 service. Then click on next. For which permission do you want to give? Select S3 full access. Click on next. And the role name is demo06. Click on role. And let me show you demo06 role is successfully created. Here you can see the name role demo06 is available for me. Folks, maximum session duration from 1 hour to 12 hours. And even if you go for custom duration also, you can provide in terms of minutes. But maximum is 12 hours, not more than that. So this is the way how you are going to edit the roles. So as I discussed, folks, these are the 3 steps. First, creating the role, then granting the access to the role like what I assigned. Then you can test the access by using a different account. IAM, Identity and Access Management. IAM is a service which provides access control to AWS resources. In simple terms, you can say that who can access what, which provides access control to AWS resources. Now, AWS Identity and Access Management is a web service that enables users to securely regulate access to AWS resources. Now, it enables user to securely regulate access to AWS resources. So in the secure manner, how you are going to access the AWS resources based on the permissions. Let us consider Shivendra is using S3. So why is he using S3? Because I have attached the policy. Divakar is using EC2. Because why? Again, we are attaching the policy. So based on the permissions and policies, we are going to access the resources, right? And now, IAM helps determining the authentication, that is signed in, and authorization permission to user to utilize the resources. Now, authentication. If I take the example of online banking, first username, password, then captcha, OTP, then submit. Once you submit this, all the information will be validated. If everything fine, then only you will be signed in. Is nothing but authentication. Then only you will be redirected to online banking dashboard, right? This is nothing but authentication. Now, what is authorization? Everyone is familiar with the online banking dashboard. Here, my online banking dashboard is available where you can check the balance. You can take the statement of 3 months or 4 months. Then you can add the beneficiary. You can change the password. You can change the transaction password. Even you can do the deposit and everything like some investment. Now, here we have the option called balance. Is it possible to modify the balance? Modification of a balance is not possible. That is nothing but permissions. Authorization is nothing but permissions. What are the permissions? You have to perform the task. You can change the password. You can get the statements. Then you can add the beneficiary. You can change the password, transaction password. These are the permissions you have, but you don't have a permission to modify your balance. That is nothing but permissions, authorization. Now, some of the features of IAM. So shared access to AWS account. User can authorize others to administrator and utilize the resources in their account without sharing their password or access key. So what we are created? I think we are created a user called Kiran, because I have not shared my credentials to that user, but I created a one user with separate username and password. And here granular permission. So assign a multiple permission, a various permission to the multiple user for a different resources based on workload. So there is a concept of principle of least privilege. That means the required policy, if he is working on S3, only assign S3. Hey, I know Kiran is my best friend. I'll assign all the policies, which is not best practice. Now securely access to AWS resources. By using this IAM feature, you are going to access the applications which is running on EC2 instances. MFA, OTP, there are multiple methods we have. You will get the OTP on registered mobile number on a specific application like Google Auth. Google Auth is one of the application where you will get the OTPs. Identity federation. For identity federation, let me take one simple example. See, this is your AWS cloud and here IDP, identity provider. Now, here we have third-party user. Now, this AWS cloud belongs to AWS ABC company. Now, if third-party user want to access the AWS resources, at that time, he should verify by the identity provider. Let us consider this user having the credentials with the Gmail or a Facebook.com. So now using the Gmail and Facebook, I want to access the AWS resources. At that time, IDP is responsible to authorize the user. Once the user is authorized, then only he or she can access the AWS resources. Not only organization people, even outside, a third-party user also can access the AWS resources. If you don't have AWS account, you can use Gmail or Facebook account and IDP, identity provider, who is going to authorize the user. Once the user is authorized, then only you can access the AWS resources. There is a service called CloudTrail. CloudTrail is a service which tracks each and every API activity in the AWS environment. Who is doing the task? What are the results? Right? When the user is performing the task, everything you will get the detailed information by using CloudTrail service. Now, this IAM is compatible with PCI DSS standard, that is Payment Card Industry Data Security Standard. And IAM is integrated with many other AWS services. So always the performance is consistent. Why? Because it distributed across the multiple global data center. IAM is a free service. Which services are going to be involved to execute this task? For that, you are going to pay for it. There is one more service called STS, Security Token Service. The Security Token Service is responsible to provide temporary credentials to the roles. Okay, so STS, Security Token Services, is also one of the feature in the AWS account, which provides the temporary credentials to the AWS IAM roles. Now, how I can access this IAM? By using AWS Management Console, then command line interface, then SDK and HTTP. IAM HTTP's API. So let me tell you folks, these two options are used by solution architects, and these two options majorly used by developers. How I was created a user called Kiran. So once the Kiran user is created, you are able to get a login by using the separate credentials. So IAM users are the users within the account, not separate accounts. Each user can have the password to access the AWS Management Console. So what I created a user like Kiran. So by using the Kiran and Kiran at 123, by using the username and password, I logged in. So these IAM accounts are not separate account. So these are the accounts within the root account. So let me tell you folks, in the root account, you can create up to 5,000 IAM users. Now, as I taken the example, Santosh, Kiran, Anupur, then Prem, then Anand, who is responsible for what? He's going to work for KMS, EC2, S3, then RDS, then finally Kiran is going to work with the billing. Like that, what I taken the example. So this is all about the IAM. Let's move on to the next point, CLI, command line interface. Again, cloud. If I want to interact with the AWS services by using commands, at that time, I'm using CLI. So there are two methods we have. The first one is install CLI in your local machine, in your laptop. And the second one, in this AWS console, after search bar, there is an option here. The name is called Cloud Shell. So Cloud Shell is built-in command line interface which is provided by AWS. There are two methods. You can install CLI on your local machine on laptop, then Cloud Shell by using the built-in command line interface. You can use this one. So command line interface is an open source tool that allows user to communicate with AWS services using command in their command line shell. So if I want to interact with the AWS services by using commands, at that time I'll use CLI. How to set up a CLI in my AWS console? Just type AWS configure and provide the access key and secret key. Once you provide the access key and secret key, if you want to programmatically access AWS resources, at that time we require access key and secret key. Region name, you can, if you are working in North Virginia, you can specify as North Virginia. Then default format, always default format will be JSON. If you want to change to text or a paragraph, it's up to you. If you want to change, you can work on that. So this particular slide is not for you people. If you are already user of a CLI, so you have to just copy that particular file from the library and paste it in the tab. This is not required for you people. Now you can see I was created a user called Kiran, and now the user is called Frame. So how to generate access key and secret key? Here we have the option called security credentials. If you want to enable MFA for your account, you can enable here. If you want to generate the access keys, you can create a here. Let me create an access key. So for what purpose you are using? These are the different multiple use cases. Now, for what purpose we are using? I'm using for command line interface. Then confirm it. Next, description, blah, 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 blah. Next, let me create the access key. When I click on access key, you will get very important message. This is the time only that the secret key access key can be viewed or downloaded. You cannot recover it later. However, you can create a new access key at any time. So now you can see Frame access keys are successfully downloaded in my local system. So now let me go to the Cloud Shell. What is the command we are using? AWS. When you type AWS configure, it asks for access key and secret key. This is my access key, copied, pasted. This is my secret key, pasted. Okay, enter. So default region name, I'll keep blank right now. And the output format, I'll keep blank. So folks, here I'm successfully logged in with Frame IAM credentials. That means what are the permission Frame have? So Frame can perform all the tasks. If Frame don't have any authority, like Frame don't have to access the S3 bucket, then you will get a clear message here. You are not authorized to perform this task. By doing this, you are going to work with the CLI by using access keys and secret. Here, this is the first method. So what about the second method? AWS CLI install. Now, here is the option. Installing and updating the latest AWS CLI. Which operating system do you have? Linux, Mac, Windows. Select the OS. And here you will get all the systematic steps they are given. And you can follow and install a CLI on your local machine in your laptop. Let us start with compute and related features. So as you know that in every session, you will get a scenario, a day in the life of cloud architect. Now, you are a cloud architect for an IT company with multiple cloud-based applications. The organization has encountered routing challenges that have resulted in a significant financial losses. Hence, you have been asked to ensure that such issues are proactively prevented in the future. By the end of this lesson, you will have a concise understanding of crafting routing requests, creating EMI images, Amazon machine image, and exploring the types of load balancer. So now what are the learning objectives? By the end of this lesson, you will be able to create an AMI, Amazon machine images for fast deployment. Launch and connect to a Windows instance to enable disaster recovery. Deploy various load balancer to improve scalability. Create a routing request in application load balancer to enable path-based routing. So these are the learning objectives. Now, what is EC2? So in the previous session also, I was discussed about the Elastic Compute Cloud, EC2. It's a virtual machine. So actually, EC2 here, let us consider we have user, right? So now a user is taking one virtual machine on a rent, where in AWS environment, right? So EC2, Elastic Compute Cloud, is a web service that provides a scalable compute capacity in the AWS cloud. So now, as you know that in the previous session, I was discussed about the compute. Compute is all about processing, where you can process your scalable data. Like sometimes it's high, sometimes it's low. As per your user requirement, you are going to process the data. Now, what exactly this compute here? So you are being a user, you are taking one machine on a rent in the AWS cloud. And how many hours, how many minutes, how many seconds you are using, based on that, you are going to pay for it. That is pay as you go model. Now, what are the benefits I'll get if I'm using EC2 instances? First, EC2 increase or decrease the storage capacity in a minute. So now there is a concept called autoscaling. Okay, we are talking about storage, right? When I am expecting a huge amount for my application, this is my application which is available in a server, right? So now EC2 will increase or decrease the storage capacity in a minute. When my EC2 is expecting some high traffic for the applications, automatically the storage capacity will be increased. When I'm expecting low traffic for my application, automatically the storage capacity is also decreased. And it launches thousands of server instances simultaneously. Here we have the concept called auto-scaling group. So what is auto-scaling group? Here, a multiple EC2 instances you can launch within a single minute. And the concept is called auto-scaling groups. Now, flexible cloud hosting service. So now you can launch the numerous operating system, instance types, and software in a minute. Numerous operating system means like if you want a Windows operating system, Mac operating system, Linux operating system, Fedora operating system, which one you want, you can select as per your requirement. Instance type, like here we have general purpose instances, then storage optimized instances. There are different instances we have. Now software in a minute. Even if you want to install any software in the EC2 instances, that you can perform within a minute. So folks, in the previous session, I hope everyone remember, I was taking the comparison between your on-premises server and a EC2 machine, where being a network engineers, where everyone is very excited to choose a different configuration, right? So like that, in EC2 also, you have the authority to select a configuration. What type of a memory you are going to use, what type of CPU, which CPU you are going to use, what type of instance storage do you want to use, and what about the boot partition size, which is best for your application and operating system. Even if you go for your on-premises server also, if you want to install your operating system, you will create some partitions. So like that, here also, if you want to make that kind of a partition, that is also possible. Now, AWS integration. Now this EC2 is integrated with many other AWS services like S3. So S3 is what type of a service, folks? Storage, RDS, database. So now this EC2 is integrated with S3, RDS, SQS, and even more services. Now, folks, reliability and security. Now, EC2 provides a highly reliable environment where the replacement of instances can be quickly and consistently deployed. See, replacement of instances can be quickly and consistently. There is a concept what I discussed, auto-scaling group. Let us consider here I have 4 instances. If one of the instances is unhealthy, at that time, AWS will automatically replace this unhealthy instance with the new one. And that too consistently it will be deployed without any downtime. Now, user can easily create a secure and robust network to run their EC2 instances using the virtual private cloud. Now, all the services you are deploying in the EC2. Let us consider EC2, RDS, S3, everything you're deploying in this area. So that's why we are creating a secure and robust network, whether you are deploying EC2, RDS, or anything into this virtual private cloud. Now, low cost. AWS charges user in seconds. They only pay for what you use. The rates are lower than existing on-premises infrastructure. How on-premises server, being a network engineer, you have taken the suggestions, right? So finally, we are concluded with EC2 is the best solution. Then here you will get the complete control on your instances, right? Even you have access for the root to all the instances. So now user can use APIs, which is already designed by the AWS. If I want to stop the EC2, if I want to start the EC2, and even if I want to maintain a data in the storage, and again, if I want to come back, it should start from the same state. There is a concept called hibernation. there is a concept called hibernation. Even if you want to store a data, and again, when you start it back, resume it back, again, it should start from the same position where you have left. That is also possible with the hibernation concept. So the thing is, every operation, whether it is stop, terminate, hibernation, or start, anything, everything is happened by using the API, which is already created by AWS. Right? So these are the benefits of EC2. Let's move on to the next topic. So now we have the topic called EC2 storage. How this EC2 can use with the different storage types. So here you can see I have the EC2 different storage option. First one is EBS, Instant Store, EFS, and S3 with EC2. So let me tell you folks, first I'll take up this explanation for the different storages, how we are using with EC2. After that, I'll do the comparison. As you know that there are different options are available. The first one is EBS, Elastic Block Level Storage. This is my EC2. This is my EC2, and this is my Elastic Block Storage, EBS storage, right? So as you know that folks, EBS is a block level persistent storage. Now it allows user to create a EBS volume, then attach this EBS volume to EC2 instance. So now this EBS, which provides a durability and data persistence. So because of that reason, this is suitable for if I want to store some critical data. At that time, go with EBS. Let us consider if I want to deal with the database, go with EBS. And the very important, if you want to install your operating system, go with EBS, because this EBS volume is connected with the EC2, and that too, here it provides low latency communication. Latency in the sense delay and high IO operations. So this is for EBS now. Now what about the instance store? So folks, let me take one simple analogy called RAM. This one, if I talk about the analogy, let me take SSD. Right? So now folks, RAM. As you know that RAM is a temporary storage. It, like here also, instant store is temporary storage option, which is provided by EC2. And it provides high IO performance. So that because of this reason, this is best suited for temporary data. So caching is the best example. If you want to go for caching purpose, at that time, you can go with instant store. Now let me take one scenario. Let us consider Vimal Singh is using one desktop system. He's working on abc.docx. There is no backup for this system, and suddenly power cut off, and the document is also not saved. What will happen? Data lost. So whatever you have the data in the instant store, in the RAM, everything will be lost. It's not recoverable. Now same scenario, let us consider Vimal Singh is already, the document is stored. Now when it is not stored, it's available in the instant store. When the document is already stored, then it's available in EBS. So now there is a sudden power cutoff. Is it possible to retrieve the document? After saving the document, is it possible to retrieve? Yes, because the data is stored in a persistent storage. Persistent in the sense, it's like a secondary storage service, like SSD. That is the reason you can again retrieve the particular document. So this is the comparison also with the EBS, EC2. Now, EFS. EFS is a scalable managed storage service. And here, these are multiple EC2 instances. Right? First, second, third, and fourth. So now you can mount with the multiple EC2 instances. Now you can see this EFS file system where I'm going to work with the multiple EC2 instances. So because of that reason, it makes us suitable for the application which requires shared access to the file across the instances. Now, if I talk about the use cases, the first one is, let me take content management system, CMS, right? Let me take, okay, development testing environment. Now let us consider the development environment where the multiple developers are working from a different EC2. And finally, the software will be stored in this EFS. This first developer is working on first module, second is working on second, third, fourth. And finally, the results are going to be stored in this EFS file system, which is a shared file system. Let us consider for a social media, for a one person, multiple EC2 instances are maintaining some data like personal information, then a professional information, then activities, then comments. Multiple servers, like multiple EC2 instances, are going to be maintain a data within a single shared file system. Now, S3, as you know that S3 is a simple storage service, right? So now this is my S3 bucket, right? And this is my EC2. As you know that S3 is unlimited storage. You can store any kind of a data, either it is images, audio, video, photos, anything. Now, but S3 is not directly attached to the EC2. But now this EC2 can store the data and retrieve the data by using HTTP APIs. Now your EC2 is not attached with S3. But your EC2 can store a data and retrieve the data by using the HTTP APIs. So S3, you are not going to connect your EC2 to S3 directly. But if you want to store a data in S3, if you want to retrieve the data from S3 at that time, we are using HTTP APIs. Now, what about the use cases? So folks, let us consider if I want to take a backup for longer time, if I want to do archiving for a longer duration, at that time, we are going to use a S3 with the EC2 option. Let us consider if I want to take a backup archiving purpose, at that time I can go with S3. So these are the different types of storage which is available with EC2. Now let me take the difference between these storage classes. EBS is what kind of a storage? Block level storage, and this is ephemeral, means temporary block storage. Next, what about the EFS? File storage. Then what about this? S3, object level storage. Next, if I talk about the capacity, see here the capacity will be up to 64 TB. Then here it depends on the instance type. Your instance store will be depend on instance type. This is unlimited. And here also it's unlimited, right? And now here this is persistent storage. This is persistent. What about this? Non-persistent. This is also persistent. And fourth, this is also persistent. Now, how many EC2 I can attach here? Single. What about this? Here also single. And what about this? Multiple. And what about this? Yes, it accesses through using HTTP APIs, which is created by AWS. Now, the final difference, let me take with the use cases. So I can use for, okay, if I want to install operating system databases, at that time I can go with this. What about this? Caching. Next, EFS, shared files. Where you want shared data, at that time you can go like CMS, social media, development environment, and even more. Next, can I go for backup? Can I go for archival? Can I go for web applications? Can I go for big data, folks? I'm talking about the S3. Can I go for web application? Can I go for big data? There are a lot of applications we have for S3. If I talk about the pricing model, so here pay per provision size. And here this is related to instance type. And if I talk about the file storage, pay per usage, that means how much storage you are using and what is the throughput of that. And here for object level storage, we have a different storage classes. How many days you are storing a data, and that too in a which storage class you are going to pay for it, right? So it's all about the storage request and how much you are utilizing that. Based on that, you are going to pay for S3 with EC2. So this is all about differences between the different storage classes and the explanation of everything. Let's move on to the next topic called instance types. There are different types of instances are available for us, like a general purpose instance, compute optimized instance, memory optimized, then accelerated computing and storage optimized. So now you can see there are different types of instances with when should I use which instance type, right? What are the use cases and what are the different instance families are available. Now, the first one is general purpose instance. General purpose instance. As you know that instances are virtual server in AWS cloud. So now this EC2 offers various instance types, which allowing to select your CPU, memory, usage, and even networking which is required to run your application. So now folks, these general purpose instances are very much useful to design the web server, code repositories that require these resources in a equal parts. Now you can see here we have the example of instance type like T4G. This one. T stand for general purpose now. That to a general purpose bustable performance. This is processor version 4, and G is nothing but Graviton processor. So let me tell you folks, AWS supports three different types of processes. First A, second G, and the third one is I. A stands for AMD, G stands for Graviton, and I stands for Intel. Recently, AWS has added the one more processor. G is Graviton. First AMD, G Graviton, I Intel. Like last month, AWS has added one more processor called B200, which is accelerated by NVIDIA Blackwell GPU. Now, the next one is compute optimized instances. So now compute optimized instances are suitable for compute intensive applications that benefits for high performance processor. Now, when should I use this? Let us consider I am dealing with batch processing workloads where I have a huge amount of data, then dedicated gaming servers, scientific ad server engines, and scientific modeling, and so on. So now C7G. That means compute optimized. 7 is processor generation, Graviton processor. C6I, 6 processor, Intel. So where you don't have the processor, you can use any type of the processor. Memory optimized instances. Memory optimized instances are intended to provide a rapid performance for a workload that processes for large data set in the memory. So where you are going to process the large data set, like a databases, like electronic design automation workload, real-time analytics. So folks, any example for real-time analytics? Can I consider stock market? So stock market or a trading platform are the best example for real-time analytics. Now real-time caching servers. Folks, can I consider live streaming like YouTube Live, Facebook Live, where catches the content to the users? And here is the option R5A. So R is nothing but a specific memory optimized instance type with the 5th processor generation with AMD processor. So always, every time you have a size here. The size might be a small, medium, or large, or 2x large, 3x large. It depends. There are different instance types are available. Now, the next, accelerated computing instance. So accelerated computing instances use hardware accelerator or a coprocessor to execute the task more effectively than software which is running on CPU from 2005 to 2010. If my processor was not supporting high definition games, like I was trying to add something to my laptop or a desktop system, especially I'm talking from 2005 to 2010, where the processor will not support some high definition graphics card. So folks, can I call this graphics card is like a co-processor in that system? So now here also, it acts like a co-processor to execute your task effectively then, which is running on CPU. Now for which task you can use? I can use for floating point number calculation, graphics processing, data pattern matching, and even so on. Right? So here we have P4, accelerated computing with the 4th generation you can use. Nowadays, NVIDIA is provided a separate processor for that. Now, yeah, one more thing, G4DN. So now G4DN. So G for graphic intensive with the fourth processor generation. And here this indicate the specific option, and this is additional capability with Intel or AMD or any kind of a processor. Now, storage optimized instances. Storage optimized instances are designed to provide the application with tens of thousands of low latency random IO operations per second. Now, what kind of a workload you are going to consider? Let us consider when I have the high sequential read-write access to the large data sets on a local storage. Any specific example, folks, for this? Where you are performing sequential read-write access from the large data set, and that too which is available in a local storage. IRCTC, in-memory DB, stock market prices, online banking. Now you can see there is a storage thing here. This is my instance family. C7GN. This entire we are calling it as an instance family. C is nothing but series. This 7 is nothing but generation, and these are the options. These are the additional capabilities. This entire thing we are calling it as an instance family, and this is size. And this entire total family along with the instance size, we are calling it as an instance type. Now, C for compute everything, the all abbreviations are given. C, D, F, G, H, everything. And here you can see AMD, NVIDIA B200, Graviton, and Intel processor. Right? These are the different processor which are available for us. Let's move on to the next topic called AMI, Amazon Machine Image, AMI, which contains the information about the EC2 instance, what you are going to be launched. Now, what kind of information? Like which operating system you are using, then which elastic block storage you are using, which instance type you are using, right? Which security groups you are using. Everything you will get the detailed information in this template, right? So now, folks, by using the same AMI, if I launch one EC2 instance, so the configuration will, what you define, it's available. Now, is it possible, like if I use the same template, if I launch the multiple EC2, so the configuration of the EC2 will be same or different? Same, because what you have the template here, if you are using the same template to launch your EC2 instance, if you use for multiple EC2, the configuration will be same. If you want different, then you have to create a separate template for that. For example, for Windows is different, for Mac is different, for Ubuntu is different. Like this, you can create. So AMI is a virtual instance that includes templates for the root value of your instances, even which consist of a launch permission to control the AMI launch instances, and even a block device mapping for the specific value which are attached to this particular EC2 instances, right? So now here we have one simple diagram. So now you can see, if you want to create an AMI, within the AMI, you have to use the EBS also, EBS snapshot. Snapshots are nothing but the backup, right? So when you try to create AMI, so first you have to register this, and by using this AMI, you can launch a EC2 instance. That means you can create a EC2 instance by using the same AMI. You can copy this AMI from one region to another region. Let us consider now, if you're not using that AMI, then you can deregister or delete that AMI. That is also fine. How we are going to create a AMI? What are the methods we have? There are three methods. The first one is private, and the second one is specific AWS account, and the third, public, right? Let us consider private. Private in the sense, when the users, let us consider the Pradeep is created one AMI. So this AMI will be used by only Pradeep, because he created that AMI which is available in a private, right? No one can access this AMI. That's why we are calling it as private. Now, specific AWS account. Let us consider Pradeep is created one AMI and he want to share with this specific account. Let us consider Gagandeep is available with the 456 account and Pradeep is available with 123 account. If you want to share with this specific account, you can go with specific AWS account option. Now, if you want to publicly share your AMI where anyone can buy and sell the AMI, there is a place called AWS Marketplace. So let me tell you folks, AWS Marketplace is the place where you can buy and sell AMI. It's like a OLX. But here, AWS Marketplace is the place where you can buy and sell the AMI. So who all are there? Like community members, some third-party users, some of the AWS experts, community members, right? And even a third-party users, and even you also available here. So you can create your own AMI and you can sell. That is also possible in the AWS Marketplace. So first is private, then specific AWS account, then public. Now let me show you the first lab of your AWS Solution Architect Associate course. So here, launch instance, and the name is, let me give the name called demo server. Okay. Now here you can see AMI, Amazon Machine Images. Here we have for Linux, Mac, Ubuntu, Windows, Red Hat, SUSE, Debian. Just now, I click on this launch instance option. No any other steps. Folks, let me give demo server. You can provide any name. Here you can see AMI, Amazon Machine Images, right? Linux, and even more. So if you want to go for more AMIs, then click on browse more AMI. You can see quick start AMI 45. My AMI is 0 because I have not created any AMI here. That is the reason it's 0. AWS Marketplace 6,838 AMI. Some of the AWS and third-party trusted AMIs, community AMIs, published by anyone, 500 AMIs. So here is the place where you can buy and sell your AMIs, right? Now let me go back. Okay. Now click on launch instance and here provide the name called demo server. Okay. So now folks, if you see here in the AMI list, there are multiple AMIs are available in Amazon, but for practice purpose, only Linux 2023 kernel 6.1 AMI is available, where you can see entire thing, 64-bit architecture, AMI ID, then virtualization HVM, ANME enabled, and root devices EBS, Elastic Block Storage, which is attached to this AMI. Now let me select this free tier eligible. Here you can see the architecture. So there are two options are available, x86 64-bit x86 and ARM processor. So now I'll go with x86 architecture. There are different types of instance type. What I completed before AMI, the topic T3.micro, T2.micro. Are you able to see this? T2.large, T3.micro, everything, the different types of instance types are available. General purpose, compute purpose, accelerated computing, storage, compute optimized, everything, all the instance types are available. Right? So let me tell you one more thing. Even if the instance type is same, for a different operating system, the charges will be different. Now you can see for T2.micro, T2 family, 1 virtual CPU, 1 GB of a memory, current generation is 2. For Windows, 0.0162 USD per hour. Ubuntu is different. Then SUSE is different. Linux based pricing is totally different. So like this, for every operating system, the different pricing will be there, right? And the very important folks, always you have to use T2.micro, not T3. If you use T3, then you are not able to launch your EC2 instance. This is for instance type. Now folks, key pair. Key pair is like a additional security for your EC2 instance. So if you want to connect your EC2 instance by using CLI or SDK, at that time, this key pair are required, right? Key pair is like a additional security for your EC2 instance. Let us consider Yomi. Yomi is one of the software engineer who is working in one of the MNC and right now he's located in Mumbai. Because of some work, he's shifting to another city. So at that time, he'll lock the door. First, he'll lock the door of house. Once they're done with the main lock, then he'll lock a gate also for additional security. Like that, here also, along with the security groups, we are providing a key pair. But make sure that when you create a key pair, it should be kept in a safe place. If someone will get the key, then you are gone. That is the reason I'm talking about the industry example, industry relevant examples. For example, now you're working in a development environment, right? In the development environment, you have one EC2 instance and you forgot that key pair or someone got the key pair, then easily they can connect and destroy your entire architecture. Now, right now I don't have any key pair. If I want to create a key pair, here is the option. The name is demo. There are two different types of key pair we have, RSA and ED25519. These are the two different types of keys which are available. Now, private key format. So do you want to go for PEM or PPK? Folks, PPK is like an older concept now because for this PPK, we need a third-party application called Putty. So that is the reason we are not going with the PPK now. Let's go with PEM. Directly you can utilize. So once I click on create key pair, you are able to see a key will be downloaded on my local machine. Demo 12 PEM key is successfully created. All right. So now the key is successfully downloaded. Now, folks, in local machine, can you see this? Demo 12.pem is successfully downloaded here. So whenever you are connecting your EC2 instance, you have to import from the particular location. Then you are able to connect. Right? Now, networking setting, folks, keep as it is. Don't touch any of the option. So right now, no need to think about this. Just keep as it is. Everything as it is. Okay, let's launch EC2 instance. Okay, now you can see successfully initiated launch the instance. I'm ready with my instance now. You can see here, folks, the name of the server, instance ID, and which is running now. And here you can see initializing. Status check is initializing. So here you should get 2x2 check pass. That means your AWS will check a system check and instance check. So system check with all the configuration is fine. Now instance check whether the instance is successfully deployed on the system. Everything will be checked here. Once everything fine, then you will get 2x2 check passed. Right now, this is your demo server. Let us consider I want to create an image of this particular server. So for this, you have to select the server. I am going to create the image. That means same configuration, one more template. Let me go to the action, and here is the option called image and template. You have the option called create image. So in this image, I'll give the name called example, description, blah, 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 blah. Say reboot instance, it's up to you. When you select this, your EC2 will be reboots. The instance data is rest when the snapshot of attached volumes are taken. So it makes sure that the data is consistent always. So when your EC2 reboots, right? So data will be available, the snapshots which are available in the persistent storage here. Now you can see the EBS volume which is attached to our previous EC2, because in the previous EC2 the size was 8 GB. If you want to change the capacity, it's up to you. If you want to change the volume, it's in your hand. If you want to increase or decrease, it's up to you. Let's click on create image. Now you can see just now I created the image which is available in. Now here you can see AMI option, images, what I completed. Folks, if you click on AMI, is it the same AMI what I created just now? Now let me show you in the instances tab. Instances tab. So now click on launch instance one more time. Let me show you one interesting fact. Earlier, my AMI was 0. Now the new tab. Here I have my AMI. Let me click on this. When I click on my AMI, is it the same AMI what I created just called example, folks? Right? Even if you go for browse more AMI, in that my AMI was 0. Now it becomes 1, created by me. Just now I created a AMI with the description what I given. Example is the name. Is it available for me? So by using this AMI, you can launch multiple EC2 instances. This is overall demonstration for AMI. So now let's move on to the next topic called placement groups. So folks, placement group is one of the features that enables a user to deploy interdependent instances to handle your workload in a more efficient manner. If you have one EC2 instance, that means based on the configuration, its capabilities, it can provide the results. When I'm using placement groups, where I'll get the multiple EC2 instances, and that too, each are dependent on other. And by using the capacity and capabilities, you are going to deal with your workload in a more effective manner, right? So here we have some important points. So up to 500 placement groups per account you can create. And always a name of placement group should be unique. And it's not possible to merge placement groups. Now, there are 3 different types of placement groups are available. In that, the first one is cluster, partition, and spread. For the placement group, I have one custom diagram document. So what is this custom diagram? Let me tell you. I'll use this custom diagram to provide in detail information how logically works your placement groups. By using this diagram, you can easily understand. As I discussed, this placement group consists of 3 different categories. The first one is cluster, second is partition, and the third is spread. Now, what is cluster? A cluster placement group which consists of multiple EC2 instances, but it launches on the single or a same rack. Can I say that rack is a place where I'm going to host my servers? So now, by using this single rack, I'm going to launch the multiple EC2 instances. So if rack fails, then all the EC2 instances will fail. That is the mainly disadvantage. Now let me show you some information. See, cluster.
same rack in same availability zone. Always your cluster will work within the same availability zone. And that will provides a great network, low latency up to 10 Gbps bandwidth between the instances. So what is the disadvantage? If rack fails, let us consider if rack fails, then all the EC2 instances will fail at the same time. Then there is no any EC2 which is available for us to provide a service. So when should I use this? Let us consider I'm doing with a big data job that need to complete a fast access. Some of the application with low latency and high throughput. So folks, can I consider stock market as an example? Application with low latency, high throughput, trading platform as the best solution, and even the instances. Here, the EC2 instances want to communicate with each other. So instance like a low latency communication can be done. So that is the reason you can consider the trading platform is the best example, right? Now, the next one, partition placement group. Let us consider you are running one high performance data intensive application like our real-time trading platform. So now high performance data intensive application. So what we have, real-time trading platform which requires the low latency communication. So cluster is one which provides a 10 Gbps bandwidth compared to other options. This 10 Gbps of a bandwidth between the communication of instances. See, we are talking about a low latency communication between the instances, right? So here, by using this solution, a best possible network performance, right, you will get through the cluster. And that is the reason we are using a cluster placement group. We have the strategies to overcome that problems. We have the strategies, but you will not get a low latency communication between the servers compared to cluster. So the main focus is communication between the two instances with the 10 Gbps of a bandwidth, right? So you like here in the cluster, we know that how to manage your racks. In some cases, if something went wrong, at that time it affects. But this type of a low latency communication, you will not get in a partition or a spread. That is the main reason. Now, partition placement group. Partition placement group, folks, let me tell you, this is also can be used within the single availability zone. And let me tell you here, the separate partition will be maintained. Up to 7 partitions you can maintain, right? Every partition have the separate rack, and these racks are related to this partition. If something went wrong, so that doesn't going to affect second and third. If second something went wrong, first and third will be not affected. If third something went wrong, first and second will be not affected. So here in your partition placement group, you can launch hundreds of EC2 instances with the separate partition, right? So in this partition, in a single availability zone, you can create up to 7 partition, not more than that. There is a restriction, right? Now, so up to 7 partition per SG with the hundreds of EC2 instances you can launch. The one instance, the instance of one partition, do not share the rack with the instance of other partition, as I clearly discussed. A partition failure can affect many EC2 instances from the same partition, but it won't affect the other partition, which is available in same availability zone, right? So now let me take one simple example for partition placement group. Now, let us consider you are building one mission critical fault tolerance application. So what kind of application you can consider for mission critical applications? Banking, can I consider defense, weather forecasting, health, right? These all are mission critical fault tolerant workloads. So let us consider you are building one mission critical fault tolerant application that must resilient to a hardware failure. So now to achieve this, you want to distribute your instances across different partitions within the same region. So using the partition placement group, if one partition goes down, the second and third will be ready. If second goes down, first and third ready. If third goes down, first and second will be ready. Now, spread placement group. Folks, spread is available with multiple availability zones. That too within a single region. The first difference, like 1A, 1B, 1C. And here a separate hardware and a rack will be maintained. So within the same availability zone, a separate hardware and separate rack will be maintained. For this EC2, separate hardware and separate rack will be maintained. So same thing for 1B, 1C. Even if one EC2 instance goes down within the same availability zone, because a separate hardware and rack is there, that is the reason it doesn't going to affect the next EC2. That is the power of spread placement group. Now let me show you. So now when you click on advanced details, here is the option called placement group. Yes, here is the option to create a placement group. Right now I don't have any placement group in my account. Let's create a new placement group. And let me give the name called demo07. So what strategy do you want to go? Cluster, spread, or partition? I want to go with the cluster. Create a group. So now placement group is created successfully. If you go back, here still this option is not available. Let me refresh. So here placement group demo07 strategy cluster with the shade no is available for me. So whenever you're launching the EC2 instance, so if you select the cluster placement group, the EC2 will be deployed in that group and you can launch the instance. And let me tell you folks, by default placement group will be not selected. If you want to use, then you have to create, then you can utilize that. Okay. So this is all about the placement group. Now let me take you to the next topic called metadata. What is metadata? Data about data. Metadata about EC2, what you're expecting. Configuration details. In metadata concept, you will get the information about the EC2 instance, like what is the AMI ID, what is the instance type, then what is the public host name, then network, what is the network, MAC address, instance ID, profile, everything you will get the detailed information. Now let me show you. This is my meta server. Select the Linux operating system, keep as it is, t2.micro, and here is the option. I'll go with proceed without keep here. Networking settings I'll keep as it is. Once you scroll down, there is an option called advanced details. And here folks, you have the option metadata versions. You can see there are two versions are available for metadata, version 1 and version 2. If you see here, metadata accessible, enabled, but only for V2. If you want to go for both versions, V1 and V2, you can select the first option. By default, it's only V2. And now you can go for V1 and V2 both. So let me tell you what is the difference between V1 and V2. So V1 is a simple method, right? There is no any authentication. But V2 is token-based authentication. So here first you have to put for a token, then you will get the information, right? So now this is V1 is not secure, V2 is secure. And V2 you will get 6 hours of a session to get the responses. So token will be generated and you can perform the task, right? So V1 is like just simple HTTP get request, right? So now V1 and V2 I'm selecting both options, and now let me launch a instance. So now I am successfully done with launching my second EC2 for meta server. Now how to connect? So now select the meta server. If you want to directly connect your server, here we have the option called connect. So here instance connect. Now your EC2 will be directly connected by using instance connect option. So this is public IP address and this is private IP address of your EC2. This is Amazon Linux 2023. Just now what I created the EC2, right? AMI along with the EC2 user. This is private IP 172.31.18.195, right? So folks, again, I have one document, a standard URL. Always, if you want to check the metadata of any EC2 instance, we have the command called 169.254, 169.254. Just copy and paste it. Folks, you can see curl HTTP 169.254, 169.254 for latest metadata. Right now, just enter. So now these are the different attributes which are available for us. Let us consider if I want to check AMI ID, just slash AMI-ID. Enter. Now you can see this is the AMI ID of my EC2 instance, right? Like this, if I want to check a MAC address. So this is the MAC address of my EC2 instance. So you can check it out, all the attributes, whichever you want. Then you will get the in-detail information. So now, sample examples where we need metadata base. See, let us consider I want to do some automatic app configuration. When you want instance ID, regions, public IP, private IP, right? Let me take a simple example. You have one web application and you want to write the logs tags in an instance ID automatically by reading your metadata. At that time, this is very much useful, right? Even you can use in fetching temporary credentials like IAM role, then auto discovery, right? Bootstrapping in that case, which is very important. Let's move on to the next topic called, a topic is EC2 purchasing options. We have the different EC2 purchasing options. In that, the first one is on demand. Now, what we are using, if you are not selecting any of the plan, then by default, it's on demand only. Because here we don't have any upfront cost. There is no any upfront cost. And even this is very much suitable for short-term workloads. Now, the next one is, in saving plan, you have to commit for 1 or 3 years. And you will get the discount 65 to 70% of a discount compared to your on-demand instance. Now, reserved instances. Here also 1 or 3 years of a commitment, but you will get a 72% of a discount compared to your on-demand instances. Why? What is the difference between saving and reserved plan? Let me tell you, folks. In saving plan, if you want to shift from T2 to M3 or M3 to R4, it's possible to change the instance family. But in reserved instance, if you are using R4, you have to use only R4 for this entire 3 years. You don't have authority to change the instance family, right? Now, might be you have the question, sir, where I can use this? In which use case? Let us consider Pranit is one of the solution architect for IRCTC organization, right? So now Pranit know that I am going to get this much of a traffic. That's why I decided to use R6.large for this IRCTC application. Now this R6.large application can run for 3 years, because Pranit know that for 3 years I'm going to get this much of a traffic. So that's why I decided to use R6.large. Even I already know that this much of a traffic I am getting. That is the reason I'll select a high-end instance type. So you can't change this. But saving plan, let us consider my workload. Now I'm using R6 here. But what I expected, I'm not getting that much of a workload. So you can downgrade your instance type from R6 to T4.large. So you are doing cost optimization by reducing, downgrading your instance type. That is nothing but saving plan and reserved instances, right? Now, the next is spot instances. So folks, in spot instances, you will get the 90% of a discount. Now, why I'm getting 90% of a discount? What is the reason behind that? So here in the different plans, those who are the clients, those who are selected the different purchasing options, some of the capacity or a memory which is not used, that is surrendered to AWS. So that kind of a space will be allocated to the user. Now, how exactly the spot instances work? Let me take with the single example. Here we have one hotel or lodging facility. Let us consider this is hotel and lodging facility we have. And here we have one manager. So folks, in this hotel, we have 100 rooms, right? So all the 97 rooms are occupied with the 1,000 rupees amount, right? Now, these 3 rooms are vacant. 3 rooms are vacant. And after 24 hours also, no one is occupying these rooms. So manager is thinking, what happened, right? Now suddenly one person will come and he'll ask for this room. Hey, can you give me this room? I'll pay 400. Everyone is already given 1,000 rupees for a single room. Now he's asking for 400. Now manager is going to put one condition. Okay, I'll give the room, but there is only one condition. What is that? Someone will arrive with the value of 500. At that time, you have to leave the room. So same thing in spot instances. Let us consider for Vimal, the space is allocated. Now suddenly Satya Prasad will come into the picture. So now the space is allocated to Vimal Singh, right? And now Prem will come into the picture. And suddenly Vimal is bidding. He's taken the space for $200. And suddenly Prem will come into the picture. He bid for 300. Now AWS will send a notification to whom? Vimal Singh. So this space is allocated to someone else. Please complete your task. And before 2 minutes, you'll get the notification from AWS. That is the reason you are getting 90% discount, right? So once the 2 minutes completed, this space will be allocated to Prem. Now Prem can utilize this space. And because of this reason, AWS is clearly specified. Don't use any complex data or mission critical data or important data for spot instances, because before 2 minutes it will be terminated, right? And when should I use this? The best example is batch processing. Why? Because where you left the last process, you can start from the same place. That is the reason for batch processing. The best example is our spot instances, right? Now, let me take the last option, dedicated host. Dedicated host. If I compare with all the options, dedicated host is too costly. Dedicated host is too costly. Why? Because an entire physical server will be provided to a single customer. So entire physical server will be provided to a single customer, right? So here you control your placement of virtual machines, instances of the host, right? So performance is same as your instance family, right? But here you will get a more predictable performance. Defense system, right? When you have some compliance requirement, right? Dedicated host means, let me take one example. You need to run one Windows server with your own license. So at that time, you use a dedicated host to comply with your Microsoft licensing rules, right? So these are the different plans which are available for EC2.
Let us start with hibernation. Any idea what is hibernation? System in sleep mode. What is the goal of that particular hibernation process? What you are achieving by doing that? Hibernate your EC2 instance. Again, you can start from the same state where exactly you have left. And the very important, you don't have to pay for the hibernation setup. For that specific duration, you are not going to pay anything. So hibernation is a process where your system is going for sleep for a certain duration. And when you resume it back, again, it starts from the same state. Now here we have a diagram. Here you can see I have an EC2 instance along with the EBS. All right. So the first condition is, if you want to do hibernation for your EC2 instance, make sure that your EBS should be encrypted. Otherwise, it's not possible to hibernate your EC2 instance. Now, operating system sends a signal to the system. Now, stop hibernate. Stop hibernate means now it starts from the stopping process to stop process. From stopping to stop, there is a process. What is process in operating system? Process is a program under execution. And what is that execution? From stopping to stop state. Now your EC2 is successfully hibernated. This is my EC2. After EC2 stop, my EC2 is hibernated, and this EC2 is attached with EBS and instance store, right? So now folks, my question is, when my EC2 is hibernated, am I going to pay for it? No, 100% no. But you are going to pay for only the EBS value, because EBS is a place where it stores a current state of the system. That is the reason you are going to pay for the EBS value. And one more thing, whatever you have the data in the instance store, as you know that instance store which acts like a RAM, a temporary storage. When you hibernate your EC2 instance, all the data will be vanished. Totally the data will be deleted. And only the EBS data which stores your last state of the system, and even when you resume it back, it starts from the same state, right? So here instance store is nothing but temporary storage. It acts like a RAM. Now when you hibernate your EC2 instance, all the data will be vanished from the EC instance store. But when it comes for the EBS, all the data will be available. Even you can start from the same state where you have left. Now, when you hibernate your EC2 instance, even the public IP is also changed. The private IP will be same. Now, let us consider if I want to make my EC2 instance should not change the public IP, then we have the concept of elastic IP. So folks, elastic IP are the static IP addresses. When you allocate to your EC2 instance, even if you are hibernating also, then it never change the IP address. And these are chargeable. Now, there are multiple things we have. Like if I talk about the EBS value, even if you are doing a hibernation of your EC2 instance, if you want to do any modification related to EBS, that is possible. If you want to do some optimization settings for EBS, that you can do that, right? And this hibernation is supported by the new operating system what we have. these are the features of hibernation. Now, if I talk about some limitations also, in that the first one is when I am hibernating my EC2 instance, all the data from instance store will be deleted. Now, the next, let us consider if I have more than 150 GB of a RAM. In that situation, it's not possible to hibernate. As per the architecture, AWS clearly specified if you have more than 150 GB of RAM at that time, it's not possible to hibernate. And the next, let us consider, folks, if your EC2 is hibernated for 60 days, then AWS have the authority to terminate that instance. Let me show you in the console. Now, let me launch the instance. I'm going to show you the hibernation option now. Okay. Now let me give the name called demo Linux. Proceed without keep here. All right. So when you click on advanced details, here we have option called hibernation. Here you can see there is an option stop hibernation behavior. It should be stopped. So first you have to enable. If you enable, then only you are able to hibernate your instance. If you are not enabled while launching the EC2, then it's not possible to hibernate your EC2 instance. And now what I'm doing, hibernation behavior is enabled and it should be stopped. Now let me launch the instance. Just now I got the error. Why? What is the reason? The reason is your EBS is not encrypted. For hibernation, the root device value must be encrypted. I did the instance configuration. And where is your EBS value? Before advanced detail, here we have the configure storage option. Click on advanced. And this is the value, EBS value. And here you can see encrypted, not encrypted, right? Let's encrypt now by using default KMS key. So what is that KMS? I'll discuss here. KMS stands for Key Management Service. It's a centralized repository where we are going to maintain a cryptographic keys for encryption as well as decryption. Now I'm using default key. Okay. Let me launch the instance. So now my EC2 instance is successfully launched. Let me show you, folks. Still it's pending. Yeah, now it's running. Usually if you go to instance state, right, these are the options. Let's select the server and here instance state. So usually this option is disabled until and unless you have to explicitly enable that, right? Now, if you click on Hibernate instance, click on Hibernate. I got the error. Why? What is the reason? Because my server is still initializing. If once it's 2x2 check pass, then you are able to hibernate your EC2 instance. So this is all about the demonstration for hibernation process. Let me hibernate your EC2. Now let me hibernate. So select the server and here instance state, hibernate instance. I'm done with the hibernation. Now folks, this running becomes stopping. And once the stopping will change to which state? From stopping to stopped state. So what is the difference between stop and hibernate? When you stop your EC2 instance, all the data will be totally deleted. It's not possible to take from the last state. But when you hibernate, it's possible to take from the last state of a system, right? So now even you can see here, folks. So now you can see here from stopping to stop. Successfully, my EC2 is stopped. So if I want to again start the instance by using the start method, again, I can start from the same state. So this is the way how we are performing hibernation. Now, folks, we have the topic called EBS, Elastic Block Storage. So here you can see I have the option called advanced details, right? Before this, we have a configure storage option. Click on advanced and here we have a different storage, a different volume types. Storage type is EBS and this is the name, and snapshot, that is nothing but backup. And here is the size. So here, folks, you can see there are different volumes we have. What are those? The first one is EBS. So now let me take you to the EBS volume. Folks, just a minute. See, here the different volumes are available. Folks, here you can see the 8 GB, you can change the size and the volume type. Here we have the different volume type. The first one is solid state drive, SSD. Then the general purpose SSD, provision IOPS SSD, right? So apart from this, we have a magnetic standard and then hard disk drive. So why we are shifted even if you check it out our laptop also, why we are shifted from hard disk drive to solid state drive? What is the main reason? Because it's too faster, which improved the IOPS, input output operations per second, right? Here you can see SSD, we have two categories, GP3, GP2, IO1, IO2. So these are general purpose. GP3, GP2 are general purpose SSD, which provides up to 16,000 IOPS. And the capacity of GP3 and GP2 is from 1 GB to 16 TB. And when should I use this? For example, I'm dealing with some low latency applications like our development and testing environment. At that time, you can go for GP3, GP2. Now, if you go for provision IOPS, SSD, IO1, IO2, let me tell you folks, it provides a 64,000 IOPS per value. And now, when should I use this? When I want a workload which requires a more IOPS, more than 16,000. At that time, you can go with IO1 and IO2. Usually, we are going with IO intensive database workloads, right? And the capacity will be from 4 GB to up to 16 TB, what we have for IO1 and IO2. Now, if I compare with hard disk, HDD, hard disk, SC1 or ST1, there are two options are available. Here, the size will be 25 GB to 16 TB. And let me tell you the IOPS rate, only 500 IOPS per volume. So general purpose, which provides a 16,000 IOPS. This is 64,000 and this is only 500. Now, how many number of input output operations per second your EBS volume can perform? So now you can customize as per your requirement. So delete on termination. When you terminate this, EBS volume will be deleted. Now, encryption, as I discussed just now, if you want to encrypt a value, it's optional, but when you are going for hibernation, it should be mandatory. Here we have a default key. If you want to go with the custom key, key management service is a centralized repository where you are going to maintain a cryptographic keys. So here you can create your separate customer key and without sharing to anyone. At that time, for more security purpose, if you want to share with the client, at that time you can use that particular keys also. By using KMS, it's possible. So this is all about the EBS value, what we have in our AWS environment, that too for EC2 launching machine. If I talk about the concept called load balancer, now we have topic called elastic load balancers. What is load balancer? Let me tell you what exactly it is. Elastic load balancer, it distributes your incoming application traffic across the multiple targets. Now the target might be any EC2 instance, containers, or any Lambda function. In our scenario, the targets are EC2. So now folks, so here we have features. The first one is load distribution. Now here we have 100% load for this load balancer. Target means EC2 instance, container, or any Lambda function. See, Lambda is also one of the compute service. At EC2, you know that containers, it's a standard way to package your application, such as code, dependencies, runtime, repository into a single object, that is container. Lambda is nothing but serverless compute service. So now the target might be any EC2, container, or any Lambda function, right? Now, here we have 100% load. The first one is load distribution, right? Elastic load balancer is responsible to distribute a load equally to registered targets. So now it starts dividing the load 33%, 33%, 33%. Might be you have the question, sir, what about that remaining 1%? That is also equally divided. The next is fault tolerance, right? So now elastic load balancer, it sends some heartbeat package to check whether the web server is active or not, healthy or not. When load balancer sends a heartbeat package to the server, if suddenly got the acknowledgement, that means ELB declared as this web server is healthy. Like that, this web server might be busy to provide a service to other customer. So you now in that situation, you can't say that the server is not healthy. For that, we have the concept called interval. So now I'll put the 2-second interval. Let us consider Prem is busy in doing the breakfast, right? I'm continuously taking Prem name. Prem. I can't wait up to evening.
because Prem is busy in doing breakfast. I can't wait up to evening. Once he'll free, then I'll get the acknowledgement. No, I can't wait. So because of that reason, I'll specify 2-second interval along with 2 minutes of a duration. If I'm not getting with the 2 second of intervals, praying, 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 after 2 minutes also, then I'll declare as frame is not available. This web server is unhealthy. This server is not able to receive the traffic. Then I'll declare as unhealthy. Again, load distribution. Again, we have the 100% load. Now it starts equally dividing this load. 50% to this, 50% to this. Why? Because the first server is unhealthy. Then the server 1, server 2 equally handle the traffic from a load balancer. Now, the third point, security. How this load balancer provides a security. So now when a client is requesting to the Elastic load balancer will equally divide the traffic, right? Now, after equally dividing the traffic, from where exactly you are getting the responses, client is not going to understand. Because of security reason, Elastic load balancer, it hides the public IP of the web server. From where exactly you are getting the responses, the customer is not going to understand that. That is the third feature of security of your Elastic load balancer. Now, if I talk about the benefits, Elastic load balancer are highly available, secure, scalable, and even flexible also. Now, here we have three different types of load balancer. Yeah, the first one is application load balancer, and the second one is network load balancer, and the third one is classic load balancer. So are you people familiar with the OSI model? APSTNDP. Application, presentation, session, transport, network, data link, and physical. So now, which is the first layer? Physical layer. So no need to go in detail about the OSI networking layer model. So just this is physical layer, data link, network, transport, session, presentation, and application. So now here we have application load balancer. So let me tell you folks, here it deals with the HTTP and HTTPS traffic. Using the application load balancer, always it routes a traffic to the targeted within the VPC based on the content of the request. It routes a traffic to the targets within VPC based on the content of the request, right? And let me tell you folks, in which layer it works. Layer number 7, that is application layer. Now, network load balancer, NLB. So folks, network load balancer, which deals with TCP, UDP traffic. And here also it routes traffic to the targeted VPC regardless of the content request. And do you know folks, in which particular OSI layer it works? Network load balancer. Always it works with the transport layer, 4th layer. And now this classic load balancer is the combination of both HTTP and as well as TCP. That's why it works in layer number 7 as well and layer number 4 as well. TCP, UDP are like, see, classic load balancer is the combination of both application as well as network load balancer. Now, folks, let me show you the same thing in the console, how exactly your load balancer works. If you check it out, the first step, you have to create a security group, right? Now, this demo is for creating a load balancer with the registered targets. So first you have to create a security group. Now, then you have to launch the instance with the different availability zone. Then how to launch an instance in a different availability zone, that I'll show you. Then after that, I'll show you how to create a load balancer. Then how to deploy this classic load balancer to the EC2 instance. Now, what is the first step? You have to create a security group. Let me go to the console. And if you check here, there is an option called security groups. See, here we have an option called security group. So now, folks, click on security group. Folks, security groups are the virtual firewall at EC2 level, where you are going to define your inbound and outbound traffic. Which traffic is allowed to your EC2 instance, that you are going to decide here by specifying inbound rules, right? Now, let me take the name also the same, my HTTP server. Okay, then description. If you want, you can, otherwise you can leave that. Don't change anything for this VPC. Keep as it is because we are using default VPC. Now click on add rule. SSH first one, secure shell. SSH is nothing but secure shell, and that to anywhere from IPv4 address. Next, HTTP. Anywhere from IPv4. Let me take one more rule. HTTPS. HTTP anywhere from IPv4. HTTPS anywhere from IPv4. Even I included HTTPS also, right? So now the traffic from SSH, HTTP, HTTPS is allowed to my EC2 instance. Now let me create a security group. Now I'm ready with my security group called my HTTP server. So what is this second step? The next step is launching the instance with the different availability zone, and that too Linux 2 operating system. Keep here, see, keep here is not required. Let me take the name called HTTP server 1. Okay. Now let me launch the instance. So now let me take the web server 1, HTTP server 1, the name. And here Linux operating system 6.1 AMI, 6.1 is fine. And now instance type is t2.micro. Okay. And here keep here not required because we are not using not required. Folks, if you see the networking setting, right, how to deploy, what is the condition? You know that how to launch a EC2 instance, you know that. But how to launch a EC2 instance in a different availability zone? For that, you have to click on edit. And here you can see the subnet options. Keep VPC same as it is, default subnet. You can see the availability zones. 1B, 1C, 1F, 1A, right? Right? You can select anything. You can select any of the availability zone. So now I'm selecting 1A. So now firewalls. Do you want to use firewalls? Yes. I think just now I created one security group. My HTTP server. Select this. And along with a default one. Default where I want to provide a more granular permission to my EC2 instance. Now, EBS I'll keep as it is. Advanced details. Right. So here we have user data section. Let me show you the document. Okay, let me explain. Folks, here you can see. Now here we have a script. That too, bash. Using the bash shell, we are providing a script now. Right. So I'm going to add user data section. Right. What is user data now? If I want to do the automation, let us consider automatically Apache server should be installed and the operating system should be started. So at that time, I'll use the user data. If you want to do some automation kind of a things, like here are the commands. Automatically the Apache server should be installed and then it should be ready to use. Now the first two lines are, you can see, command lines. So now yum update -y. Folks, here it update all the installed packages on an instance. And this -y indicates automatically says yes to your prompt. And then yum install -y httpd. So it installs the Apache HTTP server, that is HTTPD, using Amazon Linux Package Manager, right? Then systemctl start HTTPD. It starts the Apache web server immediately. Then it starts the Apache web server immediately. Then systemctl enable HTTPD. Now, folks, it configures Apache to auto start on a boot, right? If the instance restarts or Apache runs, at that time it is required. Now, echo, it's like a output message where you can see a simple HTML file, which is homepage for your web browser, right? And now hostname -f. So here it insert the instances fully qualified hostname dynamically. That means here, what is your EC2 instance private IP address? You will get the information here. And finally, this is your what you call a file placed in Apache default document root. Finally, the data will be stored here. Now, let me copy this. Open a notepad, and paste it. Folks, make sure that the last line should be in the previous line. See, if you are not doing this, you will be redirected to Apache homepage. If you take the last line into the previous line, then only you are able to see this AWS network web server, right? Let me copy this and paste in user data section. My EC2 is running. Let me show you. My HTTP server is still running. Right now, just now it started. So now how to check whether my server is running or not? So just go to the instance ID. And here we have public IPv4 address. Copy it and paste it into the new tab. Copy the public IPv4 and paste it in the new tab. Folks, is it the message what I given in the document? Welcome to AWS Network Web Server along with the host name. Welcome to AWS Network Web Server with the private IP address 172.168.1.320.34. I am ready with the first instance, right? So as per your assisted practice, they are clearly specified in 2.6. Repeat the steps to launch second instance with a different availability zone, right? Let me launch one more EC2 instance. So again, I have to launch one more instance with same steps. Only the thing is you have to change the availability zone 1A to 1B or anything. Okay, let me take HTTP server 2. So HTTP server 2. Okay. So now same as it is, the steps are same. Now all the steps are same. T2.micro, keep here without keep here. Only the modification is as per the condition we have to. So as per the condition where I have to deploy now in different availability zone. So where should I deploy now? Okay, 1B selected, right? So again, I'm using the same security group. Default, right? My HTTP server along with the default. Fine. Now, advanced details, I'll use the same user data. But to make sure that it should be differentiated, right? So for that, I'll add here 2222. I hope everyone got the point why I'm differentiating. I should know for which web server my load balancer is hitting, right? Let me launch the instance. So how to check whether my server is running or not? By using IP. Now this is my HTTP server 2. By using public IP, IPv4 address, copy it and paste it in a new tab. So folks, is it my second server? This is my first server and this is my second server, what I differentiated. So this is my second server. So now folks, let me tell you, see, until and unless your first and second server are working properly, you got the message like both servers are working properly, then only go for creating a load balancer. Otherwise, don't go for it. If you are not getting this message, then don't go for creating a load balancer. Now I got the message. Let me go to the next step called creating load balancer, right? The name is called CLB demo. Let me copy this. Okay. And here, when you scroll down, there is an option called load balancer. Create a load balancer. Classic load balancer. Let's create now. And the load balancer name is CLB demo. So now folks, internet scheme, how you want to route a traffic, right? Internet facing or internal facing. Internet facing in the sense, all the traffic will be routed over the internet, and that too it uses all the public IP addresses. And internal in the sense, it routes a traffic to the specific VPC, and that too using a private IP addresses. And if you create a load balancer with this specific schema, after creating, it's not possible to change this particular scheme. Now let me go with internet facing. And this is very important. So where your EC2 are available, in which availability zone, you have to map that one. Now 1A and 1B. 1A and 1B, right? Done. Now security group default is available. Select my HTTP server. All right. Then, yeah, here you can see as per your document. If you want, you can add the response timeout 5 seconds, interval 30. In advanced settings, response timeout is 5 seconds and the interval is 30 seconds. Okay. Now, Next, you have to add the instances. Here is the option to add. That means I'm going to register my EC2 instance with load balancer. This is registration process. Which two servers? HTTP server 1 and HTTP 2 server, what I created for my load balancer. Confirm it. Right? So now your two registered are successfully added, but still not registered. Right? So keep as it is and now create a load balancer. So folks, now you can see my load balancer is successfully created. And if you see these steps here, and that too, step number 4, deploying classic load balancer to EC2. Here, a 4.2 description tab is not there. Description is changed to, let me show you. Click on the load balancer and description is changed to target instances. So folks, here you can see in target instances, still it is out of service. The health of both servers are out of service. Why? What is the reason? Here the reason is also given. If your servers are unhealthy, out of service, you will get the reason also here. What is that? Instance registration is still in a progress. That means your EC2 instances are registering with the load balancer, which is taking a time. And once it becomes successfully registered, you are able to see in service. Both options are in service. If something went wrong, unhealthy threshold value, then you have to check it out your EC2 instance along with the load balancer. Now still instance registration is still in a progress. Let's wait for 30 seconds. Let me refresh. Both are in service, successfully registered. Right now, let me take a DNS name. Copy the DNS name. Copy the DNS name and then go to browser. Paste it. This is my first server. Let me refresh. Server 2. This is my second server. First, second. So this is how your load balancer is distributing a load to the different servers. Okay, let's move on to the next topic, auto scaling. Here we have a custom diagram. So now what is auto scaling? According to the condition defined by the users, right? EC2 auto scaling allows them to automatically add EC2 instance and remove the EC2 instance as per the demand. So why we are using this auto scaling? To make sure that my application should be highly available. So as per the user defined condition, EC2 auto scaling, which allows the automatically adding the EC2 and removing the EC2. Now here you can see I have multiple web servers, right? And here we have CloudWatch service. Let me give the introduction to CloudWatch. CloudWatch is monitoring service in AWS environment, which monitor the entire environment and store the data in terms of logs. Then ELB, as you know that load balancer, which distribute a load equally to the servers. Auto scaling, as per the defined condition, it increases and decreases the number of EC2 instances. Now, here you can see if my CPU utilization 20, 40, 60, and this 80. That means 70 is here, a threshold value. So what is the condition if CPU utilization is greater than 70%? 5 minutes, 10 minutes, 15 minutes, 20, 25. This is time now. Okay. So now folks, as per the condition, if CPU utilization is more than 70% for 5 minutes, it should be for 5 minutes. Still it is not completed 5 minutes. Again, there is a fluctuation. Now folks, now do you think this condition is true? Right? Because now the 70% of a utilization is done for 5 minutes. That is the reason it adds one EC2 instance to the auto scaling group now. Right? Same scenario. Let me take for less utilization. If CPU utilization is less than 40% for 5 minutes, one EC2 should be removed. So now let me take a graph. Right? And here we have time. Right? And here, let me specify this is 40%, 80, 120, right? So now this is my threshold. So now folks, do you think this condition is true? No. Do you think this condition is true? Less than 40% for 5 minutes. Do you think this condition is true? Yes. This condition is true now. This condition is true now. So when it crosses a threshold value less than 40%, what we have the 4 instances, it removes the one of the instance from the autoscaling group, because as per the condition less than 40% for 5 minutes, it should remove the one EC2 instance now. Right. So now folks, here we have the concept of minimum, desired, and maximum. So now I'll specify minimum as 2, desired as 4, maximum as 6. So always try to avoid a same values, 2, 2, 2, 4, 4, 4, 6, 6, 6. Avoid, try to avoid that kind of a values. Now minimum number of instances means 2 instances. This is minimum. Desired is 4. This is desired. And maximum is 6. This is maximum now, right? So now folks, when I launch any autoscaling group, always it will be in a desired state. 1, 2, 3, 4. Right. So folks, when I'm getting a huge amount of a traffic for my application, what is the maximum number of EC2 I can increase here? Automatically AWS can increase this. So maximum 6. Now let us consider I'm not getting any traffic. Hardly 2 people are accessing this web server. So at that time, minimum how much? Minimum 2. Because already you have defined this. Always when you launch any autoscaling group, it will be in a desired state. When a traffic goes down, minimum 2, and when the traffic increases, maximum 6 now. One condition I want to specify here. Always make sure that desired should be greater than or equal to minimum. Now the condition is true. 4 is greater than or equal to 2. The condition is true. Now, there are different types of scaling we have. Let me specify here. In the first one is scheduled scaling. Then predictive scaling. And then dynamic scaling. Folks, now scheduled scaling, predictive scaling, and dynamic scaling. What is scheduled scaling? Folks, scheduled scaling is nothing but where already for certain duration, I am going to get the huge amount of a traffic. Before only I know that. So now let me take the example. Can I consider Flipkart Big Billionaire Days, Amazon Prime Sale, Black Friday Sale, right? In that, we know that for certain duration, I am going to get the huge amount of a traffic. That is nothing but scheduled scaling. Then what is predictive scaling? Folks, predictive scaling is based on historical data. So can I consider weather forecasting is the best example for predictive scaling? One more example. Can I use machine learning algorithms? Can I use machine learning applications where I'm going to train the model based on the historical data? Now, what about the dynamic scaling? So sometimes the traffic is high, sometimes traffic is low. There is no any constant actual load. You can say that. Sometimes the traffic is high, sometimes the traffic is low. We are calling it as a dynamic scaling. What are the benefits I'll get if I am using auto scaling groups? Cost saving is one. Performance. So in terms of enhancing performance, I can say that I'm going to increase the application availability, right? Better fault tolerance, increased application availability, lower cost, right? And even folks, when I'm talking about the auto scaling, it monitors every instance health. If something went wrong, if instances failed or unhealthy, AWS automatically replaced with the healthy instance. That is the power of auto scaling. And even it balances the capacity across the availability zone. So within the single, always your availability zones works within the region, and that to multiple availability zone if you want. Now, let me show you. Okay, now go to Autoscaling groups. If you scroll down at the left side, we have the option called Autoscaling groups. So now folks, let me create a Autoscaling group. You can see in the dashboard itself what I explained: minimum, desired and maximum size. When it is required, it will be scaled up as needed. Now let me create a Autoscaling group. So for this, you want a template. So now you can see I have one document. You can see this document, right? So folks, let me show you this console. Here we are going to configure manual and dynamic scaling, right? So for this, if you want to launch one EC2 instance, you want an AMI. So like that, here we are creating a template of that and we are launching the EC2 instance. Let's create a launch template. So now the name is called, let me take the launch template name called example. Description, blah, 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 blah. It's up to you. Do you want guidelines? It's up to you again. Now, which operating system do you want to use for that auto scaling group? Let me take quick start. And this is my Linux operating system, right? 6.1 AMI. That 5.1 is removed now. 6.1 is available. This is very important. You have to include your instance in a template. Otherwise, you will get the error. So T2.micro. T2.micro, right? Keep here. Don't include keep here in the template. Network, keep as it is. Everything keep as it is. No need to change anything. Click on launch template. Click on this. Now launch template is created. So if you see the launch template option also, the example what I created, it's available for me. Now go to auto scaling group. Fine. So here give me the name called demo. Today's date is 13, demo 13, right? And launch template. Is it the same template what I created just now called example? Select this. So once you select the template, you are able to see the configuration, instance type T2.micro, everything, AMI ID, everything you are able to see. Then click on next. And here you will get the options. This is VPC and this particular auto scaling group should map with which availability zone. I want to select 1A and 1B. Now your auto scaling can do a auto scaling in 1A and 1B region because I have selected both availability, not region, both availability zones, 1A and 1B. Next. Now here it asks, do you want to attach the load balancer? If you want to attach, you can select this existing load balancer you can use. Now attach the new load balancer. Here itself, AWS is given the option to create a new load balancer and you can attach. No load balancer, right? So I'll go with no load balancer. Keep as it is, then click on next. Now configure group size of scaling. As per my example, desired is 4, minimum is 2, and the maximum is 6. Now keep as it is, click on next. Notifications, optional. Tags, optional, right? Review it, click on create auto scaling group. When you launch auto scaling group, in which state, how many number of EC2 you have here? Desired is 4, minimum is 2, maximum 6. When you launch any auto scaling group, what will be the updated capacity now? Always it will be desired state. So still it's updating. How many number of instances are available? 4 at desired value. And if I show you the dashboard of EC2 also, if I refresh this, folks, 1, 2, 3, 4 are 4 EC2 instances which are running right now. How it is possible? A power of auto scaling. 4 EC2 instances are successfully launched. Now, let us consider I want to attach a auto scaling group. In some scenario, auto scaling group is fine. But in some scenario, let us consider I want to attach a auto scaling group to main server. Let us consider this server 1 is main server and I want to attach this server 1 to auto scaling group. Select the server, go to actions, and here is the option called instance settings, right? And attach to auto scaling group. And here make sure that your auto-scaling group and the main server should be in a same availability zone. If you remember, my first server is 1A availability zone, right? So now if you see here, demo 13, 1A, 1B, auto-scaling group is mapped, right? So now this demo 13, you are attaching with your main server. Let's attach. So this is like just now I attached your auto-scaling group with the main server successfully. So now folks, if I show you the auto-scaling group capacity, let me refresh. Desired value and instances are changed. Why? What is the reason? One main server is added to the desired value. That is nothing but a desired capacity value. How we are added to the main server. Yeah, let me share one more thing, which is important also. AWS auto scaling limits. AWS is given the limit also for everything quota. Auto scaling group per regions 500. Auto scaling per auto scaling group 50. Everything they are given. Let's move on to the next module. So now folks, in this module, I'm going to discuss about the storage service, a day in the life of cloud architect. So you are a cloud architect in an organization and have been asked to identify the cloud services for data intensive e-commerce company. Your task includes establishing scalable, highly available, secure database system to manage data effectively, implementing version control to preserve, retrieve, and restore every version of the object in the database, and ensuring the data encryption for high security. So using the standard SQL queries on the data and providing an option to upgrade the volume type to adjust the database performance as needed. Now to achieve this, we have some few concepts in this lesson that will find the solution for given scenario. So now folks, what are the learning objectives? By the end of this lesson, you will be able to create Amazon S3 bucket to store data and objects in the cloud. Enable versioning in Amazon S3 bucket to enable data protection. Demonstrate static website web hosting using the S3 to optimize the cost and enable the scalability. Share Amazon S3 bucket between the multiple accounts to centralize the data storage within an organization. You can take a backup and sync the data with Amazon S3 to provide a data durability and redundancy. Transfer files from S3 to on-premises storage to perform data analysis on-premises. So these are the learning objectives, or you can consider outcomes. Now, let me discuss about the introduction of S3. As you know that S3 is object level storage, where you are going to create buckets. So what is this bucket? Bucket is like a container which holds the object. And here, these object might be anything, whether it is image, audio, video, PDF, doc, anything. There is no restriction. You can store any kind of a data. This is unlimited storage. And you can create up to 10,000 buckets in an account. No doubt these buckets are unlimited storage. You can store any kind of a data. There is no restriction. But there is a small restriction. What is that? What we have the objects in the bucket, it should not cross more than 5 TB. And when I'm talking about the object, it's an object level storage. Each object contains 3 information. What are those? The first one is data. Then second, metadata. And the third, key, unique identifier, right? So now folks, data, what exactly it contains? Metadata about object. That means when it was created, what is the file extension? What is the size of that particular object? When it was created, file, then size, everything you will get the detailed information about the data. That is nothing but metadata. Now, key is nothing but unique identifier. So every object in the buckets are identified uniquely. So that is the reason every object have a unique identification with a specific ID. Fine. So these all are the basics of S3, and that too object level storage. S3 is simple storage service. It's a web-based storage service which is offered by AWS. So especially we are using for archiving and backupping a data online. So let me tell you folks, S3 is more popular for archiving purpose and if you want to take a backup data online. So let me tell you, this S3 is highly reliable service and that too where you can store, retrieve and manage a large amount of a data seamlessly and that too from any time. Now, what are the different like here features are available for S3? In that the first one is availability. Folks, always your S3 data is highly available, right? As you know that it provided 99.99% of a assurance. Your data is highly available. And now it ensures that your data is accessible and reliable at all the time because high availability is one of the crucial for your application that requires a continuous access along with what you have stored a data. Now, scalability. So as you know that scalability is one of the standard feature of S3. So because of this reason, it makes an ideal choice for wide range of application. That too from small scale to enterprise level solution where you can store a massive data storage. Now, durability. S3, it ensures that the data is well protected and resilient against the potential failure. It's a redundant storage across the multiple facilities and the devices that guarantees your remains highly available and secure. Now, performance. How we can increase the performance? There is a concept called multi-part upload. Let us consider I have the object with the 4 TB. So now the 4 TB object will be equally divided 1 TB, 1 TB, 1 TB, and then finally stored in the bucket. So this process we are calling it as a multi-part upload. If the object is larger, then it will be equally divided, then it will be stored in S3. And this option is not available in the console. Multi-part upload is not possible through the AWS console. You can go for CLI or SDK to perform this multi-part upload options. Now, cost efficiency. Yes, cost efficiency. Here we have S3 different storage classes. So based on that, you are going to pay for it, right? Now, security. S3 supports SSL, Secure Socket Layer data transfer, which encrypts your data while it being transferred over the network. Encryption, it helps to prevent the unauthorized interception and also which ensures your data remains secure during a transit between your application and S3 storage. So here S3 is responsible to perform, SSL is responsible to encrypt your data when it is traveling from your application to S3 bucket. That is nothing but security. Now, components of S3, which is already completed. What is bucket? Buckets are containers. Keys are nothing but unique identifier. Regions, a geographical location where we are going to create a S3 buckets. Now, buckets can store text file, images, videos, and even more. Any number of objects can be stored in a bucket and total bucket size is 5 TB. It should be object size. Any number of objects can be stored in a bucket. The total object size should be 5 TB, not more than that. Now, here you will get the complete control. For example, let us consider Rupesh is created a bucket. Now, Rupesh can decide who can create a bucket. Now, Siva can create a bucket. Kiran can retrieve a bucket. Then Prashant can retrieve the bucket. Surbhi can delete a bucket. So being a owner of this bucket, Rupesh is going to decide who can create, who can retrieve, and who can delete the particular bucket. Right? So these all are the components of S3. Now the next topic is called S3 storage classes. Let me take one example here, right? When we are using the storage classes, as you know that S3 is unlimited storage where you can store any number of objects. If you're not selecting any of the storage class, then by default, it will be stored in standard. If you are not selected any of the storage class, then by default, it will be stored in S3 standard. And let me tell you, this is costly also. Compared to other storage classes, this is costly also. But if you're not selecting any of the storage class, by default, it will store in S3 standard. Now, folks, let me take one example to explain the remaining storage classes. Let us consider for this Sayara object, I'm getting every day 10 million requests per object, right? So always S3 standard is the best solution because it instantly stores the data and instantly retrieves the data. If I'm getting 10 million requests per day, so that means I'm going to store this object here in this standard. Now, infrequent access. Are you going to get the same number of hits for this Sayara movie after 30 days? So let us consider after 30 days, if I'm not getting that much of a hits, then why should I pay more? Then it will store in infrequent access. After 30 days, an object of Sayara movie is available in infrequent access. So now the next option is one zone infrequent access. So what is this one zone infrequent access? Folks, if I talk about the S3, all the data will be replicated in 3 availability zone by default. Now, what is one zone infrequent access? When your data is stored in one zone infrequent access, the data will be available in only one single availability zone. So now the data will be available only in single availability zone. So now, folks, AWS itself clearly specified, don't use one zone infrequent access. If you have critical data or mission critical data or any important data, why AWS is clearly specified, don't use. If the data is lost, it's not possible to recover it back. Now, do you think after 90 days, are you going to get the same number of hits for your Sayara movie? No. See, might be here after 3 months, you are getting 10K. Let me consider 1K also. After 3 months, Sayara movie will be like 1K hits. So again, the cost is less. But once you are stored a object in S3 Glacier, if you want to retrieve an object, it will take time from 1 minute to 1 hour. Now, after 90 days, it's available in Glacier. Now, folks, do you think, are you going to get the same number of hits after 180 days? Here might be 100 views per day after 6 months. Then why you have to pay more? Then again, this is less costly, deep archive. And here, after 180 days, that means after 6 months, hardly I'm getting 100 views or 10 views sometimes. So that is the reason I'll keep the object in deep archive. Now, intelligent tiering will come into the picture. Based on access pattern, this Sayara movie object, it shifts the object, right? So here, after 90 days, I'm not getting that much of a traffic. Intelligent tiering is responsible to shift the object from Glacier to deep archive. These are the frequently accessed, these are infrequent access. Now, folks, in deep archive, if you talk about the retrieval time, it takes from 1 hour to 12 hours of a time to retrieve the object. Now, intelligent tiering is responsible to shift the object from one storage class to another storage class based on access pattern. And let me tell you, folks, for intelligent tiering, it's like a subscription fees. You have to pay monthly basis because intelligent tiering is responsible based on the access pattern. After 30 days, if I'm not getting that much of a responses, intelligent tiering will automatically shift that object to Glacier, then deep archive after 6 months. So now, folks, let me show you how to create a bucket. So right now, I don't have any buckets in my account. Let me create a bucket. So there are 2 options are available. General purpose and directory. General purpose means all the storage classes can be utilized. Directory means only one zone storage class, which is specially designed for low latency use cases. Let me create a demo 13. Array, why I'm not able to create a bucket? Folks, here you can see bucket with the same name is already exists. What exactly it means? But just now I shown you I don't have any buckets in my account. Then how it is possible? A bucket name should be always unique because bidding S3 is a global service. When you type any bucket name, it check it out in all the 38 regions whether this bucket name is already exists, right? So demo 3 is already available. Let me make it as unique with the numerical value. Now let me create a bucket. Now I'm able to create a bucket, right? So here I have one document for S3 naming conventions. You can see here, these are the rules for general purpose bucket rules. You can see here, minimum 3 characters, 63, maximum characters, all the rules they are given. Yeah, let me take version control. Let me give one scenario. Let us consider Prashant is using
one system, right? Like he's using one laptop. Now in that, he's creating one folder called ABC. Within the ABC folder, we have a file called XYZ. Now, folks, if Prashant is trying to copy one more file called XYZ, then what happens? System will warn, okay, show error, same name file exist, overwrite or not allowed. So, folks, if you nowadays you will get one pop-up. Do you want to maintain both copies or do you want to replace with the existing one? Now, version control is one of the feature in S3 bucket. This is my S3 bucket now, right? So usually this versioning is used to keep and maintain the multiple variants of the same object, and that too in a same bucket. This is main object, and these all are variants of that the same object, right? If you have a single object, you can maintain the multiple variants of the same object, and that too within a same bucket, right? And even it is also used to preserve, retrieve, and restore the earlier version of the object which is stored in S3 bucket. Now, I have one object, I am storing a multiple variants of the same object. Now, let us consider I have deleted this object, right? And the previous version of the object becomes main object. If I deleted this object, then previous version of the object becomes next object. If I delete this, then previous version of the object becomes next object. So now, folks, each time when you upload a object, S3 will automatically maintain the previous version as well. What exactly it means? It means that if you overwrite or delete an object which is versioning enabled bucket, now the previous version remain accessible and not permanently lost. So you can retrieve, you can restore, and even you can permanently delete a specific version of the object. And here we have three different states of versioning. In that, the first one is unversioned. Then second is versioning enabled. And the third one is versioning suspended. Okay. So unversioned means a bucket is available, but you can't maintain the multiple variants of the same object. Versioning enabled means the bucket is created. You can create a object multiple variants. Here it's possible. Versioning suspended. See, let us consider Barun is one of the solution architect for his organization, right? And now Barun is created one S3 bucket. Barun is created one S3 bucket with versioning enabled. When he was enabled the versioning, there are lot of storage it's occupied. So again, you have to pay for that, right? So that is the reason after analyzing 2 months data, being a solution architect, Barun is decided, hey, it's huge amount of data and I am going to pay a huge amount of for this object, which is not required for me. So after that, after 2 months analysis, he decided to suspend this. What exactly it means? Suspend in the sense, after the suspension, whatever objects you are putting into the S3 bucket, here it will not maintain multiple variants. Before that, whatever you have the multiple variant, that will be maintained. But after suspension, whatever you upload an object to this bucket, all the objects will not maintain a multiple variants, right? That is nothing but suspension. So now let me show you the same thing in the console. See, here we have two buckets, like two different types as I discussed. So now let me give the name called demo. Demo, today's date is 14. Let me make this bucket as unique. Otherwise, it's not possible to create a bucket. Can you see this? There is an option called bucket versioning. Even from AWS best practice, you can say that one of the best practice always enable bucket versioning, right? So folks, let me tell you, even sometimes what I heard, you will get the question based on the bucket versioning in AWS Solution Architect Associate Examination. What is the main use case of bucket versioning? So to avoid the accidental deletion, we have a versioning concept. So here we have disable and enable option. Let me create a bucket. All right. Now, let me upload an object into this bucket now, what I created just now. So here is the upload option. Just click on add files. Now you can see, folks, I have one launch template.txt. Let me upload one more time. Done. Okay. Now again. So folks, now this is my bucket, destination bucket. How many times I uploaded the particular file now? 3 times. Then as I can see, only one document I have here. So here, folks, there is an option called show versions. So now you can see 1, 2, 3. 3 different time what I uploaded the same file with the different version ID. So as I clearly specified in the previous session, also every object in the bucket are identified by the version ID. So if I delete, let us consider I'll delete this object. Let me delete this. All right. So here you have to type delete. So once I delete the object will be marked as delete marker and it will be available in versioning. Let me show you. Now no object, because the object is successfully deleted from the bucket. Now here it's available in versioning with the delete marker. If I delete this permanently, the previous version of the object becomes the main object. Now let me delete permanently. You can see here the permanently delete option I have. So folks, let me tell you, once you permanently delete the object, what you have deleted, it's not possible to retrieve it back. So now the object is successfully deleted. If you go to the bucket, folks, in the bucket, I have the previous version of the same object. Once I deleted successfully the object, permanently deleted, now the previous version of the object becomes my main object. And here, again, the versions are available. So these are the different versions. Even here, let me show you where exactly you will get the suspension option. Go to properties, encryption. Yeah, here itself, bucket versioning. Enable suspend. Even after the creation of a bucket, also, if you want to suspend, after suspension, no object will be considered as versioning. Now, folks, there is a concept called cross-region replication, CRR. So you can see here, first bucket and this is second bucket. So now, folks, cross-region replication is one of the bucket level feature. Enables the automatic and asynchronous copying of an object across the bucket in a different or a same AWS regions. So now this cross-region replication is a feature which is specially designed to enhance the data durability. Not only durability, even availability by maintaining redundant copies of your object in the multiple region. If you are maintaining the same data in the multiple region, then when should I use this? What are the use cases? So folks, can I use for disaster recovery? If this particular bucket is failed, this bucket, now disaster is occurred at this bucket. Now you can rely on the replicated data in the destination bucket for a data recovery, right? And here, folks, when I'm talking about the asynchronous process, it means that the object replication occurs automatically in the background without affecting the performance or a latency of your application. So whenever asynchronous comes, asynchronous copying of an object, that means automatically in the background without affecting the performance, it performs the task, right? And let me tell you, folks, even if you want to use MFA for that, like a multi-factor authentication for cross-region replication, that is also possible, right? You can use for disaster recovery, even you can use for even region outage. At that time, you can use this cross-region replication. Now, let me take you to the console. So now, shall I consider this as a source because already we have created this bucket? So now let me create a destination. So let me make it as unique. Okay, now keep as it is, bucket versioning enabled. Yeah. One thing is, if you want to do the cross-region replication, make sure that both buckets should be versioning enabled. This is the condition. Now let me create a bucket. All right. So now my source and destination. Demo is source, destination is a destination bucket, what I created. Now go to source
So let me show you one more thing, folks. I don't have any objects in my bucket. In destination, I don't have any objects in my bucket. But same thing, if you see source, here I have some objects along with the versions. Right? Now go to source. And here, folks, there is an option called management. Click on management. Now here you can see replication rule. So create application rule now. Put the name demo 14. Now, so it should be status always enabled, right? Rule will be enabled or disabled. Now source bucket. This is my source bucket, right? And do you want to go for more specific for the objects? You can apply the prefix for the filter. Right now, I don't want to go for it. I want to apply for all the objects in the bucket, entire bucket, right? So now you have the option, choose bucket in the same account. If it is same account, you can directly choose the bucket from here. If you want to go with another account, what is required, folks? Let us consider I want to do the cross-region replication with different account. Let us consider this account is belongs to Prem and the another account is belongs to Shubham. At that time, what is required? If I want to communicate with you, what is required? Let us consider Riju is available in Mumbai. I am available in Bangalore. If I want to communicate, so what I'm using? First thing, you require the account ID of the next person and the bucket name you can select. So now choose a bucket in this account. Right now, I'm using from this account. Let's select. Destination is a bucket where I'm going to replicate my data, right? Choose path. After selecting the path, here, see, permission to access the specified resources. The role should be created. And let me tell you, no need to think about this. Click on create new role. AWS will take care about this. Then it's additional features if you want. Replication RTC, replication matrix. So RTC is nothing but within a 15 minutes, the object will be replicated in the destination bucket, right? There is a special feature. And these all are the special feature. Replication marker, delete marker replication. These all are the special features. It's up to you being a solution architect, whether should I use or not. It's up to you. Now click on save. Okay. So now there is a pop-up. Do you want to replicate all the objects or do not replicate the existing object? That means now it's asking, do you want to replicate all the object which is available in source bucket to destination? Yes, I want to replicate. Submit it. Okay, now are you people familiar with the batch operation? Okay, let me explain. Batch processing is nothing but a bulk number of processes are going to be executed at specific time. So now here it starts copying an object from source to destination. And here you will get the complete report. That means whether any task failed. Now, do you want the report only the failed task or all tasks? I want all the tasks, whether it is completed or failed, everything should be recorded. And where you want to maintain the report, I want to maintain the report in the same account. And that too, whether do you want to go with source or destination. So I want to store the report in destination. And again, permission. Again, I am new role, AWS will take care. We don't have to do anything for this batch processing. Let's click on save. So now, folks, once I click on save, yes, you can see successfully created the job ID. You can see here. Just now, what I created, status is new, replication, operation is replication. See, total number of objects. Once it starts copying of an object from source to destination, you are able to see how many number of objects are copied and how much it is completed and how much it is failed. If something went wrong, why it is wrong, everything you will get the detailed information and what is the percentage it is failed. Right now, this is all about the batch processing, like how your cross-region replication is doing from source to destination. Let's move on to the next topic. Now let's move on to the next topic called S3 Lifecycle Management. In simple terms, you can say that it's a manual process. If you remember, in the previous session, I was discussed about the S3 storage classes, where intelligent tiering is responsible to shift an object from one storage class to another storage class based on access pattern. Now, here we have a different storage classes, right? Let us consider this is standard. In S3 lifecycle management, you are going to manually specify the number of days. Here in standard, I want to maintain the object for 30 days. Here in infrequent, I want to maintain for 45 days. In archiving, I want to maintain for 90 days. In deep archive, I want to maintain for 180 days. What I'm doing now, I am specifying my object should be available in this storage class for 30 days. After that, I'll shift to the infrequent access. After that, 46th day, I'll shift to the glacier. After this, I'm going to shift to the deep archive. Why I'm doing this? So to save the cost, because standard is costly. After 35 days, I want to shift to 45 days, a next storage. After 90, a low cost. 180, too low cost, right? As I discussed with the example, when I'm getting a huge traffic for the Titanic object, which is available in deep archive based on the access pattern, it shift to the standard. Now, in this lifecycle management, it's purely manual process, right? The major difference between your S3 storage classes and here manual process is here we don't have any reverse gear. That means if for this object, even I'm getting a huge traffic, it's not possible to shift this object to previous storage class. What is the reason? Because already you have defined the number of days, and even you will get the option after how many days you want to delete the object. If you put 178, it will not accept. Why? Because up to 180 days, the object will be available in storage. So you will get the message, it should be greater than 180. You can put 181, anything. Then after certain duration, the object will be deleted. You can't use 160 because the object is available up to 180 days in a deep archive. Then how you can delete that object? After 180 only, you can specify at the 181 day, the object will be removed. Now, so folks, this S3 life cycle management, actually we are doing this operation to manage our objects in a cost effective manner throughout the entire life cycle to save the cost, but everything is manual. And even let me tell you folks, the intelligent tiering is also considered as one of the storage class. So here we have two types of actions. What are those? The first one is first transition action, and the second one is expiration action. So now what is transition action, folks? Now this particular actions, it deals with moving an object from one storage class to another storage class at specific time. Time what you're defining, based on that the object will be shifted. So no doubt, which helps to optimize the cost. Now expiration action, the name itself indicates expiry. So now this particular actions, it delete the object after certain period, and even it ensure that the data should not store the longer than necessary time. Longer than necessary time. Now this S3 lifecycle management is a XML file which contains the information like rules and predefined actions which can be applicable to S3 objects and the rules entire lifetime. So now this S3 lifecycle management you can access by using AWS console, CLI, then SDK. These are the options. When you apply any lifecycle configuration rule to the bucket by storing the lifecycle rules, it will applicable to the sub resources which are attached to the buckets. Right? Now, same thing, let me show you in the console. Okay, let me take this only, source demo bucket. Go to management, and here is the option called lifecycle rules. Create a lifecycle rule. Let me put the name called demo 14 for rule name. And do you want to apply a specific objects? No, I want to apply for all the objects, right? Acknowledge this. So these are the life cycle rule action. So now you can see, folks, the two important actions in that the transition and expiry, right? If you scroll down, I don't have any option. When you select this transition current version of the object, it considered transition non-current version of the object between storage classes. That means this will be versioning object, versioned objects that will be considered, right? So now if I selected transition current version of the object, acknowledge it, you can add here. And now I don't have any expiry option. Let me take the expiry current version of the object. Now here I'm able to see the expiry of the object also. Let me add some values. Standard, let me add 30 days. Next, folks, you can see here, intelligent tiering as a storage. One zone, 90. Next, flexible retrieval. Let me take it as 150. Now, deep archive. Let me take code 365. All right. So now, folks, if I provide delete after object creation, that means you can delete the object. If I'll give the value called 333 also, you will get the message. It should be greater than 365 value. Now, if I use 366, then it will accept. Same thing here. If you change this to 210, so now let me consider, let me give the 279. Here you will get the message. The value should be greater than 280 now. This is all about the manual process S3 lifecycle management. Let's move on to the next topic called access control. Access control. What is access control as per your knowledge? How you will define this access control? Let me take more simple terms. Can I call it as a basic read-write operations or read-write permissions? Access control is nothing but granting the basic read-write permissions to other AWS accounts. By default, the account that owns the object can access and grant the other user to access through the ACL, right? So by default, all the objects belongs to the owner of the object. If you want to provide access to another user at that time, you can use ACL, right? Let us consider here we have a one bucket and this is 1, 2, 3 and the owner of bucket but 2, right? So now there is another account called 456 and here the user is Jidnesh, right? And now you want to provide a cross account access. There are multiple options we have. By using the ACLs also, you can provide access to other accounts. There are multiple options we have. Now let me take 3 different scenarios. The first is, if you want to change the default behavior of this particular bucket, then you have to change the object ownership. If you disable the ACL, that means all the objects of this bucket will belongs to only bucket owner. And the third, if I want to provide a access control to other user, can I use IAM policies, ACL, IAM role, and there is something called SCP. Then we have service control policy. Let me explain what is service control policy. Usually, service control policy will be used in multi-account environment. And this level, we are calling it as OYO level. This is organization unit. If you want to apply a policy at OYO level, then we have a concept called service control policy, SCP. Always SCPs are used in multi-account environment with multi like AWS organization service, right? So here SCP will be applied. Why? Only the childs which are inherited to this parent will be shared the properties of this particular node. That is the power of SCP. If you want to share the bucket between the multiple accounts, you can use IAM policies, right? Resource-based policies, then ACLs, cross-account access. If I want to go for cross-account access, you can go with IAM roles and even more options. As I discussed, even in the previous topic also, there are different types of replications we have. Cross-region replication, same region replication, and the one more is replication with the time control. This is one of the feature. Within a 15 minutes, it copy all the object from the source to destination. Now, let me show you about the ACL. When you click on create bucket, here is the option. Here we have object ownership. This is recommended. Disable means all the object of that particular bucket will be owned by the only bucket owner. If you want to access to this bucket and objects specified using the policies. So when you enable this, objects in this bucket owned by other account. So using ACLs, you can provide a permission to access with the other customer. So ACL is one of the method. You can use IAM policies, IAM roles, bucket policies, and this ACL also. When you disable, all the buckets are secure. All the objects within the bucket are secure because only owner can access. When you enable, it's up to you how you are going to provide access to other customer. And if you want to change the behavior of this bucket, always you have to change the bucket ownership. Then only it's possible. This is all about the ACL now. So now, folks, let me take you to the next topic called storage gateway. So before going to storage gateway, what is gateway, folks? Let me design a single routes, entry and exit point. The next entry point. Okay. See, just now taken one analogy here. This is one house with this boundary with compound and gate. So can I call this gateway single entry, single exit point? Okay. Now this is one house along with the boundary and a gate. So now if I want to connect from this premises to so-called society, whether it is to entry or exit. So this environment is totally different. This environment is totally different. Now, same thing. This is my on-premises environment. And here we have storage gateway. And this is my AWS environment. This is my storage gateway. In simple terms, if I want to extend the capability of on-premises data center to AWS environment, at that time, I'm using storage gateway. So now, see, here I've taken the name called storage gateway. Let us consider if I have any type of a gateway, whether it is storage gateway also, how I can improve the performance of the storage gateway. What are the factors I can consider here? You can add the additional CPU resources to the gateway host. Even you can add the additional CPU resources to the application environment. If you want to perform at this level of a read-write permission, so what kind of a storage I can use here? Which provides the highest IOPS. So here you can use the SSD, a high performance disk. You can add the resources to the gateway host. You can add the resources to the application host. And even you can increase the bandwidth between your application and gateway. These are the things when it comes for the gateway performance. So now you can see here, this is my on-premises environment. Now you can see there is a diagram. This is my on-premises environment, right? And this is my AWS environment. See, in simple terms, why we are using storage gateway? As you can see, if I want to extend the capability of my on-premises data centers to AWS, at that time, I'm using storage gateway. Now, logically, how it works? Here you can see in on-premises, we have file gateway, volume gateway, tape gateway, right? So using the different protocols, what we are using. So storage gateway in between we are using between on-premises and AWS environment. If I want to connect from on-premises to AWS environment, here we are using a strategy called direct connect. There are different options are available. You can use site-to-site connectivity. You can use direct connect. You can use VPN connection. There are multiple options are available. So being a solution architect, you know that which particular option should be selected in which particular situation. Let us consider Arun is one of the solution architect for ABC organization. Now, Arun is one of the solution architect for ABC organization. So now storage gateway, which serves as a crucial component for this ABC organization. And now they are seeking to build a hybrid cloud storage solution. This ABC organization, they expecting a hybrid cloud storage solution. How? By seamlessly integrating your on-premises environment with a cloud storage, right? So now this ABC organization can enhance the accessibility, scalability, and cost efficiency, where you will get the vast array of cloud services, where storage services, different storage classes, backup, archiving, FSX, right? Even automated backups. There are different options are available, right? So when I'm talking about a collection, a hybrid solution, it is a collection of hybrid cloud storage service that bridge the gap between your on-premises data centers and virtually limitless cloud storage, which is available on AWS platform. Now, for ABC organization, it empowers to use a cloud storage seamlessly while maintaining hybrid architecture. Hybrid in the sense, it combines the both benefits of on-premises infrastructure as well as cloud services. Again, I'm repeating, it combines the benefits of both on-premises infrastructure as well as AWS environment. So this is the power of storage gateways. Now let me take you to the next option called encryption. So now folks, encryption. So what is encryption, folks? Plain text to ciphertext, encoding to decoding, readable form to non-readable form. Here we have a different options. There are different encryption types. If you are not selecting any of the encryption type, by default, it will be considered as SSE S3. In every operation, we are not selecting any of the options. So by default, it will be encrypted by using SSE S3. And let me tell you, this is totally free service. And here it uses the AES, Advanced Encryption Standard 256 algorithm, which is one of the strongest block cipher to encrypt your data. So there is no any additional charge. It's a free of cost. Now the second option is server-side encryption with KMS. When you select this option, it asks you, do you want to choose from the KMS keys? Always there is a default key available for you. If you want, you can create default one. You can use default one. No, if you want to enter the ARN, create a key, copy the ARN. That is also fine. No, I want to create an entire new key. That is also possible. And folks, let me tell you, this is chargeable. KMS is Key Management Services, chargeable. You have to pay for it. Now, how to create a KMS key? Let me click on that. Here we have option symmetric and asymmetric. Symmetric means what? Single key will be used for encryption and decryption. But here asymmetric means public and private key will be used. In AWS environment, ARN, Amazon Resource Name, is the unique identification for every service. Like S3, KMS keys, EC2, like that for every services, even IAM user, IAM roles. For everything we have ARN. Now, symmetric, asymmetric, single key and public private key. For what purpose you are using? For encryption and decryption purpose. Click on next. So provide the alias name. Display the name of the key. Let me take demo 14. Same. Okay. Description is optional. Leave it. Next. So what are the key administrative permissions? This is also optional. Key administration permission to whom you want to give. Let me take myself. 328 is the username. Select the user. Click on next. What about the usage permission? Same usage permission I'll provide to myself for demo. Sorry, this is the key policy what we have. Automatically it will be generated. Then click on next. Now you have successfully created a KMS key, demo 14. So folks, this key is available. And now if you want to use this key, now it's available. Is it the key what I created just now in front of you people? Select the key and create a bucket. Bucket name, demo, make it as unique, then create a bucket. Now the bucket creation is successfully done. Now, is it possible to modify the encryption type after creation of a bucket? Then yes, 7373. And here we have properties, right? Default encryption, you can change. If you want to change from KMS to SSES3, you can go for this. Okay. There is one more type we have, dual layer server side encryption. That means at the board layer, encryption will be done. And this is like you are going to pay more for this. If you want more advanced security and more features, at that time, usually we go for this. Okay. Now, let me show you this key. Let us consider I'm not using this key for longer duration. So first, if you want to delete directly, it's not possible. First, you have to disable this. Even after disable also, you can't delete directly. You can make schedule key deletion directly, which is not possible. And here you can specify the duration from 7 to 30 days. So now I'm specifying 30 days. After 30 days only, this key will be deleted. Confirm it. Now, once I confirm, after that only the key will be deleted. That means after 30 days, your key will be deleted. Let us consider, no, again, I'm going to use the same key. In that situation, you can cancel the key deletion. That is also fine. Then you can use the same key if you want. If you want, you can enable. Again, you can use the same key as per your requirement. Let's move on to the next storage type called Amazon FSx. Where FSx is also one of the family of a service that makes easy to launch, run, and scale a shared storage which is powered by a popular commercial open source file systems. So this FSx supports a two different popular commercial file system. The first one is FSx for Windows file server, and the next one is Lustre. Amazon FSx for Lustre. Let me focus on Windows file server now. Okay, then we'll go for Lustre. Windows file server, FSx for Windows file server is managed by AWS. And let me tell you, this is specially designed to provide a fully native Windows file system capabilities. So Windows file system capabilities, that too in AWS cloud. And now this Windows file server, it allows the seamless integration with AWS environment. So because of this reason, it makes an excellent choice for Windows-based application as well as a Windows-based workload. Now, and folks, let me tell you, this Windows file server, as you know that, it is designed to provide the fully native Windows file system capability. And even this is specially designed to scale as per the growing demands of your application. Now, user can easily adjust the capacity and the performance of their file system to meet the change requirement. So now, folks, this scalability part is very essential for the workloads that experience fluctuating demands. Fluctuating means sometimes it's high, sometimes it's low. So at that time, this is very important. Now, FSx for Windows server can be accessed by using the protocol called SMB, Server Message Block Protocol, right? And apart from that, it allows a seamless integration with Windows-based application. And even it makes an easy to move existing file workload to AWS environment. That too without any modification. That too without any modification. Right? Now, apart from that, this is specially designed to provide advanced administrative features like a simplifying data management and even user access. So now even a quota, a maximum limit for the users, and user can restore the enhanced usability, and system will provide a overall productivity of every services. Apart from this, there is one more important feature. So now this FSx is integrated with Microsoft Active Directory, which allows your organization to manage the existing management of an infrastructure. And even this integration will streamline the process, a user authentication, access control, providing more advanced features to the end users, right? So now these are the important points about the FSx for Windows. Now, first, okay, Pranit, first point is Windows file servers are specially designed to provide a fully native Windows file system capability in the AWS cloud. Now, if I want to deal with the Windows workloads, so now it's a native file system capability which is provided in the AWS environment. Now, what are the benefits I'll get? The first one is it builds on a Windows server. Now, this is simple and manageable. And folks, SMB protocol, if I compare with the other protocols, SMB is the lowest cost, which provides flexible performance, secure and compliant, and even broadly accessible. So these are the benefits for FSx for Windows. Lustre is also one of the file system here which have the ability to deliver a high-speed processing. What is that high-speed processing now? Folks, let me tell you, the data throughput which exceeds more than 100 GB per second. So now this throughput is one of the essential for a performance intensive application that required some real-time analysis and quick data access. So because of this performance, this is widely adopted by the HPC community. So Lustre file system is adopted by HPC community and to its scalability because of the scalability and performance characteristics, right? So when you are using this Lustre file system, it brings the benefit of performance capability to AWS environment. Because of that reason, it provides the reliable and fully managed solution to the performance critical workload, right? So now, no doubt, Lustre is designed to handle a high performance computing workload. What type of a workload? What are the use cases? Can I consider data analytics as one of the HPC workload, high performance computing workload? Folks, can I consider scientific simulation? Consider the machine learning, also one of the high performance computing workload. Data analytics, scientific simulation, machine learning, where you are going to train a models. Right? No doubt, these provide some exceptional performance. And because of that reason, we are using a Lustre file system, which are valuable assets for your organization for fast data processing. Now, Lustre is integrated with one more service. This is my Lustre, and this is my S3. Now, integration with Amazon S3, it opens the new possibility for a data access and collaboration. So you can access a large scale data set which is stored in this S3 using the Lustre file system, right? Even it enables efficient data sharing and analysis. So Lustre file system is given a 2 deployment option. In that, the first one is Scratch and this one is persistent. Let me give the hint what exactly it is. Scratch is like instant store. Persistent is EBS. Scratch file system means it stores a temporary data. And here the data can be stored up to 14 days, not more than that. Persistence. So now persistent, it includes the durability throughout the automatic backups and even which is suitable for long-term storage, right? So here, this particular option is preferred to store a critical data that requires some persistent storage, reliable storage. At that time, you can go with this option. Now, if I talk about the benefits, so folks, high performance computing, scalability is also one of the part, right? Then next, let me take reliability also. Next, seamless access to S3, Scratch and persistent, multiple deployment option. So these are the benefits of Lustre file system. If we talk about the FSX for Windows as well as Lustre. Yes, Prani, because it provides the up to 100 Gbps throughput. Lustre is in which operating system by default? Lustre, you're talking about the Lustre in which operating system by default? See, Arun, Lustre itself a Linux-based parallel file system. Lustre is itself a Linux-based parallel file system. If I talk about the Lustre file system drawbacks, Lustre can be only used for Linux file system. So now here we have two services. The first one is Glue and the second one is Athena. Glue is serverless data integration service. Serverless means no need to think about provisioning, updating, patching. Everything will be taken care by AWS. Glue is serverless integration service that helps you for ETL data, that to extract, transform and loading from the various sources into the centralized data store, right? Centralized data store. So usually these ETLs are used for preparing a data for analytics purpose. Extraction, transformation or you can say extracting, transforming, and loading. So you can get the data from the various sources, that too for a centralized data store. So what are the features of this Glue service? Here we have a concept of data catalog. Then data catalog. Data catalog is used to store a metadata about the data set. Now ETL jobs, where you are going to perform extract, transform, load. How? By using Python script to transfer your data. And here we have one more feature called crawlers. Crawlers are used to automatically detect the schema and update the catalog. Schema is nothing but the systematic representation of a data. So schema is nothing but systematic representation of a data. Now crawler will automatically detect the schema and update the catalog. As per the data set, metadata will be updated. And the fourth feature is serverless. Serverless. No need to think about provisioning, updating, patching. Everything will be taken care by AWS. So this is for Glue service, which is specially designed for ETL jobs. Now, Athena. Athena is also one of the service in AWS. Athena is also serverless service, which allows you to run a SQL queries directly on stored data which is available in S3. Again, Athena is serverless. If I talk about the features, Athena is also serverless. No need to manage your infrastructure, and it works with the S3. And here it supports the SQL. No need for database engine. Directly you can perform a queries by using SQL services. Now, if I talk about the Athena, okay. Now, if I take the example of Athena, now let us consider Pranit is data analyst and want to analyze the customer transaction log which is available in S3 bucket. Now, first thing, you have to store all the transaction into S3 bucket. Now, if I want to create a data or a catalog Glue service, the first thing is, the first step is done. Now, all the transaction will be stored in S3 bucket. And now in the second step, I am going to use the Glue service to create a data catalog. And now, after creating a catalog, I am going to run the SQL queries using the Athena service to analyze the data without setting up a database. This is all about the Athena service now. Let's move on to the next module, that is networking. Here the topics are VPC, networking, and content delivery. As you know that in every module we'll get a scenario, a day in the life of cloud architect. So being a cloud architect, what is your responsibility? Cloud architect in an organization and has been asked to address security concerns about moving the company infrastructure to the AWS cloud. The company has outlined a specific requirements. They seek an entity that can attach to any AWS resources, defining its access permissions. Instead of distributing long-term credentials like username, password, or access keys, the company requires a solution offering temporary rights to application when they interacting with AWS resources. They aim to manage governance, compliance, operational audits, and risk assessment within the AWS accounts. The security and compliance of application on AWS should align with the company's standards. So now John's responsibility include setting up an AWS account and utilizing the AWS command line interface to engage with AWS services and resources. He must also master using the AWS identity and access management to ensure the secure access to AWS resources. To achieve this, he will learn a few concepts in this lesson that will help you to find the solution for given scenario. Now, what are the learning objectives? By the end of this lesson, you will be able to configure IAM and its policy to ensure secure access management, create and configure CloudFront distribution to distribute the content globally, create and configure VPC endpoint to privately connect AWS services without public internet exposure, implement a range of routing methods to manage a network traffic efficiently. So folks, these are the objectives, or you can call it as outcomes. Once you complete the module, you are able to answer the questions based on these topics. What is networking? Networking is nothing but establishing a connection between two or more devices to share the resources. Simple terms. Here you can see first is VPC, Internet Gateway, NACL, Network Access Control List, Public Subnet, Route Table, Security Group, EC2. VPC, Virtual Private Cloud. So virtual private cloud is an isolated area where you can deploy your AWS resources. Like in the previous session, you are created one EC2, right? You are deployed in this VPC. You are created one load balancer. You have deployed in this VPC because it's a isolated area. No one can enter without your permission. Let us consider this is Gagandeep VPC. Now Gagandeep is the owner. Without Gagandeep permission, no one can enter. This is Divakar VPC. This is Santosh VPC. This is Shivam VPC. Now, without Gagandeep, without Divakar, without Santosh, without Shivam, no one can enter this environment. So it's a service which isolates the resources. Now Divakar is going to use EC2, S3, or we have RDS, Relational Database Service. Then we have KMS. Everything is going to deploy. All the he services is going to deploy in this VPC because it's an isolated area. No one can enter without your permission. Now, by default, per region, you can create 5 VPCs, not more than that. If you want more, then you have to contact AWS support team if you want to increase this quota. Now let me take one simple example here. Okay, let me take plot. Now this is 60/40 site. Okay, this is my VPC. If you see here in this diagram, first VPC, just now what we have completed. Now we have subnet. What is subnet now? Let me discuss. Subnet is nothing but range of IP addresses. That means within a single VPC, how many IP addresses I can utilize. That is nothing but subnet. And this subnet is divided into two types. The first one is public subnet and the second one is private subnet. Okay, this is public subnet, the range of IP addresses that customer can interact. Private subnet, the range of IP addresses within VPC they can interact. Now, let me take this 60/40 site. Now here I have one gate and this is my sit out. I'm talking about the 60/40 site, right? And this is hall, dining room and all. This is public area now. And this is private area of your house, right? Now, here we have kitchen, then bathroom, washroom, and a bedroom, everything. Now, folks, let us consider a new person arrived to the home. This new person can access the public area. Now, this new person want to access the private area of your house. Then he should take a permission from a family member. Then only he is allowed. He or she is allowed. Now, same thing. Let me take with VPC. This is public subnet. And this is private subnet. Let us consider I have Flipkart website. So for this Flipkart website, everyone is able to access the website. Everyone. That means I should launch one EC2 instance. One EC2 with this Flipkart app. All the customer can access this application. It should be in a public area. Now, my question is, do you have access of Flipkart database? No, because it's available in private subnet. If you want to access this private subnet resources, you have to take permission from public subnet, family members. Now, this EC2 want to interact, then there is no restriction because family members can interact with each other. They can access all the rooms, everything, hall, kitchen, everything, right? So if someone from outside, if they are trying to access the private resources, they have to take the permission from public subnet. Now, let me discuss about the subnet. Here you can see there is a concept called subnet. So now, what is IP address? IP address in simple terms, I can say that a unique identification for a system in a network to identify that machine. So now there are two types of IP addresses we have, IPv4 and IPv6. So both are supported in AWS. What is the size of IPv4 addresses? 32-bit is for IPv4. What about the IPv6? It's 128-bit. So in AWS, both are supported, but in our scenarios, we are using IPv4 addresses, 32-bit. So now, folks, here we have the concept of CIDR, classless interdomain routing. Here you can see 172.31.0.0/16. 16 is nothing but /16 is nothing but a masking value which determines how many IP addresses you can use in a VPC. In this example, you can see the VPC value is 16. We are calling it as a masking value. Let me discuss the calculation how the IP addresses are allocated by using CIDR. So what is the size of IPv4 address now? 32. Masking value 16. 32 minus 16, 16. So now 2 raised to 16 is how much? 2 raised to 16 is 65,536 IP addresses you can utilize in a single VPC. Let me take that same example, a 6040 site, and this is VPC. This is public subnet. So this is AZ1 and this is AZ2. Now I'll divide. This is public area. This is private area. This is public area and this is private area. Now same thing, I'll divide this. Now constructing one building with for a commercial purpose. Let us consider this is block A and this is block B. And this is public area, private area. This is public area and this is private area. Right? Same thing. Now, just now I calculated for VPC up to how many IP address I can use? 65,536 IP addresses I can use now. The maximum IP address what you can use in a single. Now you can see a first 65,536 I can use a IP addresses. So first 4 IP addresses are reserved 0, 1, 2, 3 and the last one is like 36, 65,536, right? Last address is also reserved now. So now if you see in this diagram, we have subnets 172.31.0.0/20. Now the maximum number of IP address 65,536 I can use. So always make sure that you should not use a masking value less than 16. You can't use 15, 14, 13, 12, not available. Not possible. Why? The maximum range of IP addresses for a single VPC is 65,536. So you can use 17, 18, 19, 20, it's up to you. Now, if I calculate IPv4 32-bit, 32 minus 20 is 12, 2 raised to 12 is 4096. 4096 addresses, 4096 addresses, 4096 addresses. Here 4096, 4096, 4096, 4096. In this site, I can put 4096 objects here, 4096 objects here, 4096 objects here, 4096 objects here. This is how we are calculating. Let me take one more example. See, now I have a VPC range called 10.0.0/16. Okay, if I calculate this, 32 minus 16 is 16 and 2 raised to 16 is 65,536. Now this is subnet 1. Now subnet 1 IP range is 10.0.1.0/24. Now folks, what I'm doing, this is my VPC. I can create up to 65,536 IP address within this. I can put the objects. So what is the subnet 1 value? How many IP address I can use in subnet 1 and subnet 2? Let me calculate. So subnet 1 value is now 10.0.1.0/24. The range will be 10.0.1.02. Folks, if it is 24, how you will calculate? 24 means 32 minus 24 is 8. 2 raised to 8 is 256. Clear? So that means within a single subnet, you can use 256 IP, not more than that. So now the range is 10.0.1.0 and up to the maximum range 10.0.1. Up to how much? 256. Always it starts from the 0 means it should be 255. Let me take second subnet. Now 10.0.2.0/24. Now value is, if I take 32 minus 24, 8, 2 raised to 8 is again 256. Here I can use 256 IP addresses. And what will be the range now? 10.0.2.0 up to 255. How it works? First 2.0, 2.1, 2.2, 2.3, 2.4 up to 255. After this 3.0, 3.1, 3.2, 3.3, 3.4. It continues. I'll come back to my custom diagram. So now, just now I completed VPC and subnet. The next component is, these all are VPC components. Now, route table. What is a route table? Let me tell you, route table consists of collection of routes, which determine how exactly you are going to route a traffic to the destination. This is my subnet. And this is my route table. Usually this relationship will be there. So whatever the traffic is there in route table, what you have the address, the traffic will be routed to internet gateway. Now, can I connect a multiple subnet with the single route table? It's possible. Now same, let me reverse the scenario. I have only one subnet and these are my multiple route tables. Now, is it possible? The answer is no. Let us consider I'm in a Bangalore, so I'm using Gmap. In that, what I'll put the first destination, M0, Gabban Park, then Vidhan Sauda, then Vishweshwaraya Museum. Like this, I'll put the multiple destination. Even Gmap will be confused how to reach the destination. So if you put the multiple destination, it's not possible to reach to the destination. That's why this is not possible. But multiple subnet can be connected with the single route table. That is possible. This is all about a route table. Now, here we have security groups. If you see here in the diagram, let me show you first. Now, security group is virtual firewall at EC2 level. So what is security group now? Let me define it. The things. This is my EC2. Okay. So now, folks, these are inbound rules. Inbound rules, and these are outbound rules. So even you can say that incoming traffic, outgoing traffic. So now what is security group? Security groups are virtual firewall at EC2 level. So now here we have the concept of inbound rule and outbound rule. Now what is inbound rule? You can set rules to define which incoming traffic is allowed to your EC2 instance. So it includes a specific IP ranges, or you can use a port number or any protocol. Outbound rule. Outbound rule, you can establish a rules for a outgoing traffic from your EC2 instance. What connection your EC2 instance can initiate. And let me tell you folks, a default behavior. If you have just now created a security group, what is the default behavior? Now always all the incoming traffic is blocked and all the outgoing traffic is allowed. This is default behavior. So you must explicitly set the rules to allow the inbound traffic. And now here we are calling it as stateful in a nature. It's a stateful inspection. What exactly the stateful inspection? If you allow any request from the IP address to enter, the response is automatically allowed regardless of outbound rule, because it maintains a history. If I am allowing 17.10, just I'm taking example, a partial IP, 17.10, that means now traffic will be allowed. So now after allowing whatever you are allowing the incoming traffic, by default, outbound is also allowed only, regardless of outbound rule. So why we are calling it as stateful? Let me take one simple example. Here I have one apartment, and for apartment, I have one security guard. Now there is a third person who is visiting to this apartment. So now this security guard will check, who are you? Why you are here? What is the reason? To whom you are visiting? Everything he is going to cross check. Once everything is fine, everything is cross verified, then only he'll allowed to go to the apartment. And once the work done, folks, again he's leaving the apartment. Do you think the security guard is going to ask again, who are you? Why you are here? What is the reason? To whom you are visited? No, it's already passed the security. That means, can I say that
he's maintaining a history in terms of some documents, register documents. So he is maintaining history. That's why we are calling it as stateful. I know that I only allowed this traffic. That is the reason I am without authentication. I am allowing the traffic to go from my EC2. That is the power of stateful because it maintains a history. So folks, this is all about the security group. Now we have NACL. Let me specify NACL. Network Access Control List. This is also virtual firewall at subnet level. So if I talk about the default behavior, all the incoming or inbound traffic is allowed. Outgoing traffic is always allowed. This is default behavior. And here we have a concept of rule processing. So what is that rule processing? Let us consider here I have rules. These are the multiple rules. Okay. Now, which is minimum value now? 100. See, now always your rules are processed in a order. That too, starting with the lowest number rule first. So as soon as the rule matches the traffic, the evaluation stops and the traffic is allowed or denied accordingly. Whether the traffic should be allowed or not. These are all access rules. And now folks, here you can see about default behavior is all the incoming and all the outgoing traffic is allowed. Now, if I talk about inspection, this is stateless in a nature. Why we are calling it as stateless? Because it doesn't maintain history. Now, let me take one example. This is airport now, and here we have passport officer. Now, let us consider Battu. Battu is leaving India for some work. He's going to Dubai. So he's leaving morning at 6 a.m. from Delhi. So passport officer is going to verify everything. Okay. Now, once everything is successfully authenticated, then he can travel to Dubai. Now he reached to Dubai and again in evening, Battu is back to India, right? So here passport officer is there. Do you think this passport officer can say that, hey, I know the Battu, no need to show the documents, you can leave? No, right? So can I relate? This is stateless because this passport officer is not maintaining any history. So this is the default like stateless inspection of NACL. So here you can specify the rule number. Here in the NACL rules are the rank from always lowest to the highest number. If traffic matches to the lower number rule, the system is ignore any conflicting higher number values. And then a different type of traffic, protocols, ICMP, like TCP, UDP, ICMP, right? Then even what is the source, what is the destination. And let me tell you, here it supports both allow and deny both. So now, if I talk about the security group and NACL, what are the differences between security group and NACL? Security group is on EC2 level. Now, at subnet level, this is stateful and this is stateless. All the incoming traffic is blocked and outgoing is allowed. And here all the incoming and outgoing is allowed. That is also one of the difference. But one more important difference, here it supports only allow rule. Only allow rule. Here it supports allow as well as allow or deny, both. Again, I'm repeating folks, here it supports only allow, right? So allow rules, what exactly it means? Only what to define the traffic is allowed. Any traffic not explicitly allowed is automatically denied. So that's why it supports only allow rule. And here it supports both allow as well as deny. So folks, there are different types of IP addresses we have. Public IP address, private IP address, elastic IP address, right? Public IP addresses are reachable over the internet. And user can use these address to communication between your instance and internet, right? Private IP addresses are not reachable over the internet. And here, if you want to do the communication between within a VPC, let us consider if I want to do the communication within the instance, right? Instance with the database and all within a VPC, private IP addresses are used. Now, elastic IP addresses. Elastic IP addresses are the static IP addresses which are associated at account level, and these are chargeable. Now, let me demonstrate a demo for VPC. Let me create first So what is this, folks? Now, the first thing. So this is my VPC, right? Okay. So now let me show you, folks. This is my dashboard of VPC. These are multiple features which are relevant. You can say that multiple services which are available with VPC, right? So now let me create a VPC. First, as you know that default VPC is also available for your quick workload. Click on create VPC. I have two options. First is VPC only, and the second one is VPC and more. When you click VPC and more, everything will be taken care by AWS. Even a project name, what is the CIDR range and tenancy, how many availability zones are available, how many number of public subnets, private subnet, NAT gateway, everything. Just you have to click on create VPC. And let me tell you, folks, AWS is given a very beautiful presentation of your VPC. If you click on this, all the subnets are active. As you know, public subnets are routed through the public route table to the internet gateway because these are reachable to the customer. Private subnet, these are not reachable to the internet. Always it routes the traffic within a VPC. Now you can see if I focus on within a VPC, two route tables are active along with the two subnets, private subnets. And same thing if I click on internet gateway, public subnet with the two public subnets are available in the different availability zones. Right now, let me create entirely new and that too custom as per my requirement. I'm going to create and the name is my demo. Okay, so here let me give the CIDR range 10.0.0.0/16. So total how many number of IP addresses will be allocated to this VPC, folks? If I talk about the 10.0.0.0/16, 65,536 IP addresses will be allocated. Now let's create a VPC. So now VPC is created. What is the next step? Let me create. So what is required? I'm ready with my layout. I should construct hall, bedroom and all, right? Kitchen, everything. So can I make it as subnet? This is my public subnet. Okay, this is my public subnet and this is my private subnet. Okay, let me create a subnets. Here at the left side, we have option to create subnet. Now, here default subnets are also available. Let me create new subnet. So here, this is my public subnet. Okay, now availability zone 1A and the range is 10.0.0.0.0/17. So 32,768 IP addresses can be utilized, right? Now let's create a subnet. Successfully created public subnet. Now let me create another subnet, private. This is my private subnet. Okay, same availability zone and the IP range. Make sure that it should be not overlap 10.0.128.0/70. So here also 32,768 IP addresses can be utilized. Let's create a subnet. So both subnets are successfully created. Now, folks, as per the diagram, right now for time being, don't think about private subnet. Let's think about public subnet. After public subnet, what is the next step? Let us consider this customer want to access the public subnet. So what is the next point is required? If you want to create a NACL, you can create a NACL here. So here you can see there is an option called NACL, network ACL. So here you can create a network ACL. So name is my NACL. Select VPC, my demo, right? Let's click on create network ACL. So now see, my NACL is successfully created, right? If you click on NACL, here you can see, you can associate to your subnet. Still it is not associated. Now which subnet you want to associate? I want to associate to public subnet. Save the changes, right? So now this NACL is associated with public subnet. If you want to edit the inbound rules, you can add the rule number. Here you can add the rule number 100, custom TCP. I want to go with the STTP, right? Then it should be allowed or denied as per your requirements, right? Now it's allowed. If you want to add one more, HTTPS, right? Whether it is allowed or denied, it's up to you what you are adding, right? If it is allowed, save the changes. So now I'm done with NACL. After this NACL and public subnet, if the customer want to route a traffic, what is required? A route table. You should have one route table. So now you can see I have a route table. Now let me create a new route table. The route table name is my routes. Okay, select the VPC. My demo, what I created. Click on create route table. So now, just now I'm done with the route table. Is it possible to route the traffic from public subnet to route table now? There is a gap, right? Then there is no connection. How it is possible? So you have to associate your route table with public subnet. So here there is an option after creating route table. There is an option called subnet association, right? When you click on subnet association, there is an option edit subnet association. Now I am going to attach my public subnet with this route table. Then done. So now the association is done, but I should inform to public subnet all the traffic should be routed to route table, right? Now here you can see the subnet association is done. So what is next? From route table, where it should route a traffic, it should reach to the customer. So what is destination here? Before that, some gateway is required, internet gateway. So now here we have internet gateway. So let me tell you folks, internet gateway is a VPC component that connects, which establishes the communication between your VPC and internet. Let me create internet gateway now. So the name is myIGW. Okay. Create internet gateway. So internet gateway is successfully created and directly it's asking, do you want to attach to the VPC? Yes. Which VPC? My VPC, what I created. Attach internet gateway. Now successfully done with attaching internet gateway, right? My internet gateway is attached. All the route table traffic should be routed to internet gateway. So for this, you have to edit the routes. Go to route table. And here my routes, what I created, click on this. And here we have option edit routes. So now add route here. Always for your internet gateway, there is a standard IP 0.0.0.0/0. Now in this list, which is target internet gateway, select, save the changes, right? So now successfully my internet gateway is connected. This route table routes a traffic to the internet gateway and now customer can access this. So this is all demonstration of how your public subnets creates a NACL and how it routes to the route table. Then it connects to the internet gateway and reaches to the customer or a client. Now we have a concept called VPC flow logs. VPC flow logs. This is my VPC now. Okay. So this is my VPC and here I have the concept called flow logs. Okay. This is incoming and this is outgoing. See, flow log is one of the feature of VPC that captures information about IP traffic, right? So now these flow log records you can store in two options, whether you can go with S3 or you can go with the CloudWatch logs. So if you want to go with the CloudWatch logs, at that time you have to create a role, because to read the logs we require a role, right? So there are two options. If you want to store the information about the IP traffic, what kind of information? What is the source? What is the destination? What is the IP address, right? From where exactly you're getting the traffic? These multiple attributes are available. Multiple attributes are available. And if you want to store, I'm talking about the single traffic, more than 10 to 15 attributes are there. If I want to store this every information of traffic, you can store in S3 or a CloudWatch logs. If you want to go with the CloudWatch logs, at that time it requires a role. Directly you can store in S3. Now let me show you how you are going to store this information. So let me take my VPC itself, what I created just now. Select the VPC, go to actions, and here we have option. And now here my logs. So what type of traffic it should be captured? Only accepted or rejected? I want all the traffic, whether it is accepted or rejected. Now, maximum aggregation interval. So by default, it's 10 minutes. You can customize to 1 minute also. What is that aggregation interval? So once the packet is received at the VPC level, when I'll get the multiple packets to the VPC, I'm going to aggregate, then I'm going to store into the storage services, right? Now, here you can see CloudWatch logs, S3 bucket. These two options usually we'll discuss in a professional level, that to Kinesis part, right? So I'm going to store in the S3 bucket. If you click on yes, CloudWatch logs, here is the option to create a role, service role. Now let me go with S3 bucket. I don't have right now buckets. Let's create a bucket now because I want to store all the log details here. Okay, so let me create a bucket called flow logs. Make it as unique. Okay, keep as it is. Bucket versioning enabled. Create bucket. See, now the bucket is successfully created. If I go back to the VPC, here you are able to see. You can enter the ARN of your bucket. Where you will get the bucket ARN, just click on the bucket. And if you go to the properties, there is an option to copy ARN. Copy it and paste it in the ARN section, right? Let us consider Raw is one of the solution architect for their organization, right? And if you check the default format, version, account ID, interface ID, source address, source port, destination port, protocol, everything will be everything. For a single traffic, you will get all the information. Now, Raw is one of the solution architect for their organization as per the client requirement. So client specified how many, like, I don't want these all fields. Can you give me only source address and destination address? So now being a solution architect, Raw decided to go with the custom format, right? Which attributes you want? I want account ID as per my client requirement, source address, destination address. Then you will get only this information for every traffic. So you can decide which one you want. You can customize. That is possible. Now, if you go with the default format, let me keep default and see how you are going to store a data in a text file. By default, it's a text. Even if you want to go with a different file method like Paraquet, you can go with that. Right? So keep as it is everything. Now let's create a flow log. So now flow log is successfully created, folks. If I'm getting any traffic to the VPC, all the data will be captured and stored in this particular bucket. Let me show you. Right now, I don't have any objects. Let me refresh. Can you see this? AWS logs. A folder is automatically created by AWS logs. And if I'm getting any traffic to my VPC, here you will get the in detail information. Let's move on to the next topic called NAT gateway, Internet Gateway and NAT gateway. So what is Internet Gateway, folks? As I discussed, Internet Gateway is one of the VPC component that scales horizontally, right? Redundant, which offers a higher availability. Even you can say that Internet Gateway, which enables the communication between your VPC and Internet. So whenever you are using the Internet Gateway, there are two main purposes. There are two main purposes of this Internet Gateway. What is the first one? Always it acts as a target in the VPC from a route table. Always it acts as a target in the VPC route table that targets the Internet Gateway. And next is it handles the NAT, network address translation of the instances with the public IPv4 addresses. NATing is a process of converting from private IP addresses to public IP addresses. So now, folks, here we have a concept called NAT devices. Network address translation devices. So now, folks, these NAT devices which allows the private subnet to connect their internet, like connect to the internet or any other AWS services. Let me give a quick recall for the previous diagram. So folks, in the previous diagram, I was discussed only public subnet. Now here is my internet gateway, right? This private subnet EC2 want to connect the internet gateway. At that time, NAT is required. Now, I have This is only public part. And here we have internet gateway. And now, as you know that private subnet cannot connect to the internet. And now there is a scenario if my EC2 want to, this EC2 is available in private subnet and this EC2 want to connect with the internet. In that situation, I'm going to use NAT devices. In simple words, NAT devices which allows the instance in a private subnet to connect the internet or any other AWS services. Now, there are two different types of NAT devices we have. The first one is NAT gateway. Right now, what we are using. The next is NAT instance. So let me tell you folks, NAT gateway is a new concept. Now what we are using, right? And this is highly available. NAT gateway is highly available, fully managed by AWS. This service is provided by AWS, right? And it is designed to automatically scale and it can handle up to 45 Gbps of a bandwidth. And let me tell you folks, these NAT gateways are always inherent in the redundant availability zone, within the same availability zone. Because of that reason, it makes them a more resilient option for the production workload. The power of NAT gateway. Now, these NAT gateway are also inherently redundant within the same availability zone. Because of that reason, it makes them a excellent choice, that too for production workload. Now, if I talk about the NAT instance, this is older concept. Before NAT gateway were introduced. So now user have to launch one EC2 instance. Then you have to perform NAT operation. This is purely self-managed service where user is responsible for availability, scalability, or any update or a patches for the instance. Everything should be taken care by only the user. No one is going to help you in this case. Now, folks, if I do the comparison, this is my NAT gateway and this is my NAT instance. What are the differences I'll get? Autoscaling, this is AWS managed and this is self-managed. The first difference, autoscaling is also one of the difference. So NAT gateway, it supports autoscaling, but here no autoscaling. You have to configure. Next, performance. Which performance is high? Particular NAT device performance is high. NAT gateway, then it's low. When you launch any EC2, it depends on the configuration. So now, whenever if you want to do the NAT instance operation, you have to launch EC2. Now this EC2 means it's restricted to the configuration depend upon instance type. It will not cross the limit of this configuration. Instance type means there is a specific configuration. Based on that only it performs. If I talk about a NAT instance's characteristics, first thing, bandwidth and scalability. Multiple protocol support like TCP, UDP, ICMP, and even a NACL network access control list will be supported, and even concurrent connections also supported. Now, if I talk about limitations, so single elastic IP you can use for this NAT gateway. Some routing constraints also we have. Based on that, these are the limitations, right? Now, folks, I have one custom diagram. Let me show you for the NAT gateway. Here you will get the clear picture. There are two diagrams we have. This is diagram A and this is diagram B. Okay. Which diagram is, this is internet gateway, which is connected to the internet. By using internet gateway, you are connecting with the internet gateway, right? So now you can see always your public subnet will be connected to internet gateway. Now in this NAT gateway, now let us consider I have one EC2 instance here in a private subnet. And this EC2 want to do some updates, patches. And for updating and patching, again, it should connect with the internet. So at that time, as you know that, what is the strategy if I want to connect the internet with the private subnet resources? NAT gateway, right? So as you know that, what I have the private subnet resources in EC2 here, when it's trying to connect an internet gateway, here we are using NAT gateway. So now this private IP address, as you know that the NAT devices which converts private IP to public IP. Now this private IP will be converted into public IP. Then it will be connected to the internet gateway. Through the internet, all the updates and packages are successfully downloaded. Because private subnet resources can't directly connect to the internet. So if you want to access the internet from the private subnet resources, make sure that here a NAT gateway should be always deployed in public subnet, because here always your private subnet resources have the private IP. This private IP will be converted into public IP, and NAT gateway will convert that and connect it to the internet. And once updation, everything is done, here it provided to the specific EC2. So there will be a 2 route table in B. So this is all about internet gateway and NAT gateway. Now let's move on to the next topic called VPC endpoints. VPC endpoint, it enables a user to connect their VPC to other AWS services without using internet gateway, NAT devices, VPN connections, or any direct connect. Then how we are connecting? So now VPC endpoint provided 2 different types of VPC endpoints. So what are those? Let me discuss. Types of VPC endpoints. In that, the first one is interface. And the second one is gateway endpoint. So what is endpoint? Endpoint is nothing but this is also one of the features that enables a user to connect their VPC to other AWS services without using internet gateway, without using VPN connection, without using site to site, or without using direct connect, right? So what we are using, there are 2 types of endpoints we have. The first one is interface endpoint. The second one is gateway endpoint. Okay, before going to this, why we want endpoints? Interface endpoint. So let me tell you folks, interface endpoints are powered by AWS private links. Allows a secure and private communication between your VPC and other AWS services through dedicated network interface. And here you can connect with all the AWS services. There is no any restriction. Now, gateway endpoint is specially designed to only 2 services. Gateway endpoints always deals with only 2 services. The first one is S3 and the second one is DynamoDB. And it provides a scalable and cost-effective solution for accessing these services from a VPC. So now, even here also without traveling to the public internet. Let me tell you folks, this interface endpoints are chargeable. You have to pay for this. And this gateway endpoints are totally free. If I do the comparison between your gateway and interface and this is gateway endpoint, right? And these are the differences. Let me take. So first, this is chargeable and this is free service. Next, here it supports all services. And here it supports only S3 and DynamoDB. So folks, if you remember, as I clearly specified, in interface endpoint, always it routes a traffic by using dedicated interface. That is elastic network interface, ENI. In gateway, always it uses a route table to route a traffic. Let us consider you have S3 free service and S3 chargeable service. Then why they are given S3 in both cases? S3 free also, S3 chargeable also. The reason is S3 chargeable, it provides some additional features. Like even using the interface endpoint, you can connect with on-premises to S3. That is possible. So here on-premises environment will be supported, but here on-premises not supported. Here we are using dedicated ENI, elastic network interface. This is basically a virtual network card. It's like a LAN card for your computer. Now ENI is a private IP, which is even you can say that secondary IP, right? it consists of private IP, secondary private IP, and public IP, MAC addresses, security groups, subnets, everything. And now you can attach and detach for your EC2 instances. Why ENI is important? Basic networking and even a multiple network interfaces you can use, which is highly available, right? So now if I want to route a traffic from the any specific resources in an interface endpoint, always it uses the ENI. Now I taken the example for EC2, right? For other resources also you can route a traffic by using ENI. Now with comparison with the gateway, if you want to route a traffic with the gateway interface, always it uses the route table. Through the route table itself, it routes a traffic. Even when you are performing a demonstration, lab demonstration, in that you can clearly differentiate. When you select interface, you will not get the option of route table. When you go for gateway, at that time, you will get the option for route table. Now, let me take you to the demonstration. Here, folks, if you see, there is an option called endpoint. I don't have any endpoints. Let's create a endpoint. So now, this is my interface. My interface endpoint. And these all are the different categories. Now I'll go with the AWS services. If I type ES3, let me show you. If you select ES3, both gateway and interface both are available. If you go with the interface, chargeable, gateway, free, right? And let me show you the difference. When I select interface, I'll not get any option for route table. But same thing, if I go with gateway, I'll get the option to select route table. That is the major difference how you are going to route a traffic. Now let me take, for this, let me take EC2. Why should I go for same service? Let me take EC2. And I got the option called interface, right? So now all the traffic with, let me take default now, keep as it is, create an endpoint. Let me go to the creating next endpoint. This is my gateway. Gateway endpoint. Okay. Now let me go with gateway. I can, let me select ES3 now. And here is the option, right? So select the route table, which one you want. Now create an endpoint. So just now successfully I created a VPC endpoint for interface as well as gateway. So now folks, let's move on to the next topic called VPC peering. VPC peering establish a direct and secure link between two VPCs. The first one is source and the second one is destination. Peering connection that establish a direct and secure link between two VPCs. Now, user can create a multiple VPC peering connection for each of them. And whenever you can see here, this is my source and destination, I'm giving one name. Now, if you see, whenever you are creating a VPC peering, make sure that these 2 points. So what are those? The first one is always check it out. IP addresses should not overlap. The first condition. The second one is transitive pairing is not allowed. So what is that transitive pairing? Let me show you. So folks, A to B, B to C is not possible, right? A to B is possible, then A to C is possible, and even if you want to do the pairing, no direct pairing is created between B and C. If you want to do, then you have to create a pairing between B and C, right? So now A to B, B to C, this is not possible. Transitive pairing is not possible. If you want to do this, A to B, then A to C, then you have to create. If you want to make a B and C to be communicate, at that time you have to create a B and C pairing. Then only it's possible, right? Now, if I talk about the use cases about VPC pairing, so folks, where I can use this? Okay, can I consider for inter-organization collaboration? Right? See, organizations which often need to share the resources or collaborate on a project while maintaining a separate AWS account. So now VPC peering that enables a seamless, direct, private connectivity between the VPC of different AWS accounts, which facilitating secure, efficient data sharing or a system integration across the company boundaries. Now, folks, can I use for production, testing, development environment a separate VPC? For disaster recovery is also one of the best use case you can consider, right? Now, this is all about peering means one-to-one. Let us consider if I want to connect a multiple VPC simultaneously at a time. So here we have a concept called transit gateway. Folks, transit gateway where you can connect multiple VPCs around the world. Transit gateway is responsible to connect on-premises environment also, right? These are multiple VPCs. VPC 1, 2, 3, 4, 5, 6, 7. So up to maximum 5,000 VPC can be created. If I want to deliver my application around the world, the transit gateway is the best use case, right? And even you can host a multicast application in the cloud. And here rapidly you can move to the global scale. Right now, let me show you folks a demo in a demo. Here you can see I'm going to create a 2 VPCs for peering source and destination. And this is my source now. This is source now, right? And CIDR range is 10.0.0.0/24. Okay, let me create a VPC peering. The next, one more VPC for destination. Let me give the name called destination. Okay, and the CIDR range is, let me take 8.0.0.0/16. Fine, 8.0.0/16. So as per the first condition, make sure that the IP addresses should not overlap, right? Now, if you just scroll down, there is an option called peering connection. Now you are going to peer a connection. So folks, my peering name is my peer. Okay. So now folks, as you know that just now I created a 2 VPC. In that, the first one I'll consider as a source, as I given the name called source. And do you want to peer a VPC within the same account, same region, or same account, different region? Right now I have same account, same region. Right now, folks, if I want to go with another account, what is required? Let us consider I want to connect the VPC which is available in another account. So what is required here? It's account ID. Account ID you have to specify, then VPC ID you have to specify, right? Now, right now in my scenario, my account with the same region. So destination what I created, I'll select this. See, now in this particular scenario, you can see I'm selecting my account, that too from same region. What I created, destination, right? So let's create a peering connection. So now folks, peering connection has requested, not successfully created. So for this, you have to go to the destination. Right now in my scenario, both source and destination are in the same region. If you have the destination in a different region, you have to change the region. Then you have to check the peering connection. Right now, it's in same region. I got the request pending acceptance. So folks, usually in your social media, Facebook or Instagram, how many days your request will be available? Forever, until and unless you have to accept or delete the request. But here, let me tell you, the request will be available for only 7 days, not more than that. If after 7 days also, if you are not accepted the request, then automatically AWS have the authority to delete this peering connection, right? And let me tell you folks, by default, up to 50 peering connection per region you can create. If you want to extend the limit, up to 125 peering connection can be created by taking the permission from AWS support. Now, pending acceptance, select the peer, and here is the option. Do you want to accept or reject? It's up to you. accept it. So now folks, successfully pairing is done. My two VPCs are ready now. So now, do you think now both VPC A and B can communicate after VPC A and B is successfully created and pairing is done? Do you think A and B can communicate with each other right now? You have to specify the A traffic should be routed to, in route table, you have to edit the routes. It should route to the B. And here in this route table, all the traffic should be routed to A. Then only the A and B and B and A can be communicate with each other, right? So this is how your A and B VPC can communicate with each other. I was discussed about the AWS private link also, folks. AWS private links which establish a secure and private connections between your VPC and other AWS services and even on-premises service also. So some of the benefits we have with the private links. So some of the benefits we have of private links, like it enhances the security also, it provides the streamlined network management, and even it provides the smooth cloud migration, right? So multiple things we have. Folks, we have another service called System Manager. What are the resources? So here we have System Manager as a service. One of these service called System Manager. So System Manager is very powerful tool, right? Where it grants a user comprehensive visibility and control over the AWS infrastructure. And let me tell you folks, this System Manager is closely integrated with CloudWatch service, where it allows you to create a dashboards and operational data and even reporting the bugs. At that time, the System Manager is very important. Let me take the first tab. In this, we have application tools. Application tools in this app configuration. So what exactly this app configuration? So it helps you to create, manage, and deploy your application configuration. Then application manager. Application manager, here you application can make a logical group of AWS resources that you want to operate as a single unit. Then parameter store. It provides a secure and hierarchical storage for your configuration data and remote management. Then here, folks, we have one more tab called change management. See, automation. What is automation? Automation can automate the common maintenance and deployment tasks. Then change calendar, which is related to date and time. Change manager, which is very, very important. See, let us consider you are working in one of the project, right? And the project is live. If you do any modification, are you going to deploy that modification directly into the live project, or you are going to take the approval from your higher authorities? Approval is needed. So folks, change manager, it is an enterprise change management framework. First, you have to request, then approval will be done. After that, you can implement, and whatever you are implemented, then you have to make a report of that. Whatever you have made the changes after implementing, you have to report the operational changes, right? And you have to maintain a documentation for that. Everything will be maintained in terms of documents here. Then we have maintenance window. It's a setup of requiring some schedules for managed instances to run the administrative tasks, right? So this is all about the change management. Now, there is one more important tab called operation management. Here, as I clearly specified, this system manager is closely integrated with CloudWatch service. Then Explorer. It displays the aggregated view of operation data on the AWS accounts and across the AWS regions. Then incident manager. Folks, let me tell you, incident management, here we have a console to help user to mitigate and recover from the incidents. Then operation center, it provides a centralized location where the operation engineers can view, resolve, and investigate the operational items related to AWS resources, right? So these are the some of the important tabs which are available in System Manager service. So this is all about System Manager. Now, folks, here we have the next topic called VPN connections. VPN stands for Virtual Private Network, right? So VPN is a solution that establishes a secure connection between users on-premises network to the remote offices, client device, or a AWS global network. So here there are different types of VPN connections we have. The first one is site-to-site VPN, AWS client VPN. See, when it comes for the AWS client VPN, here AWS client VPN that offers us secure access to AWS resources. So this particular solution is particularly very much useful for a remote workers, contractors, or a partners who need to securely access a AWS resources without need to be physically present in the corporate network, right? That is nothing but client VPN. Now, what is VPN Cloud Hub? Let me tell you, folks, VPN Cloud Hub is the combination of multiple site-to-site connection. Let me define here. This is my VPN Cloud Hub. So VPN Cloud Hub that simplifies the setup of multiple site-to-site VPN connection. It acts like a central hub, which allows the communication between multiple on-premises to Amazon VPCs. And the last option, a third-party software VPN appliances. So folks, third-party software VPN appliances that establish the connection between on-premises network to AWS. Third-party VPN appliances, it provides the flexibility in terms of software selection and customization, right? From my end, if I talk, let me take one of the example as a third-party software VPN appliance, Cisco Connect. Let me take one more, 45. See, like this, we have multiple third-party software VPN appliances in the market. See, now we have an option called site-to-site, the first one. Let me show you, folks, one important custom diagram for site-to-site connection. Now, folks, here you can see there are two different environments. The first one is on-premises VPN server, and this is AWS environment within a single VPC, right? And these are managed connections. Sometimes it is static or a dynamic also. Now, here you can see VPN connection. It's a secure connection between your on-premises equipment and your VPCs. Folks, within this VPN connection, we have VPN tunnel. So what is that VPN tunnel? It's an encrypted link where the data can passes from customer network to AWS network. So in this VPN connection, always we are using IPsec protocol, right? So now, folks, here you can see customer gateway device. Actually, this customer gateway device is a physical device or a software application on customer side, that too on-premises server. Now, here we have virtual private gateway. Virtual private gateway is the VPN endpoint at the AWS site in a site-to-site VPN connection. And let me tell you, folks, this virtual private gateway can be connected to only single VPC, not more than that. Here, I can connect a transit gateway. Using a transit gateway, I can connect with the multiple VPCs, right? Virtual private gateway can be used for single VPC. Transit gateway, if I want to connect multiple VPC, at that time, transit gateway, right? So why we have two endpoints? What is the reason? Folks, let me tell you, the two endpoints are for high availability purpose. If one of the endpoint goes down, the second is ready to provide a service. That is the power of two endpoints, right? Now, folks, here we have one more strategy. This is all about the VPN connections, what we have completed. We have one more strategy called Direct Connect. So what is Direct Connect? Direct Connect is one of the cloud service solution that establish a dedicated network connection, right? So let me tell you, folks, Direct Connect, here we are using a physical cabling to connect from on-premises environment to AWS environment. And let me tell you, physical cabling, that to fiber optic cables with the speed of 1 Gbps, 10 Gbps, and up to 100 Gbps link. right? And here, some of the things you have to consider. What are those? You have to take a special permission from government. Then you have to make a SLA, service level agreement, and you have to take the permission from local authorities because you are going to put the separate fiber optic cables here. So here you are going to pay for ports. A particular dedicated ports are allocated to you. So whether you're using or not using, you have to pay for it, right? Now you can see on-premises AWS environment, right? So here we have direct connect location, which consists of customer router and AWS router. As you know that a router can route a traffic from on-premises to AWS side and AWS side to on-premises. The task of customer router and AWS router. It routes a traffic from AWS environment to custom on-premises environment and on-premises to AWS environment. And let me tell you folks, the speed of these router, so the speed of these links are 10, 100 up to 100 Gbps of a links, right? So folks, when I'm using this direct connection, what are the benefits I'll get? First, here we have a reduced bandwidth cost, easy to use, right? And a very important, it's a private connectivity from on-premises to VPC. And the very important, always the performance will be consistent, right? Always you will get the consistent network performance because it's a dedicated network connectivity. What are the differences between direct connect and site-to-site connectivity? Now you can see site-to-site VPN connections 1.25 and this is up to 100 Gbps connection. This is faster to configure compared to direct connect. It requires special agreements, physical cabling to the data center, and you don't have to pay for inactive connection. But what I taken the example of port hours, whether the connection is active or not active. So always encrypted in transit by default, but travels over a public internet, side to side. No need to encrypt. Why? Because it's private dedicated connection. That is the reason. Now, folks, we have a topic called CloudFront. So how many regions we have? How many regions we have? It's 38. How many availability zones? 120. Earlier, it was 37. It was 117. Now it's 38 and 120. So edge locations, we have a CloudFront edge locations, 700 plus edge locations are available around the world. Now, folks, CloudFront is global content delivery network service, which is specially designed to securely and efficiently distribute a content to the end users and ensuring low latency plus high transfer speed. CloudFront is nothing but a global content delivery network service, right? Which is specially designed to securely and efficiently distribute a content to whom? To end user, ensuring low latency. Low latency means low delay and high transfer speed, right? So as you know that it's a global content delivery network service. The primary function is to accelerate the delivery of web content, images, videos, APIs, and other assets that to around the world, right? Now, let me show you one simple diagram to explain this. So folks, these all are my regions. Okay, these all are my regions. Now, Vimal Singh is available in Mumbai region. Okay, he's available in Mumbai. Okay, so these all are my regions. Total 38 regions are available. And these all are my edge locations. So total 700 plus edge locations we have, right? Now, Vimal Singh stored a document called example.com. Example.com in North Virginia region. This is my North Virginia region. Okay. So folks, now when Vimal Singh is requesting for example.com, always it checks in the edge location first, which is nearest to the customer. Again, I'm repeating, edge location we check within nearest to the user, right? So now the nearest edge location is this one for Vimal Singh. Example.com is available in this? No, the document is not available. Now,
Here we have origin server. So what is that origin server? Origin server is nothing but a place where exactly your data is stored. Now, the origin server might be any S3 buckets or any web server. So now in my case, I have S3 bucket. So example.com file is available, right? Now, when Vimal Singh is requesting for example.com, first it check in the edge location. If the document is not available, then it check it out in the origin server in North Virginia region. Now the bucket is available in North Virginia, right? Now the result is fetched and provided to the customer. So before providing to the customer, it catches the content in the edge location, then it provided to the customer. Parallelly, right? Let me show you with one more similar diagram. See, when Vimal Singh is requesting example.com, first it check it out in the edge location. If the document is not available here, it check it out in the origin server. When Vimal Singh is searching for example.com, then first it check it out in the nearest edge location to the user. The document is not available, and now it check it out in the origin server. So now, once the document is found, then result will be provided in the edge locations. Edge locations are nothing but which stores a frequently accessed data to the customer, near to the customer, right? Now, after receiving the document in the edge location, parallelly it start transferring a data to the Vimal Singh, right? And next time when Vimal Singh is trying to fetch the data example.com, the result will be provided from edge location. This operation will be not performed. By default, 24 hours, the object will be available. If you want to customize the object duration, there is a concept of TTL, where you can customize a default time, minimum time, and maximum time, where you can store the object. So now, folks, can I say that by using this acceleration, I am achieving a caching a content strategically located in this edge location. I'm reducing the distance between the user and the data what we are requesting. Can I say that? By caching a content strategically located at the edge locations. Then only it's possible. Now, what are the steps we have for a cloud front? Let me specify the steps, how to create a CloudFront distribution. First, you have to specify origin server. Then upload file to origin server. Then we have third step called create CloudFront distribution. Right, these three steps I'm going to show you in the console. Now, folks, if I talk about the use cases, CloudFront can be used in static website content delivery. Folks, can I use CloudFront in on-demand videos and live streaming videos? Yes, as I clearly specified at the beginning itself, it deals with the all kind of a data, either it is video, images, audio, anything, right? So you can serve on a on-demand videos and even live streaming video. Now, folks, same thing. Let me show you in the console. See, Cloudinary, Amazon XXL, then Mesh, Hulu, then Prime Video, Amazon Geo Savan, Saw Music, Net Media Works. There are different many organizations right now. They are using CloudFront, right? So let me show you the same thing in the console. So what is the first step, folks? Let me create an origin server now. Create a bucket. Let me create a CloudFront server. Okay. Let me make it as unique. Then versioning enabled. So, folks, first CloudFront server is successfully created. After this, edge is third. Upload a file. Let me show you. I have one simple HTML file called 11.html. Now what I'm uploading. This is my file, right? Now let me upload 11.html. Okay. So upload it and click on upload. Create a CloudFront distribution. So let me tell you folks one thing here. Recently AWS, like last week only, AWS is updated the interface, first page for CloudFront distribution. Get started. Name, let me create demo 20. Okay. Description, it's up to you. So for what purpose I'm using? I'm using single website or application. Okay. So I don't want any domain also. Click on next. Now, right now in my scenario, I have S3. Let's create a CloudFront distribution and the name is demo 20. Click on next and S3. As I can see, I have buckets in my account, CloudFront server. Let's create one more time. Demo 20. Click on next. Select this particular server. Select the particular server. That means now this is my origin server, right? So select the CloudFront server as origin. I'll keep as it is. Click on next. I don't want to enable the web application firewall. Okay. Click on next. Review it and create a distribution. Once I clicked on create distribution, you are able to see here distributed domain name and here last modified is deploying, right? It means now my CloudFront is deploying, right? So now I'll copy the distributed domain name, right? I'll paste it in a new tab, right? So for this, you have to add a file name. What is the file name? What I given 11.html. Okay. How quickly I'm getting the document? Just check it out. Let me paste one more time. See how quickly I'm getting the document. So that is the power of edge location. That is the power of CloudFront service. How quickly you will get the content.
In the topic How to Design Cloud Services, we will take a look at the AWS well-architected framework. And we'll take a deeper look at the 4 pillars which make up the framework. And these are security, reliability, performance efficiency, and cost optimization. We'll then take a look at where you can find more information about designing cloud services for Amazon. And we will look at the AWS Quick Start reference deployments and where you can find out real-life examples about how real businesses are using Amazon Web Services. So let's start by looking at the AWS well-architected framework. Now this was introduced because building cloud infrastructure services is vastly different to what you're used to with on-premise infrastructure. So AWS created this framework to help you understand the pros and cons of decisions you make while building systems on AWS. The AWS framework documents a set of foundation questions that allow you to understand if a specific architecture aligns well with cloud best practices. And there's 5 principles it helps you with. The first of which is stop guessing your capacity needs, test systems at production scale, lower the risk of architecture change, automate to make architecture experimentation easier, and allow for evolutionary architectures. And we'll take a look at each of these in greater detail. So firstly, let's take a look at stop guessing your capacity needs. Now, imagine you're designing a brand new application for your business. All the infrastructure decisions you will make are made using estimates, which are basically guesses. If you overestimate, you might end up buying too much hardware and have a fleet of expensive idle resources. Conversely, you might underestimate and have to deal with the performance implications of limited capacity. With cloud computing, these problems go away, as AWS helps you eliminate the guesswork in your infrastructure capacity needs. You can use as much or as little capacity as you need and scale up and down automatically depending on your demand. The cloud allows you to test systems at production scale. Traditionally, in a non-cloud environment, it's usually very difficult to fully test new products or services in development, as it's cost prohibitive to have like-for-like environments, or you just don't have the resources available. Personally, I've lost count how many projects I've worked on when things have gone wrong as soon as the product's gone live, due to insufficient testing. With the cloud, you can duplicate environments on demand, and when you've completed your testing, just shut them down, and you only have to pay for the time the test environment was up and running. So you can test fully before you go live in production. AWS allows you to lower the risk of architecture change, as you can automate the creation of test environments. So you can emulate your production configurations and carry out testing against comparable environments. You can also remove testing bottlenecks where various teams are lining up to use your test environments. As with AWS, you can cheaply spin up as many test environments as you need and ensure that all the production changes have been sufficiently tested. You can automate to make architecture experimentation easier. If you need to make a change to production but not sure what the impact will be, well, you can automate the creation and replication of your systems at low cost and low effort to test these changes. You can then audit the impact, and then, if necessary, you can revert the changes and try again. With AWS, you can allow for evolutionary architectures. In a traditional environment, architecture decisions are often implemented as a static, one-time event that you have to live with during the lifetime of a system. But with the cloud, the capability exists to automate and test on demand to lower the risk of design changes. So you can implement new innovations and features easily. What this means is you aren't stuck with last year's technology, and you can implement new technology as soon as it comes out. As mentioned earlier, the well-architected framework is based on 4 pillars: security, reliability, performance efficiency, and cost optimization. So in the coming slides, we're going to take a further look at these 4 pillars, starting with security. So Amazon defines security as the ability to protect information, systems, and assets while delivering businesses value through risk assessments and mitigation strategies. What this means is you can apply security at all layers. So rather than just running minimal security, like firewalls, at the edge of your infrastructure, you can use firewalls and other security controls on all of your resources. For example, security groups on EC2 instances allow you to define who and what can access that specific resource, rather than just defining it at a global infrastructure level. You can enable traceability, so you can log and audit all changes to your environment. You can automate responses to security events, so you can monitor and automatically trigger alerts depending on your needs. You can focus on sharing your system. The AWS shared responsibility model allows you to focus on securing your application, data, and operating systems, whilst AWS secures your infrastructure and services. And you can automate security best practices. AWS allows you to create and save a custom baseline image of a virtual server, and then you can use that image to automatically launch new servers. This way you can ensure that all new resources adhere to your security standards. So I just briefly mentioned the AWS shared responsibility model. Now we take a look at this in more depth in a later lesson. But what it means is that the AWS shared responsibility model allows AWS customers to focus on using services to accomplish their security and compliance goals, because AWS physically secures the infrastructure that supports your cloud services. So if you look at this diagram, you can see it split into 2. Security measures that the cloud service provider implements and operates is the security of the cloud, and that's the responsibility of AWS. Then there's the security measures that the customer implements and operates, and this is related to the security of customer content and applications that make use of the AWS services. And this is security in the cloud, and this is the responsibility of you. So let's take a look at security in the cloud, and this is composed of 4 areas: data protection, privilege management, infrastructure protection, and detective controls. Let's start with data protection. Before architecting any system, practices that ensure security should be in place. With data protection, these are categorizing data based on levels of sensitivity, granting least privilege while still allowing users to perform their work, and encryption to protect your sensitive data. If you're storing customer credit card data, obviously this needs to be categorized as sensitive and it needs to be encrypted. But log files from a daily maintenance task wouldn't need this level of security. Now there's a number of tools AWS offers to assist you with this. AWS makes it easy to encrypt data and manage keys and key rotation using IAM and Key Management Service. You can perform detailed logging using CloudTrail. And AWS offers resilient storage systems like Amazon S3, which has 11 nines of durability. Now, 11 nines of durability means that if you store 10,000 objects with Amazon S3, on average, you can expect to incur a loss of a single object once every 10 million years. So in other words, you're not going to lose many files. And finally, AWS offers versioning and lifecycle management, again with S3, so you can protect against accidental deletes or file overwrites. Now, a central part of any information security program is privilege management, so that you can ensure that only authorized and authenticated users are able to access your resources, and that they can only access them in a way that is acceptable. For example, if a user needs access to a resource, don't just give them admin or read-write permissions by default, because they might actually only need read-only access. Now, to control your privilege management, you need to have a few things in place. The first of which is an access control list. And this is a document that needs to be maintained which lists access permissions attached to an object. So if you have some particular documents, you need to define what access is allowed to it. Then you have role-based access controls, and this defines the permissions for a particular end user's role or function. So an administrator would obviously need administrator access to various resources, but a regular end user might only need read-only access. So you need to define which roles have which permissions. Then there's password management, and this includes complexity requirements and change intervals. So you define how often people need to change their passwords and how complex they need to be. Now, Amazon helps you with all this with the Identity and Access Management, or IAM, service. And this is the primary service used to control access to AWS services and resources. We cover IAM in huge detail in a later lesson, but briefly, it allows you to apply granular policies which assign permissions to users, groups, roles, or resources. And you can also control the password strength using this, as well as federation with your existing directory services, such as Microsoft Active Directory. You also need to protect your infrastructure, and to do this it's recommended to have multiple layers of defense and also multi-factor authentication to meet best practices with industry or regulatory obligations. Now, Amazon allows you to do this by implementing stateful or stateless packet inspection, either using AWS native technologies or by using partner products and services available through the AWS Marketplace. Amazon Virtual Cloud, VPC, enforces boundary protection and monitoring points of ingress and egress, and then there's CloudTrail and CloudWatch, which provides comprehensive logging, monitoring, and alerting. You should always have detective controls in place so you can detect or identify security breaches. This needs to happen so you can provide both a quality support process and meet compliance obligation. And by a quality support process, I mean one in which when you have a problem, you're committed to finding out the root cause and actually resolving the issue rather than just saying, oh, we think it was that. Let's hope it doesn't happen again. I mean, I know I've worked for some places like that, and it's certainly not a quality support process. AWS helps you with your detective controls by providing these services. AWS CloudTrail is a service that logs API calls, so you can find out the identity of callers, the time of calls, source IP addresses, and things like that, so you can find out who is doing what and when. Amazon CloudWatch is a monitoring service for AWS resources, so you can log EC2 CPU usage or network activity, and you can use CloudWatch with many different services like RDS, EBS, and more. You can also set up alarms, so you can be notified when certain things happen. AWS Config is an inventory and configuration history service that provides information about the configurations and changes in infrastructure over time. With Amazon S3, you can see data access auditing, so you can find out who's been accessing your S3 data and when they did it and when. And Amazon Glacier, you can use the Vault Lock feature to preserve mission-critical data with compliance controls that are designed to be auditable for long-term retention. The next pillar is reliability. And Amazon defines this as the ability of a system to recover from infrastructure or service failures, dynamically acquire computing resources to meet demand, and mitigate disruptions such as misconfigurations or transient network issues. With reliability in the cloud, there's a number of things to look at. Firstly, you can test recovery procedures. Cloud infrastructure means you can test how your system fails, and you can validate your recovery strategy. Places I've worked at in the past, disaster recovery was a big event. It was only done annually, it took months of preparation, it involved working a whole weekend and then some, and was also incredibly disruptive to the business. Imagine being able to duplicate your production environment and test failure and failover whenever you want. You can automatically recover from failure with the cloud. Monitoring a system for a key performance indicator, or KPI, you can automatically trigger automated recovery processes when a threshold is breached. You can scale horizontally to increase aggregate system availability. Using multiple small resources instead of one large resource will reduce your single points of failure. And also you can stop guessing capacity. Gone are the days of using lack of memory or not enough CPU as a failure for a resource. With the cloud, you can scale as and when you need to, so you can't blame badly estimated capacity as the reason for reliability issues. Now, reliability in the cloud is composed of three areas. These are foundations, change management, and failure management. To achieve reliability, a system must have a well-planned foundation and monitoring in place, plus systems for handling changes in demand or requirements is also required. In an ideal world, your system would be designed to detect failure and automatically heal itself. Before architecting any system, you should have foundations in place so that your reliability is not impacted. You should have sufficient network bandwidth to your data center. You should have sufficient compute capacity. Your staff should be trained in the areas they need to be, and you should have support contracts with your vendors. With AWS, network bandwidth and compute capacity is already taken care of. AWS also offers a range of support contracts to help you with issues and a range of training courses for your staff. Change management is a critical part. Being aware of how a change affects the system allows you to plan proactively, and monitoring allows you to quickly identify trends that could lead to capacity issues or SLA breaches. With AWS, you can monitor the behavior of a system and automate the response to KPIs. For example, you can add additional servers as a system gains more users. So you can control who has permissions to make system changes and audit the history of these changes. Unfortunately, it's a given that failures will occur, so you need to have some failure management in place. It's good practice to understand why things failed so you can prevent it from happening again. No one wants to work for a company that, when things go wrong, they just get it working again with no understanding of why. A key to managing failure is frequent and automated testing of systems to failure and through recovery. Ideally, you do this on a regular schedule and also after you've made significant system changes. Now, Amazon allows you to do this with a few products. Firstly, AWS CloudFormation. This allows you to launch temporary copies of whole systems at very low cost, so you can use automated testing to verify your recovery processes. You can use CloudWatch to set up automation to react to monitoring data that indicates a failure. And you can store all your data on Amazon S3 buckets for future use. The next pillar is performance efficiency, and Amazon defines this as the ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. So what does this mean? Well, performance efficiency in the cloud means you can democratize advanced technologies. AWS provides products such as NoSQL or media transcoding or even machine learning as a service. So rather than your IT team having to learn how to host and run these new technologies, AWS does it for you. You can go global in minutes. AWS allows you to easily deploy your systems in multiple regions around the world with just a few clicks of your mouse. So this leads to lower latency for your customers. You can use serverless architectures in the cloud, which remove the need for you to run and maintain servers to carry out traditional compute activities. For example, storage services can act as static websites, which remove the need for web servers. And you can also use serverless technologies such as Lambda or elastic Beanstalk. And you can also experiment more often. With virtual and automatable resources, you can quickly carry out comparative testing using different types of instances, storage, or configuration. So performance efficiency in the cloud is composed of 4 areas: compute, storage, database, and something called space-time trade-off. And let's take a look at each of these. With the cloud, finding the optimal server configuration for a product will vary based on application design, usage patterns, and configuration settings. Traditional IT infrastructure requires making estimates in advance, which can lead to incorrect server configurations and lower performance efficiency. AWS is virtualized, so you can quickly change the EC2 server configuration to increase its performance efficiency. It may be optimal to run serverless computing. For example, AWS Lambda allows you to execute code without running an instance, and elastic Beanstalk allows you to run web applications in a similar manner. From an operational standpoint, you should have monitoring in place to notify you of any degradation in performance. The optimal storage solution for a particular system will vary based on whether you need block, file, or object storage, the type of throughput required, frequency of access, and availability and durability constraints. Well-architected systems use multiple storage solutions and enable different features to improve performance. In AWS, storage is virtualized and is available in a number of different types. This makes it easier to match your storage methods more closely with your needs, and also offers storage options that are not easily achievable with on-premise infrastructure. For example, Amazon S3 is designed for 11 nines durability and provides a variety of storage classes for your different data categories, like Glacier for archived data. EBS and EFS offer numerous options for your EC2 instances based on the level of performance you require from your storage. The optimal database solution for a particular system can vary based on requirements for consistency, availability, partition tolerance, and latency. Many systems use different database solutions for various subsystems and enable different features to improve performance. Selecting the wrong database solution and features for a system can lead to much lower performance efficiency. Now, for database usage, you need to be able to monitor them, test them, and also you need to have some database platform knowledge. But Amazon makes this much easier for you, as it provides a suite of Amazon Relational Database Services, which are fully managed relational databases. For example, Amazon DynamoDB is a fully managed NoSQL database that provides single-digit millisecond latency at any scale. Amazon Redshift is a managed petabyte-scale data warehouse that allows you to change the number or type of nodes as your performance or capacity needs change. You can also make use of Aurora or AMIs, where you install your own databases from templates. So what is the space-time trade-off? Well, you can think of space as memory or storage, and you can think of time as the processing time or the compute time to complete a task. So when you're architecting solutions, there's always a series of trade-offs, where it might be better to have more memory or storage to reduce the processing time, or maybe you're happy to sacrifice the processing time in order to reduce your memory or storage requirements. AWS gives you the option to maximize one or the other. For example, you could launch your systems globally, so you're increasing space and memory, so that they're closer to the end users in order to reduce latency, or the time. But whatever resource you use, you need to have monitoring in place to notify you of any degradation in performance. And the final pillar of the well-architected framework is cost optimization. This is defined as the ability to avoid or eliminate unneeded cost or suboptimal resources. AWS Cloud has a number of ways you can provide cost optimization. Firstly, you can transparently attribute expenditure, as the cloud makes it easy to identify the costs of a system and attribute IT costs of individual business owners, so those owners will have an incentive to optimize their resources and reduce costs. You can use managed services to remove the operational burden of maintaining servers for tasks such as sending email or managing databases. You can trade capital expense for operating expense. Instead of investing heavily in data centers and servers before you know how you're going to use them, with AWS, you pay only for the computing resources you consume when you consume them. Also, AWS allows you to achieve higher economies of scale because they can buy way more servers and hardware than you could ever imagine, so it's much cheaper to use their hardware than buy your own. You should also stop spending money on data center operations. AWS does the heavy lifting of racking, stacking, and powering servers, so you can focus on your customers and business projects rather than on your IT infrastructure. Cost optimization in the cloud is composed of 4 areas: match supply and demand, cost-effective resources, expenditure awareness, and optimizing over time. Matching supply to demand will deliver the lowest costs for a system, but you'll need to be able to provide sufficient extra capacity to cope with demand and failures. In AWS, you can automatically provision resources to match demand. Autoscaling, time-based and event-driven and queue-based approaches allow you to add and remove resources as needed. Monitoring tools and regular benchmarking can help you achieve much greater utilization of your resources. Using the appropriate instances and resources for your system is key to cost savings. For example, a reporting process might take 5 hours to run on a smaller server, but a larger server that is twice as expensive might be able to do it in just 1 hour. Both jobs give you the same outcome, but the smaller server will incur more costs over time. But to be able to find out these things, you need to have monitoring of expenditure in place and also regular benchmarking. AWS helps you with this. AWS Trusted Advisor goes through your resources and tells you where you can make savings. You can use on-demand instances, so you only pay for compute capacity by the hour with no minimum commitments required. Or you could use reserved instances, which allow you to reserve capacity and offer savings of up to 75% off on-demand pricing. And with spot instances, you can bid on unused EC2 capacity at significant discounts. You can also take advantage of managed AWS services, such as RDS or DynamoDB, which can also lower your costs. AWS and its virtually unlimited on-demand capacity requires a new way of thinking about expenditures. So you need to have a different way of budgeting, and you need to understand your business unit's usage. To do this, you can use cost allocation tags to categorize and track your AWS costs for AWS resources, such as EC2 or Amazon S3. And AWS generates a cost allocation report with your usage and costs aggregated by your tags. So you can set up tags for each of your business categories and units. This increased visibility of costs makes it easier to identify resources or projects that are no longer generating value and should be decommissioned. Billing alerts can be set up to notify you of predicted overspend, and the AWS Simple Monthly Calculator allows you to calculate data transfer costs. And you can set up SNS alerts so you can be notified when certain resources or cost breaches occur. Optimizing over time is an important strategy to reduce your costs associated with your cloud environment. AWS is always releasing new products and services. As such, you need to reassess your existing setup to see if it's the most cost effective. For example, rather than running a database on an EC2 instance, it might be cheaper to run an Amazon RDS database. Or Lambda might be more cost effective than EC2. But where do you find out more information about these new products and services from Amazon? Well, the first place to look for any new architecture guide is the AWS Architecture Center. This is a resource that provides you with the guidance and application architecture best practices to build highly scalable and reliable applications in the cloud. Here you'll find the AWS reference architectures. The AWS reference architecture datasheets provide architectural guidance to help you build an application on the AWS cloud. You'll find datasheets that include a description of how each service is used, plus visual representations of the application architecture. For example, web application hosting, or large-scale processing and huge datasets, or even building elastic web front ends for an e-commerce website. AWS white papers provide a comprehensive list of technical AWS white papers that cover all Amazon-related topics. such as architecture, security, and economics. There are new white papers being released all the time and are written by some of the most knowledgeable AWS people around. AWS Quick Start reference deployments use AWS CloudFormation templates to rapidly deploy a fully functional environment for a variety of enterprise software applications. Supplementary deployment guides describe the architecture and implementation in detail. In this course, we'll deploy things manually, step by step, so you can see how it works. But with CloudFormation templates, you can do several hours' work with just a click of a button. Examples of CloudFormation templates are SharePoint, RD Gateway, or even SQL Server on Windows Server failover clusters. And finally, case studies. AWS maintains a large list of case studies and success stories from their clients. You can check to see how some of the largest and most successful companies on the planet use AWS for their business. You'll learn how the AWS well-architected framework is used in planning and designing. We'll take a look at scaling and all the different versions. We'll look at the importance of loose coupling, how you can build redundancy into your cloud infrastructure, how you can save money by cost optimization. We'll look at automation and how it can make management of an IT environment easier. And also we'll take a look at security and how you can secure your cloud resources. So let's start with scalability. In the past, you would have to estimate the peak load of your systems and purchase your hardware accordingly. So perhaps you were setting up a new website and you were estimating that you were going to get 1 million people per month hitting your website. So you buy the hardware accordingly. But then you find out that only 50,000 people are hitting it, or 10 million people are hitting it. So your hardware is inappropriate for the work. Cloud computing provides virtually unlimited on-demand capacity, so you can scale whenever you need to. To do this, your designs need to be able to seamlessly take advantage of these resources. And there are 2 ways to scale, vertically and horizontally. Vertical scaling means increasing the specifications of an individual resource. For example, increasing the memory or the number of CPUs on a server. With AWS, this is easily achieved with a restart of your virtual server, so that it resizes to a larger or smaller instance type. The advantage of this approach is that it's very easy and requires little thought in the short term. However, this type of scaling can eventually hit a limit and sometimes be cost inefficient, especially if you scale up to some very, very large instances. Horizontal scaling means increasing the number of resources rather than the specifications of each individual resource. For example, adding additional web servers to help spread the load of traffic hitting your application. This is a great way to build applications that leverage the elasticity of cloud computing. However, not all architectures can distribute their workload to multiple resources. A stateless application is one that needs no knowledge of previous interaction and stores no session information. An example of this would be a web server that provides the same web page to any end user. A stateless application can scale horizontally as any request from any end user can be serviced by any of the available compute resources. You can add more resources as required and then remove them when the capacity is no longer available. Stateless applications do not need to be aware of their peers. All that is required is a way to distribute the end user sessions to them. And there are 2 ways to distribute load to multiple nodes. The first of these is the push model. A load balancer, such as the AWS Elastic Load Balancer, is a popular way to distribute a workload across multiple resources. An alternative, but less recommended approach, is to implement a DNS round robin using Amazon Route 53, where DNS responses return an IP address from a list of valid hosts in a round robin fashion. This is an easy to set up option, but it can cause issues if DNS records are cached. The alternative to the push model is the pull model. Tasks that need to be performed can be stored as messages in a queue, and multiple compute resources can pull and process the messages in a distributed fashion. Examples of this are big data processing scenarios, where many servers work to analyze data and return results, or media file conversion processes, where multiple servers convert the files as they arrive. Amazon SQS or Amazon Kinesis are services that can provide pool model load balancing. Most applications need to maintain some kind of state information. For example, an automated multi-step process will also need to track previous activity to decide what its next action should be. You can make components in your architecture stateless by not storing anything on the local file system, and instead storing user or session-based information in a database, like DynamoDB or MySQL, or on shared storage, like Amazon S3 or EFS. Additionally, Amazon SWF can be used to centrally store execution history and make your workload stateless. So the opposite of stateless applications are stateful applications, as it's not possible to turn some layers of your architecture into stateless components. For example, databases, which are stateful by definition, or applications that were designed to run on a single server. Providing multiple users a consistent view of the database or application is much simpler when your components are not distributed. Distributing the load is possible, though, through session affinity. This means that all transactions of a session are bound to a specific compute resource. However, this means that existing sessions would not be able to utilize newly introduced compute nodes. And also, if a node is shut down or becomes unavailable, users bound to that session will be disconnected. For situations when you need to process large amounts of data, it's always beneficial to see if a distributed processing approach can be used. Imagine a task that requires a huge amount of data processing. If it was to run on a single compute resource, it would max out the resources and take a long time to complete. If you can divide the task into smaller fragments of work, then each of the tasks can be executed across a larger set of compute resources. Examples of this are the AWS Elastic MapReduce service, which allows you to run Hadoop workloads across multiple EC2 instances, or Amazon Kinesis allows you to run multiple shards of data on EC2 or Lambda resources for real-time processing of streaming data. The concept of disposable resources is completely new with cloud computing, as cloud computing completely changes the mindset of an IT infrastructure environment. Traditional environments involved purchasing hardware up front and required manual configuration of the software, network, etc. Whereas with cloud computing, all infrastructure is temporary or disposable. You can launch new instances when you need them and get rid of them when you are done. Automate compute resource initiation is a way to speed up the creation of new environments. AWS has plenty of features to make new environment creation an automated and repeatable process. And there's 3 options available which we'll look at in the coming slides: bootstrapping, golden images, and a hybrid approach. Bootstrapping means you can take a newly launched AWS resource with its default configuration and then execute automated scripts to install software or copy data to bring that resource to a required state. So you could launch an EC2 instance and copy data on so that it becomes a web server. Scripts can be parameterized so that different environments, production or development, can be initiated easily. With AWS, bootstrapping can be achieved with your own scripts, Chef or Puppet, ops work, lifecycle events, or CloudFormation. Golden images mean you take snapshots of your EC2 instances or RDS instances or even EBS volumes, and they can be used to launch new instances. These EC2 instances can also be customized and saved as AMIs, Amazon Machine Images, and then you can launch as many instances as you want from this template. If you have an on-premise virtualized environment, you can also use AWS VM Import-Export to create your own AWS AMIs. The hybrid approach makes use of both bootstrapping and golden images. You can launch new instances from a golden image, but then bootstrap to configure other actions. Basically, with AWS, you are only restricted by your imagination or coding skills. AWS assets are programmable, so you can apply all these techniques and principles that we've just talked about to entire environments and not just individual resources, so you can completely rethink the way you work your IT infrastructure. Automation is a big part of planning and designing cloud infrastructure. AWS allows you to reduce the level of manual interaction in your environment. Using automation, you can react to a variety of events without having to do anything. Let's take a look at some examples. AWS Elastic Beanstalk. Developers can upload their code, and the Beanstalk service automatically handles resource provisioning, auto-scaling, load balancing, and monitoring. EC2 Auto Recovery. In some situations, you can use auto recovery to automatically recover an EC2 instance if it becomes impaired. The recovered instance is identical to the original, instance name, IP address, metadata, etc. Auto-scaling. You can automatically add resources to cope with demand spikes and decrease again during quiet times. CloudWatch alarms and events. CloudWatch can send SNS notifications to alert when a particular event occurs. For example, CPU usage is too high. The notifications can be used to perform follow-up actions, like run a Lambda function. OpsWorks lifecycle events. You can continually update your instance's configuration to adapt to environment changes. For example, if a new database instance is added to your environment, then an event can automatically trigger a chef recipe that points existing applications to the new server. Loose coupling is an important concept. Applications should be designed so that they're broken into smaller, loosely coupled components. The desired outcome is that a failure in one component should not cause other components to fail. This is achieved through a variety of measures. Firstly, well-defined interfaces. By ensuring that all components only interact with each other through specific technology-agnostic interfaces, for example RESTful APIs, will result in being able to modify resources without affecting other components. Amazon API Gateway is a fully managed service for APIs, which you can do this with. Loose coupling needs services to be able to interact with each other without having any prior knowledge of their existence. For example, imagine two servers communicating on hard-coded IP addresses. Then the addition or modification of resources will result in manual interaction to update the configuration. However, loosely coupled infrastructure is an essential ingredient in making the most of cloud computing elasticity. The easiest way to achieve this is to use an elastic load balancer service to provide a stable endpoint for all your services. This way, they don't have to worry about each other, the elastic load balancer does that for them. Rather than use synchronous integration, where server A completes an action and passes it to server B, which then passes it to server C, asynchronous integration involves the use of an intermediate storage area, like an SQS queue. This approach means that when a server A completes its action, it sends a notification to SQS. This way the compute resources are decoupled and not directly linked to each other. This means you can easily add or remove resources without having to update the configuration of the existing compute resources. Designing applications to fail gracefully allows other resources to continue a service without causing a complete outage. Examples of this would be if your primary website fails, the Route 53 DNS failover feature points your users to a backup site hosted on a static website on Amazon S3. The idea is to continue to provide a service, even if it isn't the full experience. Traditional IT infrastructure involves developing, managing, and operating applications with a wide variety of underlying technology components. AWS isn't just about EC2 instances. There are a suite of products to do everything mentioned and a lot more besides, to help you lower your IT costs and allow you to move faster as an organization. For example, managed services. AWS provides many services that are fully managed: databases, machine learning, analytics, search, email, etc. This lessens the burden on your IT infrastructure department. RDS databases mean you don't have to worry about backups, fault tolerance for your simple databases. S3 allows you to store as much data as you need without having to concern yourself with capacity management. Serverless architectures. You can reduce operational complexity of your applications through the use of serverless architectures. Tools such as the Internet of Things, Lambda, S3, Beanstalk all allow you to run your applications without paying for any server infrastructure. In a traditional IT environment, the type of database in use is typically restricted by constraints on licensing, support capabilities, hardware availability, and things like that. AWS provides you with multiple managed database server options that remove these constraints, meaning that you can choose exactly the right database for your needs rather than making use of what is available to you. AWS offers fully managed, easy scalable services for relational databases, NoSQL, data warehouses, and search functions that provide fully managed, easily scalable services that can create synchronously replicated standby instances in different availability zones. And they'll also automatically fail over without the need for manual intervention. We'll cover databases in a whole lesson later on in this course. Now we'll take a look at redundancy. Introducing redundancy will ensure your systems are highly available so they can withstand the failure of individual or multiple components, for example hard disks, servers, or network links. Introducing redundancy will remove single points of failure from your systems. This is achieved by having multiple resources for the same tasks in either standby or active mode. Standby redundancy is often used for stateful components like databases. The standby resource becomes the primary resource by failing over to it. The standby resource can be brought online only when required to save cost, or it can already be running to speed up the failover process and minimize the outage. Active redundancy is where multiple redundant compute resources share requests and are able to absorb the loss of one or more of the instances failing. Examples of this would be multiple web servers sitting behind a load balancer. Automatic failure detection allows you to react to an outage automatically without the need for manual intervention. Services like Elastic Load Balancer and Route 53 let you configure health checks so you can automatically route traffic to healthy resources. For example, setting up a health check to test for a HTTP 200 response, which means OK, would allow AWS to know if a node is healthy or not. Services such as OpsWorks, Elastic Load Balancer, and EC2 Auto Recovery will let you replace unhealthy resources with brand new healthy ones. Durable data storage is an important part of planning your cloud resources. Replicating your data to other sites or resources will protect its availability and integrity. There's 3 ways you can replicate your data: synchronously, asynchronously, or quorum-based. Synchronous replication ensures that your data has been durably stored on both the primary and replication locations. Any write operation will only be acknowledged as complete when this has taken place. This should only be used on low latency network connections where absolutely necessary to try to ensure maximum performance. Asynchronous replication decouples the primary node from the replica so that a write operation doesn't have to wait for any acknowledgement. This can introduce a replication lag, but does not impact performance. And from personal experience, I've seen the difference between synchronous and asynchronous replication changing performance as much as 100%. Quorum-based replication is a mix of both synchronous and asynchronous replication. Replication to multiple nodes is controlled by defining the minimum number of nodes that must participate in a successful write operation. So if you have a cluster of 4 replicas, you can say, I need confirmation from at least 2 of them before the acknowledgement is sent back to the end user. A traditional data center failover scenario involves failing over all your resources to a secondary distant data center. Because of the long distances between the 2 data centers, synchronous replication is often impractical, slow, and usually involves data loss and isn't tested very often. However, it does protect against low probability scenarios such as a natural disaster. So if your main data center was in New York and your secondary was in, say, Washington, if New York had a massive outage, you could fail over to Washington, but it's going to be slow and practical and take some time. A more likely scenario is a shorter interruption in your data center, which isn't predicted to be too long. In this situation, your choice is to sit it out and wait, or initiate the complex failover procedure. AWS data centers are configured to provide multiple availability zones in a region, with low latency network connectivity. This means you can replicate your data across data centers in a synchronous manner, and as a result, failover becomes much simpler. Also, this concept is baked into many AWS services, such as RDS and S3. Active redundancy is great for disaster recovery situations or balancing traffic, but what if all the requests to your resources were harmful? For example, if a particular request caused a bug and it resulted in multiple instances crashing. A practice called shuffle sharding means only sending some of the requests to some of your resources. This way, if one shard of resources is infected or down, the other shard of resources will be up and running. In the example shown here, if request 2 is bad, then at least one set of resources is still protected. AWS economies of scale offer organizations huge opportunities to make cost savings. By making further use of AWS capabilities, there's even more scope to create cost-optimized cloud architectures. Right-sizing is one such approach. In stark contrast to traditional IT infrastructure, cloud computing means you can select the most cost-effective resource and configuration to fit your requirements. EC2, RDS, Redshift and Elasticsearch give you a wide variety of instance types to choose from. Through benchmarking, you can determine the optimal configuration for your workload. In some cases, it might be optimal to select many of the cheapest instance type available. In others, it might be more beneficial to select fewer instances, but of a larger instance type. AWS Storage offers the same level of right-sizing opportunities. Amazon S3 offers many different storage classes to suit your needs. EBS also comes in a variety of different volume types, all of which will be covered in later lessons. AWS offers many elasticity options to help you save money. You can auto-scale your EC2 workloads horizontally or vertically. You can turn off production workloads when you don't need them. And where possible, you can use Lambda compute workloads so you never have to pay for idle resources. EC2 on-demand instance pricing means you only pay for what you use with no long-term commitments. However, there are two more ways to pay for EC2 instances. One of these is reserved capacity. By committing to a defined period of between 12 to 36 months, you can receive significantly discounted hourly rates compared to on-demand pricing. AWS Trusted Advisor, or AWS EC2 usage reports, identify the resources that would benefit from reserved capacity. There is technically no difference between on-demand and reserved instances. The only difference is the way you pay for it. This concept also exists for Redshift, RDS, DynamoDB, and CloudFront. EC2 spot instances are ideal for workloads that have flexible start and end times, as you are allowed to bid on spare EC2 computing capacity, and spot instances are often available at significant discounts compared to on-demand pricing. Your EC2 spot instance is launched when your bid exceeds the current spot market price, and it will continue to run until either you terminate it or the spot market price exceeds your bid. When the latter happens, your instance is terminated, and you'll not be charged for the partial hour that it was running. So there's three strategies to use for spot instances. There's the one we've just discussed, which is bidding. You could bid much higher than the spot market price for as long as the instance runs. This way, even if the market price spikes occasionally, you'll still make a saving overall. The mix strategy. AWS recommends designing applications that use a mixture of reserved, on-demand, and spot instances. This way you can combine predictable capacity with opportunistic access to cheaper additional compute resources. And then finally, there's spot blocks. AWS allows you to bid for fixed duration spot instances. These have a different hourly pricing, but allow you to define a duration requirement. If your bid is accepted, your instance will run until you terminate it or the duration ends. Now let's take a look at caching. Caching data means storing previously calculated data for future use, so you don't have to recalculate it again. There's two approaches. Application caching. You can design applications to store and retrieve information from fast managed in-memory caches. This way, an application can look for results in the cache first, and if the data isn't there, it can then calculate it or retrieve the data and store it in the cache for subsequent requests. This approach improves user response times and reduces load on your resources. An example of this is Amazon Elasticache, which is a service that provides an in-memory cache in the cloud suitable for use with web services. Edge caching uses Amazon CloudFront, so you can cache static content such as images or video and dynamic content such as live video around the world using edge locations. This way users can be served the content that is closest to them and resulting in low latency response times. The principle applies to both download and upload with edge caching. And finally, security. It's important to have security built into your plans and designs for AWS infrastructure. AWS allows you to take most of the security tools and techniques that you already know and improve them by formalizing security control design into your AWS platform. This simplifies the system for administrators and auditors alike. Now, we're not going to cover too much here because this is all covered in the IAM lesson. But there's things like defense in depth, which allows you to add multiple layers of protection to your resources. Reduced privileged access, to only give people the access they require. Security as a code, lets you capture security requirements in one script that you can use to deploy new environments. And real-time auditing. AWS has multiple services to ensure you can test and audit your environment in real time. AWS offers a wide and deep set of functionality that allows you to integrate your existing network, security, data, lifecycle management, and resource management capabilities with the cloud. AWS allows you to extend your existing on-premise network configuration onto your AWS virtual private clouds, so that your AWS resources will operate as if they're part of your existing network. You can do this using Amazon Virtual Private Cloud, VPC, which is a logistically isolated network in the Amazon cloud that gives you complete control over your virtual networking environment. You can choose your own IP range, subnets, route tables, network, etc. Then there's Direct Connect. Rather than use internet-based connections between your on-site resources and the Amazon cloud, Direct Connect lets you establish a dedicated network connection between the two to provide lower costs and a higher level of service. You can use AWS to reliably and cost-effectively back up and secure your data. AWS allows you to replicate your data across geographical regions, manage the lifecycle of the data, or even synchronously replicate your data to a local AWS data center. AWS Storage Gateway is a VM that you install in your data center and configure to be associated with your AWS account. Then you can either use Gateway Cached, which lets you use Amazon S3 storage as your primary data storage, while retaining frequently accessed data locally in your storage gateway, or Gateway Stored. Gateway Stored volumes let you store your primary data locally and asynchronously back that up to AWS. Amazon Simple Storage Service S3 offers a practically unlimited storage that's available for backing up and archiving your critical data, and Amazon Glacier is extremely low-cost storage for infrequently accessed data, for which recovery intervals of several hours are suitable. AWS Security and Access Control is easily managed using IAM or Microsoft Active Directory services. AWS Identity and Access Management is the service that enables you to securely control user access to all your AWS services and resources. An AWS Directory Service is a managed service that allows you to connect your AWS resources with an existing on-premise Microsoft Active Directory, or you can set up a new standalone directory in the AWS cloud. AWS Security and Access Control is easily managed using IAM or Microsoft Active Directory services. AWS Identity and Access Management is the service that enables you to securely control user access to all your AWS services and resources. An AWS Directory Service is a managed service that allows you to connect your AWS resources with an existing on-premise Microsoft Active Directory, or you can set up a new standalone directory in the AWS cloud. And there's three flavors of Active Directory. There's Microsoft AD, which is a fully blown managed Microsoft Active Directory service that supports up to 50,000 users. There's Simple AD, which is a standalone managed directory that's available in two sizes, small and large. Small is for up to 500 users, and large supports up to 5,000 users. Or there's AD Connector, and this is a directory gateway that allows you to proxy directory requests to your on-premise Microsoft Active Directory. And this also comes in two sizes, small and large. A small AD connector is designed for small organizations of up to 500 users, and a large AD connector is designed for larger organizations for up to 5,000 users. You can also use integrated resource and deployment management tools in your hybrid environment. AWS provides monitoring and management tools with robust APIs, so you can easily integrate your AWS resources with on-site tools. And most major software vendors already support AWS, like Microsoft, VMware, and BMC. Tools such as AWS OpsWorks allow you to deploy and operate applications in the AWS cloud or in your own data center. You can use templates or build your own tasks to specify an application's architecture. AWS Code Deploy automates code deployments to instances in your existing data center or in the AWS cloud. AWS Code Deploy simplifies the code deployment process to your instances.
What is the course introduction? So basically, we are going to see what is cloud computing, and after the cloud computing, we will try to focus on AWS. After that, I will try to teach you all the basic things related to AWS. And in the solution architect training, we will see the services in very detail again. Okay. So basically, let us discuss what is cloud computing part. Okay. Now, cloud computing has been there very popular in the market, probably from in the era of 2006, 7, 8, 9. Worldwide cloud computing started over, especially in India, it started almost, it became famous after 2011, 12, and then people started understanding cloud. There are a lot of businesses running their infrastructure on cloud. And that is why people like us who are the IT professional got attracted towards this field. And we are looking at it as a dream career. And we are having a good hopes that if we learn cloud, definitely we'll get good results and good career in that. How to tell you the stories called storytelling technique. So what was there prior to that? So for example, here Mr. Raj is there and he is a client of some company, right? So that company is, let's say, Simplilearn. Simplilearn is, for example, an IT company, right? So Raj goes to Simplilearn and he says, okay, now Simplilearn is an IT company, right? Now, similar to Simplilearn, there are a lot of IT companies available. Now, this IT company says, okay, you want to start business online. So what do you require? You require a website, and that is very important thing. Number, then you require a database, and this is what we will help you to do that. Okay. So Raj says, I don't know anything about it. Whatever has to be done is all your responsibility. So this is the IT company's responsibility. So they say you want website, you want database, you want storage, you want everything, right? A lot of things, blah, 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 they told him. And then for that purpose, right, this is all software part. They also want a hardware. So what this IT company would be doing, they would provide hardware to run those softwares over it. And that is called as the very famous word called server. And a lot of servers are placed on data centers. So whenever any IT company used to help their clients to start the online businesses, so those websites, those softwares, they must be running on some hardware servers, right? And those hardware servers are the hardware machine. These are the computers. These are maybe, you can call it as supercomputers or the computers having higher configuration, which can help to run the big applications. Now, all those online businesses were running over the hardwares, and these hardware servers were placed at one place called as data center. Now, data center is actually, a place where you see a lot of servers are connected to each other through networking components, and those servers have their own purposes. Some server run the website, some server run the databases, some server providing the storage devices. A lot of things are there, and this place is called data center. So you must have listened, this particular, you must have heard this word, okay, there is a data center of this company. This company has its data center in Mumbai. That company has its data center in Delhi. That company has its data center in Tokyo. So this data center, how do they look like? I'm considering if you are not aware of how does it look like, I'll use Google. Why it's not loading? Okay, it's loading. Thank you. So data center is something I want to show you the image. Okay, let's look at it in a most simplistic way. What do you see? These are the images, right? Okay, let's take this one. Forget about what is this website is, but Yeah, look at the image, right? These are actually the places. It can be a warehouse, it can be a big hall, it can be a building where a big space is there, and in that big space you will see the racks, the metal racks. You see this particular page. Okay, on that metal rack you see different machines are placed horizontally. These are all hardware. Server literally means who serves the service, right? So when a website has to be launched, it has to be run over a particular server. Similarly, any other application, a database application or other application, software in simple term, they want to be run, they require a hardware server. And these servers are connected through some networking component. There are cables, there are internet connectivity 24/7, sockets, routers, a lot of devices are there. And this is a pure setup which is connected to internet. You can also observe this is provided by 24/7 electricity. This is also having air conditioner facility to keep the temperature of servers down. And these servers are running continuously 24/7, right? So that the software, the websites that you want to run, those will be running continuously for their end customer. The point here is that earlier companies used to have their own data center. And because of that, right, what were the problems that they were facing? And then if we understand the problem, then we'll realize what is the need of cloud computing. Okay. So when any IT company used to start their business online, they used to have their own data center. So when you have your own data center, then a lot of problems that you face. What are the things? First of all, the first thing is cost. Okay, so you're like, okay, so how cost is an impact, right? So first of all, it requires a huge amount of initial investment, right? What is it by initial investment? For example, you see practically, you will be like, okay, we want a space, number one. So you have to pay the rent for that. Number two, you have to order the racks, the networking components, electricity, continuous backup, inverters, air conditioners, internet facility, the hardware servers, different each and every small and big component of networking devices. You have to invest huge amount in order to make that data center setup. That is the first thing. Okay, so a company has to invest a lot initially. Then there's a problem with the time. Okay, how time to set up? It takes a lot of time, and practically it is understandable that you're creating a data center. You're not creating a very small thing. So it takes time to create the data center. But at the same time, if you want to scale your infrastructure, okay, can somebody tell me what is my scale? When I say that you want to scale the infrastructure, what does it mean? Scaling is difficult in terms of scaling takes time and money. Okay, so in simple word, to increase the number of server. So you'll be like, if you don't know what is my scale and why it is needed. So I tell you simple example. Okay, everybody knows Amazon.com. We are from different countries, but we know something that is common is Amazon.com. Are we known about Amazon.com? Yeah. So what is this? This is an e-commerce website. Okay. So you know that they do some, they launch some sales, right? Or probably in the Christmas last year, 25th of December, they have launched a sale. And what happened? Suddenly, a lot of people started visiting the website. So if a lot of people started visiting the website, we call it as traffic, right? A lot of requests comes. And in that case, a lot of requests comes to the server, then the whatever 5 or 6 server, whatever available servers are there, they become insufficient. In that case, it is needed to increase. So it is required to increase number of server to support it. That is called as scaling, and it is increasing. Okay. Sometimes it may happen that after the sale is over, right? After the sale is over, in that case, will you keep those extra servers? So initially, for example, Amazon was running on 2 servers and there is a sale. So you added 3 more servers to support the traffic. A lot of requests were coming, right? So what you did, you added the thing, right? You added more server. But after the sale is over, will you be keeping these 5 servers as it is? Will you be using these 5 servers? What do you think? When the sale is over, the traffic is less. at that time you want to decrease the server, right? So you will decrease probably some of the servers from here. So it is called increment decrement. So you're going to grow the size as well as shrink the size. So it's both the ways. Server, the number of servers. That is called as scaling, right? Scaling means adjusting the capacity as per the traffic. So scaling in case of own data center, scaling becomes difficult because you are involved in purchasing new servers, and again a lot of money is required, again time is required, right? Next, the problem is with security. So maintaining security becomes your responsibility. Maintaining security is your responsibility. If you want to monitor the resources, it is again your responsibility, right? Okay. So when I look at these problems, and there are a lot of other problems also in terms of like you require manpower to maintain that and all the things. So in the era of 2005 or even in between 2000 2005, there are a lot of companies who started thinking about providing a service online where the companies do not need to have their own data center. Let's say companies like Microsoft, Amazon, Google, right? So AWS stands for Amazon Web Services, and this is the company that is a subsidiary of Amazon. It focuses on cloud. This is called as cloud provider. Similar to AWS, we have Azure. Now this Azure is Microsoft's cloud, and then we have GCP. GCP has a long form called Google Cloud Provider. That's a long form. Azure do not have any long form. So Azure belongs to Microsoft, or I can say like Microsoft Azure likewise. These are the three market giants. Apart from them, there are other providers also, like we have Alibaba and we have IBM and many more in the market, right? Yeah. So these are the top three one. And these companies started thinking about providing the services, IT services online. So what they did, they literally did the thing what Uber has done. All of you are aware of Uber service, the cab provider, Uber. Okay. So what you do with Uber is that you are using a car and the service of cab of some third party company. And what you do, you pay for the usage. Am I right? Similarly, AWS started the business in 2006 officially, and they started launching the AWS platform, wherein they started calling it as cloud. So what is cloud? Cloud is that a company like AWS, they have created their own data centers all across the world. And let me show you. AWS has created their own data center all across the world. The official content that I'm showing you, I'm not showing anything which is a third-party content. This is the AWS official website. You can see. And I wanted to show you this particular diagram. You see the world map here, and there are circles on that side. All right. So these are representing the world maps, and these circles are representing the places where AWS has created their data centers. And what they did is they created services which were running on that data center. And around 300 AWS services are available, more than that, which are running on all these data centers. I'll show you the name of the cities where these data centers are there. We'll start with USA. You can see Canada, North California, Oregon. Then we have government cloud just for US government. And then we have Ohio, again, government cloud for US government and military. This is Northern Virginia, and we have Canada Central. So these are all North US, regions. And then we have this one in the South America. We have in Africa, only one called Cape Town. We have Tel Aviv in Middle East, Bahrain, UAE, you can see, Spain, Ireland, London, Paris, Europe, a lot of places. In India, we have Hyderabad and Mumbai. In Australia, Sydney, Melbourne. Here we have Auckland in Scotland, I believe. This is Singapore, Thailand. In Asia, we have Chinese regions such as Ningxia. They have Beijing, and in Japan, we have Tokyo, as well as there's one more called Osaka, and Seoul is again in China, I think. Okay, so if you see, all these clouds are available, all these data center are available for us. These government clouds, which you see in US, they are just dedicated for government. Clouds are not available for private customers. Okay, I think this much is understandable. When it says government cloud, so this is only for US government, and it is also for their military. That is purely for government side. The circle, if you see, few circles are red circle. I think in total there are 4 red circles. If you go to red circle, they will say coming soon. So Jamil, the green one are the existing one, and the red one are the upcoming one. So the coming one is Germany. So they are going to start their data center in Germany. So they are trying to spread their infrastructure all over the world, right? So what AWS started doing is that they are providing data center. Now this is AWS data center. I'm sorry, AWS data center. There are AWS data center. On top of that data centers, AWS is providing services in different category. For example, compute service. Now, compute service provides you servers, virtual machines. There is database services, provides you database server. There is storage services, provides you storage devices online. Okay. Then it provides you, for example, networking related services to create your own network components. There is CDN service, content delivery network. If you don't know what does this CDN means or what does this networking means, no problem. These are the categories. Okay. After that, you have different services. Even I can show you on my lab site, or you can also check if you have opened your lab. In the practice lab, I'll show you immediately what are the different categories and what are the things shown here. So the idea is very simple. You go, you create an AWS account. Once you create the account, you'll be able to use different AWS services which are running on AWS data center. Now imagine tomorrow, suppose Mr. Jamil Basha, he is a great photographer, and he thinks that, Raj, I want to start my own website and do the business online. I want to sell the photos that I have done. I want to do the auction online. So I'll be like, okay, Jamil, you don't need to worry about that. Okay, what you do is like, you must be ready with your photos. That's all. And if you do that, you must hire one developer who can help you to develop the website. And then you can use any cloud provider. These cloud providers are providing you the whole setup of data center, everything they already have. Different customers are using their services. So what Jamil has to do, Jamil has to come and use the AWS services and launch his web. He can do that thing within few minutes if he knows how to create the architecture, or he can take the consultancy of some cloud architect, and cloud architect will help him to launch his website on AWS account. So Jamil has not to worry about whatever problems we were thinking, because we are outsourcing these jobs to third party. Now the whole thing of data center part is now taken care by AWS. It is similar to Uber, right? So when somebody thinks about Uber, you can compare it with having your own car. So when you have Uber option, do you need to invest into your car? No. Do you need to maintain your car? No. Do you need to hire a driver, pay him a salary, or put the gasoline, petrol, whatever? No. The answer is completely no. What do, you just use it, and you're paying for usage. The same thing AWS does for you. AWS says, we have created the whole network of data center. This has the physical server. Number two, we are providing you more than 300, 200, 300 services. You can use those services for your purposes, and then you can launch your different IT infrastructure elements. And what you need to do, you need to pay for usage. The model says pay for usage. It's like Uber model, right? So you are using somebody's infrastructure and somebody's services, and you're just paying for how much time you are using it. They have their own pricing structure. And this made the whole revolution in IT industry. Nowadays, as there are a lot of companies, especially we can take some example, Amazon.com. Amazon.com is an e-commerce website which is running on AWS cloud. Netflix running on AWS cloud. Disney Hotstar running on AWS cloud. A lot of customers available. Nowadays, all startups, whatever startups are coming up, they want to grow themselves rapidly, fast. I think cloud is something which is the best option. And the main thing is that AWS is expert in providing of infrastructure scaling, monitoring, security, everything from their own way. So your focus is only on your business part. You don't need to worry about its IT infrastructure or anything else. And that is what this became very attractive option. And it is very easy. What people do is that people create account. Okay. So this is the AWS account. Can you see my screen? I have opened a couple of services here. Analytics, application integration, blockchain, business application. Can you see these words? Thank you. So if I click on analytics, now analytics has multiple services. Athena, clean rooms, cloud search, data exchange, pipeline, data zone, EMR, entity resolution, FinSpace, Glue data brew, Kinesis data firehose. Likewise, you go to application integration, you see blockchain, you see business applications, financial management, compute category. You have app runner, batch, EC2, image builder, Beanstalk, Lambda, Lightsail, Outpost, customer enablement, database services. You have developer tools like end user computing. All these are the category, and in every category there are services. Okay, so what I was showing you is different categories on the left side, and on the right side the services. So these are all AWS services. A customer has to come, use the service, and yeah, all these things which you see on the screen, all these services are running over these data center. I can show you the picture of AWS data center. So this is official AWS website. I'm not showing something which is of different company. This is official AWS website. So this is not the actual image. This is the graphics created image. And you see some of the photos, right? So this is all physical setup, physical data center you see on the left side. This is the one of the photos of AWS data center. And similarly, like there are so many data centers available all across the world. On these data centers, your services will be running. And that is how the business will start. That is called cloud computing. And if you see, how do we define it is that it is the availability of IT resources over internet. Simple. Whenever you want, you can use those resources. You want it at 12 o'clock in the night, 3 o'clock in the morning, 12 o'clock in the afternoon, whatever time you say, you go there, create the resources, you can scale, you can increase number of resources. And what you do is that you're paying for your usage. That is called very famously pay as you go pricing model. It means it is similar to Uber model. Whatever you are using, you are just paying for the usage, nothing else. You don't need to do invest, you don't need to know anything like that. That's called as cloud computing. And this is what AWS has evaluated. So I'll not waste your time here. You know that, and even in your ebooks, it will be available. Okay, the benefits we talk about is cost effective, scalable, it is elastic, it can help you to give data security, it can prevent the data loss. These are few benefits which you'll see on your screen. This will be continuously discussed in each and every lecture, right? So you will be becoming very friendly and very usual with that particular thing. Okay, so some of the customers you can see, but the list is not limited to this. There are a lot of customers. Somebody was asking me, I forgot the name of the student or the participant, and he was asking that, okay, who is the famous one or who is the one having more business? So as per the Gartner's review, AWS is the top market giant in terms of cloud provider. They have much more business, followed by Microsoft and then Google, and then Alibaba, and then IBM. I think this is what the sequence Prajwal. So AWS is leading the market as per what Gartner's survey says. So people do survey, different companies do survey, who are the market leaders in that particular sector. And Gartner is one of the companies who does that survey, very famous. And in that, they found that AWS is the market leader in terms of cloud providers. This is what I know officially. Okay. So this course has this particular path. Today we are starting with course introduction. After the break, we will do introduction to Amazon Web Services, and then we will start with compute service, network service, likewise. Okay, this way it will go. After network, we'll go to storage services. We'll get introduced to that, databases, then monitoring services, security services. Okay, so Prajwal is saying among service industry in terms of TCS, Infosys, etc., what is the preferred cloud technology? Prajwal, a lot of customers are using AWS. A lot of customers are also using Microsoft. It all depends on the project. And companies like TCS, Infosys, or any other IT company, if they are providing cloud consultation, you understand? Companies provide cloud consultation. They help the customers to create their infrastructure on cloud. So these are the middlemen. So it depends. Like some of the project might be running on AWS. Later on, after 2 years, 3 years, they migrated to Azure. It up to them, right? So they switch also. It's like you have, let's say, Geo SIM card, and then tomorrow you are using Airtel also. Maybe your one SIM is Airtel, other is Geo. So they have huge business, right? So I will not be able to tell you what TCS is using, what Infosys is using. The reason is they have a lot of projects. Some projects might be using run on AWS, some are on Microsoft. But if you want to know at larger scale who is having more business, so that's why I told you the ranking, right? Okay. So after this course, what are the outcomes we are expecting? All of you will be able to explain the terminologies and concept. You know how to use the account. You will get introduced with services like identity and access management or compute service, database service. This is what we are expecting from you, right? Okay, so this is something which I have already explained, so I'll just skip that part. And now we will be starting with introduction to AWS services. Okay. Now there is a question from Jamil. Jamil says, does all the cloud providers has the same cost or different? That's a good question. It will never happen that everybody charge you same, right? Because it's not only single cost. There are different services, Jamil, and for every service, different cost structure is there. So cost will be little different, right? How they compare the cost is like they can estimate the project cost in AWS, in Azure, in GCP, and accordingly they will see different differences between the cost, Jamil Basha, right? So it will never happen that everybody is providing everything at same price. That would be a little different. All right, so it is almost 1 hour 45 minutes we have spent. This is the time which is we are in the middle of the session. We have 4 hours of session, so almost 2 hours are going to finish. During the middle of the session, what I do is I take a poll, and you have two questions on your screen now. Number one, how are you doing? How is the session so far? And number two is rating. So how are you doing is what you can say. Okay, if you are okay, you can say I am great. You are right on the target, or otherwise you have other two options. In rating, 0 means worst, 10 means best. Okay, so you can give a rating accordingly. I can see question from Priyadarshini. In a single project, can we have some services of AWS and some from Azure? Technically, you can try to do that, but Priyadarshini, generally, we use one cloud provider for one project. That makes it easy for compatibility, Priyadarshini. I hope I have done resolving your doubt. And then we have Mohammad Imtiaz. He's asking how to select cloud provider. Well, see, generally what happens if you are a solution architect person, Mohammad Imtiaz, then you will be explaining to the clients what are the benefits of different cloud providers. And then you will compare cost and benefits. And accordingly, whatever client will tell you, like, see, I am impressed with all the facilities, the benefits that AWS is giving, and the cost is also effective. So I think we can go with AWS. However, if you can run the same project, you can do the same project on AWS, on the Azure or GCP. All are providing almost same services. So they are the competitors of each other. You understand? I mean, if you want, you can take a cellular SIM card from Geo, from Airtel, or from VI also, right? Because all are giving the same thing. It's just that what is the recommendation from the solution architect? What is the recommendation from the consultation company? And also the cost is also important factor in there. These are the few things that we choose while choosing the cloud provider. Okay, Oscar says, what about the assistance? How this is verified? In the main page of the course, I could see there is not progress in my live session. Thank you. You are asking about that problem that we had in the initially, the self-learning part? Mr. Oscar? No, what you are asking is like Assistance, how this is verified in the main page of the course. I could see there is no progress in my live session. What do you want to see on your live session? You want to see recordings, Oscar? Are you expecting recording to be shown here on your live session part, or self-learning videos? What are you asking right now? Okay, he's not able to answer. Prajwal says, Rajendra sir, does cost play an important role as well? Yes, cost is also important because these are big projects and cost is also important. Oscar says, I want to see that 30% of increase. But in what? I don't understand what 30% increase you want me to show you. Can you please help me to understand what 35% increase is? What the progress is tracked? Okay, the progress you're talking. Okay, so Oscar, can you please try to see the progress maybe after the session is over? Maybe tomorrow it will be calculated. The session is still going on. Don't worry. Your attendance is tracked. Okay, so you'll be able to get that after the session is over. Okay, so team, shall we go for a break? We take a break of 20 minutes. Thank you, Oscar. Thank you, Anil. Okay, shall we go for a break, team? Yes, Prajwal, sir. Thank you. All right, so how long? It's 20 minutes. So let's have a 20 minutes break. Yes, Prajwal, before I go for a break, please ask the question, Prajwal. Is cost a big concern or the service? Cost as well as performance, both things are required, Prajwal, right? Suppose you purchase a car, you just don't see the cost of the car, you see the performance also. And it is not saying that Azure is preferred than AWS. That is a wrong observation from my side, Prajwal. It is like, this is their market, their marketing, how do they do marketing, and how do they convince the people. But you cannot conclude that somebody is preferred on other one, right? So it's up to their experiences, their expertise in the team. Okay, so let's come back after 20 minutes. Thank you very much. And let's have a 20 minutes break. Okay, Anjan says how we can provide our example, cloud is cost effective compared to on-prem infrastructure. How can we provide or give an example that cloud is cost effective compared to on-premise? Okay, so I will answer that, Anjan, after the break. Is that okay? Because some few things need to be explained for that. Thank you. Okay, in the program, will GCP will cover? I don't think GCP is there. Can you all please confirm? Is GCP option is available at your site? GCP is an optional self-service module. Yeah. Okay, fine. Okay, Saurabh is asking, is there any resolution with self-learning videos under the tab? Okay, so Saurabh, I'll take the feedback from the faculty. And Shiv Kumar says, you said GCP. Kumar, can you try to see, is there GCP available on your course? Here. And I did not say what I said about GCP. It is in electives, I think. Right? In electives, I think you will be able to see a lot of electives are there. I think you should talk with the sales guy. I'm not a right person. You talk with the salesperson who have introduced or got you here in this training, right? I'm teaching you AWS. I think I'll be able to help you with AWS part. Thank you. Okay, shall we declare a break, team? Thank you. All right, welcome back, team. Can you all confirm if you are there after the break? Are you back after the break? Okay. Thank you. So now we will continue. And what are the things that we are going to see is we are now going into one by one things, right? So first we will start with what is called as AWS Global Infrastructure. So first we will understand how does AWS Global Infrastructure is spread all across the world, and then we'll start introducing with different AWS services. So what is AWS Global Infrastructure? We will be talking about physical infrastructure of AWS that is spread. Now, it all starts with the concept of data center. So what is data center? It is a building, and in that building, you can have multiple servers placed in the racks, and that is called as a single data center. I have shown you the diagram, the pictures of that on Google. So this is a single data center, let's say. In that single data center, there will be multiple hardware servers provided by internet, electricity, physical security, surveillance cameras, all these setups are there. And as such, there are thousands of data centers of AWS are available. Now, on this data center, the actual physical server is there. So this data center is a building, and in that data center is basically you see a different actual server on which services will run. As such, there are many data centers available. Those data centers are created in quantity in a particular place in the particular country called as region. So suppose this circle is indicating something called as region. Now, what is region? Region is the AWS presence in that country. For example, all the circles that you see, these are all called as regions. Now, in India, we have Hyderabad, Mumbai. These are regions. Now, in Africa, we have Cape Town. This is also a region. In America, we have Canada. We have this Oregon, Northern California. These are all called as regions. These regions indicate AWS presence in that particular country. And what region consists of? So definitely region consists of many data center. So single data center is single building. So there will be multiple buildings available. And when these multiple buildings are there inside a region, they are grouped together in a particular group. So this is the first group. This is the another second group. Suppose this is the third group. So I'm taking example of three groups. These blue color three groups are called as availability zone. In short, it is also called as AZ. That is a short form. So what is meant by availability zone and what is that? So availability zone is a group of data center. Now I'm actually writing the data centers inside the availability zone. So suppose these are representing the buildings, the data centers. So here we am showing some data centers here, some data centers here, some data center here. So what they do inside the region, they create groups of data center. So availability zone is basically a group of data center, right? AZ is a group of data centers. Am I correct? And multiple AZs combined together as region. So region consists of multiple AZs. Do you understand the relationship? Data center is a building. Availability zone is a group of data center, and region is a group of availability zones. That's all. And region indicates the presence of AWS data centers in particular country. So for example, I take one example as Mumbai. Now you know that Mumbai is a region of AWS in India. Inside the Mumbai region, they have created some availability zone, which are the groups of data center. And inside the availability zone, there are definitely multiple buildings are there. So the group of buildings is called availability zone. So availability zone region are all logical concept, right? The physical thing is the data center because data center is actually a building where you have servers. Now, if you ask me about quantity, right? So first of all, how many data center is there that is not available? If you ask me, sir, how many data centers are there per AZ or per region, that is something which AWS keeps secret. Okay. So there is no answer for that because there is no official, numbers given that what is there inside it. However, availability zone numbers are made public. So these numbers are made available that generally you find it varies and minimum 3 to If you see maximum, they have reached up to 6 data centers availability zone. And this maximum number is always limitless. They can keep adding it. So if you see Northern Virginia, you will find there are 6 availability zones. In some of the availability zones, there are 4 availability zones, some of the region. If you ask about Mumbai, Mumbai has 3 availability zones. So minimum 3 would be always seen everywhere. Minimum 3, you will find it in every region. Okay. So what is the significance of region and what is the significance of this particular physical data center? So the first thing is that all these data center are nothing but the buildings where the hardware servers are there. So when you launch a particular service, okay, what is the use of understanding or learning this infrastructure part? Because if you go and use AWS service in the account and you create some resource of that, suppose you go to S3. Now, what is S3? That is not important right now. Just consider S3 as one of the AWS service. What you create with S3, a resource called as bucket. So I'm creating a bucket where I can store some files. So I created a bucket in S3. Now, on this bucket, I can upload some files. It can be video file, image file, anything else. Now you tell me, this is all running in S3 service, right or right? Correct, right? Whatever photos, videos, other files I will be uploading, they are all in S3 service. Am I right? And if you see this bucket which I created, it is created in which region? Northern Virginia, right? So I created a bucket in Northern Virginia region. And where is Northern Virginia region? You see in US, it is here, Northern Virginia on this side. Okay, this, you see that? In this Northern Virginia region, I have created S3 bucket. So whatever you create in AWS in any service must be running on this region and data center. Are you able to understand? Suppose you try to create a virtual machine. And for that purpose, you have a service called EC2. On that virtual machine, you will launch your website. So when you launch your website, okay, so they will ask you that where is your virtual machine running, on which AZ. So suppose I choose okay, I said, okay, I want to launch my machine on Mumbai region and within availability zone A, in the first availability zone. So they will immediately create a machine which is running on the first group of availability zone. So you'll be like, Raj, how a machine is running, how a virtual machine is running on multiple data center that they create multiple copies of VMs. See, multiple copies of VMs are running over different data center. And one VM, what you created is actually created in the availability zone. The problem with this architecture is when you create one machine, right? You have a dependency on this machine. Suppose your website is running, it is running on that machine, correct? And you will be like, okay, Raj, one machine is enough. I created one EC2 server, it is running my website, and that is enough for me. I say, no, that's not the good practice. What we say that we ask you to create multiple machines. Do not depend on one machine. Why? Because it is not highly available. You'll be like, what is it by high available? Okay, I give you one example. Imagine you have to go to exam tomorrow. There is some exam tomorrow and it is a written exam. So my question is, how many pens will you carry? You have to go for exam. How many pens will you carry? How many pens will you bring there? Okay, Smita says 5. Okay, a lot of people says minimum 2 I will give. Like some people will be like, okay, go with the 3 or what. Is there anybody who is go with only 1? No, nobody want to take risk because what we think that, suppose if I'm using one pen, if that broke down, it goes out of link, or if I lose that, then there should be spare. Smita, it is not called backup. We use the wrong English word in common speaking also. It is called spare. There is a difference between backup and spare. Okay. The other pen that we carry, Smita, is a spare pen. A spare pen which is used when the main pen is broken down. So now imagine, everyone, please imagine that suppose there is only one machine you have created, one resource you have created where your website is running. And if there is some internet problem, there is some physical calamities happen to that particular ability zone, all those distance areas, then will it be risky? Yes or no? Your website will be down, correct? Maybe until you recover your servers, right? So why don't you create 2 servers or 3 servers or multiple servers? I'm using a word multiple. And while creating multiple servers, what I recommend you is to create those servers in different availability zone. Now, please, I'm using a very important sentence. Create multiple servers in multiple availability zone. Multiple availability zone. Why? Because I told you, okay, create 2 machine, 3 machine, some quantity I told you. So is it like I'm asking you to create 2 machine in one AZ? No. When you create 2 machine, try to create it in multiple availability zone. And why? Why multiple availability zone? Because that reduces the risk. Now you see that I have created 2 virtual machine. One I created in AZ-A and the other I created in AZ-B. And you know that there is always a physical distance between 2 availability zones. So suppose there is some problem happen in group A, there is less chance that the same problem will be happening in group B or group C. Do you agree with me? Maybe some natural calamities are happening, flood, earthquake, something is happening. So they have made it so smartly. Some of the data center they place in group A, some of the data center in B, and some of the data center in C. So when you create machine and multiple machine, then you have to create machine in multiple availability zone. Why? So that you can achieve something called as high availability. High availability. This is the concept. The first concept that you have learned along with the global infrastructure called as high availability. Now, what is by high availability? High availability means creating an architecture, where even if any failure occurs, so in the situation when one machine is down because of XYZ reason, to still have other machine running in another availability zone, and then whether your application will be down, tell me, will it be down in that situation? There are 2 machines, so definitely one machine is down, other machine is available. Still people are able to access your website. Yes or no? Are you getting? So what the purpose here is to save your business. The end user of the website should always get the website available, and you can achieve that by creating highly available architecture. And that is the reason why AZ's concept come. Now you understand why I'm telling you the whole story, to make you understand that why there is a subgroup inside the region. Somebody can think, okay, Raj, you can have a single group called region, and in that you can have multiple data center and launch your machines in that. No, that is not the good practice. We create subgrouping inside the region just for the purpose of high availability. Okay. So similar to Mumbai region, in every region, this kind of architecture is there. You take Hyderabad region, you take Tokyo region, Sydney region, all possible, around 26 regions are available. In every region, this is same kind of architecture. I already told you about the count. If you ask me, Raj, how many DCs are there per AZ? There is no answer because AWS has kept it secret. They don't publish that count. But you know that what are the AZs are there inside the region. So generally that number is shown here. For example, if you go to Hyderabad, how many availability zones are there? Naga Varma, how many AZs are there? 3, right? Similarly, for every region, different count. If you go to Northern Virginia, around 6 AZs are there. Cape Town, 3 AZs are there. If you go to UAE, 3 AZs are there. So similarly, for every region, the count is given, right? So that count is made published. That is why we are able to see. But what is this learning from this? I have written one formula. High availability can be achieved. How can we achieve high availability in your architecture? Is that you have to create multi-AZ architecture. No problem. We will do it practically also in solution architect training. So that time also this will be revised. But this is what the global infrastructure element is. This is the inside of one region, and around 26 regions are there. And you know one thing, every region is connected to each other physically through fiber optic cables. Are you aware of this thing? Yes? Okay. So all the regions are connected to each other through fiber optic cables. And these fiber optic cables are dedicated connection between the data centers within the region. So you can see Cape Town is connected to, for example, Tel Aviv, and this way an AWS network. Yes, Prajwal, all actual physical fiber optic cables lying inside the sea. There's a water, right? Okay, so that is called as AWS private network. What is meant by AWS private network? Okay, Shiva Kumar says, how possible physical cable? If you don't trust Shiva Kumar, I think you are lacking a knowledge. If you know how internet works, have you seen any YouTube video, anything in your life, like how internet works, how actually they land the cables, how they forward the internet? No? So please watch, please try to Google that, that it is actually these data centers of AWS are physically connected through physical cables. They do that. Trust me. I mean, that is available. Yeah, the whole world, every 26, all 26 region, that is called as AWS private network. And why it is called private network? Because through that private network, data will travel. Do you get that? Through that private network, data will travel between the data centers. Okay. And Chandrapala Pathak is correct. Cables are run under the sea. Now that is not the discussion going on. Yes, submarine fiber cables. So it means that see the thing, like sometimes we get a surprise and we don't imagine that even this is possible. But that is the reality, that AWS private network exists, which connects every region physically through fiber optic cable. That is all. Okay, that is the fact that I'm teaching you. I hope this is clear to everybody. Global infrastructure. Can I get yes, no? Okay. Do you have any question on global infrastructure? We are going from fundamental view. In solution architect, we will learn something new also, right? So it is step-by-step teaching. Okay. You will come to know in couple of days. You'll understand my strategy, how I bring the topic and I try to convey the message. Okay. So Prajwal says, but why AZs are concentrated in a particular region? So what do you want then, Prajwal? You want pages to be open and become global AZs? No. The thing why this is so, Prajwal, is that when you go and create something, right? So that particular virtual machine or a server would be running in a particular area only, the group of data center, right? If its agenda is to avoid BCP thing. Okay. So Prajwal, the thing is that what is the entity that is focused here is a region. So you cannot have something, which is running within two regions or three regions at the same time. Let's say you create a virtual machine, just an example, Prajwal, and that virtual machine you want to launch. And what is the area where that you can launch? First of all, the area is region, and inside region you have to choose AZ. You cannot run or create something which is running cross region. You understand? You cannot have something which is running at the same time in Mumbai and at the same time in USA. That is something will increase a lot of cost, and that doesn't make sense. Because see, the latency matters a lot, right? So if you are creating a single and what we call it as instance, I hope you understand this word instance. It is instance is what single machine, right, of particular resource. Suppose EC2 instance or a particular other service instance are there, right? So there is one machine created. So you create and you choose a region. Suppose you choose Tokyo region. And in that Tokyo region, what I'm telling you is that they're asking you AZ. So you have chosen, okay, you said, sir, I will use AZA, no problem. But I say, Prajwal, don't rely on single machine. Try to create at least multiple machine. It is up to you whether how much traffic is there. And practically speaking, nobody works with single machine. Okay, people try to create highly available architecture. So they create multiple machine. So I'm saying you that if you want to create multiple machine, why can't you create it in different availability zone? That is the strategy I'm teaching you, that there are multiple availability zone available. So what I'm saying that don't create all the machine in single AZ. Try to create machines in separate availability zone. Then there is a chance that two machine will have a distance between them, which will reduce the significant impact especially in natural calamity situation, or in, for example, in the situation where you have uh, internet issue, electricity issue, or software related issue. Okay. Saurav is saying, my question is that if Mumbai or Tokyo is one region and we select multiple AGs from the same region, how come it solves the purpose of high availability in case of natural calamity? Okay, so Saurav, multiple AGs are far from each other. When you look at Mumbai region, just an example, it's not that there is one ground and they have created DCs there. Mumbai region indicates group of AGs in that particular area. So you consider, suppose, the map of India like this, and if I zoom, suppose this area is dedicated as Mumbai region. So they keep distance between three AZs. There is a distance between two. It is around 100 kilometers, 100 miles, 60 kilometers. And why it is not going to see? Because any generally natural calamities happen, that happens within the span of 50 kilometers, 40 kilometers, 30 kilometers. It's not more than that. So that is why they are very smartly kept the distance between the two AZs. And that is how, if something bad happens to this, it is not going to impact other. Now, somebody can think that, okay, so Mr. Raj, it may happen that the whole area of that particular country is destroyed, right? Probably some bad thing happened at very larger scale. Now, you must have seen that war situation happens. So many things that happen. In that situation, there are different strategies. Today is not the right day to explain that, but I'll give you hints. Okay. In that situation, if something you are thinking about region level failure, you say that, okay, Raj, we agree AZ is good for high availability, but AZs are giving high availability at within single region. But what if you want to have global high availability? Don't you think like that? Sir, we would like to have global high availability. What does it mean? It means if the whole region is destroyed, I had three machines, all were in three availability zone inside Mumbai region, but the whole region is destroyed. The whole thing like that happened. Then there are some strategies that we teach you, which are called as backups. We expect you to create backups of the resources in another region. Suppose there are few machines you created, and we ask you to take the backup of those machines in, let's say, Tokyo region. So your main infrastructure is in Mumbai, and the backup you have taken Tokyo. Or you can create same setup, which is called as disaster recovery site, DR site. Have you heard of this word? Disaster recovery site means whatever architecture you created, let's say in Mumbai region, same architecture you will create in Tokyo region with less infrastructure. And when there is a problem at Mumbai region, you immediately have another site which can switch over. So there are multiple strategies, and during the course, we'll discuss that as well. But I think the question that was being asked, that why the AZs are stick inside the region only, I think I have answered that. Still, if you have any counter question, you can respond me accordingly. Or if it is cleared, please respond accordingly. Especially those who asked the question, I forgot the name. Okay, so not regarding AZs is clear. So Prajwal, what is your question about AZ? Can you re-ask? This is the diagram in front of you. What's your question? Can you re-ask? This is so that to understand it even much better. Does AZ setup depend on markets? How? Which market? An AZ setup is not done by me or you or any customer. It is actually the physical infrastructure is there. Okay, so you mean that whether number of AZs depend on whether there is a demand more. Of course, if more demand is there, Prajwal, then more data center would be required. Yes or no? For example, you can see Northern Virginia is one of the first region of AWS, and they have more business into that, and they have 6 availability zones. Why? Because more data center were created in there. Okay. And he says, and the regional AZs are dedicated to that country. Have you learned Azure before coming to AWS? Have you learned any other cloud? No. Okay. So, because the word that you're using is regional AZ. Every AZ is regional AZ only, right? There is no other, I mean, there is no other type of AZ. There is only one AZ. I mean, AZ is only the regional component. And you are saying that regional AZs are dedicated to that country. It's not dedicated to the country, it's dedicated to the region. So let's say United States is the country, and there are around 8 regions available. So Northern Virginia is one of the region, right? Okay. So Shiva Kumar says AZ depends on S3 and security. What is meant by S3? Shivakumar. And who told you that AZ depends on S3? What is meant by S3? S3 is the name of the service. Okay, Anil says you will be like, okay, there are a lot of regions available. So how to choose the region? Okay, I'll answer you. Fine. So generally, how you will start with Prajwal, right? You will start with choosing a service. For example, you go to EC2. Suppose you want to create virtual server. This is most commonly used service. Okay, I'll start with that service. When you start with this service, you go to create a particular machine inside that so that you can launch your website. So when you do that, I'll show you a setup. They ask you network settings. In the network setting, what they are asking, VPC and subnet. Now, what is this? I'll not teach you that, but I'll tell you one thing. What is the region is being chosen, Prajwal? You look at my screen and tell me what is the region being selected? Virginia. Am I right? I could choose Ohio, Northern California as per my choice. I can switch between any region, right? So right now, my selected region is Northern Virginia. Means when I create EC2 machine, I can create inside the region. So when I am creating it inside the region, they ask me some questions called as subnet. Here I can choose the availability zone. Do you see the options? Availability zone US East 1E, then this one is US East 1F. So there are letters A, B, C, D, E, F. You see A, then D, C, B, F, E. I'm choosing a particular AZ. Let's say I have chosen AZA. So when I choose this setting, then I'm giving my choice. I'm telling to AWS that, look, my machine should be created in a particular region and a particular AZ. And that is my single machine being created. Then when I create the second machine, I will again tell which region and which AZ it should be created. So AZ is the sub part inside the region. Is it clear now? Still, if you have question, please re-ask. Got it. Okay, fine. And slowly in the course of practical, you will come to realize again. Now, Fasika Kumar is asking, is subnet similar to with AZ? It is not similar with AZ, Fasika. Subnet can help you to choose a particular AZ in some way, and you will learn it in networking part, probably next week or tomorrow. How the time comes, I don't know. But maybe probably tomorrow or next Saturday, you will come to know. Subnet will help us to choose the AZ. That is what I can tell you in terms of EC2. But there are different things, and technically speaking, there are two different concepts. Okay. But just for layman language, I wanted to explain the concept to tell Prajwal that AZ is inside the region, and that is how it works. All right. So is it all clear? You still have any question? Please ask. But remember this formula, high availability is equals to multi-AZ architecture, because when I'm going to launch the resource, right, at that time, I'm going to follow that particular strategy. All right. So we are going to create a network. In that, we are going to create subnets, and these subnets will try to launch in multiple availability zone. So for example, I created this network subnet in AZA, and this is in AZB. Minimum 2, right? So you can have 3, 4 up to your choice. So when you launch your machine, try to launch in multiple availability zone. In this example, how many availability zones you see? How many I have considered? How many AZs I have considered? 2. So minimum 2 is enough for multi-AZ environment? Yes or no? Minimum 2 is enough or not? Minimum 2 is okay, right? You can have 3, 4, whatever is the capacity based on that. So my region is Northern Virginia, and I have considered 2 AZs. And look at this, I'm launching 3 machines. So 2 machine I have launched in AZA and 1 machine I have launched in AZB. That is called as multi-AZ environment or multi-AZ architecture. Do you understand? And what will happen? From the public internet, when people will try to access your website or application, right? They will be like their request, and it is not single customer. Thousands, millions of customer will try to hit the website. So everybody's request will come. Somebody's request will come to here, come here. So this way the request will come. So let's say if there is some problem with one of the AZs, and the server is not available, but at least other AZ is available, which is healthy because there is a distance between the two. They are distance from each other. However, they are in the same region, but they are having distance between them. So the other machines which are running in healthy AZ, of course, you have a good chance that your website is still running. So my question is, your customers will face downtime or not? Will they face any downtime of website? No, that is the whole idea, right? Somebody says yes. Let me ask Chandra Patak, how do you think they will face downtime? Do you think they will face any downtime? Downtime means the website is not available. All right. So let's go. Jamil says, if both the edges doesn't work, then they will face. Definitely. Chandra Patak says intermittently while switching from one AZ to other. Nobody is switching from there. See, what happens is there is some service called load balancer, and that actually receives all requests. So the moment it realizes this machine is not working, it doesn't stop request to it. It will forward all the requests to that remaining machines. They are called, they're like routed to good machines. We will learn that tomorrow, how that happens. But this is what the significance of the whole discussion. My point here is to tell you that uh, the diagram which I shown you, that there is a region and there are total 26 regions. And within the region, you will have multiple availability zone. And in within the multiple availability zone, you will have data center. So whenever you launch the resources, try to launch it in multiple availability zones. So first of all, launch multiple resources and try to launch them in multiple availability zones. That is what the thing is. And if you think that Chandra Patak, that I was connected to a particular machine, I am a client, I was connected to a particular machine which was running on a particular AZ, that AZ got down. If when that AZ got disconnected, it doesn't disconnected suddenly, right? So every machine has some period where they can let that last request, whatever last request was there, which was captured, that last request will be handled very easily. That they will allow it to complete. So there will be no loss. Or sometimes in a very bad luck, if you have still bad luck, you refresh and you get everything back again. Simple. People do refresh if something is hanged. Okay, so Rishi says, will load balancer can switch to another region if both AZs are down? This is the higher level question, Rishi. Today is not the right time to teach you that. Tomorrow we will learn that. Okay. Raju says, is load balancer also dedicated service? I'm sorry, Raju. We will do it on tomorrow. That is tomorrow's topic. Because there are other friends of us who are new to cloud. Probably you guys have very well known about some services that you are directly asking question. But other people are new and we will go step by step. Okay. So that was the whole agenda so far. Still, if you have any question, please ask. Shubhamay says, in Northern Virginia, it is showing 6 AZs, 14 A local zone, 8 available zone. What is the difference between all three? AZ is clear. Okay, rest of the things we will discuss in solution architect training, Shubhamay. All right, fine. So what I will do is I'll take help of your introduction slide of introduction to AWS. And like we are discussing about servers and the different infrastructure element about let me show you if there is some slide about that. Yes, region, availability zones, all these things. And yeah, this is what I shown you actual live also. Okay, now we will see just an introduction that what are the services category, what are the services available. So generally we do uh, you know uh, we have categories of services for different purposes. Like you can see compute category, storage category, databases category. There is a category of the services which does analytics for analytics job. There is some mobile app related services. There are some networking related services, some CDN services, DNS services. And I've shown you that also. Like here in the services part, you see analytics part. So if you see analytics, there is a group of services who can help you to do analysis of the data. Uh, there is application integration, the blockchain related service. Even you have compute service. These are to run your applications, right? To run the application, you require compute service. EC2 is giving you virtual machine. However, there are other services which are important. Container services are there. There are database services. Here you can have a lot of bunch of different database services on which you can have different types of databases. And when you create a resource of this service, Prajwal. Suppose you go to RDS and you create an RDS machine, they will ask you, Prajwal, can you tell me which AZ you want to create this particular machine? And then it is your choice. You decide, you say that, okay, sir, we want to create RDS machine in Mumbai region, in AZA. You understand? You are choosing that. So if you ask me whether the services can run on all the availability zone, so first of all, forget about availability zone. Now we will discuss about regions, whether all services are available in all region. It is about the choice of region and then choice of AZ. Suppose I say a particular service runs in Mumbai. It means it can run in all AZs. Yes or no? Okay, I want answer from everyone. When I say that something is running in Tokyo, it means it can run in every AZ, right? So the question is how to choose a region, how to choose a correct region. There are so many options available. Suppose I'll give you one story. Okay. For example, this is Mr. Raj. He has cloud knowledge. Okay. He decides to create a website for his business. So then he goes and open an account and he knows that what service he has to use. Suppose he want to use EC2 service. Then he get confused. He says that, sir, whenever I go to create EC2, should choose. What is the criteria? And we recommend you 4 criteria. Some of the criteria I can show you and explain you here. Okay, so I'm showing you criteria where you can choose the region because you got confused. Mr. Raj is confused in which region I should be able to create EC2. You see, different options are available. Yes or no? I go to, let's say, RDS machine. I want to create RDS machine. I am confused. Should I create in Paris or I should create in London because I like London country much more, London city much more? Or if I go to Tokyo, is it the correct choice? How it will impact my business? Should I go with Northern California? Or I'm an Indian, so should I go with Mumbai? So to answer that, these are some criterias, and we call it as criterias to choose a correct region. That I'm going to teach you. Is it clear? So number 1 criteria is, first of all, you should be aligned with what is called as data regulations rule of your government, right? What is my data regulation rules? For example, I give you one simple example. Let's say Mr. Raj is from India and he want to start an online business where some important data of their customer, let's say, something which is related to government project, and that website is working on that particular project and he wants to launch that project on cloud. So definitely the client of Mr. Raj is like government of India, or maybe client is, let's say, from banking industry, or maybe the client is from some XYZ industry, and they say that, Raj, we have some data regulations rule, some local rule we have. And it says the country or the customer says that as per our compliance rules, as per our licenses, or as per our government rules, it is mandatory to launch your resources in our country only. So if you are launching it on cloud, make sure that your physical infrastructure should be in India only. So how many options Mr. Raj have then? He has left with 2 options, either Mumbai or Hyderabad. Correct? Of course, he has only 2 options because in India, he has only 2 things. But for example, if Raj business has no such a obligation, he has no such a rule which is applying, which is making him confused about choosing only the local or only choosing the region inside its country, then this becomes not applicable. So this is the first criteria that you have to think. You should ask yourself, to this particular website, to this particular business, whether any local rule is applicable, whether any rule related to compliance, whether any rule related to license, whether any rule related to the government. Suppose some Aadhaar card data. Aadhaar card is basically a citizen identification number in our country, India, right? So everybody has their own card number. And if government says that if your data is related to Aadhaar card, don't launch anything outside the country. Then you cannot disobey that rule, right? In that situation, your selection becomes very limited. You have only option inside India. So that is number one, right? Number two is called as latency. Latency. What is by latency? Does anybody knows? Can you write down the definition or whatever you know about latency? Latency. What is by latency? The delay in response. Okay. Now you tell me, if your customers, let's say your end customers of your website or your application, if they are in USA, like all those are US customers who are the end user of your website, where you will launch your resources. Definitely, you will try to go more and more closer. Arizona, there is no such thing called Arizona, Prajwal. Whatever US regions are there, Prajwal, again, you are confused. It's not about zone, it's region. Use the correct word. We'll try to choose US regions, right? Everything is selective based on region only. So either you will use Northern California, Northern Virginia. So you will try to use. Okay, if your customers are in Asia, if you think that, sir, my end customers of the website, suppose I'm talking about Mr. Raj. So I will try to choose the region from where the latency will be less, the delay will be less. Yes, exactly. Because the more closer the servers are, suppose your customers are in USA, your server is in Mumbai. Now you tell me, the request will travel all over down to Mumbai region, correct? And then the response will come back. So between client and server, if you try to bring less distance, definitely the delay will be also less. And that was the key factor. You have to choose the region which gives you low latency. That is the second criteria. Okay. So as long as possible, try to get the closer regions, closer to your end customer. Is this clear? Number three is cost. Now, within AWS, if you launch a machine in Mumbai, and if you launch the same machine in US, let's say Northern California, if you launch the same machine is in Cape Town, or if you launch the same machine in Tokyo, cost will be different. Do you understand? So you have to understand one thing is that cost varies region to region. Cost varies region to region. So make sure when you choose a particular region, make sure what is the cost of that particular resource that you're paying. And that is the reason why cost is also important factor in that situation. Okay. Cost is very important factor because businesses run based on cost management. And that is why you want performance at the same time you want to balance the cost. So cost is also important. So compare the cost of multiple regions. And number four, which is very natural, is something called as service availability. So you should ask yourself that in my architecture, if I want, let's say 5 services, I'll just take some alphabets for that, A, B, C, D, E. Some random 5 services are required. So I should ask myself whether that service is available in that region. Suppose I want service A, and service A is not available in, let's say, some latest region, let's say some new region, let's say Tel Aviv is there, which launched in 2023. So if that particular service is not available in Tel Aviv, do I have any option of Tel Aviv then? So it is very common sense that if you are choosing a region, make sure your services are also available. In other words, all the 300 services are not available in every region. Please note down. Whenever regions are newer, okay, the latest one, like in today's, with related to today's context, the regions which are launched in 2022 or 23, or the regions having lower business in that area, they do not have all services available. They have less services available. The regions which are very popular, which are old regions having more business, you may find all services present there. And for that purpose, there is a very good link that I'm going to share you all. It's called as AWS services availability by region. So region by region, you can see whether a particular service is available or not. Okay. So this is the link, which is of official list. the list of AWS services available by region. You can cross check. If you have option of Northern Virginia, find out whether the service that you are looking for, whether it is available or not available. You can just change the, like you are confused between Hyderabad and Cape Town. So find out Hyderabad services, whether your requirement is fulfilled. Find out Cape Town services, whether all the requirements are fulfilled. And accordingly, you can compare and see for a particular service, whether a particular region is providing that service or not providing that service. And hence, these are the 4 criteria that you can keep in mind. Whatever links that I'm sharing you can keep them in a Word file for your future preferences. These are all official links. Okay, there is nothing third party or unofficial. These are all official AWS website links. Okay, so I think now this doubt is clear to everybody that how someone can choose a region. You can keep majorly these 4 criteria in your mind. If you have any government restriction of choosing the data center in a particular country, then go there rightwise. Okay, so not every region is providing every service, Prajwal. Most region provide all services, some region provide less services. So technically speaking, it is safe to check whether that region provides that service. It happens at very low level, but you have to check that. That is what recommended thing is. Arushi Vijay has a question. Can we have one service be on one region and one service on another region, like storage in one region and EC2 is in another region? Of course, you can do that, Rushi, no problem. But you like sometimes when 2 services talk to each other, there are some requirements that they must be from same region only. So it varies. Okay, you will get with the experience when you deal with multiple services, you will realize that whether it is applicable, whether it is not applicable. Jamil says, I am an Indian user. I'm looking for some service which is not present in India region. So I need to select other region. There will be some issue. Jamil, you are not end user. Try to understand. You are a user creating a website. Let's say Raj is creating a website, but Raj is not the end user of website. It doesn't matter where Jamil is sitting. What matters is that where the users of his website are sitting, because those are the people who are going to send the request. Yes or no, Jamil? You are from India, doesn't matter. But if your customers are in USA, you will choose US region. And in US region, there are multiple options. Then compare them with respect to cost. The one which is giving you lower cost option, choose one. You have 6 options available in US region. Or suppose you're saying that, no, sir, my end customers. End customers means the people who are going to visit your website. Those end customers are in India. Then I give you 2 options. One is Mumbai and second is Hyderabad. And then you say, sir, almost latency will have no much impact because both are very close. So basically, I will compare them with the help of cost. The one which is giving me with the lower cost, I will go and create my resources in that region. Now you understand, Jamil? Okay. The confusion is with the lack of understanding between the word user and end user. It's on a service which is not available in the region. So Anil, in that situation, you don't have any option, right? I'm just answering to your comment that if something is not available in some region, we cannot have other option. Like we will try to go to next closer region. That's all we can do, right? Number 1. Number 2, coming back to Jamil's question, Jamil says, I am an Indian user. I'm looking for some service. So why you will be looking for service if you are an end user, Anil? That is why I said the question is not valid. He says that I am an Indian user. I'm looking for a service. You are not user. You are user. You are not end user. For example, Mr. Raj is here. He has his business. He created website. He is the user of cloud. He is a user of AWS, right? And there are all these participants which are attending my training who are going to visit my website. These are called end customers. You understand? So what matters is not where Raj is living. What matters is where end customers are living. Because let's say if Raj's server is here in Mumbai and the website is running here only on Mumbai region. So who is going to choose this region? It is Raj. Raj is going to choose Mumbai region to run his website. And the end customers are going to visit the website. They are going to visit the website. So where they sit is important. If they are sitting in Asia, then Mumbai can be the better option. If they are sitting in USA, then Mumbai will be the worst option. Why? Because distance is so large. Do you understand? I'm asking both Jamil as well as Anil. Jamil, what about you? Is your confusion resolved? Okay. Now the next part that is being said by Chandra, I think the terminology should be service provider and end user. Yeah, that way also you can see. But service provider is the consultant, whether it is a consultant or AWS. Service provider is AWS. It is AWS service. Raj is helping us to launch the resources. He is a customer of AWS. Raj is a customer of AWS. And these groups of people are customer of Raj business. So Raj can be Amazon.com. So Amazon.com is a customer of AWS. And we all are customer of Amazon.com. Let's say Netflix. Netflix is a customer of AWS. And we all are customer of Netflix. So what matters is where the end users are living. Shubhamoy Giri says if end users is from Mumbai region and service is not available, so what will happen? Nothing will happen. If the service is not available in Mumbai, Giri, then you choose another region which is closer. I mean, if that is not available, then what can you do? You can't do anything, right? Try to choose the next closer region. You can choose Hyderabad, you can choose China region or Japan region. Whatever is available, you have to choose from them only. And out of that, Mumbai doesn't have that service. Then there is no option of Mumbai. You go and create that resource in Hyderabad. Probably Hyderabad is the next closer one. Then we have Oscar. Oscar says, as a company, you choose where and what to serve to the users. In India and USA, you have multiple choices option. The importance that is that your availability zones have the availability in that country is like that. So the thing is like Oscar, there are two things. I'll just reiterate it. This is very small topic, but still, if you get confused, the first thing is that why I'm talking about these factors. These are practical problems that people face. If something is applicable related to data regulation, they don't have option going beyond their country. Second, performance-wise latency is important. Cost-wise, cost comparison is also important. So this is to get better performance and also related to cost. And second thing, what I talk about multi-AZ environment, Oscar, multi-AZ is for availability purposes. Okay. So for example, you have chosen, okay, sir, I have chosen Tokyo, which fulfills all criteria. After comparing all criteria, we have chosen Tokyo region for launching our server. Then there is a question comes for availability. Then I say that within Tokyo region, try to launch machines in multiple availability zone. That's all. It is that simple. AZ-A and AZ-B. So try to launch machines in multiple availability zone within that region so that you will achieve high availability. Is that clear? Okay, I have it clear. Thank you. Vaibhav says the question is same. There are a number of countries where there are no AWS services. In that case, there is no option that choosing the nearest region to that end user along the criteria listed by Rajesh sir. See, Vaibhav, the absence of service is very less. Don't think it's so, don't take it so overloaded on your head. And this is for everyone. When I say service availability, it is a very rare situation that you will miss some service in some region. Almost in most of the region, you will find all services. Look at my sentence. Most of the region, you will find all services. This is very rarely happen that you are not able to get some service in some region. That is very rare. But we are telling you because sometimes if you are unlucky, you must be aware of this thing. But the ratio is very less. So don't worry and don't think so much about most of the time you will find all services in all regions. That is what my final conclusion on this particular discussion. I hope you got the sense of it, right? Now, what Vaibhav is saying that if some services are not there in some regions, then what is the next closest possible? This kind of situation will never come practically. Vaibhav, you are thinking what is all you are thinking is hypothetically. You think that there are 10 regions where I don't see the service, which are the closer one. Then there will be latency problem. No, these kind of things never happen. This is very rare situation that if a service is not available in that region. Next from Priyadarshini, she says, Priyadarshini says, due to data regulation, we cannot choose a region outside India. Let's say just an example, but at the same time, the service is not available in this scenario. Is it possible? But India doesn't have only Mumbai option. India also have Hyderabad option. That's all. Simple. Priyadarshini, you have multiple regions available in a country, and if that service is not available, you can take optional service in that situation. For example, for databases, there are multiple services. If one service is not available, you can choose another one. Is it clear, Priyadarshini? Prajwal says, "Do all startups use cloud?" Nobody knows this question in the world. Nobody will be able to answer you, Prajwal, because this is very hypothetical question. Whether all startups use cloud, who knows that? I have to deal with somebody has to review this in the whole world. Millions of startups are there. We have to talk to every startup and ask them whether you are running on cloud or not. Okay. But if you ask in general, then in that situation, a lot of startups use cloud because they don't have much money to invest into and maintain into infrastructure, and they get a lot of benefits, right? Fine. So that is, I think it's a great discussion. I like it. You guys are taking interest, asking question. That's really wonderful. I hope you are clarified with all the discussions, and timely, slow by one, day by day, when will switch to next topics, you will understand it even clearly. A lot of times your doubts get resolved automatically, because this is day one. You are getting introduced very first time. Then day two, you will learn something new. Then your perception will become very clear. Right? Okay. So let us see the categories I have shown you and what are the services are there. For example, if you talk about AWS Compute Services. Compute Services are such services where you can run the application. Okay. Some kind of application, let's say some website application, any kind of application you can run basically, which is related to computation. It does some job. For example, you can see the name of the services: EC2, ECS, Lambda, Elastic Beanstalk, Lightsail. There's some range of AWS compute services. And we are going to learn basically as a solution architect that how these services are useful with different use cases or different applications. And choosing the right service for right purpose is what my training intention is. You will be able to understand that in what situation which service to be used. Okay. Similarly, we have storage services. Now, what is my storage? So suppose I'm showing you one architecture. Don't go in very detail, but just to make you understand, suppose I create a 3-tier or 2-tier architecture. Now, in the 2-tier architecture, tier 1 will be running your websites, and tier 2 will be running your databases. And then there will be communication between website and database. Your customers, which are in public internet, they will try to visit your websites. Now, for better purpose, for better high availability, you launch your website on 2 machines or 3 machines, and you try to launch them in multiple availability zone. You use load balancer. That load balancer helps you to distribute the traffic to multiple machines, and this is the way it works. So that is why different categories are there. Now you have compute machine like EC2 to run your website. You have databases like RDS to run your database. You have storage services. Now storage is to store certain files. So of course we have storage services such as we have Glacier, storage gateways to transfer the storage data, Snowball again to transfer the data, S3 is there, EBS is there. There are database services like relational, non-relational, uh, RDS, Aurora, Redshift, TimeStream, QLDB, DocumentDB. These are all multiple services. Now, the main important thing is like when you start with the project, you have to deal with migration work, because your customers might be running everything on their on-premise and they want to migrate from on-premise infrastructure to AWS. Am I right? They want to migrate from on-premise infrastructure to AWS. And that process of shifting all the infrastructure to AWS is called migration. So migration will carry the migration of resources like your virtual machine or databases or storage devices, your websites, your database servers, uh, everything you want to migrate. And how does it do that? It has migration services. So whenever I will teach you databases, I'll teach you database migration service. Whenever I'll teach you storage, I'll teach you storage or data migration service. Now that time we will get to know that what are those services available. Then we have network services. So if you are new to IT, you must know that while launching the resources, you must require a virtual network created. So to create the network, we have to learn and understand network services. So it is required to create architecture, a network architecture within your account. And for that purpose, network services are there. Then you have content delivery for lowering down latency for global customers. Then you have other tools like called as monitoring tools. Now these monitoring tools gives you information about how the services are working. You have automated tools also to create automated infrastructure using CloudFormation. You can see the list, right? CloudTrail for audit purpose, config for configuration. These are some services like related to security. So security services so much. For example, you want to do encryption, there is a KMS service, key migration, key management service, or for security there is a shield service. Now shield is for shielding your infrastructure from DDoS attacks. We have WAP service. So we will get introduced with all those services one by one in every module. There is a messaging service, notification services, IoT services, blockchain services. So all those different services are there in your introductory part, right? So these are very less which are shown on the slide, but actually you see all the categories, you will be able to see much better in your lab itself. These are the actual categories which are available at your site. So our agenda will be from next module to focus on particular services, and I will take one service, will teach you about the importance and usage of that service, and then we'll move to one by one each and every service. Okay. Now we have some comment from Prajwal. He says, with respect to data, is it always straightforward or it needed some handling from traditional database to cloud service? So we'll learn it specifically in migration topic, Prajwal. Migration being supported from traditional database to cloud databases also. And you understand, Prajwal, that whenever cloud services are created, they must be compatible. Let's say I give you one example, and this is for everyone. Suppose you have a traditional server with MySQL database. Okay. I tell you what you can do with cloud if you want to migrate. So if you have MySQL database and traditional servers, you can go with RDS. In RDS, when you create, you can choose MySQL option. You see the MySQL option here. Can you see that? You choose the MySQL option and you create the MySQL server at your site, at cloud site. So on the left side, if you have traditional MySQL server, on the right side, you have AWS MySQL server, which is both are supporting MySQL, and you can easily migrate from one place to another place. So the cloud has been made such a way that it can be made compatible so that on-premises services or application can be easily migrated to AWS cloud. Okay. So Chandra Patak says, do we complete full practice for database migration? What does this question mean, Chandra? Do we complete full practice for migration? You mean that in our training, are we going to learn how to migrate the databases? No, that is not a part of solution architect training. And even solution architect is the further training. Right now we are learning fundamental. It has nothing to do with how to do migration. It is related to what is by migration that I have told you. You must have understood that. But how to practically do migration is not a scope of this training. Migration itself is the part of some another training. Chandra Patak. All right. However, in solution architect, I'll make you introduce with AWS service called as DMS, and DMS stands for database migration service. So I'll teach you how it works. But the practice word that you use is like practically doing the migration is not a part of this training. All right. Okay. Any other question, team? Jamil says AWS has more services well compared to other cloud service providers, right? No, it is not like that, Jamil. A lot of cloud providers have a lot of services. There's no such comparison whether who has more, who has less. Oscar says, but there is a lective, I think, no, Raj, EC, AWS database migration. There is a lecture, I think. There's a lecture in, okay, so I said that database migration is the migration concept that we have in fundamental. In solution architect, we learn how it works, but there's no practical migration happens in this training. It is not a part of AWS solution architect training. It is not a part of fundamental training, Chandra Patak. You have to talk to sales team in order to understand which training course provides migration practical. So please connect with the sales team and ask them which course will provide practical of migration from on-premise data center to AWS. All right. So what is the takeaway from today's session? What I generally do, you know what, is that I generally give a conclusion by the end of the day, that what we had learned today. So conclusion that I could make today is that we learned what is in by cloud computing. We learned what is in by AWS cloud. We got introduced with AWS services. We got introduced with AWS console, or we can say AWS account. We got introduced with the AWS global infrastructure. And in that specifically, we got introduced with a lot of concepts such as I can say data center, and then availability zone. Then we have learned high availability. Then we have learned what is meant by region. Then we have learned multi-AZ environment architecture. That is what I have drawn the diagram of. And finally, we have learned criteria to choose correct region. Okay, so criteria to choose correct region is what something that we have learned. So this is a little summary wherein you will be able to understand what we had focused today. So today's agenda is all about, we are going to start with compute services of AWS, and then we'll talk about networking services. All right. So these are the two categories of services that we will try to cover. And for that, I will take one by one approach. Yesterday, what we have seen, that is also I'm going to recap. Yesterday, we started with basically, all right. So there are questions. Let me stop now. Oscar says, Rajendra, where we go to see what you are teaching today? Uh, so basically, Oscar, you have, self-learning this material. I think I can show you. You can see my screen. Foundation preparatory module. Uh, Basically, I always show you the agenda every day, what we are going to learn. Also, I tell the agenda for next day, what are the things that we are going to see. Otherwise, you have some self-learning materials. If I can have reference material. If you see the reference material option here, I hope this is visible to everyone. In reference material, you have ebooks. You can download the ebooks that can be your study material. Okay. And every day I'm going to tell you the agenda. Agenda is actually the plan for that day. So today's agenda is discussion about compute services and networking services of AWS, right? So what we are learning is the fundamental of cloud training. Fundamental of cloud. Now in fundamental of cloud, we are getting introduced with different categories of services. Today we are starting with compute and networking. Next week we will have remaining categories, and accordingly we have certain syllabus that we will complete. After that, after next week, then we'll start with solution architect. Okay, so I am sharing. Okay, so Rushi says, do you have to submit project on 21st Jan? Uh, about project submission, I think you will be given 2-3 days more, or maybe probably 1 week. But Rushi, we can confirm it from the faculty. So Jagat, if you can hear us, Rushi has asked, what is the project submission date? I think that would be around 1 week, as per my information, Rushi. But we will ask the same question to uh, Mr. Jagat, who is our LSM today.
Uh, yes, Rajendra. So usually the projects when deadline for the learners is 7 days from the last live class. So say Cloud Fundamentals, this particular course ends tomorrow. Within the next 7 days, they'll have to submit the project. So that is the deadline. So I'm just taking today's class as an option, like as an example. So your class pretty much gets over next week, right? So 7 days from the next Sunday. Yes.
So if we calculate like 21st is the last day, so probably till 27, we are expecting you to submit the project of that time. Got it. Thank you. Any other question, team, before I start it? Okay, so Jamil says, I have one doubt. If any availability zones or region, if it is down, what kind of errors we will face or we will see? All right, fine. So Jamil, basically, suppose you are running, let's say some application, okay? And that application is running on a particular service, let's say EC2. Okay. So when that application is running and your customers are trying to access the application, in that situation, that particular machine, that website will not be reachable. That will be first observation, Jamil, that if any problem happens and this is down, there's a downtime that we are facing, maybe at AZ level or regional level. So that machine would not be uh, accessible, right? So this end user will not be able to get response from the website. Number two, we are going to learn services like CloudWatch. I'm giving you a reference. CloudWatch is basically a monitoring service. So these type of service who can monitor different resources, that service would also give us, some statistics regarding the machine's information. Let's say for EC2, it is, for example, CPU utilization. So how much CPU is being utilized right now? Imagine if the machine is down. In that situation, CloudWatch won't be able to collect the information from this machine, monitoring data. And that's the reason we will again be able to understand that this machine is down. Again, today I'm going to teach you Elastic Load Balancer service. Elastic Load Balancer service has a feature called as health check. That ELB load balancer continuously check the health of the EC2. And if it doesn't get response, then it can declare that EC2 as unhealthy. So there are different ways we can understand if this is all about if the machine is responding or not responding, Jamil. I hope I have resolved your doubt. Anil says, can we take note of questions and answer these towards the end of the section? Okay, that's also good. Okay, so I want all of you to tell me what are the strategies you want me to follow. I suggested one strategy that I will first of all teach you something and then we'll do Q&A. Is that fine? Okay, because see, a lot of people are new. Some of the people who have already learned cloud, right? And I saw one comment also that writing the question on chat box is not good. I think as far as I know, like I understand your question which you have written. I try to answer them as much as possible. If you still think that my answer is not appropriate, you can tell me in the chat box again that see whatever you have answered, I could not understand. Then I can use some different approach. Okay. So some participants are telling me that we should take Q&A at the end of the day. Okay. So shall we follow this? And should I start teaching with all of permissions? Great. Thank you. So the recap is like what we had learned yesterday. We had learned AWS Global Infrastructure, and in that global infrastructure, and before that, we have learned also cloud computing. What is by cloud computing? And then we had also seen small topics in global infrastructure like availability zone, data center, region, AWS private network. Okay. Apart from that, we have learned what is the concept of high availability and how we can achieve by using multi-AZ feature. So if we try to create an architecture which is multi-AZ architecture, then our system will be highly available. In case of failure, other servers are always available. Apart from that, we got introduced with, the AWS account. Then we have seen different ways to interact AWS services. So the three ways, if you could recall, the first was AWS console, second was CLI, third was SDK. After that, we have seen introduction of different categories of services, right? So I shown you different list of services which are available on our console, right? So this was roughly the recap that we had seen. And today we are going to start with service by service. We'll get introduced with compute services, then network services, and I'll try to teach you the fundamentals of that. I have seen one comment yesterday that from day one I want to see practical. I just want to clarify this thing that you see there is an approach for particular training, right? These 4 days are fundamental training, and in fundamental training you will find most theory and less practical because this is the introductory part. After this 4 days training is over and we start with solution architect, then you will find let's say if we talk about 50% theory, then we will do 50% practical. So the practical portion will also increase. Okay. For example, if I keep doing practical for every topic, then this training will be converted into solution architect training. And actually, these are two separate trainings. So now I'm doing fundamental one, and that approach will help me. You have to, I think, align with this. Okay. And just see a couple of lectures, you will realize what I'm trying to say, because this is I'm telling you from my experience with previous batches. All right. Okay, let's start. So now yesterday we know the physical infrastructure part. Now we'll talk about how can I start with the projects of AWS Cloud and what are the different categories of services play their important roles in this, right? So the first category we are starting with compute services. The word compute indicates computation. Now what is meant by computation? Computation means doing some code execution. So when we see program, now program is what is basically the way we can implement our algorithm in the form of some programming language, and that program when executes, it helps us to do some task, right? That basically is called as software code program. And now compute service is a service which will help us to run the application. Applications are nothing but software. And for any project, you will be finding, okay, there will be some applications and those applications needs to run on servers. But there is no single server available. See, for different purposes, AWS has created different services. Compute services are specially created to run your main application, like your web application or the applications which are a front-end application, you can say. In compute services, the virtual machine that is being provided by the service called as EC2. So we will first of all start with Elastic Compute Cloud. That is a long form of EC2. And what this service is, it gives you a virtual machine. So if you don't understand what is virtual machine is a kind of e-machine, we can say. So virtualization is a technique wherein we can optimize our hardwares, right? So basically, the global infrastructure, the data center has hardware server. And that hardware server will have its own OS. On top of that, you will be having a hypervisor. This is what the architecture inside the data centers. So AWS uses, and in fact, the cloud uses virtualization technology. So what this hypervisor or virtualizer does, it helps us to create multiple virtual machines which can run over single hardware server. So what is now below this line is the hardware infrastructure. And what is above is all E, means it is all related to services. Now I'm talking about EC2 service. So EC2 service basically gives you a plain virtual machine on top of which you can install your application. That is called as deployment. You can deploy your application and that machine will continuously run and that will run your application. So now imagine just a hypothetical example. There is the one hardware server in front of you, which is present in the data center. That hardware server will have its own OS. It will have hypervisor. Hypervisor basically, you can call it as a software that helps us to create virtual slots. So AWS uses their own virtualizer, a hypervisor software, and that will help to create multiple slots for creating VMs. Now what you see, 1, 2, 3, just an example I show you 3 slots. Nobody knows how many slots that particular single hardware supports. So when these 1, 2, 3 slots are available, now let's say Mr. Raj from his account has created one virtual machine. This is for Mr. Raj. Then Mr. Jamil, he is also AWS client. He has his own account. Whatever machine he creates, this is his machine. For example, there is Mr. Prajwal, his machine. So what you see is that this is customer X, this is customer Y, this is customer Z. Multiple customers create machines, use the services, create the resources on shared hardware. And that is how the cloud business works, right? So coming back, what you can do with EC2 is that you can create your own virtual machine and start deploying your application. So as a solution architect, when you try designing your project, you basically, how you start generally is what I'm going to show you now. So first you create a network. For network, a service is used called as VPC, which we will learn after the break today. Okay. Inside that, if you are following multi-AZ approach, if you remember yesterday I taught you that this network is actually a regional level thing. And within the region, multiple availability zones are available. So what we do, we generally follow multi-AZ approach. So when we follow multi-AZ approach, then in our mind, what we think is that at least try to use 2 or 3 multiple availability zone. In this diagram, I'm showing you 3 availability zone. Number 1, number 2, number 3. Suppose this is AZ alphabet A, this is alphabet B, and this is alphabet C. Now, when we see 3 availability zone and we have decided to launch our resources inside this, we start with, launching subnets in different availability zone. Now, what is this subnet that I'm going to teach you in networking part? This is all networking topics, but I'm giving you the whole idea, how we are going to design the architecture and where the different services play their role. So we will create VPC, we will create subnets. VPC is regional level, subnets are AZ level. And within those subnets, we are going to launch our virtual machine. So basically, if you want to start with launching your own web application, a website which customers are going to face, they are going to visit that website, then you will be launching those inside these subnets. And when you launch multiple machines, so try to launch in different availability zone. Let's say today I decide to launch 4 machines. So my approach would be something like this. And then what to do with this machine is that I will be installing or I will be deploying my web application on these machines. These are all EC2 instances. Instance means a single machine of that service. So this is single EC2 instance. This is also EC2 instance. That is also EC2 instance. So there are 4 EC2 instances in this particular architecture. And all EC2 instances will run the same web application. So this EC2 is actually a virtual machine, and I'll now will do a practical, and along with practical, I'll teach you how we can have our application running over a virtual machine. This virtual machine is exactly acting as a hardware machine. Only the difference is that it is not hardware, it is actually a software. That is the only difference. The nature, the appearance of that machine, it is an e-machine in simple words. The hardware computer, how does it work? It has its own CPU. You just imagine a laptop in front of it. It has its own CPU. It has its own storage. It has its own random access memory. It has all the things that are required to run a successful machine. And on that machine, we can launch OS, right? And then we can launch softwares. Similarly, EC2 is also a machine, but that is an e-machine. It is a virtual machine. The word virtual means it is not physical. And multiple virtual machine can run on single physical server. Now, when I create one EC2 machine, I create one VM. And on that one VM, I can install my OS. I can install my web application, which I would like to show it to the world, make it public so that people can access it. Because your people, the end user, will be sitting somewhere in your public internet in the whole world, and they are like, they know, like, there is a website they want to access. So whenever they send a request, their request would come to your EC2 machines, and then they will get the responses from your websites. So from here we are starting. Then later on, we will add databases so that we will understand the whole architecture one by one module. But this is what the significance of EC2. You can install any kind of application you want. So let us start now. I hope this basic foundation of the overall understanding, like how the architecture and the EC2 will play a role together, is understandable, right? So now I'm going to show you how I can actually create one machine of EC2. I'll explain you the different process, and then I'll install one web application, some application over that, and I'll show you how we all can access that machine using the public internet. From the internet, how can we access that machine? Okay. So whenever you would like, if you like these diagrams, you can take screenshots because if I don't have space, I will just remove these pages, right? So if you like these diagrams, you can take screenshots whenever you want. I show you the architecture. I again draw the hardware server. On that, its own OS. On that, they have some virtualization software. Sometimes we call it as hypervisor also. It all depends what they call it. The terminologies can be different, but okay. So this is about one single hardware server. On that hardware server, our EC2 machines are running. So this is the slot of one EC2 machine. What you see in this majorly is that, that every hardware has own CPU, true? It has its own random access memory. It has its own operating system. It has its own storage. And then finally, it has application running on it. Now, on EC2, it is also a machine. It is just a virtual machine. On this EC2 machine, we will also try to allocate. Now look at my word. We will try to allocate certain amount of CPU, which will be like taken from this hardware server, certain amount of CPU, then we'll be taking certain amount of primary memory, we'll be taking certain amount of storage. It will also require a storage, and it will also require its own operating system. It will also require its own application. Yeah. So what you see above is an architecture of a VM. What you see below is an architecture of a hardware server. Simple. So let us start. The EC2 we will show will actually, have different steps where we will be able to, as a user, will be able to configure it, configure all settings. So we will have ability to decide what OS, what application, how much CPU, how much RAM we would like to give. So user has more control over machine. That is also one observation, right? And that is the reason this particular service falls under IaaS. Does anybody know the long form? What is by IaaS? IaaS stands for Infrastructure as Service. Infrastructure as a service. So what is by infrastructure as a service? This word basically you will see three categories: infrastructure as a service, platform as a service, and software as a service, right? So now we have got introduced with one infrastructure as a service. So what is by infrastructure as a service is that a service wherein the company, like the cloud provider, is providing us only the infrastructure part. You see, when you go with EC2, all the things below this line are provided by AWS. All the things above this line are all decided by user. Now please observe. Look at this black line. Everything below this line is provided by AWS and everything above this line is decided by user. So that is what I'm saying. What you get with EC2 is only the infrastructure. Am I correct? Because on top of that infrastructure, the design of EC2 is your choice, is all your job, right? Is all the job done by Mr. User, right? That is why this comes as infrastructure as a service, wherein you have full control over OS, application, all the configuration settings. And that is why you can configure it, you can customize that machine the way you want. All right. So let us start with step by step. And what I'll do, I'll show you actually the lab where I can show you some demo. So when you go to AWS account, the first thing you have to make sure that on the top right corner, you see different regions. Okay. We have to launch resources in a particular region because a lot of services are regional services. So now, today I'm going to show you a demo. So I should use some region. What region I'm choosing is Northern Virginia, which is in USA. Okay. Now I'm using Simplilearn Lab. In Simplilearn Lab, only 2 or 3 regions are only allowed to practice. So basically, when you are using Simplilearn Lab, try to create your resources in first 3 regions only. If somebody is trying with the regions which are below, probably you will get error. And this will happen with only Simplilearn's account. If you have your personal account, no problem. Okay. For example, somebody is from UK and he or she tries to do it in London. Probably he or she is absolutely correct, but they may get access error. The reason is Simplilearn has restricted those regions. Okay. So you are given access to the first 3 regions. I will expect you to do it everything in Northern Virginia. That is very safe for you. So I have decided to choose the region Northern Virginia for creating my first EC2 machine. So that is my first job. Second job, I will click on search box. I will type my service which I would like to open. I have written EC2. And then I see the tagline. They say EC2. What is EC2? EC2 is virtual server in the cloud. That's all. So you open that. So I have opened this service. All right. This is called as dashboard of EC2. What you do with EC2 is all available here. On the left side, you can see different options such as the instances category, image category, elastic block store category, operations or possible resources you can create with EC2. I have expanded everybody. What you start with is creating a machine. That's called as instance. So this word, now you should write down that instance is basically a copy, or we can say a single machine of that particular service. So if there is one machine of EC2 you have created, it is called one instance of EC2. So I'm going to create an instance. So I click on instances and I see there are no instances at my side in Northern Virginia. Okay. So let us start by creating an instance. Instance is a single machine. Okay. So I have repeated it again and I will write it. Instance means a single machine. That's simple, right? So you create one single machine of EC2, it is called one instance, right? Snapshot is a very different concept. It has nothing to do with instance. And the purpose of image, we are going to learn in our steps. That is step number 1. So you will get the explanation over there only. So let us start creating the instance, all right? So what you have to do is like, click on launch instance. And the first question they ask you is like, do you want to attach some tag? Do you want to give some name? Okay, so I want to give it name as my first instance. This is the name I would like to give. This is my choice so that I can identify it. Then the first thing And what are the things they ask you? See, I'll show you. Okay. So let us compare the diagram. Now tell me one thing. The EC2 will require all these components which are written here. Let us start identifying those components. Number one, we'll start with OS. The EC2 machine will require its own local OS. So that will be given by application or OS image. Do you know to install any OS on the machine, you require an image file? Let's say you have a laptop and you want to format that laptop, you want to install some OS, you require an image file, right? Similarly, to install an operating system on EC2, you require an image file. That image file is called as AMI. You can see the long form here. It's called as Amazon Machine Image. And we generally, it's very popular word called as AMI. These are the images provided by Amazon. Let us see. I click here. I see some of the images. And if I click on browse, wow, I see a lot of categories. Around 47 AMIs are available. Here we have 9,000. Here we have 500. A lot of AMIs I have. So basically, these AMIs will help me to launch an operating system on EC2. All right. You could see like there are a couple of Linux, Mac OS, Red Hat. You have SUSE Linux. You have Microsoft, Ubuntu. You are aware of all the operating system, right? So based on your requirement, you will talk with your software developers and you'll ask, okay, hey, can you tell me what kind of application you are going to develop and what OS you require? I'm going to configure the machine. So they will tell you, okay, we want what type of operating system on that particular EC2. Accordingly, we have to choose. So we are going to choose, for example, number one, Linux. And this is actually a free tier eligible. So Simplilearn Lab will allow you to choose only the free tier eligible machines. Okay. So free tier means free quota. So they will not charge you for a couple of times, for a couple of minutes. So let us click on select. So when I select that, then I'm telling to EC2 that, see, I would like to have this AMI. And you take this AMI and install that respective OS on the EC2. So what is the choice with this is this particular AMI. This is the AMI ID. You know, this is the Linux AMI. That's all I have chosen. So my OS is done. I just made a choice. Okay. Then we'll go with instance type. Now, what is the second question? This instance type is something which help you to choose the combination of RAM and CPU. RAM and CPU. So if you want to have a combination of some amount of CPU, some amount of primary memory, then what is the answer for that? That answer is instance type. Let me show you. You get around 760 plus instance types, and they are named like this: T1.micro, T2.nano, T2.micro, T2.small, T2.medium, T2.large, T2.x large, T2.2x large. Like if I keep reading this, it's a long list, right? If you look at any particular instance type, suppose I take this one, T2.micro. How much CPU, how much RAM, how much memory I get for my EC2. If I choose this, I'm telling to the service that I would like to configure EC2, which would have one CPU and 1 GB of RAM. Suppose I go with other types, I go with T3.2x large, then I get 8 CPU, 32 GB of RAM. So what I'm doing is like I'm changing the configuration by changing the instance type. This is the way you are telling to the service that I want this combination of CPU and RAM. And for different types of application, different requirements are there. However, your price of EC2 also depend on what instance type you have given. Because generally, if you think like people will be like, okay, why can't we go with the higher side? If you go with the higher side configuration, you should be aware that your price will increase accordingly. Right now, I'm going to choose T2.micro. Now, this is something which is free tier eligible, and this is the only instance type that works in this lab. What is by free tier? Maybe some of you might not aware. Free tier is like AWS gives a little discount for certain duration. For example, if you're using EC2 service, so they say that you can use EC2 free of cost for 760 hours per month. After that, you have to pay. And for that to become eligible for free tier, you have to use respective some specific options only. Let's say I have created one EC2 machine. You can see on my screen. And in order to do some operation, for example, you want to install some script, or you want to update something, right? You want to install some patches, whatever you would like to do on your machine, right? Okay, so I was telling about key pair. We are talking about key pair. That is the third step. And I'm telling you what is the significance of key pair, what is mean by key pair. So that is what I have drawn here. I am writing you, I'm showing you one EC2 machine. And after creating an EC2 machine, what I'm telling is if you want to install or update, or you want to do some patching, or so what is by instance type? So instance type, if when you choose, what they have done is they have created 761 plus different combination. You can see on the list, and in that you get a different combination of CPU and memory. What you do with this is you are defining the capacity of that machine. How much is the CPU and memory? Because based on that, a different kind of application runs. Now, for that purpose, I am choosing T2.micro because this is the one which is free tier eligible. When you want to do practice in Simplilearn Lab, or even if you try using your own, you know, account, that time I will also recommend to go with T2.micro. So it doesn't matter what OS you are running. It's just telling you how much CPU and how much RAM your machine will have. Whatever OS you install, whatever AMI you choose, it doesn't matter, right? However, this kind of help you will get from your developers. They will guide you that, see, my application is a heavy application that requires more memory, or my application is more compute consuming application, they require more CPU. Likewise, so based on that you choose the instance type. So I'm choosing one CPU, 1 GB of RAM, and that is how I have selected this. The third one is key pair. In this key pair, basically, that is why I drawn this. So suppose you created your machine, right? But this machine is without application, right? On this machine, if you want to install an application, or even after installation, you want to update it, you want to patch something over there. Let's say you want to patch OS, you want to patch application. Basically, you want a remote access to that machine. What do you mean by remote access? Remote access is a way you can directly log in into this EC2. If you want to log in inside EC2, then in that case, what you need is called as key pair. So key pair, the word is key pair, and there are two types of keys given, the first key and the second key. The first key is called as the public key, and the second is called as a private key. Okay, so public key is something that will be remained on EC2 side. So it will be on EC2 side. It will be stored on EC2. Private key will be downloaded on user's laptop. So wherever you are working. Okay, and I'll show you right now. Now, what is the benefit of using this? So if you have chosen this option of using key pair, then you will be able to log in. Simple. I'll show you in this demo itself. Look at this. Now what I'm doing, when you go to this third option, everybody has to follow the same thing. You have to click on create new key pair. You can see this button here. If you click here, then give some key pair name. I'm giving some name, okay? So I'm calling it as my first key pair. Now this is the name I'm giving to it. my first key pair. So I'm seeing the key pair type. These are actually encryption algorithm. So you can go with any encryption algorithm. You will come to know when you become expert into encryption. And then the type of the file. So I'm just trying to tell you, by default it is a .pem file. This is required for SSH, secure shell access. Now this SSH protocol is actually supported by all three operating system, Windows, Linux, as well as Mac from your local laptop. And this putty is basically for Windows, which were the old versions before 2010. So those were like people were using putty and they were using .ppk private file. But now everybody is recommended to use .pem. So I just go with the default setting. I click on create key pair. And the moment I click, you see something is downloaded on my laptop. Do you see this on the right side? You could see this file, right? .pem file. It says my first key pair.pem. This is actually the private key. This is actually a private key. I don't understand what is written here. Nobody understands. This is the private key. And the similar kind of public key file will be stored on that EC2. And what will happen when I finish creating the machine and I try to log in, then what I will provide is private key. Do you remember in the old movies, like how you authenticate, right? Let's say there are two goons and they want to meet in some different country, right? How they authenticate, like somebody has a half note, half currency, and the other one has the other half. If they meet and they match, they'll be like, oh, you are the right guy. Now what you are doing here, the same logic. You, when you log in, you will provide private key. And EC2 has public key. So what this service will do, they will see that whatever private key user is providing, if it is the corresponding private key of this public key, then they will allow you to log in and let you perform some operation. I'll do it practically in front of you. That for that purpose, we are creating key pair. Okay, so keep remember that the reason key pair is created so that you can authenticate yourself while doing the login into EC2. Right now, I just click on create new key pair. I created something and that have installed private key on my laptop, and that is being chosen here. The next question is about network setting. In network setting, basically, you have to define. Now you look at my diagram, which I think I have not erased that. Look at the first diagram. When you launch EC2, you have to inform the service that within which network, within which VPC, look at my circles, within which VPC and within which subnet you would like to launch it. In this diagram, there are 4 machines. You can see there are 4 machines. And I'm doing installation of one EC2 only. I'm launching one EC2. So they would ask me, okay, so Mr. Raj, can you tell us which VPC, which subnet you would like to launch it? And now that is what I'm going to do in network. I click on edit and then I say, okay, they ask me, okay, which VPC? So I say, I have not created my VPC, but there is one default VPC available. I can see in Northern Virginia, there is one VPC available. I have chosen that one. It's called as default VPC. And second thing, they are asking me, Mr. Raj, which subnet you would like to launch your machine into? So I have a lot of options. And the first thing is like they say, no subnets found. Either the account has no subnets in this region or an invalid search has been entered. What happened? We are in Northern Virginia and we should have a subnet here. Thank you very much. If you have shown us, what we can do is we will try to create one new subnet. This never happens. Somebody must have deleted it. This has nothing to do with your regular experience. All right. So just ignore what I'm doing it. This is the part we will learn it in Okay, so I have repeated this. This is the networking part. We'll learn it during the networking lecture. Support me in that case because there was some technical problem. I have resolved that. Let me refresh and see. Yes, so the subnet which was not showing here, it was not shown here. I'm showing you right now. So what I've done is coming back in the network setting. The first question I have chosen the VPC and I have chosen the subnet. That's what I have drawn in the diagram. When you launch EC2, there should be some network and there should be some subnet. And inside that, you have to launch EC2. The subnet which I created, can you see carefully here the availability zone? What is the availability zone? Can somebody identify? What is the availability zone? You see the word naming US-East-1A. Am I correct? US East 1A. Do you see that? So in this US East 1A, what is the meaning of US East 1? So basically US East 1 is the naming of Northern Virginia, right? US East 1. And letter A indicates first subnet, first availability zone. So there are total 6, A, B, C, D, E, F. Total 6 availability zones are there. My subnet is in first. In my diagram, I have drawn that. So I'm actually creating the first machine of EC2. All right, so I have chosen that. They are asking me, Mr. Raj, do you want to provide public IP to this machine? Absolutely, I have to provide that. Why? Because then how can people access the machine if they don't have public IP? So public IP assignment has to be enabled. Next question they ask about firewall. These are called security groups. Now, what is that? They're actually going to help us to control what traffic is allowed and what traffic is not allowed. It is literally a firewall. In this firewall, right now, I'm going to create a new firewall, a new security group, and that security group act as a firewall for that EC2 machine. So I'm drawing it with, let's say, which color? The green color I'm using. So this will act as a security group. Now, what is this security group? It's a filter, it's a firewall. So whenever request comes, this filter will have the rule and they will see whether the traffic that is coming, whether the request that is coming, whether it is the one which is allowed. If yes, then they will allow it to go and reach EC2 machine. If not, they will deny, they will stop that request. They will not allow it to reach EC2. So that's why firewalls are important from security perspective. I'm creating one firewall and going to create 2 rules. And I want your observation here. The first rule that I'm going to create is for SSH type. I would like to allow any kind of SSH traffic coming from any machine. And why I'm giving SSH? If you remember key pair discussion, you remember key pair, right? Key pair is required for login purpose. That key pair, and I'm going to create Linux machine. So I would definitely require SSH protocol, to support that. Otherwise, I cannot log in. Even though I have a key pair, SSH traffic must be allowed in the EC2's security group. And for making that possible, SSH has to be there. The second rule that I'm allowing is HTTP. Now, if you ask me why, everybody knows HTTP is required because I'm going to visit the website, visit that application on my browser. And that is why HTTP traffic should be allowed from anywhere, because everybody sitting here, I think there is audience, 49 people are attending, and I can allow HTTPS also, but I have not configured HTTPS Oscar, and just for demo purpose, I'm allowing HTTP only. Okay, so if you want, we can have HTTPS as well. We can have other traffic also, but at least for demonstration, these 2 at least are required. So I'm allowing these 2 types of rules, you can see. And when I allow these rules, add these rules, then my firewall security type is simple. If you want to see what are the options available in source type, anywhere, custom, or my IP, and then here means only I will be able to do that operation. But basically, we are doing a demo. I want all my students, all my participants to check this machine. And that is why I'm saying anywhere. That's the habit, right? At least for HTTP, I would like to have anywhere. For SSH, the good practice is to have my IP or at least custom. So you can give some custom IP range. Anywhere is not recommended for SSH. That's very obvious thing. You will come to know when you start working on this. Okay. This is what I have done, networking part. Finally, after networking, very important part is storage. What do you mean by storage? Storage is actually a place, where it's like similar to your hard disk in the laptop. Okay, everybody knows a machine is incomplete without a storage device. Imagine your laptop without your storage. Then the simple question is, where is your OS going to be stored? Where is your OS files are going to be stored? Where are your application files are going to be stored? So you require at least a store where you can install your OS, you can install your application, and whenever you start the machine, your OS will boot from there. And for that purpose, in laptop we have HDD drives, we have SSD drives. Similarly for EC2, there is something called as EBS volume. Now this EBS volume, now we will discuss about that separately. Every EC2 machine, we can provide with this EC2 machine or EC2 instance is basically a representation of compute. But this machine is incomplete without a storage. And that storage to the EC2 is provided by a separate service is called as EBS, which stands for Elastic Block Store. So what's the purpose of this? At least EBS is required at least for two purposes: to store your OS, to store your application files. Minimum for these two purposes, EBS is required. Because then when you say that, okay, I'm installing Linux OS, I'm going to install HTTPD server. Well, these files has to be stored somewhere in the storage device. And that is why EBS device is required. And as one machine of EC2 is called EC2 instance, similarly, one machine of EBS is called EBS volume. So I'm creating one volume for that, where OS and application would be stored. Now you see, when I go to configure storage, one root volume would be created. Now, if you want to understand what is this is called one quantity of 8 GB. So by default, the size of the EBS volume that would be created would be of 8 GB. However, you have chance to change it. It generally varies between 1 to 64 terabyte, depend on what type of EBS we are using. Okay, we'll discuss it later on in the storage part. But now it is the part of creating machine. That is why I give some reference. Okay, when I'll teach you the storage category, that time EBS will come. We will see different types of the EBS volume and all. So let's come back. In this step, generally, we don't need to do anything. We don't need to configure anything. The reason is very simple. By default, one volume of 8 GB is always created. So keep it as it is. That's all. Finally, you will see advanced details. These are some advanced level settings. And I'm keeping it as it is, nothing. So I'm keeping it blank. All right. And then all the options I have given. On the right side, there is a summary. They're asking me, Mr. Raj, how many machines you would like to create? I say only one machine, but you can change your count also. So when you say one, click on launch instance. All right. So they say, okay, successfully. Look at this. Within 10 seconds, they have given you the message, okay, we have launched your machine. Go back and see. So I go back, I refresh, and I see there is one machine is being shown here. There is some instance ID is generated. There is some name generated. When I select this, I get the complete details such as instance ID, public IP, private IP, there is public DNS, host name, its instance type, VPC, all those things which we have decided. And finally, I see one thing which is very important before you start using this is called as instance state. What is the state of the machine? So machine is always in different states, similar to the laptop, right? So you can see here, either the machine is in running state or stop or reboot, hibernate, terminate. Only terminate is the thing that you never see in laptop. Okay. Terminate basically means you are going to shut down the machine, and that machine is completely going to be deleted. You cannot recover a machine which is already shut down. So remember, before you click on terminate, so okay, suppose if I click on terminate, this machine will be permanently deleted from my system. I cannot recover it back. However, I can restart, I can send that machine for Hibernate, I can stop this machine, I can, after stop, I can start it also. What I'm interested in is in running state. Why? Because running state is the only state when your machine is available. You can access that machine. If the machine is not in running state, it is of no use for end users, right? Now, I have one question. You have all observed very carefully that I created one machine having Linux OS, having some different settings. So I would like to show you now, how can I take a remote access to that machine and install something. You look at this. You remember key pair? Okay. So this is me in the circle. From my laptop, I will try to connect to that EC2 and will install something using the key pair. And if I don't have like that option of key pair, if I not created key pair, then I cannot connect it from my laptop's command prompt. See, this is my command prompt. Okay. If I want to connect to that machine from my laptop local machine, I will open my command prompt, will type some command, and then I'll be able to connect and log in into that machine. However, if I don't have, then I can log in from the account itself. I'm inside this account. Look at this. I'm inside the account right now. There's a button called as connect. Click on connect, which says connect to the instance. And there is an orange connect button. So when you click on connect, you are able to log in again. You don't need key pair here. You see, this is establishing the connection, but this is actually when you are within the account. You see, you can see the private IP of your machine. Now, whatever you would like to install, you type it here. Okay. However, if you don't want to connect from your login, if you have not logged in, and you say that, okay, Raj, I would like to log in from my local machine. If you want to log in from local machine, you should open your command prompt. Now, this command prompt has nothing to do with this, your account. You just minimize the account. What you have opened is simple software on my laptop. From this command prompt, from my local laptop, I will connect to EC2 machine, which is running on Northern Virginia, which is one of the AWS regions. And I'm sitting in India, right? So I'm trying to take a remote access so that I can install something on that EC2. I have a script for that. Okay, I have a very simple script I generally use. This is actually a script where I can install one HTTPD server, and on that I can install some, put some HTML file. Okay, so there are some commands to run that script. So first thing is that I'm going to install HTTPD server. Okay, why yum is not being recognized? Okay, I'm sorry, I did a mistake. Before that, yeah, I need to connect that correct, Chandra. So for that purpose, I would be writing one command here, and that's called as SSH command. I would like to highlight, make it large, SSH. Okay. So first thing is like, I'm going to connect to my EC2, and the command is SSH secure shell access. So SSH, then I would like to provide the path of the file on my local machine. Which file? Private key. So let's go, and I'll just copy the path of the file from my download folder. Okay. So this is what I have provided, the path of the file. If you see the name of the file, my first key pair.pm, this is the private key. So what I'm doing is I am trying to remotely connect. So Harun, you can see now, again, I'm repeating for you. I am going to remotely connect from my local machine. You see the command prompt? This is running on my laptop. I'm going to connect to my EC2. Now EC2 is running in Northern Virginia region in Simplilearn's account. How can I connect to that machine and install something? For that purpose, I'm using the SSH command to remotely access. And for that purpose, I'm teaching you how to write the command. The command called as SSH, it starts with SSH, then -I, it's for identifying the file. Which file? Which you are providing here. This is the path of the private key. Once you do that, then you have to type the username of EC2 @ IP address. So where is the IP address of my machine? Public IP address. You see the public IP address. I just copy that. And this makes my complete command. Right. So you would be like confused. Okay. So Mr. Raj, where you got this EC2-user as the username? How do you know that? So to know that, it's very simple. If you connect and you will see the username here. Even the public IP is also shown here. So this is the username EC2-user. And this is the public IP address, which is generally common for Linux machine. This is what the default username. All right, so I go here. I have provided the username of the machine, the IP address of the machine. I am providing the private key pair so that they can understand I'm an authorized guy and I'm trying to remotely access. So I'll just copy this command and we'll try to run it on my command prompt. Wow. So they say that, are you sure you want to continue connecting? I say yes. So permanently add it. Now my laptop is got connected to the EC2 machine. If you want to cross check, look at this IP 172.31.6.178. This is basically the private IP of that EC2. Look at this 172.31.6.178. And the username is same. So this is the proof that I've got connected. Now I can run the script. Which script? This script. I would like to install an HTTPD server. Let's go and try to install that. I got connected to the machine and I would like to run some script. Okay. So I would like to take the root level control, sudo su. So first of all, I'm installing an HTTP server. And then I'm starting that server. Okay. And finally, on that server, I'm going to put index.html in this particular folder structure. Now this index.html will have only one sentence, that is hello world. I would like to show you installing that. Even I will just not do that. I'll have to, whatever I've done so far is just the blank HTTP server. This much I'm stopping here. I would like to show you how your EC2 looks like. Take the public IP address. I'm sharing it to you. Can you all please do a favor? Open your browser and try to put that public IP address and try to see if you get any response from the server. This is the response from HTTPD server. I, sitting in India, as an end customer, able to visit the website running on my EC2. Right. So what I did is I installed the software by taking a remote access using SSH and key pair. I'm going to install one more command, which is putting one HTML file having some sentence. So I'm doing that on my server right now. So I can do updation at any moment, right? So let's say I have updated my server. Now look at it and just refresh. I got hello world from and the IP address of the machine, the host name of the machine. Are you also able to see the same? I'm getting response from that HTML, which is running on HTTPD. Exactly. The same which I can see on my screen. Great. So I have done two things right now. I have shown you how can I install something by taking a remote access. Is that clear? And number two, I have also shown you that how we are able to access the machine on the browser as the end customer. It's just that we are typing the IP addresses. That's how EC2 works. Now imagine you can install any application and run it on your EC2 server. And that is how you can create multiple EC2 server having the same website. And that will help you to do a lot of things. I hope this is clear. Don't worry, we'll do a lot of practical in solution architect also. I want to tell you right now is that if you understand the concept, that's very important in your fundamental training. I'm showing you demo to make you understand about fundamental, right? Great. Now I'm going to continue the story. Okay, the journey has not been stopped here. We have learned how a single machine works. Now I'll talk about highly available architecture. All right. Look now. I'm going to erase this. You must have taken screenshot if you have. If not, I can stop before I create a new whiteboard. Now, having one machine is not enough. When you create architecture, multiple machines you would be creating initially, maybe 2 machine, 3 machine you will start with. And based on the load, based on the traffic that is coming, based on number of requests that are coming, you will be able to expand that infrastructure. That's called scale out. Or if you have less traffic, you would like to scale in. And that's how we are going to do. For that purpose, I will again draw my network. I'll again draw my subnets. Okay, so suppose I'm taking the same example, but this time I'm having 3 subnets. Subnet A, subnet B, subnet C. Now these 3 subnets would be having, EC2 machines having the same website. So you thought that, okay, Raj, I have done fantastic job. I launched multiple machine, but I made sure that this machine must be launched in different availability zone. That is what I have achieved. I have launched first machine in AZ-A, second in AZ-B, and third in AZ-C. But now the practical problem that are going to happen is when your customers are going to reach to your machine, when there is only one machine, they can type the IP address of that machine. But what about if there are multiple machines? You can see in my diagram, these are the people who are going to visit my website. What will you do? Will you share them all the public IPs of all the machine? No, that is not going to make any sense. For that purpose, you require a common endpoint, right? Some common endpoint which can act as a single entry to your EC2s. And for that purpose, we are getting introduced with a service called as Elastic Load Balancer, which stands for ELB. All right. So this is called Elastic Load Balancer. ELB stands for. And this service gives you a load balancer server. And what is the use of this? This load balancer server acts as a common endpoint for all the machines which are available. And then what would happen? This load balancer will have its own DNS URL. And when you have the load balancer in your architecture, then you can share this URL to everybody. So now let's say there are some X number of people. All these people will hit the URL. So what will happen? Everybody's request would come to this Elastic Load Balancer. Am I right? And then what Elastic Load Balancer will do? It will try to distribute the requests one by one to each machine available. So for example, there are 7 requests come. So the first request will go to first machine, second will go to second, third will go to third, fourth will go to the first machine, fifth will go to the second machine, sixth will go to the third machine, seventh will go to the first machine. So what is this doing? This is balancing the load. You see the name, balancing the load. And they're doing it in a particular fashion. This is generally in programming, this is called as a round robin algorithm, one by one. And this is the way they are doing the balancing. So now your 2 purposes are served. You got the common endpoint, and that is distributing the traffic to all. So load balancer is required. Without load balancer, you cannot have multi-AZ environment. Now, this is the typical multi-AZ environment. Do you agree with me? What you see on my diagram is actually a multi-AZ environment. What you have achieved is you have launched multiple machines, but you made sure that you are launching the machines separately in separate availability zone. In this example, you have considered 3 availability zones. And you have also made sure that in order to technically make it possible, you require a load balancer to act as a common endpoint. And now the people will be able to access your machines. And that is the typical multi-AZ environment. And that is where ELB plays your role. So that's why ELB also comes under compute category. But hold on, the story is not yet done. Now I'm thinking about some of the issues, right? Okay, so there is one thing that is missing here is that now I would like to understand from your side. Let's say these 3 machines are enough to handle 4, 5, 6 requests at the same time. But what if the website become very popular? A lot of people shown interest and a lot of traffic is coming, like this. So in that situation, we can say that the load is increasing. So imagine a lot of people started visiting your website. A lot of requests are coming. So then those 3 EC2 machine, do you think they will be working fantastic, or do you think they will be exhausted, overloaded? Definitely, they will be overloaded. That might lead to the failure of the machine. And that is why it is needed to increase the machines, right, to scale the infrastructure. And for that purpose, if you try to do it manually, it doesn't make sense. You want automatic scaling. Am I correct? It should happen automatically based on the traffic coming. And for that purpose, you have to learn one more service called as ASG. ASG stands for Autoscaling Group. What this Autoscaling Group will do? The job of Autoscaling Group is to do automatic scaling, scale out and scale in. What it does 2 operations, and these are called as scale out and scale in. Scale out means increasing number of machine. So this ASG will increase more machine which are similar to your old machines, having the same website so that they can handle more requests. What is by scaling? Scaling means decreasing the number of machines. So let's say the situation happens in a reverse way and the traffic is less. Can you tell me, will you keep 7, like here you see 6 machines running for that? Will you be able to afford this machine? They are underloaded. They are underutilized. They are not utilized properly. And that's where scaling is also required. So whenever there is more load, scale out. Whenever there is less load, scale in. And that is why now you see the story become complete. The 3 services that I majorly use from compute category are, you can see my diagram. I will use the black color. These 3 services that we are using are EC2, ELB, and ASG. And they have their own role here. These 3 services used combined will help you to create a highly available and scalable architecture. So congrats, when you are learning fundamental, you are also understanding the architecture. That's very important. You are not just learning the services, you are able to understand the architecture also at the same time. And that makes a highly available and scalable architecture. Do you agree? Is it highly available? Because we are using multi-AZ. If one machine failed, other machines are still available. And it is scalable also. When the load is more, it will increase machine. When the load is less, it will decrease the machines. And that's how these compute services work together. Anybody's question is not yet answered. Jamil says, can you deploy additional softwares while creating Windows EC2 machine, MS Office application? We can install any application on any OS. It should be compatible, Jamil. The answer is yes, we can deploy. Prajwal says, will ELB check running status? And the second question, why only round robin? Okay, there are two questions. So Prajwal, the first thing is that ELB checks the health of the EC2s. What does this mean? ELB will be able to diagnose, it will be able to understand whether the machine that is registered here. So you see there are total 6 machines. How do we know that the machine is failed? ELB will be able to do health check monitoring. What it will do, it will continuously check the health of every EC2. And whenever it detects that, for example, one machine is down, it is not responding, then in that situation, this ELB is going to stop sending the request to it. This ELB will stop. This is the logic. So that actually help us that we don't want to waste our request to the failed machine, right? So ELB will identify. And how does it works? It's simple. ELB does a kind of ping operation. It continuously sends HTTP request to the machine for health check. And it responds, I mean, it expects if the machine is running, what you expect an okay response. Suppose if continuously HTTP requests are being sent and EC2s are responding with OK message, the 200 code response, then you can, like ELB can consider that, okay, this EC2 is healthy, no problem. But the EC2 doesn't respond. In that situation, ELB can easily identify that this machine who is not responding must be down, must be unavailable. And that's the reason it can declare it as unavailable or unhealthy. And it will stop sending requests to that particular machine. And what happens to the failed machine? The question is, in the story, is that when the machine is failed, then Mr. Autoscaling group comes forward. Autoscaling group will, first of all, replace this failed machine by a fresh new machine. So they're like having a replacement. ASG will find that ELB has declared some machine as unhealthy. So ASG will replace that machine by a new machine. Old machine will be terminated. So it will be completely terminated by ASG. So ASG is actually responsible for replacing the failed machine by the healthy machine. So I have already answered that how, based on what criteria health is checked. So ELB immediately does kind of ping operation. It sends HTTP requests continuously to the machine. And if the machine gives the response, the success code 200, then it is healthy. But if it doesn't give the response, then it will be considered as unhealthy. Simple. I hope this is clear on what criteria health is checked. You did ask the question, right? So on what criteria? Okay, let's go one by one. I have answered Mosa's questions. Okay, so he's not responding. Let me go back and see. Prajwal had second question, why only round robin? There is no such a reason for that, Prajwal. ELB follows round robin algo. This is the only algorithm which fairly distributes, the request one by one to the machine, because there is no such a logic. Every machine is similar. So what is the best way to distribute the things? In real life, let's say you have 4 workers running under you, 4 employees running under you. You want to distribute the load. So you will try to have a fair, distribution one by one. Similarly, round robin is the only algorithm that actually help to fairly distribute the requests, because you know that requests are continuously coming. So it's in a circle. First request goes to first machine, second goes to second machine, third goes to third machine. If the new request come, it will again go to the first machine. That is number 4. Fifth request goes to the second machine. So there is no answer for why. Round robin is the best algorithm that they found to be used here. That's the answer of your second question. Okay. Dheeraj says, how does it know traffic load on each machine? Pinging will just tell the health of the machine. I have already answered about health only. I have not answered about traffic load. Okay. So first of all, health issue is clear to everybody. I'm just asking everybody whether how does it check the health is clear? Fine. So that I can close that topic. Now the next question I could see from a couple of participants is that how does it understand the traffic? So basically, see, nobody understands traffic. That's my answer. What you do is You have to, like, when I'll teach you AHG and load balancer demonstration in the solution architect training, I'll actually show you in practically, and that will be a very fun activity. So when you provide AHG, you need to provide a criteria. And look at this. You need to provide a criteria for scaling. Well, this is your choice. You will tell what criteria will be used for scaling. And that criteria depends on certain values, and we call them as metrics information. For example, I give you some example with that you can understand. So you are dealing with EC2 machine. There is one metrics value called as the utilization of CPU of that machine. Suppose if I pick up that criteria, then I can tell to the autoscaling group that, see, you should focus on CPU utilization number. And I will give a criteria. Suppose CPU utilization crosses 60%. If this criteria is met, then do the scale out operation. If the CPU utilization is less than 30%, then do the scale in operation. Do you understand? I am, while defining AHG, I'm telling to AHG that I'm giving you a criteria that if the average CPU utilization of all the machines, that is the average number, if average CPU utilization of all the machines, if it is crossing 60%, then you should do scale out. If it is less than 30%, you should do scaling. So these are user defined criteria. These are called as scaling policies. We will learn it in detail in solution architect. They're called as scaling policies. So scaling policies we will define while defining AHG. And that's the answer. That's kind of criteria. There are many criteria also. For example, number of requests coming per load balancer, all those things. So using any of the criteria, we can define the strategy of increasing and decreasing the load. I mean, decreasing or increasing the capacity, which is called scale out and scaling. I hope this answers your question. Can I get a confirmation? Did you understand by what logic autoscaling group will increase or decrease the capacity? Prajwal says spawns after it reaches that utilization. Yeah, so if 60% is increased, autoscaling group will add one machine more, Prajwal. If 30%, if it is less than 30%, it will decrease one machine. This is the way it will work. I think, Prajwal, I have explained already that this is one of the criteria. CPU utilization is one of the criteria. There are many other criteria also, and we will come to see that during the solution architect training. Okay. Now the next question, Priyadarshini has just now asked, will you cover the types of load balancer? Yes. Allow me to reach to solution architect training. Definitely will get introduced because we will have a complete project demonstration also for the whole setup that I have done. Mr. Nagavarma says, when autoscaling takes place, how about application? Well, that's a good question. So what we do, Nagavarma, is that when autoscaling happens and a new machine is added, so you're worrying about application, right? So what we do is we provide something called as launch template. We provide the launch template to AHG. So this launch template has all information of EC2 configuration, including your application scripts. So just imagine, Nagavarma, that you have provided a template. It has all the information about what type of EC2 and what type of application should be there. Then it becomes easy for AHG to follow that. So whenever it will add a new machine, it will follow this launch template and will create a machine for you having some application, which is exactly the same website that is running on other machine, right? Let me go back and see if anybody's question is still not answered. Load balancer depends on CPU process. No, it has nothing to do with CPU process. Balancing is depending on round robin algorithm, Shiva Kumar. So how does load balancer balances the load? It follows something called as round robin algorithm. In this round robin algorithm, it is actually, you can understand from real life scenarios also. Like if there are, for example, 3 machines available and you are Mr. Load Balancer, the requests are continuously coming to you. Your job is to distribute the request. So what you will do? First request you will send here, second you will send here, third you will send here, fourth here, fifth here. That is the criteria. Based on that, it will distribute the request. Simple. 7, 8, 9. That's the criteria. Okay. So networking services we are going to start with. So for networking part, we have a service and we should understand this service called as VPC, stands for Virtual Private Cloud. With Virtual Private Cloud, what you do is inside your AWS account, you can create your own network using VPC service. When you create this network, what is the purpose of this? So see, the service like EC2, when it needs to be launched, it requires a network within which it would be launched. And VPC is a service in AWS that help us to get that network. So it is an isolated network, and this is actually a regional service. So when you create VPC, nothing, you're not creating data center. That's completely wrong. You're not creating data center. It's a virtual network. Physical data centers are already there. In your region, there are physical data center. Similar to EC2, this is also virtual thing. It is a virtual network that would be running on physical servers. Okay. So it is not creating their own data center. No, that's wrong. When you have your AWS account, within that account, you can create your own VPC network. And in that network, you're going to launch your EC2 machines. That's the logic. So I was talking about VPC as a regional service. When you create a VPC, it would be created across the region, right? And in that, what you can start with. So what you start with is called as subnet concept. Now the box within the box is called as subnet. Subnet is like sub network. So it is a sub network inside your VPC, and you can create as many subnets you want. Suppose I'm showing you 2 subnets. These are 2 subnets, right? So why you are creating sub network inside the VPC? The first thing is that subnet is basically a AZ level resource. So when you want to have multi-AZ environment, in that case, you have to create multiple subnets in different availability zone. In this example, I'm considering 2 AZs, AZA and AZB. So I'm creating one subnet here, one subnet here. Why? Because I can create only one subnet inside one AZ. So basically, subnetwork help you to have further isolation. And I'll teach you how. Okay. So imagine your house, just a simple example. This is my house. Okay. So, well, as a human being, why I build a house? The answer is I would like to isolate my own family from the society. That's for isolation. That helped me from security perspective. So I built a house. Within the house, I built something called as room. So suppose I create 2 rooms. And you'll be like, okay, why do we create multiple rooms? We create multiple rooms to have further isolation within the house. So house isolates us from the whole society, the world, and room isolates, creates the isolation within the house. Like, you know that some rooms are public rooms. Some rooms are private rooms. Am I correct? What is my public room? Well, a public room is a room which is accessible to the outside world. So there can be a door through which people from the world, they can access the public room. Even from the public room, you can also go out of the house and you can reach to the world, right? But private room is something which you don't want to allow people to come in. Private room is generally accessible from the public room. That's what we do in our real life. Am I correct? Is it all okay so far? Great. If you understand this example, then keep in mind this when I teach you VPC. So similar to the house, we could create VPC inside our account, which can help us to isolate our resources from the public internet. This is your public internet. Okay. So in the internet, like you have multiple machines, the customers machine, the servers, a lot of things. It doesn't matter what is there in the internet. What matters is what is there inside your VPC. Inside your VPC, like you could create sub networks. They act as a room. And if you see, they are called as subnet. Suppose in this diagram, I'm showing you two subnets, subnet A and subnet B. And this subnet A will make it as public. And the subnet B will make it as private, similar to public room and private room. This is exactly similar example. And to have a gate or to have an entrance for internet, public internet with the public subnet, we will create something called as internet gateway. What is this internet gateway? Internet gateway is a virtual gateway device. What it allows it allows an entry to the internet world, vice versa. So people from internet, when the request comes, the request can reach out to your resources through the internet gateway. Even if you want to reach out to, let's say your server wants to reach out. So you remember we had EC2 machine and we tried to access our machine. On the left side, this is Raj. On the right side, this is EC2 machine. My request reach out to EC2, which was inside the subnet. How did it reach out to EC2? Because it went through the internet gateway. And that exactly happens other way also. Our EC2 can also reach out to any public internet server and the request goes through internet gateway. It is like you are on the left side, your door, which can allow to enter into the public room. And that's how it works. For that purpose, there is a table that is used called as root table, which is actually a table where root guidance is written. So basically all the machines in public subnet will be routed to internet gateway. And that is how they will be guided. So whatever you create in public subnet, whatever resources you launch in public subnet, their request will be routed to internet gateway. And that is what we are going to write in root table. And root table is the reason behind public internet forwarding request to IGW. Now the question is, I can launch my EC2 having my website so that people can access my website. And that is how possible through public subnet. The question is, why do we need private subnet? So the answer for that is private subnet is required so that you can have your private resources within which, for example, the database servers. I do use a database servers using a service, let's say RDS. Now you must better understand a database is something which is a backend server and your website is something which is a front end server. So your database, do you want people to directly access your database server? Tell me. You want that? Will it be the safe way? Never, right? That's why you are going to create your database servers inside private subnet. And then what you want? You want that only the public subnet should access private subnet. Is it not exactly similar to what happens with your house? Okay, so I use this analogy to keep it very clear in terms of logic. So remember, when you launch your EC2 machine or the database RDS machine, you require number one, VPC, which is actually in the network. Number two, you require subnet. Subnet stands for subnetwork. Number three, you require internet gateway so that the public subnet can access the internet. And number four, you require route tables. With the help of route table, a subnet, you can make it as public or private. And this is the logic behind it. So I have one question, and you please take a screenshot. Okay, before I proceed, you know how to take a screenshot. If you want, you can take a screenshot. And now I have some question for you. So my question to you is, and is very technical. When I launch this public and private subnet, it is indicating one website server with one database server. This will be running in one availability zone. Let's say AZA. So my question is it a multi-AZ environment? No, absolutely not. Because both the subnets horizontally, they are in one AZ, right? So if I want to make it multi-AZ, what would I do in this diagram? Can you all help me? And please tell me whether I'm right or wrong. So within VPC, I am going to launch my subnets in multiple availability zone. Let us say my choice is 3. So I will launch 3 public subnets and I will launch 3 private subnets. Do you agree? Just replicate. 3 public subnet, 3 private subnet. So for my single VPC, how many subnetworks I have created? Can you please try to help me? Total 6 subnetworks I have created. The first group, the purple color, they are all public subnets. Do you agree? And the green color, they are all private subnets. The thing is like for multi-AZ environment, if you look at horizontally, the first pair is in AZA, the second pair is in AZB, the third pair is in AZC. And now our EC2 machines, definitely we will try to launch them inside public subnets. We will take help of Autoscaling group, if you remember, to scale out and scale in more machines. And in the private subnet, we will try to have Mr. Database. So suppose I use the service such as RDS. So I will have database servers like this. So our software developers will make a connectivity, application level connectivity from your EC2 machines to database servers. And what would be here? Would be your load balancer. Here it is load balancer, which will be distributing the request. And here at network level, what device is there? IGW, which is internet gateway. And the whole world is displayed as public internet. So somebody sitting here from his laptop, when he tries to access this, he should have ELB's, Elastic Load Balancer's URL, right? So whenever he hits the URL, the request like comes here, it goes to EC2s, any one of the EC2s. Like this way, multiple requests comes. So are you getting a relation, of how this service is working in combination? Are you getting? Right? Is it a two-tier architecture, a fully two-tier architecture working smoothly? This is your first architecture. Congratulations. You are on day number 2. Okay. So you are on day number 2. You have seen your first simple architecture. on AWS, how you can deploy with uh, a two-tier strategy. However, the actual projects which we work on or which actually works in industry, they are not this much simple. They are having more services used for different purposes. But at least to start off with, even you are in fundamental training, this is how you can start off with. You should have your network, you should have your subnets, you should have your internet gateway. Then there are so many components available. We are going to learn in detail about them in your solution architect training. There is a dedicated day for VPC, and we are going to see that practically also. But now this is all the resemblance of how the VPC help us here, right? Okay, so we have two questions. Harun says it's not connected to other AZ, B and C. Well, are you focusing on the yellow arrow? So Harun, you will come to know when I'll teach you a database service, especially RDS, because in RDS, how it works, I tell you, Harun, there's always one endpoint, okay? And the endpoint goes to only one database copy. And in case, and please see that, in case if database copy is not available, the endpoint redirect to second copy. If the second copy is not available, it redirects itself to third copy. So they are following the principle of active standby. So only one is active, remaining are acting as standby. So we will see that detail in database service in solution architect, and that's the reason the arrow looks like that. Okay. Prajwal is asking next question. Why are they going same database? I think this is the same question Prajwal has. Priyadarshini says, how is IGW recognized when the request comes in? Like the load balancer IP address mapped to the domain URL for IGW. Priyadarshini, the load balancer's URL is actually a DNS URL. And if you are aware that the DNS URL will be mapped to its IP address. Am I correct? Machines are identified by IPs. So whatever DNS URL somebody will hit, www.blah.com, that will be mapped to IP. So when this load balancer's IPs is identified, right, then that IP is of this load balancer machine. So when somebody's request wants to reach out to that machine, okay, so how that request will be allowed to reach to that machine? Well, that is allowed because your VPC is having an internet gateway. So literally, it's a gateway device that allows to enter to the load balancer. And the gateway is associated to the VPC. The load balancer is associated to the VPC. So that is how it would be able to recognize it. Zakir says, can resources in one private subnet talk to resources in another private subnet in a different availability zone? Yes, anybody can talk to anyone, Zakir. To understand that, you can remember the house example. Okay. So it doesn't matter which room you are sitting. Let's say there are 4 rooms. Everybody can talk to each other, right, Zakir? That is called local communication. You imagine your house. Anybody can be in any room and they can talk to each other. They can reach out to each other. This is called local communication. So basically, you can see that whatever machine I have drawn here, the total 6 machines are there. They all can communicate with each other using private IPs. That's a local communication, which is inside the VPC. Anybody can talk to each other. That's the answer to your question. And we have Zamil, like written exam. I think Zamil was indicating something. Harun has some question. You're teaching greatly. I'm following and understanding very well. Okay, great. Gateway allows subnets resources to connect to internet. The traffic, how can the traffic be going out? So the VPC is actually an isolated network. Whatever resources you launch inside VPC, they cannot talk with public internet. Even public internet cannot reach out to those resources. Even they know the IP addresses still. Because VPC is like, what do you say, the fencing. it's a fencing that doesn't allow it to go inside. An IGW, it's a gateway, virtual gateway device. It actually opens up the door, and IGW is always allowing it to the public subnet only, not to the private subnet. And that is how your request is coming inside VPC through the IGW and getting forwarded to only public subnet resources. Suppose uh, suppose you do some experiment. I give you some example. Suppose you create one VPC and you said that, sir, let me create two subnets, single AZ environment, no problem. And you said, sir, I will make it as public subnet. I'll make it as private subnet. And in that case, you have IGW. So IGW only allows to public subnet. So what would happen? If you launch your machine, there are two machines you have launched. One is here and one is here. And even if you give the IP address to this guy, you say that this is the IP address of first machine, that is the IP address of second machine. But your request will reach out to only machine X. Your request, even though you know the IP address of second machine Y, still your request won't give. The reason is your private subnet is not associated with internet gateway. It's like your private room has no door. How can somebody come in and go out? No answer. Do we have any private room having door directly to the open world? No. Private room is always connected to some public room, and thereby we can go out. But that doesn't work like that, right? So that is the reason private subnet is private. You look at the arrow, look at the black connection here. The IGW is always associated with public subnet. I hope this makes sense. You have countered question. You said, so is it some kind of NAT? Well, NAT is also a gateway. IGW is also a gateway, but NAT has different purpose. We'll learn it in solution architect, Anil. But now for this time being, I hope this explanation is enough for you. Well, we have next question. Khalid has, so there is no need of another layer of load balancer to the second half on the right. No, between databases, no, Khalid. Why? Khalid, the reason is database has endpoint. So your applications are connected to only the endpoint. Only the thing is that behind the endpoint, the copy of the database changes if something is down. Let's say first is down, so it is connected to second. If second is down, it is connected to third. You don't need a load balancer here before the databases. I hope I have answered your question. Yes, no? Yeah, next question. Mosa. Two EC2 and two different VPCs cannot communicate with each other. How to make them communicate? That's a good question. Mosa, can I park your question for a few minutes? I'll answer them in the end. Two EC2s in two different VPC, how can they communicate? I'll answer that. Okay. Prajwal, joined in a little late post break. What is the use of private subnet? So basically, the use of private subnet is to launch private resources which you don't want internet to connect. For example, databases, Prajwal. So whenever you want to keep your resources private, not accessible to internet, then you keep them launch in private subnet. So for example, you see here, the red color EC2s, they would be having website which you want to get connected. However, the RDS, the database which you don't want to get connected to internet, right? Okay, so Karthikeyan said, does it mean the database is in the cluster? Yeah, they act in a cluster. Absolutely good observation, Karthikeyan. You can say like that. Database is in the cluster. It's a cluster of databases. So one server is active, remaining are standby. You will get a deep understanding in solution architect training when I'll teach you RDS database, Karthikeyan. Okay, so Priyadarshini says autoscaling group is also used for database instance scaling. No, not at all. Autoscaling group is only for EC2. Databases, based on the type of database, we have different ways, Priyadarshini. And the same answer, how database are scaled, it varies from service to service. And everybody has their own way of scaling. So scaling of databases, we will learn in solution architect training from Mosa. Mosa says that, Raj, if you have multiple VPCs, right? So this is your answer, Mosa. For example, you have two VPCs. there are two projects probably. One is launched in one VPC, another is launched in another VPC. And the point is like, the machines are launched inside their respective subnets. So it has its own subnet, set of subnet, it has its own set of subnets. They will have their own gateways. Suppose this is the public subnet of A, and this is the public subnet of VPC B. Then the EC2 running here and the EC2 running here, they can talk to each other through public internet if they have their IPs, public IPs, right? Because they are running in public subnets, they are launched in public subnet. If they have their IPs, they can communicate to each other through public internet. That's a default way. But if you ask me, can they communicate using private IPs, bypassing the public internet? They don't want to use public IP, they want to use private IPs. Then that is also possible. For that purpose, we will learn in solution architect something called as VPC peering. So this is actually one of the resources of VPC that you can create. It's actually called as a VPC peering connection. And if you have a VPC peering connection connecting the two VPCs, then the machine do not require public internet. Okay, that is not required. Machine A, machine B, even machine C, and please see machine C and machine D, they are in private subnet. These four machines can talk to each other using private IPs. It's like combining two houses, house number 1, house number 2, and you created a private path. So imagine everybody in house A and everybody in house B, they can talk to each other like a local communication. Is it correct? So is it clear to you, Mr. Mosa? Like, this is my house, this is my brother's house. I created a path, and now that has nothing to do with public internet. We guys can talk to each other. Our family members can talk to each other privately. We don't need public internet. I mean, it's not that I will go out, will use the public road, will go back to my brother's house. No, that is not required. These four can talk to each other. And Zakir Ahmed has a good knowledge. He's thinking about the private IP should not clash. Absolutely correct. What he is saying, guys, that the four machines that I have drawn in the diagram, the private IP of every machine should be unique. It should not be same. For example, if my house and my brother's house, if I combine them through some private path, I create a peering connection. And my children calling me dad, his children calling him dad. So there is a common word, dad. So everybody is confused whom they are calling. Right. So we should have unique pet names. I hope this funny example helped you out. Zakir, the answer is yes, they should not clash. They should not overlap. Great. Okay, so that's a significance. I hope we are getting sense of that. We have some suggestion from Harun. Harun says, I'm asking a favor. Can you ask the student to wait until the end of the session to ask their unrelated topic question? Okay, fine. No issues. Sure, we'll follow that, Harun. Thank you. Great. So let me go and do some next discussion, right? So now, the more we go deep. Okay, so Khalid says, I need to investigate and learn further. So it's a win-win situation. I'm using a Paint software. I want you to take a screenshot before I leave. Okay, so whenever you find that my diagram is done, you take a screenshot, create a Word file, put that here. So guys, the next thing I would like to see that if somebody wants to create a 3-tier architecture, in 3-tier architecture, we create 3 layers, right? So the first tier, that is our UI. The second layer is our application logic. The third layer is our database. Okay. Now I want to have multi-AZ environment, so I'm creating the replica for each. So now you see horizontally, there are 3 boxes. This is AZA, and it has 3 boxes, and this is AZB, It has 3 boxes. So you have subnet A, subnet B, subnet C. So in a single AZ, why did I create 3 subnets? Because this is my 3-tier architecture. In the 3-tier architecture, the developers would want the website to run on the first tier. Generally, it is called as web tier or web servers. Then they want application logic should run on application tier. And then they want database should be run on database tier, the database servers. In this example, the same thing you will copy, replicate here. From 2 web servers, 2 application server, 2 database servers. So on the web server, obviously the service that you are going to use is EC2. For application tier also, you are going to use EC2 machine. For database, in this right now, you are going to use RDS server. RDS is one of the database services. Now look at this, how many load balancer we need. So here we will need 2 load balancers. 1 load balancer we will need here, and 1 load balancer we will need here. The green color will be a load balancer, elastic load balancer. This is also elastic load balancer. But there is something called as scheme. The scheme of green color is internet facing. This load balancer is internet facing. And the scheme of second load balancer is internal. Now what would happen? From your public internet, when people will send request, so you have gateway. I forgot to make that. This is internet gateway. Okay. So when your people will send a request will come to the first load balancer. It will distribute the request, whatever requests are coming. It will distribute request to the available red color EC2. That is the first layer. And then the red color EC2's requests would be forwarded to internal load balancer. Internal load balancer will distribute them to the second tier. From the second tier to the database, there is no load balancer required, because I told you already, database has endpoint which always connected to one server, which is called active server. And this is standby. So EC2s are always connected to only one server through the endpoint. So that is why the diagram looks like this. In case the first server is down, then the endpoint will redirect to second server. So that's why load balancer is not required before the databases. I hope it makes sense now. In the multi-tier architecture, except the database tier, if you just forget about database tier, in remaining tiers, we will require elastic load balancers. Okay. So Oscar says, are we going to do a practice in the AWS dashboard with this, or in fundamental, it's not necessary? Oscar, I will walk you through with what are the existing default VPCs are there, how do they look. However, we will do the actual practical in solution architect training. Okay, next question. Khalid says, for example, in subnet A, the front end is deployed, and in subnet B, it's the server instance. Okay, front end, yeah. Yes, both are applications. Only on the first subnet, it is just the user interface. And the second subnet, it is the backend server, which has application logic running, but it is again an application, it is not database. The subnet C will have database, Khalid. Mega says, do you mean a server when you say endpoint? Okay, that's a good question, Mega. Server and endpoint are 2 different things. Endpoint is like URL. Mega, endpoint is not server. Endpoint is a URL, the way you can connect to the server. Okay, Mubin says, can you please explain scheme again? Mubin, the first ELB, What is the scheme of first ELB? Is it receiving the request from? I'm asking you a question, Mubin. The first ELB, where it is receiving the request. You're saying a wrong answer. Where it is receiving the request from. So from where the requests are coming? Yes, exactly. You're right. Brilliant. So it is receiving the request from internet. That is why it is called internet facing. You got it? Internet facing load balancer. Okay. Fine. Then the second load balancer, where it is receiving request from inside the VPC. It is not from internet. It is opposite. It is from inside VPC. Probably from web tier. No, Mubin. It is not receiving request from load balancer. Do you see the diagram? Is there any arrow between the two load balancer? No, absolutely not. The first load balancers requests are forwarded to the web tier EC2s, and from EC2s the new requests are coming to the second load balancer, right? So the question is, the second load balancer, it is receiving the request from inside the VPC. Am I right? From where the requests are coming? From inside the VPC. That is why it is called as internal facing load balancer. Internal. It is internal to VPC. That's all. I hope I have answered your question, right? Great. So let's go to the next question. Dheeraj, web tier or public subnet? That's a good question. So here, subnet A, subnet B, and subnet C. What are your opinions? Who should be public? Who should be private? Okay, A public, B and C private. Well, the answer, what I believe is, what you were thinking, like, let's make the first tier as public and the remaining as private. But what I think is, let's make everybody as private. No one as public. So you'll be like, why, sir? Because you tell me, the load balancer is receiving the request from internet. It's not web tier who is receiving requests. Look at the diagram and arrow. When you have load balancer, who is getting the request from internet? It's not web tier. So why you are putting it in the public subnet? You don't need that. You can keep everybody in private subnet. All right. The next is from Manoj. Manoj says, no, both the subnet being, okay, that is already discussed. Zakir says, are the ELBs not part of the subnets or they are external to subnets? So basically, Zakir, load balancer are not launched inside the subnet. Okay. They are not launched inside any subnet. They are spanning across the subnets, but they don't get launched inside it. So my next question to you. Okay. So when you have a load balancer, it will generate a DNS URL. Now let's focus on DNS URL of load balancer. Okay. And we have learned and discussed that everybody sitting here will be hitting that URL. But do you know the DNS URL of load balancer? The DNS URL of load balancer is very, very long. And it is very random. Well, if it is like that, do you think you'll be able to advertise it in for your end customers that if you want to do shopping, please hit this website? It doesn't make sense, right? We have our domain names. Let's discuss about domain names. Well, if you have created an architecture and you want people to visit that website, well, what you want is you want a domain name. I have one question from everyone sitting here. Do you understand what is meant by domain name? Okay. So when you hit a website, you type www, let's say amazon.com. It's a domain name. In our layman language, we call it as website URL, right? Okay. It's not the name of the application. It's a website, or it's like the domain. But anyways, for understanding, it's correct. All right. But I have simple question. Okay, few questions to you. You, as an end customer, what do you understand? You understand English? That's why you understand what is meant by www.google.com. You easily understand because this is your language. But you tell me the server on which your Google website is running. Hey, this is Google server. Okay. So if this is running over this, so this is machine. It is a part of network. So do you think that the machines in the network, whether they understand English? Do you think that? I think no, absolutely. They understand something called as IP address. Machines get identified in the network by IP addresses. Well, this server must be having some IP. Let's say 120.17.51.12. This is the IP address. So, well, if this is like that, will you advertise? Will you advertise like if you want to do shopping, please visit 120.17.51.12? Does it work like that? No. You always tell to the public, okay, you want to visit our website, hit the domain name. So the problem is people understand domain, computer understand IP. So you require a system called as DNS. You require DNS servers who can help to map. Like what is google.com? It's 120.17.51.12. DNS stands for domain name system. This DNS server act as a kind of translator who can help you to map domain names to the IP addresses. And we know that, you must have heard of GoDaddy, Hostinger. These are third-party websites, right? These are acting as the DNS servers. They help you to purchase a domain, register the domain. They help you to map your website with the IP address, right? Similarly, in AWS, we have a service called as Route 53. And we will use this service. We will learn this service. Why? Because in case if you want to have our cloud native domain name system service, we don't want to rely on external one. We want to use something which is the AWS product. Then AWS has provided that particular solution in with the Route 53 service. What they say that if you use Route 53, you will be able to register your domain. Register means you can purchase a domain. Suppose I can purchase raj.com. I can purchase this domain from Route 53 and then I can map this domain to particular IP address. So what would happen if somebody hits raj.com, it should map to this server. So you tell me if you have load balancer, okay, whose URL is like this, would you like to use Route 53 to map, for example, www.raj.com? This is your actual domain. So with the help of Route 53, you will map this to this. You understand? You will be able to create such a mapping. And with the help of which, what would happen? Your actual customer sitting in public internet, what they will hit on their browser? What will they hit on their browser? Tell me. Raj.com. Raj.com they will hit raj.com, and that will be, with the help of Route 53, that will be mapped to the DNS URL.
Our first topic is understanding IT fundamentals. The first step includes understanding and building a strong base of IT concepts like how networks work, TCP, IP, OSI model, different operating systems like Windows and Linux, and how we manage data. This starting point will make it easier for you to understand cloud computing. Moving on to the second step, which is learning cloud basics. This includes learning about cloud computing's main features, its different services models they provide, like infrastructure as a service, platform as a service, and software as a service, deployment models like public, private, and hybrid. which will help you understand how cloud computing changes the way business work. Get to know the main cloud platforms like AWS, Azure, and Google Cloud. Understand what basic services they provide, such as computing, storage, and networking. These basics are very important for you to start your journey to become a cloud engineer. Now we will move on to the third step, which is gaining programming skills. Well, to become a cloud engineer, we do not need any coding background, but having considerable programming skills will certainly help a lot. Learning any of these programming languages like Python or Java will let us automate our tasks and work with AWS, improving our abilities as a cloud engineer. We have now covered the basic fundamentals and learned essential programming skills. We will now be looking ahead to the fourth step, which is diving into AWS services. The first step includes learning about AWS services and the tools that every cloud enthusiast needs to know. First of all, let's talk about compute services like EC2 and Lambda that allow us to run our applications and code effortlessly. Installing Linux operating system, creating directories, and installing packages is a must. AWS provides reliable storage options such as S3, AWS, and EFS, where we can securely store our data. It also uses other services for networking such as VPC and security groups to connect and secure our resources seamlessly. Also for managing our cloud environment with the use of tools like CloudWatch and CloudTrail help us monitor, track, and automate services effortlessly. Finally, using containerization technologies such as Docker and tools for managing containers like Kubernetes is very important. After learning all these services, we have almost achieved 90% of our journey. We will now talk about the cloud security. Cloud security is very important. Using identity and access management, encryption and access control make sure that our data stays safe. After ensuring cloud security, we have understood AWS services. We will now move on to the next step, which is using DevOps with AWS. So in this step, we will learn about using DevOps principle to automate setting up infrastructure and deploying applications by using tools like Terraform and CloudFormation. These tools help us to make our configuration much more easier. Well, after learning all these topics, you are all set to go. But wait, do you know having considerable knowledge without certification is not sufficient for you to become a cloud engineer? Let us see how. AWS cloud certifications are very important, and the question is, why should you get one? Well, certifications prove that you have knowledge about AWS. Having knowledge without certification is like flying a plane without pilot's license. Missing such certifications might hold you back from getting your dream job, especially if you have no work experience. Getting certified will help you validate your skills and make you stand out to employers. In short, we can say that AWS certifications are very important as they validate our skills, open doors to new opportunities, and also show dedication to growth. We now know the importance of certification. So in the next step, we will talk about some real-world projects in cloud computing. One way to gain practical experience is by working on personal or open source projects. We can create and set up a virtual machine, use different tools like Terraform and deploy them in our web app. Also, we can create cloud storage solutions. These projects will allow us to apply whatever we have learned in the real world. Another approach is to implement solutions in a cloud environment to solve real-world problems. By working on the actual challenges faced by businesses or organizations, we will get hands-on experience and learn how to effectively deploy cloud technologies to address these issues. Till now, we have covered all the essential steps. We have almost completed our journey. Well, we are all set to apply for jobs. But before that, remember, networking with professionals via LinkedIn, freelance gigs, building portfolios, and collaborating on projects to learn and grow together are very important to land your dream job. Finally, we can start a job search, prepare for interviews, and confidently secure our dream job as a cloud engineer.
Now, let's get started with the first subheading, that is, who exactly is an AWS DevOps engineer? The answer for this question is, an AWS DevOps engineer is a professional who combines expertise in AWS, that is Amazon Web Services, with the DevOps principles to streamline software development and infrastructure management. They design, implement, and maintain cloud-based solutions leveraging AWS services like EC2, S3, and RDS. DevOps engineers automate processes using tools such as AWS CloudFormation and facilitate continuous integration and deployment pipelines. Their role focuses on improving collaboration between development and operations teams, ensuring efficient, reliable, and secure software delivery. With skills in infrastructure such as IAC or infrastructure as code, containerization, scripting, and continuous integration, AWS DevOps engineers play a critical role in optimizing cloud-based applications and services. And that's exactly an AWS DevOps engineer. Now, moving ahead, we will discuss the important skills required to become an AWS DevOps engineer. The role of an AWS DevOps engineer requires a combination of technical and non-technical skills. Here are the top 5 skills that are crucial for an AWS DevOps engineer. Starting with the first one, AWS expertise. Proficiency in AWS is fundamental. DevOps engineers should have a deep understanding of AWS services including EC2, S3, RDS, VPC, and much more. They should be able to design, implement, and manage cloud infrastructure efficiently. The next one is IAC or infrastructure as code. IAC tools like AWS CloudFormation or Terraform are essential for automating the provisioning and management of infrastructure. DevOps engineers should be skilled in writing infrastructure code and templates to maintain consistency and reliability. Third one is scripting and programming. Knowledge of scripting languages, example Python, Bash, and programming languages is important for automation and custom scripting. Python in particular is widely used for tasks like creating deployment scripts, automating AWS tasks, and developing custom solutions. Next one is containerization and orchestration. Skills in containerization technologies such as Docker and container orchestration platforms like Amazon ECS or Amazon EKS are vital. DevOps engineers should be able to build, deploy, and manage containerized applications. Now the fifth one is CI/CD pipelines or continuous integration and continuous deployment. Proficiency in setting up and maintaining CI/CD pipelines using tools like AWS Code Pipeline, Jenkins, or GitHub CI/CD is crucial. DevOps engineers should understand the principles of automated testing, integration, and continuous deployment to streamline software delivery. Effective communication and collaboration skills are essential, as DevOps engineers work closely with DevOps development and operations teams to bridge the gap between them and ensure smooth software delivery and infrastructure management. Problem-solving skills, the ability to troubleshoot issues, and a strong understanding of security best practices are also important for this role. DevOps engineers need to be adaptable and keep up with the evolving AWS ecosystem and DevOps practices to remain effective in their role. Moving ahead, we will discuss the roles and responsibilities of an AWS DevOps engineer. The roles and responsibilities of an AWS DevOps engineer typically revolve around managing and optimizing the infrastructure and development pipelines to ensure efficient, reliable, and scalable operations. Here are the top 5 roles and responsibilities of an AWS DevOps engineer. Starting with the first one, that is IAC management. DevOps engineers are responsible for defining and managing infrastructure using IAC tools like AWS CloudFormation or Terraform. They create and maintain templates to provision and configure AWS resources, ensuring consistency and repeatability. Next one is continuous integration and deployment. Continuous integration and continuous deployment, or also known as CI/CD, is very critical. DevOps engineers establish and maintain CI/CD pipelines, automating the build, test, and deployment processes. They use AWS Code Pipeline, Jenkins, or similar tools to streamline the delivery of software and updates to production environment. Next is server and containerization management. DevOps engineers work with AWS EC2 instances, ECS, EKS, and other services to manage servers and containers. They monitor resource utilization, configure autoscaling, and ensure high availability and fault tolerance. Managing and logging is the fourth one. Monitoring is a critical responsibility. DevOps engineers set up monitoring and alerting systems using AWS CloudWatch, analyze logs, and respond to incidents promptly. They aim to maintain high system availability and performance. Security and compliance is the fifth one. So security is a priority. DevOps engineers implement and maintain security best practices manage AWS identity and access management, that is IAM policies, and ensure compliance with regulatory requirements. They often work with AWS services like AWS Security Hub and AWS Config to assess and improve security. AWS DevOps engineers are involved in optimizing costs, ensuring disaster recovery and backup strategies, and collaborating with development and operations teams to enhance communication and collaboration. They may also assist in automating routine tasks and prompting a culture of continuous improvement and innovation within the organization. Now, the most important aspect of today's session, that is how to become or the roadmap to become an AWS DevOps engineer. The AWS DevOps roadmap provides a high-level guide for individuals or teams looking to adopt DevOps practices in the context of Amazon Web Services. DevOps is a set of practices that combine software development, dev, and IT operations, ops, to enhance collaboration and automate the process of software delivery and infrastructure management. AWS offers a range of services and tools to support AWS practices. Here is a roadmap to help you get started with AWS and DevOps. Creating a roadmap for AWS DevOps in 10 steps can help you guide your journey towards implementing DevOps practices on the Amazon Web Services platform. The first one is understand DevOps principles. Start by gaining a solid understanding of DevOps principles and practices. DevOps is about collaboration between development and operations team to automate and streamline the software delivery process. Second one is learn AWS fundamentals. Get acquainted with AWS services and understand the basics of cloud computing, including compute, storage, and networking services. AWS offers a wide range of services that can be leveraged in your DevOps processes. Third one is set up your AWS account. Sign up for an AWS account and configure billing and security settings. You may also want to consider using AWS organizations for managing multiple accounts and AWS identity and access management for user access control. Fourth step is source code management. Implement source code management using a tool like Git and host your code repositories on a platform like AWS Code Commit or GitHub. Learn about version control best practices. The fifth step is continuous integration. Set up a CI/CD pipeline using services like AWS Code Pipeline, AWS Code Build, or Jenkins. Automate the building, testing, and deployment of your code. Sixth one being infrastructure as code or IAC. Embrace IAC principles to manage your AWS resources. Use tools like AWS CloudFormation, Terraform, or AWS CDK to define and provision infrastructure as code. Seventh step being deployment and orchestration. Use AWS services like AWS Elastic Beanstalk, AWS Elastic Container Service or ECS, or Kubernetes on AWS, also known as EKS, for deploying and managing your applications. Orchestrate these deployments using AWS step functions or other automation tools. Now the eighth step is monitoring and logging. Implement robust monitoring and logging services using services like Amazon CloudWatch and AWS CloudTrail. Create dashboards, set up alarms, and analyze logs to gain insights into your application's performance and security. Now the ninth one, security and compliance. Focus on security by following AWS best practices using AWS Identity and Access Management IAM effectively and automating security checks for AWS Config and AWS Security Hub. Ensure your infrastructure and applications are compliant with industry standards. Now, the last step, continuous learning and improvement. DevOps is an ongoing journey of improvement. Continuously monitor and optimize your DevOps pipeline, incorporate feedback, and stay updated on new AWS services and best practices. Ensure a culture of learning and innovation within your team. Remember that this roadmap is a high-level guide and the specific tools and services you choose may vary based on your project's requirements. DevOps is your culture of collaboration and automation. So adapt your DevOps practice to best suit your team's needs and the AWS services that you use. Now moving ahead, we will discuss the salary compensations being offered to an AWS DevOps engineer. Now, if you are in India and a beginner in AWS DevOps domain, you can expect salaries ranging from 3 lakhs to 6 lakhs per annum. If you're an intermediate candidate with minimum 2 years of experience, then you can expect salaries ranging from 6 lakhs to 12 lakhs per annum. If you are an experienced candidate with more than 4 years of experience, the minimum salary you can expect is 12 lakhs and it can go all the way up to 20 or more based on the project you're working with, company you're working with, and the location. Now, if you are in America and if you are a beginner in AWS DevOps domain, then you can expect an average salary of $80,000 to $120,000 per annum. And if you are an intermediate candidate with minimum 2 years of experience, then you can expect salaries ranging from $120,000 to $150,000 per annum. If you are a highly experienced candidate, maybe with 4 or more than that, you can expect salaries ranging from $150,000 to $200,000 per annum. And again, it might also go up based on the project you're working with, based on the company you're working with, and in the location. Now, moving ahead, we will discuss the next important and also the last important topic of today's discussion, that is the companies hiring AWS DevOps engineers. There are a lot of companies hiring AWS DevOps engineers, but the prominent players in this particular field is Amazon Web Services, Google, Microsoft, IBM, Oracle, Netflix, Adobe, Cisco, Slack, Salesforce, Deloitte, and much more.
So first is, why get AWS certification? So AWS certification is a recognized validation of your proficiency and understanding of AWS services. Acquiring AWS certification offers various advantages, including distinguishing yourself from other candidates in the highly competitive cloud computing industry, then elevating your earning potential and career prospects, as AWS certified professionals are sought after and typically receive higher salaries than their non-certified counterparts. Then granting access to a supportive community comprised of AWS experts, mentors, and peers. This community provides a platform for networking, sharing the best practices, and mutual learning, improving your practical skills and confidence in utilizing AWS services. The certification exams are crafted to access your hands-on experience and problem-solving capabilities, and establishing a pathway for continuous growth. Given that AWS offers a range of certification levels and domains from foundational to specialty, pursuing these certifications enables you to advance your knowledge and career in the field. So this was about why get AWS certification. Now let's move on to understand about the AWS certifications. So AWS currently provides a total of 13 certifications comprising of 7 core certifications and 5 specialty certificates. The core certifications are categorized into 4 levels: foundational, associate, professional, and specialty. The progression begins with the foundational level, followed by the opportunity to advance to associate and professional certifications. Now, under foundational certifications, there is AWS Certified Cloud Practitioner. Then under associate certifications, there is AWS Certified Solutions Architect, then AWS Certified Developer, AWS Certified SysOps Administrator, AWS Certified Data Engineer. These comes under associate level. Next is the professional certificate. Now under professional certificate, there is AWS Certified Solutions Architect, then AWS Certified DevOps Engineer. Then next is specialty certificate. Specialty AWS certifications that are more specialized focus on specific AWS services. These certifications include AWS Certified Machine Learning, AWS Certified Advanced Networking, AWS Certified Data Analytics, AWS Certified Security, AWS Certified Database, AWS Certified SAP on AWS. So these are the specialty certifications. Alright, so let's start with the foundational level certification. The AWS Certified Cloud Practitioner is designed for beginners without prior AWS experience, covering fundamental aspects like cloud services, architecture, pricing, and basic security. It requires no prior experience. This certification serves as a strong starting point, offering a solid foundation in AWS concepts. Exam domain include cloud concepts, security, compliance, technology, and billing and pricing. Exam format includes multiple choice questions. Duration is 90 minutes and cost is $100. And here is $100 US. Now coming to the associate level certification. So under associate level, there is AWS Certified Solution Architect. So let's start with this one. The AWS Certified Solution Architect is ideal for individuals pursuing roles such as Cloud Solutions Architect or Cloud Engineer, with a focus on architecturing secure and scalable AWS solutions. The certification covers core AWS services and best practices and requires at least 1 year of hands-on experience of AWS. Earning this in-demand certification unlocks various job opportunities, emphasizing the ability to design secure, high-performing, and cost-optimized architectures. So the exam format is multiple choice question again. The duration is 130 minutes and the cost is $150. So the next associate certification is AWS Certified Developer. So the AWS Certified Developer certification is designed for developers and software engineers engaged with AWS. Participants gain expertise in developing applications on AWS, integrating services and optimizing application performance. With a prerequisite of at least 1 year of AWS experience, this certification is essential for mastering crucial skills in cloud development, making it valuable for those focused on building applications on the AWS platform. In this, the exam format is again MCQ, and the duration is 130 minutes, and the cost is again $150. You can also give practice exam in $20. Now coming to the next associate certification, which is AWS Certified SysOps Administrator. So this certification is designed for system administrator, operations professionals, and individuals overseeing AWS systems, with a recommended minimum of 1 year of AWS experience. This certification validates expertise in key domains like monitoring, logging, and remediation, reliability, deployment, security, networking, and cost optimization, affirming proficiency in AWS operational tasks. So of this certification, exam format is like MCQ again. Duration is 130 minutes, and again $150 is the cost. Coming to the next one, which is AWS Certified Data Engineer. Alright, so the AWS Certified Data Engineer certification is designed for data engineers with AWS pipeline experience, data scientists seeking AWS data expertise, and professionals validating their data engineering skills, with a recommended of experience of 2 to 3 years in data engineering and 1 to 2 years in AWS data services, along with the familiarity in scripting and SQL. This certification offers industry-recognized validation, increased earning potential, and a competitive edge in the job market, ensuring a future-proof data engineering career. The certification consists areas such as data ingestion and transformation, data store management, data operations and support, as well as data security and governance. The exam format is again MCQ, and the cost is $150. So this was about these associate level certifications. Now let's understand about the certifications that come under professional certificate. Alright, so professional level certifications, let's first start with AWS Certified Solution Architect. Yes, the AWS Certified Solution Architect is ideal for experienced solutions architect seeking advanced skills in multi-tier applications, high availability, disaster recovery, and addressing organizational complexity, with a recommended of 2 years of AWS experience. This professional level certification demonstrates deep expertise in AWS architecture, covering solution design and continuous improvement and workload migration. For this certification, the format is MCQ and the duration is 180 minutes and the cost is $300. Alright, if you want to give the practice exam, then it's $40 for this exam. Alright, so now let's move on to the next professional certificate, which is AWS Certified DevOps Engineer. So the AWS DevOps Engineer certification is designed for DevOps engineers, system administrators, and those emphasizing continuous delivery. With a focus on advanced practices, including automation, security, and optimization, it requires 2 years of AWS experience and is valuable for emphasizing DevOps culture and practices in an AWS environment. Topics include SDLC automation, configuration management, IAC, resilient cloud solutions, monitoring logging, incident and event response, and security compliance. The exam format is multiple choice questions, duration is 180 minutes, and the cost here is $300. So this was about the professional certificates. Now the specialty certifications. So the AWS offers a total of 6 specialty certifications. It is essential to possess a profound understanding of the selected domain, since the examination difficulty level of these certifications is notably elevated. Expert certifications are designed for domain expert. AWS specialty certifications focus on networking and data analytics, security, machine learning, or database management. Recommended for individuals with 2 to 5 years of hands-on experience in their chosen specialty. These certifications enable a deep dive into AWS domains, showcasing specialized expertise in the field. So these certifications are AWS Certified Machine Learning, AWS Certified Advanced Networking, AWS Certified Data Analytics, AWS Certified Security, AWS Certified Database, AWS Certified SAP on AWS. Alright, so these are the specialty level certifications. Now let's understand how to prepare for the exams. So AWS Skill Builder. First of all, we have this. Boost your skills with AWS Skill Builder for hands-on practice to get ready for certification exams. This is one of the best sources. Alright. Now coming to the next one, which is AWS white papers. So read AWS white papers to understand key concepts and reinforce your knowledge for exam preparation. After that, you can also go for online courses. Take online courses designed for AWS certification preparation, providing interactive learning for a thorough understanding. You can also have a look at Simplilearn's Cloud Architect Masters program, which will help you in the preparation. Alright, now talking about some tips. So the first tip is read question twice. Ensure clarity by reading questions twice to grasp the details and answer accurately during the AWS certification exam. Then next is build your practical knowledge. So strengthen your understanding through practical application, as hands-on experience is crucial for success in AWS certification. Also, don't spend too much time. Don't spend too much time on each question. Manage your time wisely. Avoid overthinking. If a question seems challenging, move on and return later if needed during the AWS certification exam. Alright, now go for AWS practice exams. Opt for practice exams to familiarize yourself with the exam format and access your readiness, helping boost your confidence for the actual certification test. So these are some tips that you can keep in mind. So as we conclude our AWS certification roadmap, we have covered the significance of AWS certifications and delve into the foundation, associate, professional and specialty levels. Detailed information on each certification, including who should pursue them, has been provided. By understanding the why, what and how of AWS certification, you are well prepared to navigate the certification landscape. Best wishes as you embark on this journey, armed with knowledge to achieve success in your AWS certification pursuits.
On AWS versus Azure versus GCP.
Talking about market share, Amazon Web Services leads with around 32% of the worldwide public cloud share.
Azure owns up to 16% of the worldwide market share.
And GCP owns around 9% of the world's market share.
Let's talk about each of these service providers in detail. AWS provides services that enable users to create and deploy applications over the cloud. These services are accessible via the internet. AWS, being the oldest of the lot, was launched in the year 2006.
Azure, launched in 2010, is a computing platform that offers a wide range of services to build, manage and deploy applications on the network using tools and frameworks.
Launched in the year 2008, GCP offers application development and integration services for its end users. In addition to cloud management, it also offers services for big data, machine learning, and IoT.
Now let's talk about availability zones. These are isolated locations within data center regions from which public cloud services originate and operate. Talking about AWS, they have 69 availability zones within 22 geographical regions. This includes regions in the United States, South America, Europe, and Asia Pacific. They are also predicted to have 12 more additions in the future.
Azure, available in 140 countries, has over 54 regions worldwide grouped into 6 geographies. These geographical locations have more than 100 data centers.
GCP is available in 200 plus countries across the world. As of today, GCP is present in 61 zones and 20 regions, with Osaka and Zurich being the newly added regions.
Now let's talk about pricing. These services follow the pay-as-you-go approach. You pay only for the individual services you need for as long as you use them without requiring long-term contracts or complex licensing. Now on screen, you can see the pricing for each of these cloud service providers with respect to various instances like general purpose, compute optimized, memory optimized, and GPU. Now let's talk about the compute services offered. First off, we have virtual servers. For AWS, we have EC2. It is a web service which eliminates the need to invest in hardware so that you can develop and deploy applications in a faster manner. It provides virtual machines in which you can run your applications.
Azure's virtual machines is one of the several types of computing resources that Azure offers. Azure gives the user the flexibility to deploy and manage a virtual environment inside a virtual network.
GCP's VM service enables users to build, deploy, and manage virtual machines to run workloads on the cloud.
Now let's talk about the pricing of each of these services. AWS EC2 is free to try. It is packaged as part of AWS's free tier that lasts for 12 months and provides 750 hours per month of both Linux and Windows virtual machines.
Azure Virtual Machine Service is a part of the free tier that offers this service for about 750 hours per month for a year. The user gets access to Windows and Linux virtual machines.
GCP's VM service is a part of a free tier that includes micro-instance per month for up to 12 months.
Now let's talk about Platform as a Service or PaaS services. For AWS, Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, and much more. It is used for maintaining capacity, provisioning, load balancing, auto-scaling, and application health monitoring.
The PaaS backbone utilizes virtualization techniques where the virtual machine is independent of the actual hardware that hosts it. Hence, the user can write application code without worrying about the underlying hardware.
Google App Engine is a cloud computing platform as a service which is used by developers for hosting and building apps in Google data centers. The App Engine requires the apps to be written in Java or Python and store data in Google Bigtable and use the Google query language for this.
Next, let's talk about virtual private server services. AWS provides Lightsail. It provides everything you need to build an application or a website along with the cost-effective monthly plan and minimum number of configurations.
In simple words, VM Image is a more comprehensive image for Microsoft Azure virtual machines. It helps the user create many identical virtual machines in a matter of minutes.
Unfortunately, GCP does not offer any similar service.
Next up, we have serverless computing services. AWS has Lambda. It is a serverless compute service that lets you run your code without facilitating and managing servers. You only pay for the compute time you use. It is used to execute backend code and scales automatically when required.
Azure Functions is a serverless compute service that lets you run event-triggered code without having to explicitly provision or manage infrastructure. This allows the users to build applications using serverless simple functions with the programming language of their choice.
GCP Cloud Functions make it easy for developers to run and scale code in the cloud and build event-driven serverless applications. It is highly available and fault-tolerant.
Now let's talk about storage services offered by each of these service providers. First off, we have object storage. AWS provides S3. It is an object storage that provides industry standard scalability, data availability, and performance. It is extremely durable and can be used for storing as well as recovering information or data from anywhere over the internet.
Blob storage is an Azure feature that lets developers store unstructured data in Microsoft's cloud platform. Along with storage, it also offers scalability. It stores the data in the form of tiers depending on how often data is being accessed.
Google Cloud Storage is an online storage web service for storing and accessing data on Google Cloud Platform infrastructure. Unlike the Google Drive, Google Cloud Storage is more suitable for enterprises. It also stores objects that are organized into buckets.
Amazon provides EBS or Elastic Block Store. It provides high-performance block storage and is used along with EC2 instances for workloads that are transaction or throughput intensive.
Azure Managed Disk is a virtual hard disk. You can think of it like a physical disk in an on-premises server but virtualized. These managed disks allow the users to create up to 10,000 VM disks in a single subscription.
Persistent storage is a data storage device that retains data after power to the device is shut off. Google Persistent Disk is durable and high-performance block storage for GCP. Persistent Disk provides storage which can be attached to instances running in either Google Compute Engine or Kubernetes Engine.
Next up, we have disaster recovery services. AWS provides a cloud-based recovery service that ensures that your IT infrastructure and data are recovered while minimizing the amount of downtime that could be experienced.
Site recovery helps ensure business continuity by keeping business apps and workloads running during outages. It allows recovery by orchestrating and automating the replication process of Azure virtual machines between regions.
Unfortunately, GCP has no disaster recovery service.
Next, let's talk about database services. First off, for AWS, we have RDS or Relational Database Service. It is a web service that's cost-effective and automates administration tasks. Basically, it simplifies the setup, operation, and scaling of a relational database.
Microsoft Azure SQL Database is a software as a service platform that includes built-in intelligence that learns app patterns and adapts to maximize performance, reliability, and data protection. It also eases the migration of SQL Server databases without changing the user's applications.
Cloud SQL is a fully managed database service which is easy to set up, maintain, and administer relational PostgreSQL, MySQL, and SQL Server databases in the cloud. Hosted on GCP, Cloud SQL provides a database infrastructure for applications running anywhere.
Next, we have NoSQL database services. AWS provides DynamoDB, which is a managed, durable database that provides security, backup and restore, and in-memory caching for applications. It is well known for its low latency and scalable performance.
Azure Cosmos DB is Microsoft's globally distributed multi-model database service. It natively supports NoSQL created for low latency and scalable applications.
GCP Cloud Data Store is a NoSQL database service offered by Google on the GCP. It handles replication and scales automatically to your application's load. With Cloud Data Store's interface, data can easily be accessed by any deployment target.
Now let's talk about the key cloud tools for each of these service providers. For AWS in networking and content delivery, we have AWS Route 53 and AWS CloudFront. For management, we have AWS CloudWatch and AWS CloudFormation. For development, we have AWS CodeStart and AWS CodeBuild. For security, we have IAM and Key Management Service.
For Microsoft Azure, networking and content delivery, we have Content Delivery Network and ExpressRoute. For management tools, we have Azure Advisor and Network Watcher. For development tools, for management, we have Azure Advisor and Network Watcher. For development, we have Visual Studio IDE and Azure Blob Studio. For security, we have Azure Security Center and Azure Active Directory.
For GCP, we have the following tools. For networking and content delivery, we have Cloud CDN and Cloud DNS. For management, we have Stack Driver and GCP Monitoring. For development, we have Cloud Build and Cloud SDK. And finally, for security, we have Google Cloud IAM and Google and Cloud Security Scanner.
Now let's talk about the companies using these cloud providers. For AWS, we have Netflix, Unilever, Kellogg's, NASA, Nokia, and Adobe.
Pixar, Samsung, eBay, Fujitsu, EMC, and BMW, among others, use Microsoft Azure.
So as seen on your screens, the companies that use GCP are Spotify, HSBC, Snapchat, Twitter, PayPal, and 20th Century Fox.
Let's talk about the advantages of each of these services. Amazon provides enterprise-friendly services. You can leverage Amazon's 15 years of experience delivering large-scale global infrastructure, and it still continues to hone and innovate its infrastructure management skills and capabilities. Secondly, it provides instant access to resources. AWS is designed to allow application providers, ISVs, and vendors to quickly and securely host your applications, whether an existing application or a new SaaS-based application. Speed and agility. AWS provides you access to its services within minutes. All you need to select is what you require and you can proceed. You can access each of these applications anytime you need them. And finally, it's secure and reliable. Amazon enables you to innovate and scale your application in a secure environment. It secures and hardens your infrastructure. More importantly, it provides security at a cheaper cost than on-premise environments.
Now talking about some of the advantages of Azure. Microsoft Azure offers better development operations. It also provides strong security profile. Azure has a strong focus on security, following the standard security model of detect, assess, diagnose, stabilize, and close. Azure also provides a cost-effective solution. The cloud environment allows businesses to launch both customer applications and internal apps in the cloud, which saves on IT infrastructure costs. Hence, it's OpEx friendly.
Let's now look at the advantages of GCP. Google bills in minute-level increments, so you only pay for the compute time you use. They also provide discounted prices for long-running workloads. For example, you use the VM for a month and get a discount. GCP also provides live migration of virtual machines. Live migration is the process of moving a running VM from one physical server to another without disrupting its availability to the users. This is a very important differentiator for Google Cloud compared to other cloud providers. GCP provides automatic scalability. This allows a site's container scale to as many CPUs as needed. Google Cloud Storage is designed for 99.9% durability. It creates server backup and stores them in a user-configured location.
Let's talk about the disadvantages of each of these services. For AWS, there's a limitation of the EC2 service. AWS provides limitations on resources that vary from region to region. There may be a limit to the number of instances that can be created. However, you can request for these limits to be increased. Secondly, they have a technical support fee. AWS charges you for immediate support, and you can opt for any of these packages. Developer, which costs $29 per month, Business, which costs more than $100, and Enterprise, that costs more than $15,000. It has certain network connectivity issues. It also has general issues when you move to the cloud, like downtime, limited control, backup protection, and so on. However, most of these are temporary issues and can be handled over time.
Talking about some of the disadvantages of Microsoft Azure. Codebase is different when working offline, and it requires modification when working on the cloud. PaaS ecosystem is not as efficient as IaaS. Azure Management Console is frustrating to work with. It is slow to respond and update and requires far too many clicks to achieve simple tasks. Azure Backup is intended for backing up and restoring data located on your on-premises servers to the cloud. That's a great feature, but it's not really useful for doing bare metal restores of servers in a remote data center.
Let's now look into the disadvantages of GCP. So when it comes to cloud providers, the support fee is very minimal, but in the case of GCP, it is quite costly. It is around $150 per month for the most basic service. Similar to AWS S3, GCP has a complex pricing schema. Also, it is not very budget friendly when it comes to downloading data from Google Cloud Storage.
So guys, our first service is Amazon EC2, which stands for Elastic Compute Cloud. So basically what it is, Amazon EC2 basically lets you rent virtual computers, which is servers in the cloud. You can use them to run your applications without having to buy your own physical servers. And you'd be questioning that why this service is so important. So guys, the reason is that businesses no longer need to invest in expensive physical servers, which can be difficult to maintain and scale. So EC2 allows companies to adjust their computing power based on the current needs, ensuring they only pay for what they use. This flexibility helps companies to save costs during low traffic periods and manage high demand during peak times, all without worrying about maintaining physical infrastructure. Now, let me propose a case study where a company named Airbnb used EC2. So guys, this was the challenge. Airbnb experienced issues with scaling during high traffic periods, such as holidays and during major events, which leading them to system slowdowns and potential outages. Managing their own server was very costly and time consuming, as they had to predict demand and manually add capacity, which often led to over and under poisoning. Now, I'll explain what over and under poisoning is, but let us first look at what are the issues they faced. The first one, they had the scaling issue, which means that high traffic periods during holidays caused slowdowns and outages. Then there was a problem of server management. Managing physical servers was very expensive and complex. Then they had unpredictable demand. It was very hard to predict traffic spikes, which led them to capacity problems. Then there was manual capacity addition. It also required manual intervention to scale up during their resources. And finally, they had over or under poisoning, which meant that often they had many servers or few servers, which led to wasting resources or causing slowdowns. Now, what was the solution, guys? So after moving to Amazon EC2, Airbnb could automatically scale its infrastructure up and down based on the demand. EC2's pay-as-you-go model allowed them to avoid the cost of over-provisioning and handle peak traffic seamlessly. So guys, there is some statistics which I want to share, that Airbnb infrastructure scaled up by 3x during the peak period using EC2's auto-scaling feature, which led them to zero downtime during high demand seasons. They also reduced infrastructure costs by 20% by paying only for the capacity they needed. Now, let us move to our second service. So guys, our second service is Amazon S3 or Simple Storage Service. What it is, guys? Basically, Amazon S3 is a cloud storage where businesses can store and retrieve any amount of data like documents, videos, and backups. Why it was important, guys? Basically, S3 provides virtually unlimited secure storage that automatically scales with your needs. It eliminates the need for businesses to purchase and manage physical storage hardware. S3 also integrates easily with other AWS services, making it a key component for storing large amount of data like backup application files or even media streaming content. Its high durability is around 99.99%, which ensures that your data is safe and always accessible. Now, let us look at a case study of Netflix. So guys, during 2012, Netflix faced a massive outage due to a failure in their data storage system, resulting in downtime that cost them millions in lost in revenue. Their existing infrastructure could not handle the massive amount of content that required constant maintenance. Now, there are some of the problems with Netflix faced. The first one is massive outage, which means that Netflix experienced a major data storage failure in 2012, Then they had to go through a significant downtime. This outage resulted in millions of dollars in lost revenue. They had inadequate infrastructure. Their existing storage system couldn't handle the large content volume. Then there was scalability issues and also constant maintenance. The infrastructure struggled to scale up with the growing user demand and also caused them a lot of problems. Now, after migrating to Amazon S3, Netflix was able to store massive amount of data. S3's scalability allowed Netflix to handle global content distribution without interruptions or data loss. Now, let me show you some statistics, guys. So, Netflix now streams to over 230 million users globally, with S3 handling 1000 petabytes of video content, approximately. The switch to S3 reduced Netflix data loss risk to near zero and downtime dropped by 90%. So guys, this was one of the case study where Netflix used S3 and this was the amazing result that they got. Now, let us see one of the next Amazon Web Services, which is Amazon RDS or Amazon Relational Database Service. So what it is, guys? RDS is a managed database service that takes care of setting up, maintaining, and backing up databases for you. Why it is important, guys? Because managing databases can be time-consuming. It involves tasks like software updates, backups, and scaling. RDS automates these tasks, freeing up valuable time for businesses to focus on the other core activities. With features like automated backups, multi-zone availability, and easy scaling, RDS helps businesses to ensure their databases are always running smoothly and securely, without the headache of manual intervention. Now, we'll take again the example of Netflix. So guys, during this phase also, Netflix suffered from a critical database outage, leading to a data corruption and millions in losses. Managing on-premises database was very difficult as backups, scaling, and disaster recovery required significant resources and manual effort. Now, these are some of the problems which Netflix faced. The first one was critical database outage, where Netflix experienced a major database failure. Then they had to go through data corruption, where this outage caused significant data corruption. There was massive losses because there was incident resulted in millions of dollars in losses. Then there were some on-premise challenges, like managing their on-premise database was very complex and inefficient. And there was also lack of automation because manual database management increased the risk of failure. So guys, by using Amazon's RDS, Netflix automated database backups, patching, and scaling. RDS multi-agent deployment provided high availability and fault tolerance, which ensured that data losses during the failure outages are very minimal. Now, there is some statistics that Netflix reduced its database recovery time from hours to minutes in using RDS. Their database operational cost also dropped by 50% and due to the automated management features. So see how this service was very useful for Netflix. Now let us move ahead and try to understand our next service, which is AWS Lambda. But before we discuss this service, just a quick info, guys. Simplilearn has got Cloud Architect's Master Program. You can master AWS, Azure, Google Cloud with the Cloud Architect's course. You will build expertise in AWS, Microsoft Azure, GCP with the Cloud Architect certification course. You will also receive exam vouchers, which is included on any Azure course. You will access official AWS authored self-learning content. Plus, you'll also master cloud architectural principles, design, and also deploy scalable service on cloud platforms. So guys, hurry up now and join the course. The course link is mentioned in the description box. Now, let us move ahead in a discussion of what is AWS Lambda. So guys, Lambda lets you run your code in the cloud without having to manage servers. Basically, it automatically scales up when needed and only charges for the time your code runs. Why it is important, guys? Because Lambda allows businesses to run code without worrying about servers or infrastructure, paying only for the compute time used. This means companies can handle fluctuating traffic without having to over-provision servers, which means that it will help in saving cost and reducing complexity. Lambda is ideal for event-driven applications, where tasks are triggered based on the specific events, such as a file upload or a user action. Now, there is a company called iRobot, guys. So, iRobot needed to process large volumes of data from millions of Roomba devices worldwide. Managing servers to handle this real-time data was very complex and expensive, especially when usage fluctuated. Now, there was some problem, guys, with this, that they had high data volume, they had real-time processing problems, they had a problem of server management, then the cost challenges also came up, and the scalability issues. Then iRobot adopted AWS Lambda's serverless architecture to automatically scale based on the number of incoming requests. They no longer had to manage servers or pay for idle time, as Lambda only charges for the exact compute time used. So guys, what was the result? That iRobot saw a 90% reduction in infrastructure cost by using Lambda's pay-per-use model. Lambda processed over 20 million events per day, scaling effortlessly without manual intervention. So guys, these were the success story of iRobot by using the AWS Lambda service. Now let us move ahead and discuss about our next service, which is Amazon CloudFront. So guys, what is CloudFront? Basically, CloudFront is a content delivery network that speeds up the delivery of websites, videos, and other data to the users around the world. Why it is important, guys? Because CloudFront reduces the time it takes to deliver the content to users, particularly those located far from the origin server. This is crucial for businesses that need to provide a fast and seamless experience to global audiences. Whether it's delivering videos, web applications, or large files, CloudFront ensures low latency access, improving the user satisfaction and engagement. So guys, you have heard about a company called Slack. Slack once experienced high latency and slow message delivery for users located far from their data centers. This created delays and inconsistent user experience, especially for global teams collaborating in real time. Now, let us see what were the problems faced by Slack. They had a problem of high latency, where I have told you that users far from Slack's data center experience significant delay in message transmission. The slow message delivery was there. Geographical impact was one of the problems, where the latency issues were more pronounced for global teams collaborating across distant locations. Then, if we talk about real-time collaboration, were also hindered. This delay caused challenges for teams that rely on real-time communication, which finally affected and disrupting the workflow. And finally, they had inconsistent user experience. So guys, by implementing Amazon's CloudFront, Slack was able to cache and deliver content from edge location closer to the users, reducing latency and improving overall performance. CloudFront's integration with AWS Shield also improved security against potential DDoS attacks. Now, after using this service, Slack reduced the latency by 50% globally, providing real-time messaging to 10 plus million daily active users. They also experienced 40% faster file uploads and improved performance for international teams. So guys, this was the success story of Slack. Now let us move ahead and discuss about our next service, which is Amazon EBS or Elastic Book Store. So guys, what it is? Basically, Amazon EBS provides high performance storage for application running on EC2 instance. It is like a virtual hard drive that you can attach to your EC2 server. Why it is important, guys? Because EBS offers fast, reliable, and persistent storage for applications that require consistent, high-performance storage like databases or big data applications. Businesses can scale storage up or down as needed. EBS automatically backs up the data with snapshots, which ensures minimal downtime and data loss. So guys, there's a company called Expedia, which faced performance issues with their existing storage system. It struggled to handle high volume of transactions during peak booking times, leading to slow response times and frustrated customers. They had performance issues, they had high transaction volume problem, like as I've told you, during the booking busy periods. Then they had slow response time where customer experienced slow response affecting their ability to complete bookings efficiently. Then they had the problem during the peak booking. They faced challenges where the problem was basically the performance issues. Now the customers were also frustrated. So what Expedia did was, Expedia migrated their databases from Amazon EBS, which offered consistent low latency performance and automatic scaling to meet high demand periods. EBS also provided robust snapshots backups for disaster recovery. As a result, Expedia improved booking transaction speeds by 35%, ensuring faster response time during their peak travel seasons. They also increased their data through output by 2x, supporting millions of daily searches queries without the delays. So this was a success story of Expedia, guys. Now you'd be excited to know the next success story. So our next AWS service is Amazon VPC, or Amazon Virtual Private Cloud. What is Amazon VPC? Basically, VPC allows businesses to create a secure private network in the AWS cloud, giving them control over how their data and applications interact with the internet. Why this is important, guys? Basically, VPC provides businesses with full control over their cloud network, including IP addresses, subnets, and security. It allows businesses to securely connect their on-premises infrastructure to the cloud and ensures that sensitive data is kept separate from the public internet. For industries like finance and healthcare, this level of security is critical for meeting regulatory compliance. What was the challenge, guys? So there is a company name called Capital One. Capital One needed a secure and scalable cloud solution to manage its sensitive financial data while meeting strict regulatory requirements. Their on-premises infrastructure was expensive to maintain and difficult to scale securely. So guys, they had problems like need for security, scalability challenge, they had a problem of regulatory compliance, they had high maintenance cost, and it was very difficult to scale securely. So guys, by creating an isolated virtual private cloud, Capital One securely migrated its application and data to AWS. VPC gave them full control over their networking environment, ensuring compliance with data privacy regulations while reducing infrastructure costs. Capital One basically reduced their infrastructure management costs by 30% by using the VPC. They achieved 99.99% of uptime for critical applications, thanks to secure, scalable cloud infrastructure of VPC. So guys, this was one success story of Capital One. Now let us look at another Amazon Web Service, which is Amazon IAM, or Amazon Identity and Access Management. What it is, guys? Basically, IAM lets businesses control who can access their AWS resources by setting permissions and user roles. It is important because IAM ensures that only authorized individuals can access sensitive resources, reducing the risk of security breaches. It's a critical tool for controlling access in large organizations where multiple teams need different level of access to cloud resources. IAM also supports multi-factor authentication, which adds an extra layer of security. Now, what is the challenge, guys, which a company named Autodesk faced? So Autodesk had a global workforce, and managing users to access various AWS resources was becoming very complex. They needed a way to ensure that only authorized users could access sensitive data and resources while maintaining security across the board. So they faced a problem of complex user access management. Then there was a need for authorized access. Then there was a global workforce challenge which Autodesk faced. Then they had to also maintain their security standards, and they had a problem of access control. They needed a solution on access control, where a more efficient and a scalable system was required by Autodesk to simplify and secure user access management across the AWS resources. So guys, Autodesk implemented AWS IAM to manage permissions and access control across their global team. With IAM, they created detailed user roles and policies, ensuring secure access based on need and reducing the risk of data breaches. So guys, Autodesk reduced unauthorized access incidents by 60% after implementing IAM. They decreased the time spent on access management by 40% thanks to the IAM's centralized control system. And that was possible So this is how Autodesk solved this problem. Now let us move ahead and discuss about our next service. This is a very amazing service, guys. Its name is Amazon SQS or Amazon Simple Queue Service. Basically, Amazon SQS is a messaging service that allows components of systems to communicate with each other by sending and receiving messages between distributed applications. Why it is important, guys? Because SQS allows systems to scale independently by decoupling tasks, meaning different parts of an application can work on their own schedule without being dependent on one another. It's useful for batch processing, event-driven applications, and microservices. I know it sounds a bit of a technical jargon, but these are some of the scenarios where SQS is used. So guys, you have heard about this famous company called Disney Plus. Disney Plus faced challenges in managing their large volume of user requests, especially during their release of popular shows and movies. Handling real-time requests without overloading the system was a constant issue. They faced problems like high user request volume, real-time request handling, then system overload risk was there because the platform constantly struggled with the risk of system overload during peak viewing times. Scalability challenges were also there because handling large number of concurrent users required scalable solution. And also consistent user experience means they ensure to have a smooth and uninterrupted experience for all the users during high demand periods, which was not happening. Now, Disney Plus adopted Amazon SQS to queue and process tasks efficiently, decoupling their application components. This ensured that tasks such as streaming requests were processed smoothly, even during high traffic periods. And finally, Disney Plus handled over 1 million requests per second during peak streaming periods, with SQS ensuring no message was lost. The use of SQS improved systems performance by 25%, enabling Disney Plus to deliver uninterrupted streaming experiences. So guys, this is a success story of Disney Plus. Now let us move ahead and discuss about our final service. Can you guess it, guys? Yes, it is Amazon DynamoDB. DynamoDB is a fully managed NoSQL database service that is fast and scalable. It is ideal for applications that need to handle large amount of data with low latency. So this is the thing. Now you would be wondering why DynamoDB is important. So guys, DynamoDB is very essential for applications that experience rapid growth or fluctuating demand. Unlike the traditional databases, they might struggle to keep up the volumes of traffic, but DynamoDB can automatically scale up to handle millions of requests per second. This is just something which I told you. Let me elaborate this by the story of a company called Lyft. So guys, Lyft needed a database that could handle millions of ride requests in real time. But their traditional database systems could not scale efficiently to meet the demand, leading to slow response time during busy hours. They had problems like real-time data handling, scaling limitations they had high request volume, they had slow response times, and also they needed a scalable solution for this problem. Now, here comes the DynamoDB. Lyft switched to Amazon's DynamoDB, which provided fast, scalable, and serverless architecture with NoSQL database services. DynamoDB ability to handle millions of requests per second ensured that Lyft could match drivers with riders in real time without latency. Now, this is the thing which Lyft has seen. Lyft processed over 2 million ride requests per day with DynamoDB, scaling automatically to meet the peak demand. They improved the response time by 70%, ensuring a smooth experience for both drivers and riders. This is how Lyft solved this problem. What amazing service is DynamoDB.
Now I think it would be a good time to talk about what EC2 is. AWS offers plenty of services offered under different domains like compute, storage, database, migration, network, management tools, media services, security, business productivity, application integration, machine learning, game development, and a lot more coming up, out of which EC2 falls under the compute capacity. So what is EC2? EC2 is a web service which aims to make life easier for developers for providing secure and resizable compute capacity in the cloud. With EC2, it is very easy to scale up or scale down our infrastructure based on the demand. And not only that, this EC2 service can be integrated well with almost all the services in Amazon. And out of all this, the best part could be we only pay for what we use. Alright, let's talk about this use case. A use case here is that a successful business owner has a bunch of users and a successful product that's running, and now he has developed a few more products that he thinks will be very successful, that he thinks his customers are going to like. Now, how can he advertise his product to his new and prospective customers? Or the solution for this question can be addressed by AWS. In AWS, we can use services like Simple Notification Service, SNS, and EC2 for compute and S3 for storage. We can, in a way, integrate them all and achieve this business use case. And that sort of got this business owner very cheered up, and now he wants to use the service and he wants to get benefited from the service. He wants to advertise or he wants to notify his users every time the company creates a newsletter. Alright, so let's talk about what it would take to get this environment up and running, or what it would take to connect the environment and put the applications on top of it. Firstly, we would require an AWS account, and then for compute capacity, we would require an EC2 instance. And here's how we go about doing it. The first thing is to create an AMI, which is Amazon Mission Image. That's really the softwares and the application packages we would need to run our application. And the second is to choose the hardware. In here it's the instance type. Depending on the workload, we would be choosing the hardware, and depending on the intents of the workload, we will be choosing the size of the hardware. And finally, we would configure the instances. How many instances do I want? Which subnet do I want them in? And what's going to be the stop or terminate behavior of the instance, and do I want to update any patches when the instance starts running? All those pieces of information go in here when we configure the instance. And then the first three steps is really about the OS volume and the basic hardware. Now it's time to add additional storage to the EC2 instance. That would be step 4. Here we add additional storage to the EC2 instance. And then tags, we use tags, or we would configure tags to easily identify an EC2 instance at a later point. We give it some meaningful names so we can identify, like which team it belongs to, which billing department it belongs to, what's the purpose behind launching this instance, stuff like that. In an environment where we run 700 to 800 or even more instances, identifying an instance and trying to understand who owns the resource, for what purpose we created, it could be an full-time work. So tagging comes to our rescue at that time. After tagging, as step 6, we would configure the firewall, which is also called security group, for the EC2 instance. And this is where we would allow or deny connection from external world to this particular EC2 instance. Well, it works both ways, from outside and from inside out. This firewall blocks the connection based on port number and IP address. And finally, as step 7, we review all the configurations that you have done, and we make sure that the configurations is what we wanted, and finally click on submit. That's going to launch an EC2 instance. Alright, this was just an overview of how to create an EC2 instance. Now let's talk about each and every step in detail. So to begin with, let's talk about how to create an AMI. Well, the AMI is just a template that's used to create a new instance or a new computer or a new VM or a new machine based on the user requirement. The things that go into an AMI are the software, the operating system, the additional applications that get installed in it, stuff like that. The AMI will also contain software information, information about operating system, information about access permission, information about volumes. They all compact in the AMI. Again, the AMI is of two types. One is predefined AMIs, or called Amazon provided AMIs. The other one would be custom AMIs, the AMIs that we create. And if you're looking at a particular AMI that you don't want to create but still want to get it from Amazon, there is a place or a portal called AMI Marketplace. There we get like thousands of AMIs in there available for us to shop and use them on a pay-as-you-go business model and use them as pay-as-you-go billing. So there you can search AMI that you're looking for. Most probably you'll be able to get it there. Now let's talk about choosing the instance type. The instance type is basically the hardware specification that's required for a machine that we're trying to build. And the instance types is categorized into 5 main families. They are, to begin with, it's compute optimized. Now compute optimized gives us lots of compute power or lots of processing power. So if my application is going to require a lot of processing power, I should be picking compute optimized instance. And the second one is memory optimized. Now this is very good for applications that require in-memory caching. There are some applications that performs well with cache or through cache, or the application would create a lot of data that it wants to keep in cache for rereading or for processing, for lengthy processing, stuff like that. For those type of application, this memory optimized instance that comes with in-memory cache is a very good use case. And the third one is the instance that comes with GPU, otherwise called GPU optimized. GPU stands for graphical process unit, and this is very good for application that deals with gaming. This is very good for application that's going to require large graphical requirements. And storage optimized is the fourth option. Just like the name says, this is a very good use case for storage servers. And the fifth family type is general purpose. Just like the name says, it's for general purpose. If you're not particular about the family, then you generally would end up picking the general purpose, because here the services are sort of equally balanced. You'll find a balance between the virtual CPU and the memory and the storage and the network performance. It's sort of balanced. All the components, all the features that needs to go in a computer are sort of balanced in general purpose. Now these instant types are fixed and they cannot be altered because it's hardware based. We buy hardware. We do not have much control on the hardware that's being used. Well, we have options, but we do not have control on the hardware. And these instant types are divided into 5 main families. They are compute optimized, memory optimized, GPU enabled, storage optimized, and general purpose. Then as third thing, we have to configure the instance. Now here is where I have a lot of options about purchasing. What type of purchasing do I want to do? Do I want to go for a spot instance? Do I want to go for a reserved instance? Do I want to go for an on-demand instance? These are different billing options available, and that's available under configure instance. Not only that, here's where I'm going to put the EC2 instance. Do I want an public IP address assigned to it? Do I want an IAM role attached to it? IAM role is authentication. Or what kind of authentication am I going to provide? And the shutdown behavior. The shutdown behaviors include, do I want to stop the instance when the user shuts down the machine from the desktop, or do I want to simply terminate the instance when the user shuts down the instance from the desktop? So those things go in here, just like the name says, configure instance. A lot of instance configuration options comes in here. That's the third step. And not only that, under the advanced details or advanced tab under configure instance, I can bootstrap the instance with some scripts. Now bootstrap is nothing but the scripts that you want to be run in the instance before it actually comes online. Let's say you're provisioning the instance for somebody else. Instead of you launching the instance and then logging in and running some commands and then handing it over to the other person, you can create bootstrap shell scripts and paste it in a console option available under configure instance, and Amazon is going to take those commands, run it on the instance before it hands over to the user that initially requested for that instance. Now it could be a different user or just you. It sort of automates software installation procedures in the instance that we will be launching. And not only that, there are multiple payment options available under configure instance. The user can pick an instance under normal price, and that instance would apply normal rates applied to it. And there are also options like reserved instance, where the user can pay for an instance upfront before a year or before months, for a span of year or a span of months, and that way they can pay less per hour for using that instance. Not only that, you can also go for spot instance, like bidding for those instances. Whoever bids more they get the instance for that particular time. Well, these instances are a lot cheaper than on-demand instances, and through bidding and buying you can keep the instance as long as your bid price doesn't exceed the price that Amazon is proposing. And as the fourth step, we will have to add storage to the instance that we are about to launch. And here we have a bunch of storage options. I can go for ephemeral storage, which is free, or I can go for an external elastic block storage, also called EBS, which is paid and it's a permanent storage, or else I can integrate my EC2 instance with S3 for its storage needs. And the best part about storage is free subscription users, they get to use 30 gigabit of SSD storage or magnetic storage for the whole year. In this page where we are ready to add storage, we will have to mention or provide the size in gigabit and the volume type. Is it going to be an provisioned volume? Is it going to be an general purpose volume? Is it going to be a magnetic volume? Stuff like that. They are volume types, and we also need to give inputs about where the disk will be mounted and whether this volume needs to be encrypted or not. So all these options or all these inputs are received from us under the adding storage section. And then the fifth option would be adding tags. Like we discussed some time back, tags are very helpful to identify a machine in an environment where we have 700 or 1000 VMs running. And security groups are the actual firewall that sits in front of EC2 instance, and it protects that EC2 instance from unintended inbound and outbound traffic. Now here is where I can fine tune the access to my EC2 instance based on port numbers and based on IP address from which it can be accessed. And finally, we get to review the whole changes or the whole configurations that we have made to find out whether they are intact with the requirement, and then click on submit. That's going to launch an EC2 instance. But hold on, we're not done yet. When we're about to launch, or before the Amazon console actually launches the EC2 instance, it's going to give us an option to create a key pair. Remember, I said it's key pair. Key pair is two things. One is public and private. The private key is downloaded by the user and is kept with the user, and the public key is used by Amazon to confirm the identity of the user. So just go ahead and download the private key and keep it for yourself. And this private key gets downloaded as an .pem file. It's a format of the file, and it gets downloaded as .pem file. And our next step is to access the EC2 instance. And because the instance that we have launched in this example, let's assume it's a Linux instance, and that's going to require a tool called PuTTY to be able to access it. And this PuTTY tool is really needed when we are trying to access an Linux instance from Windows instance. Most of the time, Windows instance will have PuTTY installed in them, but in some rare cases, they do not come with PuTTY. In those cases, we can go ahead and download PuTTY and PuTTY generator, and we can start using it to access the Linux instance. Now you might ask, well, I understand PuTTY, what's PuTTY generator? Now the file that we have downloaded is in .pem format, but unfortunately PuTTY does not accept .pem format as input. It has to be converted into a different format called PPK. And PuTTY Gen is a tool that helps us to convert the .pem file into PPK file. So the quick way to do it is download generator, open it up, click on conversion, and insert the .pem key that we have downloaded and save the private key. And this, when we save the private key, it gets saved as a .ppk type private key. And when that's done, the next very step is to open PuTTY and try to log in. And the way to log in is to open PuTTY, put that IP address here, and then click on auth. This is where we would input the file that we have created. So click on auth and then click on browse and find the .ppk file that we have converted and stored, browse it and upload it, and then click on open. Now that's going to open up a login screen for us. And the AMIs comes with a default username. Depending on the AMI that we have picked, the username might differ. In our case, we have picked an AMI for which the username is EC2-user, and this is the default, by the way. Let's put the username EC2-user and hit enter, and that's going to open up the Linux instance using CLI. There are a few other things that we can do with the terminal that we'll explain it a little later. Alright, so we have successfully launched an EC2 instance, and yeah, give yourself a pat on your back. Launching an instance was just one part of the solution. So let's actually talk about how we can notify our customers. SNS, or Simple Notification Service, is a service or a product in Amazon that helps us to notify customers through email. So navigate to SNS in your account and create a topic, and we're going to use this topic for public notification. So let's make it public and then add subscribers to it. Now these subscribers are the people who you want to be notified about the newsletter. So we already have the email database in there. Add them to the subscribers list, and then they will start getting new newsletters as and when we post them to the topic. And as next step, create a bucket in S3 where you can store content, and in that bucket create an event that triggers a notification to Simple Notification Service. So this is how it will be set up. A notification will be sent to our subscribers anytime we put something in our S3 bucket. So S3 bucket is going to create an event for the notification, and the notification is going to make sure that it's delivered to your end customer because they're already subscribed to the topic as subscribers. And finally, let's connect the S3 with EC2 so the bucket and the AWS instance are in sync. So we put some content in the S3 bucket, our email system notifies our customers, and the customers can go online to a website that's hosted in EC2, and because S3 and EC2 are in sync, the items that we put in S3 will also show up in EC2. See how this is all connected and it's working together. And once this is all connected, our subscribers will regularly be informed anytime we put new content in the S3 bucket, and the same content will be made available in EC2 instance through the website.
So what is S3? S3 stands for Simple Storage Service, and it is an object storage service in Amazon. What this means is that it doesn't matter what kind of file you upload to S3, it will be treated as an abstraction, meaning an object. So you can upload a PDF file, you can upload a JPEG file, you can upload a database backup. It doesn't really matter. All that is abstracted away by the use of storing it within an object. We're going to talk more about what composes an object, but by doing so, what happens is S3 allows us to have industry leading scalability. So it doesn't matter if you're going to make a request for that database backup, let's say that object, 5 times or 10,000 times, that request, that demand will scale. The underlying infrastructure that is implemented behind the scenes is handled for you. So in a sense, it's kind of like a serverless service, a storage service where you're not implicated in handling anything underneath the covers. You're just uploading your objects and accessing them later on. In terms of data availability, very powerful as well, because it takes those objects and will replicate them across at least 3 availability zones. Of course, these availability zones have 1 or more data centers attached to them. So you have lots and lots of copies of your objects distributed globally, or at least at a regional, in a regional area. You can do this as well globally if you enable global replication. And you will see that your level of durability will skyrocket, and you're just not going to worry about losing an S3 object. Data security. Well, we can encrypt our data at rest, our objects at rest. We can encrypt it in transit. We can also come up with security policies at the bucket level, which we're going to talk about what a bucket is very soon. These are going to be implemented through what's called IAM policies, and you're going to be able to control who or what has access to your objects. And of course, because everything is handled underneath the covers, all the servers, all the storage nodes are cloud optimized for the best possible performance. So let's continue on our journey on what is S3. we're going to take a look at what is a bucket and what is an object. As you can see here, you have inside this bucket, which is a logical container for an unlimited amount of objects. You could have objects of different shapes and sizes. Like I said, you could have pictures, database backups, etc. So this is what's being represented here by different shapes. And you can think of a bucket really as almost like a folder where objects or files are placed within them. So there are many ways for us to place objects within a bucket. We can do this through the AWS console, which I'll be showing you very shortly. We can do this via the command line interface, or we can do this through a software development kit. At the end of the day, all those three options go through an API, right? So it's all about picking the right method that is best suited for whatever kind of end user or application that needs access to these buckets and to these objects. Now, once you've got the data or objects within this bucket, you can control pretty much how the data is accessed, how it's stored, whether you want it to be encrypted, and how it's even managed. So you can have organizations that have specific compliance needs. For example, any objects that are placed in there, perhaps some PDFs, are not to be modified or not to be touched for 90 days. Let's say we can imply object locks if we want to. We can imply security guards. We can also, for example, record all API actions that try to access, to list, to delete any kind of API operations on those objects at the bucket level or on the object level. We can record if that is some sort of organizational compliance need for auditing or for whatever internal auditing reason that you may have. So continuing on here, you can see that there are many organizations that use S3. One in point is Amazon itself. S3 is so popular and so durable that Amazon internally uses it to store its own data. You're guaranteed, almost that you're not going to lose any object in there because it has what we call 11 nines durability. Now, 11 nines durability is really an extreme amount of durability where it's mathematically almost impossible for you to lose an object once you place it in S3. You're in fact more liable to get hit by a meteorite than you are to lose an object in S3, statistically speaking, which is a pretty incredible statistic, but it's true. So if we continue here with the benefits of S3, some of these I've already described, but let's talk about the full picture here. We see the performance, scalability, availability, and durability of S3 are really first class in the industry. Again, durability, we were talking about that 11.9. So what that really means is 99.9999 in total. If you count all the nines, that's 11 of those nines. So most durable in the industry by far. And again, because everything is handled underneath the covers, it's a serverless service. They ensure the scalability and availability and the performance of the inner workings of that object level storage. Now, cost is of course always important, and S3 really shows up here with first class support again for cost. It's got very, very low cost. We can have object level storage for let's say a terabyte of object level storage for as little as $1 a month. So again, it will depend on the kind of storage class. We're going to have a discussion on different types of storage classes that we might want to transition or move over our objects from one storage class to the next, depending on how frequently accessed that data is. As you know, data over time seems to get less and less accessed as your needs shift from one place to another. We're going to talk about that coming up very soon. So we're going to want to really focus on that to reduce our end of the month costs for storage with S3. Of course, security is always at the forefront, and we want to make sure that we either simply secure by encrypting everything right off the bat, either at rest, in transit, or we want to put an object lock or just maintain security at the bucket level, maintaining, let's say, who or what has access to that data. Because by default, no one has access to the data unless we open up the door. And also we want to make sure that we don't give public access to our bucket for obvious reasons of giving away important information by mistake. So AWS makes it extremely difficult for you to accidentally do this. And I'm going to show this in a demonstration lab coming up very soon. And we can also query in place, which is very interesting. So you can imagine you putting, let's say, a file that's in CSV format or a JSON format or Parquet format, some sort of structured format or semi-structured format in S3, and you can actually use SQL queries on the spot to filter that data in place at the bucket level. You could also have other services that may want to extract some business intelligence from that data in your S3 bucket directly as well. So some other more advanced querying operations can take place at the S3 level. So this you will learn during your journey with Simplilearn as you're covering all the AWS technology stacks. And here, the most widely used storage cloud service in the industry. Because of all the points that we just covered, it really is the #1 storage or object level storage solution in the industry. Let's now take a look at objects and buckets in S3. So the objects are really the fundamental entities that are stored in S3, or the lowest common denominator, which means that we're not really interested in what kind of data is within the object at the layer of S3, because S3 doesn't have direct access to the data within an object. Like I said before, it's an abstraction of the data. So we don't know if it's a cat picture, if it's a backup of your database. It's just treated as a fundamental entity, aka the object. Now, every object is associated with metadata, so data about itself, things like what's the name of the object, what's the size, the time and date that the object was uploaded. Things of that nature are categorized as metadata. So S3 does have direct access to that. Now, the data within that object, of course, is accessible by other services. So it's not that once you've uploaded it, you've totally lost the data and it's only can be treated as an object. It's just that at this layer, it's simply just assigned metadata and a version ID, a unique version ID. And if you re-upload the exact same object a second or third time to S3, it will have its own version ID number. So a new unique version ID number will be generated. So really what buckets are their logical containers to store those objects. So of course, at an extremely high level, a bucket would be like your root file system, if you want to think about it like that. But that doesn't mean you can't go into this bucket and create separate folders. Now, when you create separate folders in a bucket, because you might want to logically organize all your objects, you might be fooled by the fact that you think this is a hierarchical storage system, when in fact it is not. And I'll talk about that in a second. So you cannot store an object without first storing it into a bucket. So of course, the first step would be for us to create a bucket and then upload objects within that bucket. So an object cannot exist without its container or its bucket. So there's no Windows Explorer view like we're used to in an operating system, because this is not a hierarchical view. No matter if you create folders within folders within folders, in fact, S3's internal architecture is a flat hierarchy. What we do instead is we assign prefixes, which are treated as folders, in order to logically organize our objects within our buckets. And I'm going to showcase a prefix in one of the demonstrations coming up very soon. So when you create, or when you're working with S3, first of all, you're working at a regional level. You're going to have to pick a region. For example, you might pick US East 1 region, or US East 2 region, and the bucket that you're going to be creating will be replicated across several availability zones, but within that region. Also, that data, those objects, can be accessed globally because S3 uses the HTTP protocol. HTTP protocol is very permissive. Everybody knows how to administrate it and work with it. So we just need to give access to that object in terms of a permission policy and give it the proper URL, or give whoever needs access to it the proper URL, and they can access that via HTTP globally. So first, when you're creating a bucket, you have to select the region, and the object will live within that region, but that doesn't mean that it still can't be accessed globally. So let's now take a minute, go over to the AWS console, and actually let me showcase how to create objects and buckets. So for our first lab, we're going to be going and creating an S3 bucket and uploading an object to it. So we first have to log into the AWS console, which we have up here in the address bar. Let's click on either create free account if it's your very first time, or as is in my case, already have an account. We're going to sign in here. You're going to have to pass in your IAM username, password, and your account ID, of course. Once you've logged in, you can search for the simple storage service S3 either by coming up here in the search box and typing S3, and you'll find it there. That's probably the easiest way. Or if you want, you can take a look at all the services and it'll be under storage over here, the first one. Okay, so pick whichever method you see best for yourself. Once we're here, we want to create our first bucket. Now I've already have a couple of buckets here, so we're going to go on and create a new bucket. The very first thing is you have to specify a bucket name. Now this bucket name has to be globally unique. If you take a look here at the region that we're in, it doesn't actually select a specific region. It selects the global option, which means that this bucket will become globally accessible. So that is why it needs to have a unique name, much like a DNS name has to be unique for your website, right? So I'm going to come up here and pick a name that I think is going to be unique. So I'm going to say Simplilearn S3 demo. All right, let's take a look at if that's going to work out. Of course, we have to pick a region, but it is globally accessible. So you either pick a region that's closest to your end users, or in our case, since we're just doing a demonstration, we can do whichever is closer to us right now. Okay, and we're going to skip these options for now. We're going to come back to them later on. We're just going to create the bucket. Now hopefully that was a unique name and allowed me to create that, and it looks like it did. So if I scroll down, you can see that it clearly got created over here. Now we're going to click on that and we're going to start uploading objects to this bucket. So let me click on the upload button, and you can either select one or more files, or you can select an entire folder. So I'm going to just go and select a specific cat picture that I have here. Okay, and again, we'll go through some of those other options later on, and we'll just click upload. Now this should take no time at all because of the fact that it's a very small object or a file that's being uploaded. So it has succeeded. We can close this up. And we see now clearly that the object is in our bucket. If we go to properties, we can see the metadata associated with this bucket. We can see the region that it's in. We can see the ARN, which is the Amazon resource name, which uniquely identifies this resource, this bucket, across the globe. So if ever you needed to reference this, let's say in an IAM policy or whatever other service needed to communicate with S3, you would need this ARN. It's a very important piece of information. And of course, we have the creation date. Some high level metadata. So objects, as we have covered already, consist of not only the data itself, but the metadata. So there's lots of metadata, and there's a lot of other features that we can go here and enable very easily. And this will be the basis of the future demonstrations that I'm going to do. All right. So just to recap what we just did, we created a unique bucket, gave it a name of Simplilearn S3 demo, and uploaded our first object to it. So let's now take a look at the inner workings of the Amazon S3. When we upload an object into a bucket, we have to select which one of these storage classes the object will reside in. So you see I have 6 storage classes here at the bottom, and each have their own characteristics that we're going to get into. By default, if you don't specify anything, it'll get placed in what's called the S3 standard storage class, which is the most expensive out of all these storage classes. Once your object gets colder, and what I mean by colder is your access patterns diminish, meaning that you're accessing that file less and less over the course of time, so it gets colder, you will transition that object from one tier to the next, all the way to, for example, S3 Deep Archive. So again, Deep Archive signifies extremely cold, so maybe you're only referencing this data once a year, once every couple of years. And so you want to have the cheapest possible storage available. So right now you can get about 1 terabyte of storage per month for about $1 a month with S3 Glacier Deep Archive. So you are going to be very interested in knowing how to transition from one or more of these storage classes over time in order to save on your storage costs. That's really why we're doing this. So let's go through some of these storage classes. By default, like I said, whenever you upload an object, you automatically get placed into the standard storage class. So any files that you're working on frequently, daily, this is the best fit for it. You've got the highest level of accessibility and durability as well. Not that the others don't have the same level of durability. However, we'll see how when you transition from one storage tier to the next, some characteristics do change in order for you to save on some costs. We're going to go through some of those. Now, this would be considered hot data, right? Data that's used all the time, maybe just by you, maybe by everybody, right? So that's the perfect place to place it in the standard storage class. Now, over time, like I said, you may find yourself working less and less, perhaps on a document that was due by the end of the month. That document was submitted, and then afterwards you don't work on that document anymore. Perhaps you're only working on revisions based on feedback from your colleagues that are asking you to make some corrections or some amendments, and so only those corrections or amendments come in perhaps once a month. And so in that case, you might find yourself finding a justification for moving that document from the standard tier to the standard IA or infrequently accessed tier. Maybe any objects not modified for more than 30 days are a good fit for that. And that's really the criteria for IA, inactive access, is that S3 or AWS itself recommends to only put objects in there if they haven't been accessed for at least 30 days. So you get a price reduction, a rebate for putting objects that are not accessed frequently in here. Of course, if you remove objects, let's say before the 30-day limit, then you are charged a surcharge for retrieving an object that you said was infrequently accessed, but it really was not. So bear that in mind. If you're going to place objects in infrequent access, be somewhat reasonably assured that you're not going to be going there and accessing them. You can still access those files, no problem, just as quickly. They have the same level of accessibility and durability. However, like I said, anything less than 30 days, you'll get a price ding on that. If you want to have long-term storage, we're talking about Amazon Glacier. So this is more anything over 90 days that hasn't been modified, or 180 days. There's 2 subcategories of Amazon Glacier that we're going to get into. And this is the cheapest storage by far. And Amazon Glacier doesn't really operate through the AWS console as the same as the standard and the infrequent access. You can't really upload objects to Glacier via the console in the browser. you can only do so, let's say, through the command line interface or through an SDK. The only thing you can do on the web console with Glacier is actually create what's called a vault, which is a logical container for your archives. But then after that, you have to go through the CLI or the SDK to do the rest of the work there. If we continue on, there's some gray areas between the S3 standard and the Glacier. One is the one zone infrequently accessed storage class. So if we go back to the regular standard and IA storage class, all of these objects are stored across a minimum of 3 availability zones. If you want a further price reduction, you can store your objects in a one zone IA storage class, which means that instead of taking that object and replicating it across 3 or more availability zones, it will only store it in a single availability zone, therefore reducing the level of availability that you have to that object. So in this case here, if that single availability zone would go down, for example, you would not have access to that object. Once it would come back up, of course, you would. The other thing is if there was an immense catastrophe where the actual availability zone was destroyed, well, of course, then your object is also gone. So if that's something that doesn't worry you because you have already many copies of this object maybe lying around on premise, then this is a good option for you because it's data that you're willing to lose or lose access to for short periods of time if ever that single availability zone goes down. So it's about an extra 20% off the price from already the normal IA standard price. There is another one called the standard reduced redundancy storage. This one is kind of getting phased out as we speak because the same price for this storage class is about the same amount you're going to pay for the normal IA standard class. What this does is, again, is a good fit for your objects that you're not really worried about losing if there is some sort of catastrophe that happens in an availability zone. There's less copies of it that are stored, and so if that data center and that availability zone goes down, then you lose your object. So of course it offered at the time the highest price reduction possible, but now the difference between this one and the normal IA standard storage class is so small in terms of price that you're probably not going to migrate to or navigate to this storage class. But it is still there in the documentation, and it may very well come up still in the certification exam, so at least be aware of that. Let's now take a look at some individual features of S3. Starting off with lifecycle management. So lifecycle management is very interesting because it allows us to come up with a predefined rule that will help us automate the transitioning of objects from one storage class to another without us having to manually copy things over. Of course, you could imagine how time-consuming that would be if we had to do this manually. So we're going to see this very soon in a lab. However, let me discuss how this works. So once it's basically a graphical user interface. It's very, very simple to use once you come up with these lifecycle management rules. But you're going to define two things. You're going to define the transition action and the expiration action. So the transition action is going to be something like, well, I want to transition an object from, maybe it's all objects, or maybe it's just a specific type of object in a folder, example, that has a specific prefix, from one storage class, let's say standard, to standard inactive or infrequent access. Maybe only after 45 days, after at least a minimum of 30 days, like we spoke of before. And then maybe after 90 days, you want to transition the objects in IA to right away Glacier Deep Archive, or 180 days. You come up with whatever combination you see fit, okay? It doesn't have to be sequential from S3 to IA to one zone, etc., because like we discussed before, it depends what kind of objects that you're interested in putting in one zone, objects that you don't really mind losing if that one availability zone goes down. So you're going to be deciding those rules. It ends up that this even is not a simple task because you have to monitor your usage patterns to see which data is hot, which data is cold, and what's the best kind of lifecycle management to implement to reap the benefits of the lowest cost. So you have to put somebody on this job and make the best informed decisions based on your access patterns, and that is something that you need to consistently monitor. So what we can do is we can instead opt for something called S3 intelligent tiering, which basically analyzes your workload using machine learning algorithms. And after about a good 30 days of analyzing your access patterns, we'll automatically be able to transition your objects from S3 standard to S3 standard infrequent access. Okay, it doesn't go past the IA one, it doesn't go after the Glacier and whatnot. Okay, so it can then offer you that at a reduced price overhead. So there is a monitoring fee that is introduced in order to implement this feature. It's a very nominal, very, very low monitoring fee. And the nice thing is if ever you take out an object out of the infrequent access before the 30-day limit, as we spoke of before, you will not be charged an overhead charge because of that. Why? Because you're using the intelligent tiering. You're already paying an overhead for the monitoring fee. So at least in that sense, the intelligent tiering will take the object out of IA and put it back into the S3 standard class if you need access to it before the 30 days. And in that case, you won't be charged that overhead. So that is something that is very good to do in order not to have to put somebody on that job. So yes, you're paying a little bit of overhead for that monitoring fee, but at the other side of the spectrum, you're not investing in somebody working many hours to monitor and put into place a system to monitor your data access patterns. So let's take a look at how to do this right now. Let's implement our own lifecycle management rules. So let's now create a lifecycle rule inside our bucket. First off, we're going to need to go to the management tab in the bucket that we just created. And right on the top, you see right away, lifecycle rule. We're going to create lifecycle rule and we're going to name it. So I'm just going to say something very simple, like simply learn lifecycle rule. And we have the option of creating this rule for every single object in the bucket, or we can limit the scope to a certain type of file, perhaps with a prefix like, I could see one right now, something like logs. So anything that we categorize as a log file will transition from one storage tier to the next as per our instructions. We're doing this because we really want to save on costs. Right? It's not so much of organizing what's your older data versus your newer data. It's more about reducing that storage cost as your objects get less and less used. So in this case, logs are a good fit because perhaps you're using your logs for the first 30 days, you're sifting through them, you're trying to get insights on them, but then you kind of move them out of the way because they become old data and you don't need them anymore. So we're going to see how we can transition them to another pricing tier, another storage tier. We could also do this with object tags, which is a very powerful feature. And in the lifecycle rules action, you have to at least pick one of these options. Now, since we haven't enabled versioning yet, what I'm going to do is just select transition the current version of the object between these storage classes. So as a reminder of what we already covered in the slides, our storage classes are right over here. So the one that's missing is obviously the default standard storage class, which all objects are placed in by default. So what we're going to say is this. We want our objects that are in the default standard storage class to go to the standard inactive access storage class after 30 days. And that'll give us a nice discount on those objects being stored. Then we want to add another transition, and let's say we want to transition them to Glacier after 90 days. And then as a big finale, we want to go to Glacier Deep Archive. You can see the rest are grayed out. Wouldn't make sense to go back. And maybe after 180 days, we want to go there. Okay. Now there's a little bit of a warning or a call to attention here. They're saying if you're going to store very small files into Glacier, not a great idea. There's an overhead in terms of metadata that's added, and also there's an additional cost associated with storing small files in Glacier. So we're just going to acknowledge that. Of course, for the demonstration, that's fine. In real life, you don't want to store very big tar files or zip files that had, one or more log files in there. Okay, that would bypass that surcharge that you would get. And over here, you have the timeline summary of everything we selected up above. So we have here after 30 days, the standard inactive access, after 90 days, Glacier, and after 180 days, Glacier Deep Archive. So let's go and create that rule. All right, so we see that the rule is already enabled, and at any time you could go back and disable this if ever you had a reason to do so. We can easily delete it as well, or view the details and edit it as well. So if we go back to our bucket, now what I've done is created that prefix with the /logs. Since we're not doing this from the command line, we're going to create a logs folder over here that will fit that prefix. So we're going to create logs, create a folder. And now we're going to upload our, let's say, Apache log files in here. So we're going to upload one demonstration Apache log file that I've created with just one line in there, of course, just for demonstration purposes. We're going to upload that. And now we have, we're going to just close that. And now we have our Apache log file in there. So what's going to happen, because we have that lifecycle rule in place, after 30 days, any file that has the logs prefix, or basically is placed inside this folder, will be transitioned as per that lifecycle rule policy that we just created. So congratulations, you just created your first S3 lifecycle rule policy. Let's now move over to bucket policies. So bucket policies are going to allow or deny access to not only the bucket itself, but the objects within those buckets to either specific users or other services that are inside the AWS network. Now, these policies fall under the category of IAM policy. So IAM stands for Identity and Access Management. And this is a whole other topic that deals with security at large. So there are no services in AWS which are allowed to access other services or data, for example, within S3, without you explicitly allowing it through these IAM policies. So one of the ways we do that is by attaching one of these policies, which are written in a JSON format. So it's a text file that we write. At the end of the day, that's the artifact, and that's a good thing because we can use that artifact and we can configuration control it in our source control and version it and put it alongside our source code. So when we deploy everything, it is part of our deployment package. So in this case here, we have several ways of doing this. We can use what's called the policy generator, which is a graphical user interface that allows us to simply click and point and populate certain text boxes, which will then generate that JSON document that will allow us to attach that to our S3 bucket. And that will determine, like I said, which users or services have access to whatever API actions are available for that resource. So we might say we want certain users to be able just to list the contents of this bucket, not necessarily be able to delete or upload new objects into that bucket. So you can get very fine-grained permissions based on the kind of actions you want to allow on this resource. So in order to really bring this home, let's go and perform our very own lab on this. Let's now see how to create an S3 bucket policy. Going back to our bucket, we're now going to go into permissions. So the whole point of coming up with a bucket policy is that we want to control who or what, the what being other services, have access to our bucket and our objects within our bucket. So there are several ways we can go about doing this. Let's edit a bucket policy. One, we can go and look at a whole bunch of pre-canned examples, which is a good thing to do. Two, we could actually go in here and code the JSON document ourselves, which is much more difficult, of course. So what we're going to do is we're going to look at a policy generator, which is really a form-based graphical user interface that allows us to generate, through the answers that we're going to give here, the JSON document for us. First question is, we got to select the policy type. Of course, we're dealing with S3, so it makes sense for us to create an S3 bucket policy. The two options available to us are allowing or denying access to our S3 bucket. Now, in this case here, we could get really fine-grained and specify certain kinds of services or certain kinds of users. But for the demonstration, we're just going to select star, which means anything or anybody can access this S3 bucket. All right. Now, depending on also the actions that we're going to allow. So in this case here, we can get very fine-grained, and we have all these checkboxes that we can check off to give access to certain kind of API action. So we can say we want to give access to, just deleting the bucket, which obviously is something very powerful. But you can get more fine-grained. As you can see, you have more of the getters over here, and you have more of the listing and the putting new objects in there as well. So you can get very fine-grained. Now, for demonstration purposes, we're going to say all actions. So this is a very broad and wide-ranging permission, something that you really should think twice about before doing. We're basically saying we want to allow everybody and anything, any service, all API actions on this S3 bucket. So that's no small thing. We need to specify the Amazon resource name, the ARN of that bucket specifically. So what we're going to do is go back to our bucket, and you can see here the bucket ARN. Okay, so we're just going to copy this, paste it in this policy generator, and just say add statement. You can see here kind of a resume of what we just did, and we're going to say generate policy. And this is where it creates for us, and make this a little bit bigger for us, it creates that JSON document. So we're going to take this, we're going to copy it, and we're going to paste it into the generator. Okay. Now, of course, we could flip this and change this to a deny, right? Which would basically say we don't want anybody to have access, or anything, any other service to have access to this S3 bucket. We could even say /* to also encapsulate all the objects within that bucket. So if I save this right now, you have a very ironclad S3 bucket policy, which basically denies all access to this bucket and the objects within. Of course, this is on the other side of the spectrum, very, very secure. So we might want to, for example, host a static website through our S3 bucket. So in this case here, allowing access would make more sense, right? So if I save changes, you see that we get an error here saying that we don't have permissions to do this. And the reason for that is because it realizes that this is extremely permissive. So in order to give access to every single object within this bucket, as in the case that I was stating of a static website being hosted on your S3 bucket, it would be much better to also at first enable that option. So I'm just going to duplicate the tab here. And once you go back to the permissions tab, one of the first things that shows up is this block public access setting, right? Right now it's completely blocked, and that's what's stopping us from saving our policy. We would have to go in here, unblock it, and save it, right? And it's also kind of like a double clutch feature. You have to confirm that just so you don't do that by accident, right? So now what you've effectively done is you've really opened up the floodgates to have public access to this bucket. It's something that can't be accidentally done. It's kind of like having to perform these two actions before the public access can be granted. Now, historically, this was something that AWS was guilty of, was making it too easy to have public access. So now we have this double clutch. Now that this is enabled or turned off, we can now save our changes here successfully. And you can see here that now it's publicly accessible, which is a big red flag that perhaps this is not something that you're interested in doing. Now, if you're hosting a public website and you want everybody just to have read access to every single object in your bucket, yes, this is fine. However, please make sure that you pay very close attention to this type of access flagged over here on the console. So congratulations, you just got introduced to your first bucket policy, a permissive one, but at least now you know how to go through that graphical user interface through the policy generator and create them and paste them inside your S3 bucket policy pane. So let's continue on with data encryption. So any data that you place in S3 bucket can be encrypted at rest very easily using an AES 256 encryption key. So we can have server-side encryption. We could have AWS handle all the encryption for us, and the decryption will also be handled by AWS when we request our objects later on. But we could also have client-side encryption where we, the client that are uploading the object, have to be responsible for also passing over our own generated key that will eventually be used by AWS to then encrypt that object on the bucket side. Of course, once that happens, then the key is discarded, the client key is discarded, and you have to be very mindful that since you've decided to handle your own encryption, client-side encryption, that if ever you lose those keys, well, that data is not going to be recoverable in that bucket on the AWS network. So be very careful on that point. We can also have a very useful feature called versioning, which will allow you to have a history of all the changes of an object over time. So versioning sounds exactly how it's named. Every time you make a modification to a file and upload that new version to S3, it will have a brand new version ID associated with that. So over time, you get a sort of stack of a history of all the file changes over time. So you can see here at the bottom, you have an ID with all these ones, and then an ID with 121212. So eventually, if ever you wanted to revert back to a previous version, you could do so by accessing one of those previous versions. Of course, versioning is not an option that's enabled by default. You have to go ahead and enable that yourself. It is an extremely simple thing to do. And so there may be a situation where you already have objects within your buckets and you only then enable versioning. Well, versioning would only apply to the new objects that would get uploaded from the point that you enabled versioning. The objects that were there before that point will not get a specific version number attached. In fact, they will have a sort of null marker version number that will get attached to them. It's only after that you modify those objects later on and upload a new version that they will get their own version numbers. So right now, what we're going to be doing is a lab on actual versioning. So let's go ahead and do that right now. In this lab, we're going to see how to enable versioning in our buckets. Enable versioning is very easy. We're simply going to click on our bucket, go into properties, and there is going to be a bucket versioning section. We're going to click on edit and enable it. Once that's done, any new objects that are uploaded to that S3 bucket will now benefit from being tracked by a version number. So if you upload objects with the same file name after that, they'll each have a different version number. So you'll have version tracking, a history of the changes for that object. Let's actually go there and upload a new file. I'll upload one called index.html. So we're going to simulate a situation where we've decided we're going to use an S3 bucket as the source of our static website to deploy one. And in this index.html file, if you take a look right now, let's take a look at what's in there. You can see that we have welcome to my website and we're at version 2. Okay, so if I click on this file right now and I go to versions, I can clearly see that there's some version activity that's happening here. Okay, we have here at 1456, which is the latest one is on the top, the current version, we have a specific version ID. And then we have a sort of history of what's going on here. Now, I purposely enabled versioning before and then try to delete versioning or disable versioning. But here's the thing with versioning. You cannot disable it fully once it's enabled. You can only suspend it. Right? Now, suspending means that whatever version numbers those objects had before you decided to suspend it will remain. So you can see I have an older version here that has an older version number. And at this point here, I decided to suspend versioning. And so what it does, instead of disabling the entire history, it puts what's called a delete marker. Okay? You could always roll back to that version if you want. Now, in the demonstration, when we started it together, I enabled it again. So you can see this is actually the brand new version number as we did it together, but you don't lose the history of previous versioning if ever you had suspended it before. So that's something to keep in mind, right? And it'll come up in the exam where they'll ask you, can you actually disable versioning once it's enabled? And the answer is no, you can only suspend it. And your history is still maintained. Now, we have that version there, and let's say I come to this file and I want to upgrade this, I don't know, I say version 3, right? And now what's going to happen is if I click on this version, just as the current one with version 2, and I open this, we should see version 2, which is fine. That's expected. If we go back to our bucket and upload that new version file, that has version 3 in there, the one I just modified, we should now see in that index.html file a brand new version that was created under the versions tab. And there you go, 1458, just 2 minutes after. You can see here we have a brand new version ID, right? And if I open this one, you can see version 3. So now you have a way to enable versioning very easily in your buckets, and you also have seen what happens when you want to suspend versioning, what happens to the history of those versions files before. Just to actually go back here to the properties where we enabled versioning in the first place, if I want to go back in here and disable it, like I said, you can't disable, you can only suspend, and that's where that delete marker gets placed, but all your previous versions retain their version ID. So don't forget that, because that will definitely be a question on your exam if you're interested in taking the certification exam. So congratulations, you just learned how to enable versioning. Let's move on to cross-region replication, or CRR as it is known. There will be many times when you find yourself with objects in a bucket and you want to share those objects with another bucket. Now that other bucket could be within the same account, could be within another account within the same region, or could be within a separate account in a different region. So there's varying levels of degree there. The good thing is all of those combinations are available. So CRR, if we're talking about cross-region replication, is really about replicating objects across regions, something that is not enabled by default because that will incur a replication charge because it's syncing objects across regions. Of course, you are spanning a very wide area network in that case, so there is a surcharge for that. Now, doing so is quite simple to do, but one of the things that we have to be mindful of is to give permissions for the source bucket, which has the originals, to allow for this copying of objects to the destination bucket. So if we're doing this across regions, of course, we would have to come up with IAM policies, and we would also have to exchange credentials in terms of IAM user credentials, in terms of account IDs and the such. We're going to be doing a demonstration in the same account, in the same region, but largely this would be the same steps if we were going to go cross region. So this is something you might find yourself doing if you want to share data with other entities in your company. Maybe you're a multinational and you want to have all your log files copied over to another bucket in another region for another team to analyze, to extract business insights from. Or it might just be that you want to aggregate data in a separate data lake in an S3 bucket in another region, or in like I said, it could be even in the same region or in the same account. So it's all about organizing, moving data around across objects, across these boundaries. And let's actually go through a demonstration and see how we can do CRR. Let's now see how we can perform cross-region replication. We're going to take all the new objects that are going to be uploaded in the Simplilearn S3 demo bucket, and we're going to replicate them into a destination bucket. So what we're first going to do is create a new bucket, okay? And we'll just tack on the number 2 here. And this will be our destination bucket where all those objects will be replicated to. We're going to demonstrate this within the same account, but it's the exact same steps when doing this across regions. One of the requirements when performing cross-region replication is to enable versioning. So if you don't do this, you can do it at a later time, but it is necessary to enable it at some point in time before coming up with a cross-region replication rule. All right, so let me create that bucket. And now after the bucket is created, I want to go to the source bucket and I want to configure under the management tab here a replication rule. So I'm going to create a replication rule, call it Simplilearn rep rule. And I'm going to enable this right off the bat. The source bucket, of course, is the Simplilearn S3 demo. We could apply this to all objects in the bucket or perform a filter once again. Let's keep it simple this time and apply to all objects in the bucket. Of course, caveat here, this will only now apply to any new objects that are uploaded into this source bucket and not the ones that are already pre-existing there. Okay. Now, in terms of a destination bucket, we want to select the one we just created. So we can choose a bucket in this account, or if we really want to go cross region or another account in another region, we could specify this and put in the account ID and the bucket name in that other account. So we're going to stay in the same account. We're going to browse and select the newly created bucket. And we're also going to need permissions for the source bucket to dump those objects into the destination bucket. So we can either create the role ahead of time, or we can ask this user interface to create a new role for us. So we'll opt for that, and we'll skip these additional features over here that we're not going to talk about in this demonstration. We're just going to save this. So that will create our replication rule that is automatically enabled for us right now. So let's take a look at the overview here. You can see it's been enabled. Just to double check, the destination bucket is the demo 2. We're talking about the same region. And again, here we could opt for additional parameters like different storage classes in the destination bucket that object is going to be deposited in, et cetera, et cetera. For now, we just created a simple rule. Now, if we go back to the original source bucket, which we're in right now, and we upload a new file, which will be a transactions file in a CSV format. Once this is uploaded, that cross-region replication rule will kick in and will eventually, right, it's not immediate, but will eventually copy the file inside the demo2 bucket. Now I know it's not there already, so what I'm going to do is pause the video and come back in 2 minutes, and when I click on this, the file should be in there. Okay, so let's now double check and make sure that object has been replicated. And there it is, been replicated as per our rule. So congratulations, you just learned how to perform your first same account S3 bucket region replication rule. Let's now take a look at transfer acceleration. So transfer acceleration is all about giving your end users the best possible experience when they're accessing information in your bucket. So you want to give them the lowest latency possible. You can imagine if you were serving a website and you wanted people to have the lowest latency possible. Of course, that's something that's very desirable. So in terms of traversing long distances, if you have your bucket that is in, for example, the US East 1 region in the United States, in the Virginia region, and you had users, let's say in London, that want to access those objects, of course, they would have to traverse a longer distance than users that were based in the United States. And so if you wanted to bring those objects closer to them in terms of latency, then we could take advantage of what's called the Amazon CloudFront Delivery Network, the CDN network, which extends the AWS backbone by providing what's called edge locations. So edge locations are really data centers that are placed in major city centers where our end users mostly are located, more densely populated areas, and your objects will be cached in those locations. So if we go back to the example of your end users being in London, well, they would be accessing a cached copy of those objects that were stored in the original bucket in the, for example, US East 1 region. Of course, you will get most likely a dramatic performance increase by enabling transfer acceleration. It's very simple to enable this. Just bear in mind that when you do so, that you will incur a charge for using this feature. The best thing to do is to show you how to go ahead and do this. So let's do that right now. Let's now take a look at how to enable transfer acceleration on our Simplilearn S3 demo bucket. By simply going to the Properties tab, we can scroll down and look for a heading called Transfer Acceleration over here, and very simply just enable it. So what does this do? This allows us to take advantage of what's called the Content Delivery Network, the CDN, which extends the AWS network backbone. The CDN network is strategically placed into more densely populated areas, for example, major city centers. And so if your end users are situated in these more densely populated areas, they will reap the benefits of having transfer acceleration enabled because the latency that they will experience will be severely decreased. So their performance is going to be enhanced. If we take a look at the speed comparison page for transfer acceleration, we can see that once the page is finished loading, it's going to do a comparison. It's going to perform, first of all, what's called a multi-part upload, and it's going to see how fast that upload was done with or without transfer acceleration enabled. Now, this is relative to where I am running this test. So right now I'm actually running it from Europe. So you can see that I'm getting very, very good results if I would enable transfer acceleration and my users were based in Virginia. So of course, now I have varying differences in percentage as I go closer or further away from my region where my bucket or my browser is being is being referenced. So you can see here, United States, I'm getting pretty good percentages. As I go closer to Europe, it gets lower, of course, but still very, very good. Frankfurt again, this is about probably the worst I'm going to be getting here since I'm situated in Europe. And of course, as I go look more towards the Asian regions, you can see once again it kind of scales up in terms of better performance. So of course, this is an optional feature once you enable it, as I...
Hi guys, I'm Rahul from Simplilearn, and today I'd like to welcome you all to the greatest debate of the century. Today, I'm joined by two giants of the cloud computing industry. They'll be going head to head with each other to decide who amongst them is better. It's going to be one hell of a fight. Now, let's meet our candidates. On my left, we have AWS, who's voiced by Apeksha.
Hi guys.
And on my right, we have Microsoft Azure, who's voiced by Anjali.
Hey there.
So today, we'll be deciding who's better on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, free tier, and instance configuration. Now, let's listen to their opening statements. Let's start with AWS.
Launched in 2006, AWS is one of the most commonly used cloud computing platforms across the world. Companies like Adobe, Netflix, Airbnb, HTC, Pinterest, and Spotify have put their faith in AWS for their proper functioning. It also dominates the cloud computing domain with almost 40% of the entire market share. So far, nobody's even gotten close to beating that number. AWS also provides a wide range of services that covers a great number of domains. Domains like compute, networking, storage, migration, and so much more.
Now, let's see what Azure has to say about that.
Azure was launched in 2010 and is trusted by almost 80% of all Fortune 500 companies. The best of the best companies in the world choose to work only with Azure. Azure also provides its services to more regions than any other cloud service provider in the world. Azure covers 42 regions already, and 12 more are being planned to be made. Azure also provides more than 100 services spanning a variety of domains.
Now that the opening statements are done, let's have a look at the current market status of each of our competitors. This is the performance round. Here we have the stats for the market share of AWS, Azure, and other cloud service providers. This is for the early 2018 period. Amazon Web Services takes up a whopping 40% of the market share, closely followed by Azure at 30% and other cloud services adding 30%.
This 40% indicates most organizations' clear interest in using AWS. We are number one because of our years of experience and trust we've created among our users.
Sure, you're the market leader, but we are not very far behind. Let me remind you, more than 80% of the Fortune 500 companies trust Azure with their cloud computing needs. So it's only a matter of time before Azure takes the lead.
The rest of the 30% that is in AWS or Azure accounts to the other cloud service providers like Google Cloud Platform, Rackspace, IBM SoftLayer, and so on. Now for our next round, the comparison round. First, we'll be comparing pricing. We'll be looking at the cost of a very basic instance, which is a virtual machine of 2 virtual CPUs and 8 GBs of RAM. For AWS, this will cost you approximately $0.0928 per hour. And for the same instance in Azure, it'll cost you approximately $0.096 per hour. Next up, let's compare market share and options.
As I mentioned before, AWS is the undisputed market leader when it comes to the cloud computing domain, taking up 40% of the market share. By 2020, AWS is also expected to produce twice its current revenue, which comes close to $44 billion. Not to mention, AWS is constantly expanding its already strong roster of more than 100 services to fulfill the shifting business requirements of organizations.
All that is great, really, good for you. But the research company Gartner has released a magic quadrant that you have to see. You see, the competition is now neck to neck between Azure and AWS. It's only a matter of time before Azure can increase from its 30% market share and surpass AWS. This becomes more likely considering how all companies are migrating from AWS to Azure to help satisfy their business needs. Azure is not far behind AWS when this comes to services as well. Azure's service offerings are constantly updated and improved on to help users satisfy their cloud computing requirement.
Now, let's compare AWS and Azure's free offerings.
AWS provides a significant number of its services for free, helping users get hands-on experience with the platform, products, and services. The free tier services fall under two categories: services that will remain free forever and the others that are valid only for 1 year. The always free category offers more than 20 services, for example Amazon SNS, SQS, CloudWatch, etc. And the valid for a year category offers approximately 20 services, for example Amazon S3, EC2, Elasticache, etc. Both types of services have limits on their usage, for example storage, number of requests, compute time, etc. But users are only charged for using services that fall under the valid for a year category after a year of their usage.
Azure provides a free tier as well. It also provides services that belong to the categories of free for a year and always free. There are about 25 plus always free services provided by Azure. These include App Service, Functions, Container Service, Active Directory, and lots more. And as of the valid for a year, there are 8 services offered. There's Linux or Windows virtual machines, blob storage, SQL database, and few more. Azure also provides the users with credits of $200 to access all their services for 30 days. Now, this is a unique feature that Azure provides, where its users can use their credits to utilize any service of a choice for the entire month.
Now, let's compare instance configuration. The largest instance that AWS offers is that of a whopping 256 GBs of RAM and 16 virtual CPUs. The largest that Azure offers isn't very far behind either, 224 GBs of RAM and 16 virtual CPUs. And now for the final round. Now each of our contestants will be shown facts and they have to give explanations for these facts. We call it the rapid fire round. First, we have features in which AWS is good and Azure is better.
AWS does not cut down on the features it offers its users. However, it requires slightly more management on the user's part.
Azure goes slightly deeper with the services that fall under certain categories like Platform as a Service and Infrastructure as a Service.
Next, we have hybrid cloud, where AWS is good and Azure is better.
Okay, although AWS did not emphasize on hybrid cloud earlier, they are focusing more on technology now.
Azure has always emphasized on hybrid cloud and has features supporting it since the days of its inception.
For developers, AWS is better and Azure is good.
Of course it's better, because AWS supports integration with third-party applications.
Well, Azure provides access to data centers that provide a scalable architecture.
For pricing, both AWS and Azure are at the same level.
It's good for AWS because it provides a competitive and constantly decreasing pricing model.
And in the case of Azure, it provides offers that are constantly experimented upon to provide its users with the best experience.
And that's it. Our contestants have finished giving their statements. Now, let's see who won. Surprisingly, nobody. Each cloud computing platform has its own pros and cons. Choosing the right one is based entirely on your organization's requirements.
Let's begin with our tutorial and let's look into what we have in today's session. So I would be covering up why we require AWS Autoscaling, what is AWS Autoscaling, what are the benefits of using the scaling service, how this autoscaling works, the different scaling plans we have, what is the difference between the snapshot and the AMI, what is a load balancer, and how many types of load balancers we have, and along with that I would be covering up a real life demo on the AWS. Let's begin with why we require AWS Autoscaling. Now, before AWS Cloud Scaling, there was a question in the mind of enterprises that they were spending a lot of money on the purchase of the infrastructure. If they have to set up some kind of a solution, so they have to purchase an infrastructure and a one-time cost was required. So that was a burden for them in terms of procuring a server, hardware, software, and then having a team of experts to manage all those infrastructure. So they used to think that no longer they require these resources if there was a cost-efficient solution for their project. That was the project manager used to think. Now, after the AWS Cloud Scaling that was introduced, automatically the autoscaling maintains the application performance based on the user requirements at the lowest possible price. So what does the autoscaling does is that whenever there is a scalability required, it manages it automatically. and hence the cost optimization became possible. Now, what is AWS Autoscaling? Let's look into deep. So AWS Autoscaling is a service that helps users to monitor their applications and the servers and automatically adjust the capacity of their infrastructure to maintain the steadiness. So they can increase the capacity, they can even decrease the capacity also for the cost optimization. And also predictable performance at the lowest possible cost. Now, what are the benefits of autoscaling? It gave the better fault tolerance applications. You can get the servers created and you can have a clone copy of the servers so that you don't have to deploy the applications again and again. Better cost management because the scalability is decided by the AWS automatically based on some threshold parameters. It was a reliable service, and whenever the scaling is created or initiated, you can get the notifications onto your mail IDs or to your cell phones. Scalability, as I mentioned, is always there in the autoscaling. It can scale up, it can scale down as well. And it has the flexibility in terms of whenever you want to schedule it, if you want to stop it, if you want to keep the size of the servers at a fixed number, you can always make the changes on the fly. And the better availability. Now, with the use of the autoscaling, we come around with the terminology called snapshot and the AMI. Let's look into the difference between the snapshots and the AMI. Snapshots versus AMI. So in a company, there was one of the employee that was facing an issue with launching the virtual machines. So he asked his colleague a question. Is it possible to launch multiple virtual machines with a minimum amount of time? Because it takes a lot of time in terms of creating the virtual machines. The other colleague said that yes, it is possible to launch multiple EC2 instances, and that can be done at a lesser time and with the same configuration. And this can be done either you use a snapshot or the AMI on the AWS. Then the colleague said that what are the differences between the snapshot and AMI? Let's look into the difference now. The snapshots basically kind of a backup of a single EBS volume, which is just like a virtual hard drive that is attached to the EC2 instance. Whereas the AMI, it is basically used as a backup of an EC2 instance only. The snapshots opts for this when the instance contains multiple static EBS volumes. When you opt for the snapshot, whenever the instance contains multiple static EBS volumes. AMI, this is widely used to replace the failed EC2 instance. In the snapshots, here you pay only for the storage of the modified data, whereas with the AMI, you pay only for the storage that you use. The snapshots are non-bootable images on EBS volume, whereas AMI are bootable images on the EC2 instance. However, creating an AMI image will also create the EBS snapshots. Now, how does AWS Autoscaling work? Let's look into it. So for the AWS Autoscaling to work, you have to configure single unified scaling policy per application resource. And this scaling policy, with that you can explore the applications also. And then select the service you want to scale. Also, for the optimization, select do you want to optimize the cost or do you want to optimize the performance. And then keep track of scaling by monitoring or getting the notifications. Now, what are the different scaling plans we have? So, in the autoscaling, a scaling plan basically helps a user to configure a set of instructions for scaling based on the particular software requirement. The scaling strategy basically guides the service of AWS Autoscaling on how to optimize resources in a particular application. So, it's basically kind of the parameters that you set it up so that how the resource optimization can be achieved in the autoscaling. With the scaling strategies, users can create their own strategy based on their required metrics and thresholds, and this can be changed on the fly as well. What are the two types of scaling policies we have? So there are basically dynamic scaling and the predictive scaling. Now, what is dynamic scaling? It basically guides the service of AWS Autoscaling on how to optimize the resources. And it is helpful in optimizing resources for availability and particular price. Now, with scaling strategies, users can create their plan based on the required metrics and thresholds So a metric can be like, let's say, a network in, network out, or it can be a CPU utilization, memory utilization likewise. Now, in the predictive scaling, its objective is to predict future workload based on daily and weekly trends and regular forecast future network traffic. So it is kind of a forecast that happens based on the previous past experiences. It uses a machine learning technique for analyzing that network traffic, and this scaling is like how weather forecast works, right? It provides schedule scaling actions to ensure the resource capacity is available for application requirement. Now, with the auto scaling, you would need the load balancers also, because if there are multiple instances that are created, then you would need a load balancer to distribute the load to those instances. So let's understand what do we mean by a load balancer. A load balancer basically acts as a reverse proxy, and it is responsible for distributing the network or the application traffic across multiple servers. With the help of a load balancer, you can achieve a reliability, you can achieve a fault tolerance of an application. That is basically, it increases the fault tolerance and the reliability. So for example, when there is a high network traffic that is coming to your application, and if that much traffic comes to your application to the instances, your instances may crash. So how you can avoid that situation? So you need to manage the network traffic that is coming to your instances, and that can be done with the load balancer. So thanks to the AWS load balancers, which helps in distributing network traffic across backend servers in a way that it increases performance of an application. Here in the image, you can see the traffic coming from a different resources landing onto the EC2 instance, and the load balancer is actually distributing that traffic to all the three instances, hence managing the network traffic quite properly. Now, what are the types of load balancers we have? There are three types of load balancers on the AWS. One is the classic load balancer, second is the application load balancer, and the third one is the network load balancer. Let's look into what we have in the classic load balancer. So the classic load balancer is the most basic form of load balancing, and we call it as a primitive load balancer also, and it is widely used for the EC2 instances. It is based on the IP address and the TCP port, and it routes network traffic between end users as well as in between the backend servers. And it does not support host-based routing, and it results in low efficiency of resources. Let's look into what we have in the application load balancer. This is one of the advanced forms of load balancing. It performs a task on the application level in the OSI model. It is used when there are HTTP and HTTPS traffic routing is required, and also it supports the host-based and path-based routing and performs well with the microservices or the backend applications. The network load balancer performs the task at layer 4 of the connection level in the OSI model. The prime role of the network load balancer is to route the TCP traffic, and it can manage a massive amount of traffic and is also suitable to manage the low latencies. Let's look into the demo and see how practically we can create the autoscaling. Hi guys, let's look into the demo for how we can create an autoscaling on the AWS console. So right now I'm logged into the AWS console and I am in the Mumbai region. What you need to do is you have to go to the compute section, and under that click on the EC2 service. Let's wait for the EC2 service to come. Now just scroll down, and under the load balancing there is an option called autoscaling. So there first you have to create a launch configuration, and then after that you have to create the autoscaling groups. So click on launch configuration, and then you have to click on create launch configurations. So click on create launch configuration. Now this launch configuration is basically the set of parameters that you define while launching an autoscaling, so that this uniformity is maintained with all the instances. So that includes, let's say, if you select a Windows OS or a Linux OS, that particular type of an operating system will be implemented in all the instances that will be part of an autoscaling. So there are certain set of parameters that we have to specify during the launch configuration, so that we can have a uniformity in terms of launching the servers. So here I would select an Amazon Linux AMI, and then I would select the type of a server, which will be t2.micro. Click on configure details, put the name to the launch configuration. Let's say we put it as a demo, and the rest of the things we'll keep it default. Click on add storage. Since it's a Linux AMI, we can go with the 8 GB storage. That should be fine. Click on configure security group. Let's create a new security group which has the SSH port open, and that is open for anywhere, which is basically source IPv4 and IPv6 IPs. Any IP will be able to access that. Click on review. Just review your launch configuration. If you want to make changes, you can do that. Otherwise, click on create a launch configuration. You would need the key pair, and this key pair will be a unique key pair which will be used with all the instances that are part of the autoscaling group. So we can select an existing key pair if you have that. Otherwise, you can create a new key pair. So I have an existing key pair. I'll go with that, acknowledge it, and click on create launch configuration. Now we have successfully launched the configuration of an autoscaling. The next thing is to create an autoscaling group. So click on create an autoscaling group using this launch configuration. Put a group name. Let's say we put something like test, and the group size to start with, it says one instance, so that means at least a single instance will always be running, and it will be initiated and running 24/7 till the autoscaling is available. You can increase the size of the minimum base instances also. Let's say you can change it to 2 also, so you would get at least 2 servers running all the time. So we'll go with the one instance. The network would be the VPC default, and in the VPC particular region, we can select the availability zones. So let's say if I select availability zone 1A and then availability zone 1B. So how the instances will be launched? So one instance will be launched in 1A, the other one in the 1B, the third one in the 1A, fourth one in the 1B. Likewise, it will be equally spread among the availability zones. Next part is to configure the scaling policies. So click on it. If you want to keep this group at its initial size, let's say if you want to go with only a single instance or 2 instances and you don't want the scaling to progress, you can put it, keep this group at its initial size. So this is basically a way to halt the scaling. But we'll use the scaling policies to adjust the capacity of this group. So click on it. And we would scale between, let's say, minimum 1 instance that we have, and we'll scale it between 1 to 4 instances. And what condition, on what basis these instances will be scaled up or scaled down would be defined in the scale group size. So the scaling policies you can implement based on a scale group size or using the simple scaling policies using the steps. So in the scale group size, you have certain metrics. You can use average CPU utilization. You can define a metric related to average network in, average network out, or the load balancer request counts per target. And if you create the simple scaling policies using steps, then you need to create the alarms, and there you can get some more metrics that you can add up as a parameter for the auto scaling. Let's go with the scaling group size. Let's go with the metric type as average CPU utilization, and the target value here you have to specify what would be the threshold that when the instance CPU utilization is crossed, then a new instance should be initiated. So you can put a reasonable threshold for that. Let's say we put something like 85%, and whenever the instance CPU utilization is crossed 85% threshold, you will see that there will be a new instance created. Let's go to the next configure notifications, and here you can add notifications. So let's say if there is a new instance that is initiated and you want to basically be notified, so you can get notifications over your email IDs, or you can get it on the cell phones. So for that, for adding the notification, you would need the SNS service, and that is called as a simple notification service. And you have to create a topic there. You have to subscribe for the topic using your email ID, and then you should get the notifications. Click on configure tags. The tags are not mandatory. You can basically put a tag. Let's say if you want to identify the instance or purpose it was created. Otherwise, you can leave it blank also. Click on review and review your scaling policies, notification, tags, as well as the scaling group details. Click on create auto scaling group, and here you go. Your scaling has been launched. Click on close, and you should get at least a single instance initiated automatically by the autoscaling. So let's wait for the details to appear. So here you can see our launch configuration name, demo, autoscaling group name, test, minimum instance we want 1, the maximum instances we want 4. We have selected 2 availability zones, AP South 1A, AP South 1B, and the instance 1 has been initiated. And if you want to verify where exactly this instance has been initiated, just click on the instances here, and here you will see that our single instance has been initiated, that is in service, and that has been initiated in AP South 1B. Now once the threshold of this instance crosses 85%, that is what we have defined in the scaling policies, then you should see that another instance will be initiated. So likewise, this is basically I have created steps to initiate a scaling policy, that means to increase the number of servers whenever the threshold crosses. Likewise, here itself you can add another policy to scale down the resources in case if the CPU utilization goes to a normal value.
And I welcome you to this short tutorial and demo on Kubernetes. Kubernetes specific to AWS Cloud Platform. So what's a part of this tutorial and demo? What's in store for you? At our offset, I would like to cover the basics of orchestration tools. As most of you would know, Kubernetes is one of the most popular orchestration tools in recent times, specifically for applications which are cloud native and deployed on some or the other types of containers. But what are these orchestration tools? Why would one need to use orchestration tools? What are the facilities or features provided by these orchestration tools? That's the first thing that I'm going to cover. After that, I will pick 2 orchestration tools specific to container management, Docker Swarm versus Kubernetes. I'm going to compare them with regard to the features that they provide, the use cases that they cover, what facilities that they provide, and when to use what. After that, I will get into a little bit details of the Kubernetes architecture, what exactly is required for setting up a Kubernetes cluster, what runs in a control plane or a master node, what runs as a part of the worker node. After that, I will end the tutorial by running you through a demo by setting up a 3-node Kubernetes cluster on AWS platform. I will use something called as KOPS, which is one of the admin tools for setting up production grade Kubernetes cluster. So I will use this to set up a 3-node cluster on AWS. Alright, now that we set the context right, let me get started. So what are orchestration tools? The application development and the lifecycle management from the time the application is developed, connecting the source code to your continuous integration, to testing them all along your development process, and eventually moving it down to production, managing your production servers, the dependencies that your software has, the requirement that it has in terms of the hardware, the features of fault tolerance, self-healing capabilities, autoscaling, all this has complicated over the last few years. As a part of DevOps, one thing that everyone is interested in is managing all this application dependency or lifecycle management using some or the other kind of a tool. So that's where these orchestration tools have become very, very popular. So what kind of features that they provide is you'll have to just let them know what are the kinds of tool sets that is required, what are the fault tolerance mechanisms that it has to be adopted to, what kind of a self-healing capabilities that application will have to need, and if at all there is any auto-scaling features that is required. If at all you can bake in all these specific parameters into your tool, your orchestration tool becomes a one-stop shop for all your deployment and configuration management needs. That's where these orchestration tools have become a very, very popular and relevant, specifically these days when people are more and more interested in adopting DevOps practices. Alright, so having said that about orchestration tools, let's concentrate on 2 of these orchestration tools specifically for container management, Docker, Swarm, and Kubernetes. Many of the applications that are written for these kind of containers are called or kind of fall into a category of cloud native. where the application need not know much about the underlying infrastructure or the platform where these applications are running. So these two, along with Apache Mesos, there are many other container management systems, but I'm going to pick Docker Swarm and Kubernetes for comparing the features that is provided by these two frameworks. For the sake of comparison, I picked up Docker Swarm and Kubernetes just because of the reason that both of them operate in the space of container management. They do something very, very similar to containers. That's the similarity that exists between these two orchestration tools. However, there's a big difference that exists when it comes to the types of containers that both of them cater to, and also the capacity of workloads they can be used for. Docker Swarm is a cluster management solution that is provided by Docker Container. Docker is one of the very, very popular containers of recent times, and in case you have your applications that is totally powered by only Docker containers, if you have a need where you want to run a cluster of servers which are running only Docker containers, Docker Swarm should be your choice for your orchestration tool. Kubernetes, on the other hand, can cater to any other types of containers other than Docker, and including Docker as well. So in case you have your applications which have got Docker in them, which have got RKT in them, which they have got LX in them, or any other type of container, Kubernetes should be your choice of orchestration tool. A Docker Swarm can manage up to 40, 50 or 60 max nodes. So in case your application is totally written in Docker containers and the load or the expected cluster size is around 50-60 nodes, Docker Swarm should be your choice of orchestration tool. On the other hand, Kubernetes is something that was open sourced by Google, and the scale of operations that Kubernetes can cater to is Google scale. So if in case your applications are more than 1,000 nodes, that is where Kubernetes comes into play. That's the big difference that exists between Docker Swarm and Kubernetes. Putting those differences aside, let me compare Docker Swarm and Kubernetes based upon other features which are similar in nature. The first and important feature that Kubernetes provides is something called as autoscaling. If at all the load on your cluster is too high and your application is experiencing more load, so Kubernetes can add new nodes to your cluster. Of course, you'll have to configure Kubernetes in order to have those capabilities where it can spin up new VMs or new nodes. If at all you do that configuration correctly, Kubernetes has got the capacity, or it has got the feature where it can bring up a new node and add it to the cluster on the fly based upon the load that exists at that moment. On similar lines, if at all the load is not too high, it can identify a few of those nodes which have got less number of replicas or less number of application containers running on it. It can move them to some other node and also scale down by deleting few nodes from your cluster. So that is the powerfulness of autoscaling which is provided by Kubernetes, and this unfortunately does not exist in Docker Swarm. The other feature of load balancing, specifically application load balancing. So Docker Swarm gives you an application level auto load balancing. However, Kubernetes gives you the flexibility of manually configuring any other type of load balancer of your choice for application load balancing. Installation. As I mentioned earlier, Docker Swarm is a loose cluster of containers which are running on nodes. It is very easy to spin up a new node and then connect them to a swarm. And this can be done in a very, very loosely coupled way where you can create swarms of your choice. Nodes are allowed to connect to swarms and quit or leave the swarms on the fly. So in and all, the installation is pretty easy and fast. Kubernetes, on the other hand, the configuration of Kubernetes, the way to spin up a big cluster specifying the size of the node, how many master nodes, how many config planes that you want, how many nodes that you want. It's a pretty tough thing to bring up a Kubernetes. Scalability. Kubernetes strength is very, very strong. They are very tightly coupled, and even they have the capability where on the cluster size, things or the nodes can be increased on the fly based upon the requirement. On a Docker Swarm, the cluster strength is weak as compared to Kubernetes. Worker nodes can be added to a swarm. Worker nodes can be asked to leave a swarm or can be taken out of a swarm based upon the requirement. So this is kind of a loosely coupled architecture for Docker Swarm, while Kubernetes, the cluster is very tightly coupled. Since Docker Swarm runs only Docker containers, containers find it very easy to share data and a lot of other things with each other because they all have the same signature. They are all from the same family. So it's very easy for them to share not just volumes, but a lot of other things. However, for Kubernetes, since it manages containers of different types, if your application has to share some data across different containers, there's a little bit of a complexity in how you would want your containers to share data. Also, when it comes to Kubernetes, Kubernetes groups containers in something called as pods. While a pod can have either one container, that's the preferred choice, or multiple containers. And the idea of pod is like each pod can run in any other node. It's not guaranteed that you would want to have 2 or 3 pods to be running on the same node. That makes data sharing a little bit of a different thing compared to Docker Swarm. GUI. So there's not a good enough UI tool in Docker Swarm, at least the CE edition of it, which will allow you to get to know what is running on your containers, what is the size of the containers, what is the volume of the containers, and all that stuff. There are some free and open source tools like Portainer, which gives you a good visibility into your running Docker containers. However, there's nothing at a swarm level that is provided by Docker. Kubernetes gives you an out-of-the-box dashboard, which is easy to configure and set up. You can also club it with some metrics services, and you can also get information about the size of the cluster that is running, what is the load on the nodes, and stuff like that. All this across your cluster in a very beautiful dashboard perspective. So that way, this is a little bit of a good UI for Kubernetes, while for Docker Swarm, there isn't anything that is provided out of the box. Let me spend some time in explaining a little bit about the Kubernetes architecture, what comprises of the Kubernetes cluster, what resides in a master or a control plane, and what resides in a worker node. This is a very high level depiction of a Kubernetes cluster. So this is the master node, which has got something called as a cluster store, a controller, a scheduler component, and an API server. And these are the bunch of nodes that are connected or administered by the master node. The master node can be 1, 3, 5, typically an odd number. This is as per the typical cluster management thing, where you would need the master nodes to be in odd numbers so that whenever there's any contention in terms of what needs to be deployed where or where to give the job to whom and stuff like that, all the masters would cast their vote and they would decide on the outcome. So that's the master node, and there are a bunch of nodes which can be connected and administered by the master node. kubectl, or the command from using which anybody can assign some workloads to the cluster, can also be run either on the same node or on a separate node. So kubectl is the command line tool that we will be installing and using in order to fire up our commands to our cluster. So if at all I have to put up a job on our cluster, if I have to give out any specific commands to my cluster, all this is done using kubectl. There's a bunch of REST APIs which is used by kubectl, and kubectl will talk to the API server and fire up the commands specific to my cluster. What runs in the master node? Master node, without saying, it's the most important component of any of the cluster. If at all you're running cluster with only one master node, if your master node goes down, there's no other way that you can, or any user can talk to the different nodes in the cluster. So master node is the most vital component responsible for the complete Kubernetes cluster. There's always one node that should be running as a master node. That's the bare minimal requirement for your cluster. So what are the other components in the master node? The most important one is called etcd. So this is nothing but a data store, a value of key value pair, which is stored, which contains all information about your cluster. So all the configuration details, which node is up, which worker node is down, all this information is stored in the cluster store. So all the managers would access this cluster store before they go ahead and decide any other work item or anything else that has to be done specific to your cluster. What's in the controller? As the name says, controller is something, it's like a daemon server that is running in a continuous loop. All the time it is responsible for controlling the set of replicas, the kind of workloads that is running based upon the configuration that the user has set in. So if at all, if you are aware of something called as replication controllers, endpoint controllers, namespace controllers, all these controllers are managed by the controller component. If any user asked for some 3 replicas of a particular pod or a service to be running, and if at all any of the nodes goes down or the pod goes down for whatever reason, the controller is the one who wakes up and assigns this particular job or the pod to some other available node by looking up for the details using in the cluster store. That's the importance of the control manager or the controller. The scheduler assigns the tasks based upon whoever is asked for any job to be scheduled based upon a time frame or based upon some criteria. It also tracks the working load as to what exactly is the load, who is running what in the cluster, and places the workload on whoever is the available resource at that time. Alright, API server. This is one other important component in our Kubernetes cluster, where how would the end user deploy or give out any sort of a workload onto your cluster? All the requests come to the API server. So this is an entry point for all your requests that come into your cluster. Anybody wants to deploy something, anybody wants to scale up a controller, anybody wants to bring down few services, anybody wants to put in a service, all this will have to come in as a part of a REST API endpoint. And API server is the entry point in case you don't want somebody to access your cluster, in case you want only specific people or specific users to be running some specific workloads. You can set all those role-based access control for this API server. So this is the entry point for anyone who wants to submit any job to your cluster. So that's a quick overview about the master node. What are the important components of a master node? Now let's go over to what runs in a worker or a slave node. As I mentioned earlier, slave nodes are something where the job that is submitted to your cluster is eventually run as a pod, as a service, as a container. So in Kubernetes world, there is something called as a pod. A pod is nothing but a combination of a container. It is a wrapper around your running containers. So slave nodes or the worker nodes typically run these pods. So that is where the whole workload typically gets run. But there are a bunch of other components in the node which also manages what runs in the pod, who has to have access to the pod, what is the state of the pod, is it in a running state, is it going down for some reason, and all the stuff. So let's quickly go over those components that is there in the slave node. The most important component, in my opinion, that should be on the node should be the container runtime. As I mentioned earlier, Kubernetes can run any different types of containers, not just Docker. So in case you want to have a node which wants to have Docker running on it, RKT running on it, LKC running on it, or any other container environment that is running on it, you have to ensure that the specific container runtime environment is available on that specific node, so that whenever a job is submitted, a description of what needs to be run as a part of the pod, what should be the image with which it should be powered, and what kind of a container to spin up. So that's what, when the job is finally assigned to this particular node, it would definitely need a container runtime to be up and running. So that exists only if at all the container runtime is installed and running on your Kubernetes worker node. Okay, now that we know what our Kubernetes node can run, how would somebody assign a job to our node? That is using something called as a kubelet. As the name says, kubelet is a small subset which talks to the kube API server. So any node which has to run any kind of a pod, all these instructions are passed around by the kube API server to the kubelet. And kubelet is capable of processing whatever job that is assigned to it and ensuring that so many pods and so many services are spun up based upon the requirement. The last component that exists in the worker node is the kube proxy or Kubernetes proxy. This plays a very, very important role, acting as a load balancer and a network proxy. So what typically happens is whenever the pods are running in nodes, the pods can be typically running in any node. There is no affinity towards any node on which these pods are running, because pods or containers are something called as ephemeral. They can run anywhere. So how would somebody reach out to these applications that is running in some pod, which is running in one container now and running in probably another container, another node altogether tomorrow. So that is where your Kubernetes proxy comes into picture, and this component will ensure that any container that is spun up or any pod that is spun up, it keeps track of all these pods and kind of connects the endpoints or acts like a DNS server, so that it knows when somebody is trying to reach out to this particular service, which is the pod on which the service is typically running. So that plays a very, very important role by acting as a load balancer and a network proxy. Now that at a very high level we know what are all the components that make up of our Kubernetes cluster, let's go ahead and create a small cluster. We'll spin up this cluster on AWS platform. Finally, we get to the demo section of my tutorial. Now that you guys are aware as to what is Kubernetes, what is the use of Kubernetes, you also know at a very, very high level what are the components of a cluster. What is a master node or a control plane? What are the components of a master node, and what should be existing in a worker node? You're probably thinking that it's going to be pretty hard to kind of set this up. So let me demystify that by running you with a quick demo of how to set up a simple 3-node Kubernetes cluster using a tool called kops. And I will be doing this whole setup on my AWS cloud. Okay, so what is kops? Kops is nothing but a simple tool. This is an admin tool that allows you to bring up production grade Kubernetes environments. As I said, setting up a Kubernetes cluster on a bare metal is a little challenging. So that is why I would use something called as a kops, and I will use this on my cluster, which I will spin up on my AWS instance. So I have an AWS account, and what I will do first is I will first spin up an EC2 server. I will power this with one of the Linux AMIs, and I will install kops on it. Now this will be my starting point from where I'm going to trigger running up a big cluster. In our case, I'll try to keep it a little small. I don't want too many nodes in my cluster. I'm going to have one master node and 2 worker nodes. This whole operation would be done programmatically by installing this kops admin tool. So as you may know, AWS, it's a little hard for me to programmatically run other components or rather bring up servers. It's not pretty simple. So what I would do is I will create an IAM role which will attach to my EC2 server, so that my EC2 server gets powered with all the required role, so that it can go ahead and spin up cluster based upon my configuration that I'm going to specify. Alright, so once I have my cluster set up, I will also install kubectl, which you would probably know by now is nothing but a command line utility using which I can kind of connect to my cluster, give out some jobs, put some pods and stuff like that. So I will use kubectl. I will also have a pair of SSH keys, so that from this machine I would be able to successfully get onto the master node and submit jobs on my behalf. So let me begin by first logging into my AWS account. All the steps that I will be following to bring up my AWS cluster, Kubernetes cluster, will be documented, and I'll be sharing you this document in a GitHub repository, so that in case anybody wants to try, you'll be more than happy to find all the required instructions in one place. Okay, now the first thing that I would need is to launch an AWS EC2 instance. Now this is an instance where I'm going to install kops, and I will use it as a base server from where I'm going to fire some commands which will bring up my Kubernetes cluster. So let me log into my AWS account, and let me stick to one particular region, and let me bring up one EC2 instance. Alright, so let me launch my instance. Let me choose, doesn't matter either ways, but in case you want to try it on your free tier, I would recommend choose free tier only and choose an AMI of your choice. Let me choose this instance. I will make it T2 micro. That is good for me. Configuration, instance details. All right, I don't want to change anything here. That looks good. Maybe I will change this 30 gig. That's good for me. Let me add a tag to my instance. I will name this as my kops server. Alright, I would need a bunch of ports to be opened up. So what I will do is I will create a new security group called Open to the World. I would not recommend that you do this, since I don't want to, it will take a long time for me to specifically pick and choose the ports that has to be opened for running my cluster. I don't want to do that. I will open up all the HTTP and HTTPS ports so that it's quicker. So I will say all TCP I would say from anywhere, just to be on the safer side. Also open HTTP and HTTPS, and I will make this anywhere and anywhere. This is good for me. I will say review and launch. Alright, so I chose a T2 micro instance. Just for the sake of easiness, I've opened up all the ports, and the instance details are, you've seen what is that I've chosen. Alright, now important part is like I would need a key pair. I need to create a new key pair. I will call this as Simplilearn keys. I will download this key pair and then I will launch the instance. It will take some time for my EC2 instance to come up. In the meanwhile, what I'll do is I will convert. I have this PEM file, which is the pair of keys, the SSH keys with which I need to log into my EC2 instance. So I'll need to convert this because I'm trying to connect from my Windows box. I would need to convert this into a PPK file. So I have puttigen. I'm going to load my set of keys here and convert that key into a PPK key. All right, open. All right, I would say save. Hang on, save private key. Yes, I would say Simplilearn or Simplilearn private key. I'll save this here. Done that. That's also. This is my public key, which is the PEM file, and this is my PPK or my private key. Now, using the private key, I will log into my EC2 instance. Okay, now my EC2 instance is up and running. It is running in this Ohio region, and this is the IP address of my public IP address of my machine. So let me connect to it. So I use MOBA Xterm, which is nothing but an SSH emulator. You can use PuTTY or any of these sessions which allow you to do an SSH. This is my IP address of my machine, and since I've spun up an Amazon AMI, this is the default user. I would need to specify the private keys for my session, and this is the private key for my session. Say OK. I am in my Amazon EC2 instance. So let me look at what are the other things that I need to do. Alright, so as I said, I just brought up my EC2 instance, but I would need my EC2 instance to run few things on my behalf so that it can spin up other EC2 instances. It can also talk to an S3 bucket where I'm going to store the instance state of my Kubernetes cluster. Also some sort of an auto-scaling group because I want to spin up more and more instances. I also want to have a private hosted zone using my Route 53. So I would need my EC2 instance to have all these sort of permissions for my server. So what I would do is I will go and create a permission, a role in the EC2, rather in the AWS IAM role, and I will attach this IAM role to my EC2 instance. Alright, so let me go to my IAM, which is nothing but the identity and access management. I will create a role called as possibly COPS role. I will create a role. This role will be used by my EC2. So I'm going to click on EC2. I will say next permissions. They would need a lot of permissions, specific permissions to be very honest. And the permissions are all listed out here. S3, EC2 and all this stuff. Just to keep it pretty simple, what I would do is I will create a role with the administrative access. Alright, so I don't want any tags. I'm going to review. I'll create a role name. I will say COPS role for EC2. Alright, so I'm going to create a role which has got administrative access role. So I'm going to create a role. So this would ensure that my EC2 instance from which I'm going to run my cluster would have all the prerequisite permissions so that it can go and spin up instances, talk to S3 buckets and all that stuff. Alright, now let us have our running instance get powered by this role. So I will connect this role to my running instance. Alright, so this is my EC2 instance that is running. I will say action, attach, replace IAM roles. So there is no role as of now. I would want my COPS role for EC2. This is the role that I created. So I want this new role to be assigned to my EC2. Alright, great. Now my EC2 instance, which is my COPS server, has got all the required permissions so that he can create a cluster on my behalf. Great. Now before this, let me do a sudo yum update -y. So that any of the, because this is a newly provisioned VM, I just want to ensure that all my system libraries are all updated. So that when I do install COP and kubectl and all those things, none of them will fail because of some dependency or package issues. So I'm just running a sudo update -y so that all the libraries are updated. Okay, looks like it is done. So let me go ahead and install kops. Kops is a pretty simple installation. It is available in a particular location. I have to just copy this and ensure that I do a curl and I install this particular stuff. All right, so it is fetching the kops tool. It's installing for me. Once it is copied down, let me change the mode so that I can execute it, and then also let me move it to my user local bin so that it is available for me in my path. Okay, that's pretty much the kops installation. Let me also do one other thing. Let me install something called as kubectl. So this is what would be, a tool using which I'm going to be firing my commands to my Kubernetes cluster once it comes up. Right, this is a pretty smaller executable. So kubectl. All right, so I have kubectl as well as kops installed on my EC2 server now. Okay, now what I'll do next is I'm going to create an S3 bucket in AWS so that the Kubernetes cluster state is persisted in this bucket. So let me create a simple bucket with this name, S3 bucket with this name. So let me go to S3 and let me create a simple bucket with this name. I will just say create a bucket. Okay, so the Simplilearn.Kubernetes is the bucket that I created. So this bucket will store all information about my cluster. Let me now go and create a DNS entry or a DNS zone or a AWS Route 53 hosted zone for my cluster. So this is required so that I can give a cluster name for my Kubernetes cluster that I'm coming up. So I will create a private hosted zone, and possibly I will call this as Simplilearn.in. So this will be my name of my private hosted zone. In case you already have any other public hosted zones in your name, you can always put a Route 53 hosted zone specific for your domain name. Since I don't have anyone, I'm just going to create a simple private hosted zone. So let me head down to Route 53, click on any of these and you'll get these hosted zones out here. So I'm going to create a hosted zone here. I'm going to create a hosted zone. Click on create hosted zone. This would be Simplilearn.in. I want to create a public. No, I don't want a public. I want a private hosted zone, and I'm going to associate my VPC ID for this hosted zone. Since I'm going to try out all my exercises in the Ohio region, I will associate the VPC of the Ohio region for this. All right, so this is the one that is specific to the Ohio region. So I will say this one. I'll say create a hosted zone. Great. Now let me come back to my EC2 box. My EC2 is all powered with whatever it needs in order to go ahead with the installation of my cluster. Only few things that I need to take care of is that, now that I put a name for my cluster, I also have an S3 bucket that I've configured for my cluster. I will have to ensure that I need to put in these two configurations as a part of my cluster building activity. So I will open my bash rc file and I'm going to export these two variables. If at all you remember well, these two variables are nothing but the cluster name, which is nothing but the the private hosted zone that I created, and the S3 bucket where I'm going to create, or rather I'm going to store my cluster state. So let me copy these two and open up my bash rc file. All right, so I will just add these two and copy these and export them out as my variable. I'm going to save this here. Now let me ensure that this gets picked up. All right, I've got these two that I've configured, and I've also ensured that these environment variables are set. Now let me create a pair of SSH keys. This is to ensure that I can log into the box that I'm going to be provisioning as a part of my cluster. SSH-keygen. I don't want to give any parameters. Let it go to the home directory with the default name and without any passphrase. All right, so I created a bunch of my key pair. Now I'm all set to go ahead and run my kops. Now kops will ensure that this will take some time for the cluster to come up, but this is exactly how I would define my kops command. I already got it copied here. So kops create cluster. The state of the cluster will be stored in this particular variable, which is what I have exported out. The number of node count is 2. Node count is the worker node count. If at all I don't specify, there's a configuration for specifying the master or the control plane as well. If I don't specify that, the default one is 1. So I'm going to create one primary or the master node and two worker nodes. Size of my master, node size of the worker nodes, what are the zones where I want this to be created, and where do I store the cluster information. And okay, I've already added this master count. This is actually not required, but this is the command that I'm going to fire off so that I bring up my cluster. All right, that went off very fast, but this actually did not create a cluster. It is just the definition of a cluster, and that's why this came out very fast. Now that everything looks good with whatever configuration that I specified, now let me go ahead and create the cluster by saying corps update cluster -a. Yes, now this will take some time, a good 5 to 10 minutes for it to, because this will actually start provisioning the servers. And as I mentioned earlier, based upon my configuration, I'm going to come up with one master server and 2 nodes, or the worker nodes. All right, so this is the command for me to validate the cluster, and I'm going to try it out first. I'm pretty sure that it will fail because all my servers are not up yet. It is taking some time. The validation, everything failed. But let me try to look at my EC2 instances and see how many servers do I have running as of now. If you see, I had only one server that I had started, which was my COP server, and automatically the other 3 instances, one is called nodes.simply.in. These 2 are the nodes, and this is the master node. So these 3 got automatically provisioned by the COPS command that I ran. Alright, so this may take a while for it to get validated, a good 5 to 10 minutes. So what I'll do is I'll pause the video now and I'll come back once the cluster is up and running. It's been a good 8 to 9 minutes since I started my cluster. So let me validate now. Okay, seems good. So there's a master node, minimum 1, max 1, some nodes which are nothing but the slave nodes or the worker nodes. There are 2 of them, T2 micro, subnet. So my clusters seem to be up and running, and my cluster name is Simplilearn.in. So what I would want to do is now let me just log into the master and see if I can run some pods. So let me get back to my installation steps here. The validation cluster is done. So let me log into since my cluster name is Simplilearn.in, this is the way to log into my box. So let me get into my box. So if you see here, this is the host name of the machine that I'm currently in. If you see this is nothing but this COP server. This is a server. Now from here, I'm trying to get into the master box. Alright, so if you see, the IP address has changed. I was in a different box. I'm in a different box now. If I see host name, you'll find a different host name. So this is 153, which is nothing but the master node. Yep, it's 153. This is the particular host. So I'm getting into this machine now. So I started the cluster from my COP server here. It ran and brought up 3 nodes. So I'm actually getting into my master node and see if I can run some pods on it. Alright, so let me try kubectl get cluster info. Try kubectl get nodes. Alright, so there are 3 nodes here, master node and 1 master node and 2 worker nodes. So let me see if I have some pods here. Kubectl get pods. So there's no pod as of now. So what I'll try to do is let me just spin up a very, very simple pod just to check if my connections everything is correct or not correct. I have a simple Node.js application that I've built and I've got a container for that. This is already pushed to the Docker Hub registry. It is called Simplilearn Docker Hub, and the image name that I have here is called my node app, and I will use this image to power one of my pods that I will run. So this is the way in which I'm going to launch my pod. Let me show you these commands. Kubectl run, the name for my deployment that I'm going to run, -- image, and this is the image that is going to be powering my container. So this is Simplilearn Docker Hub / my node app -- replicas equal to I want 2 replicas to be running, and the port that I want to expose this particular pod is on 8080. So let me run this. As soon as this is run, it creates something called as a deployment. Alright, now let me just say I'm not really interested in the deployment. I'm interested in checking if at all the pods are up and running. So I will say kubectl get pod. Alright, so that was pretty fast. So I have 2 pods that are running here. These are 2 replicas because I asked for 2 replicas. These pods are running, so I can run kubectl describe pod pickup. Alright, I can pick up any of the pod name and see what is the pod, what is the information does it contain, from what is the image that is pulling, what is the image name, ID. This is actually running my pod, which is actually spinning up a container. Great, so far so good. So in Kubernetes, the pods are ephemeral, so they can be there at any time, cannot be at any time. If I need to expose my pod outside, I will have to create a service for my pod. So what I'll do is I'll create a very, very simple service by exposing this particular deployment. Before that, let me check kubectl get deployment. So there's a deployment that is created. The deployment name is Simplilearn app. So I will expose my deployment Simplilearn app as I'll just expose this. Let me see. All right, I'm not specifying what type and all. I don't want to get into the complications of what are the different types of exposing this service and all that stuff. So if I don't specify anything, it gives me something called a cluster IP. So this is where my pod is actually exposed. So let me just check if at all this pod is up and running. I'll just try a simple curl command. Curl http : this is my cluster IP, and the port is 8080. If at all I hit this, it's actually hitting my application and giving me whatever. I put a simple sys.out kind of a thing where I'm just printing the container ID of whatever pod is serving being served out of. So I'm actually hitting my container and I'm getting this output from the container. So everything looks good. My container is up and running. So let me just go and clean it up. I will say kubectl delete deployment Simplilearn app. This should get rid of all the pods that I created. kubectl get pod. All right, these pods are interminating things. Let me just check kubectl get services. There's one service. I don't want this service. Let me delete that. kubectl delete service. I don't want this. All right, that sounds good. So let me come back to my host, my COP server from where I'm running. So I managed to successfully verify this pod, see if everything is up and running. So what I'll do is I'll just go ahead and complete this demo by going and getting rid of my cluster. So cops delete cluster -es. All right, so this will ensure that it will clean up my complete cluster that I created. So I had 3 or 4 running instances. If you see that, all the 3 are shutting down because the COP server, which had COPS installed on it, has now got a mandate to go ahead and shut down and clean up the whole instances and all those things that are created as a part of my deployment.
And today I'm going to be covering these following points. I'm going to be covering what is cloud computing. I'm going to be showcasing what AWS is in terms of cloud computing, and I'm also going to be covering the core fundamental service of the Simple Storage Service, which is a object storage service. We're going to be covering the benefits of the Simple Storage Service, better known as S3, what objects and buckets are, and we're going to be seeing how things are working in the background and implementing that in terms of lab assisted demonstrations in order for you to see what those features of S3 are. And then we'll perform a wrap up of the material we've done in a conclusion. So let's get started. What is cloud computing? So here is a definition of cloud computing, but I'm going to paraphrase it. Cloud computing is nothing more than you gaining access to infrastructure through web services with a pay-as-you-go model. Now, this is a very, very different model than we're traditionally involved in on an on-prem data center. So when I mean on-prem, I'm saying on-premise. Okay, so you'll hear that a lot, on-prem. Now, when we are on on-premise data center, we have to provision lots of infrastructure even before we get started with deploying any type of application, whether it be a mobile application, a web application, etc., etc. So every application needs some sort of underlying infrastructure, whether that be bare bone servers, databases. They're obviously going to be needing some types of storage, etc., etc. So all this is something that we have to kind of fight against in order just to get started with deploying our application. So this takes usually, traditionally, depending on the size of the company, about 3 months to set up. So what if we could leverage all this infrastructure as a service and just through some API call, that's what the web services is all about, we could provision a server or we could provision a database within minutes and then deploy any type of application that we want to on top of that stack, and also take advantage of any storage that we may want. We may want object level storage, which is what we're going to cover. We may want an elastic file system, right? So there are different types of storages that we're eventually going to look at as you go down your learning path with Simplilearn. So cloud computing is really about provisioning of all these kinds of services, but not only at the infrastructure level. We're going to see how we could move up the stack and get entire platforms as a service, or even softwares as a service. So what is AWS? Well, AWS is really a cloud computing platform that will offer us many services through these API calls. Some are, again, just bare infrastructure like a service. Other can be a service as a software, for example, email. So here we have an example of the public data storage. This is S3, the simple storage service icon that you're going to see over and over again. This is a representation of an actual bucket in S3. So this will become more clear as we continue the slide deck and actually reinforce this with some hands-on lab. But as you can imagine, you may want to provision a private software-defined network in the cloud. And so we can do that in AWS. We can provide load balancing. We could provide scalability in terms of auto-scaling groups that will respond to increased demand as your application, let's say, becomes more popular. You want that infrastructure to grow elastically. So doing this on premise is traditionally not only extremely expensive and thus prohibitive, but very difficult to implement physically speaking as well. So by going with a cloud provider like AWS, we can severely reduce the expense and the complexity of setting all of this up, because we're trading capital expense for variable expense. So capital expense is about you procuring all the hardware that you need beforehand and the budget being approved before even getting that hardware in through your door, right? And then you have to configure it. So there's that complexity factor. Whereas if you're doing this through AWS, you can within minutes just provision all of that very quickly. So you're also not paying for everything all up front. You're paying this with a pay as you go model. So very different. We're now removing what's called undifferentiated lifting, which is everybody has to do the same thing, but it's not really bringing any value to their end product. We all have to buy servers and configure them and scale them, etc., etc. So if we remove that element and have AWS handle that, we can concentrate on our business, which is our application, and improving that application and responding more to our clients' requests. We can be more agile, more flexible. So all of this leads to these points that we see here on this slide. Much easier to use, much easier to get our application to market. We're actually going to be leveraging the physical security that AWS implements for us. They have data centers all over the world that we're going to plug into, and that physical security is already implemented for us. There are varying levels of security that we're going to get into through our AWS journey, but right off the bat, you know that you have physical security. Of course, we're going to be talking about storage in this demonstration or in this slide deck over here. But the nice thing is we only pay for what we use. So that's that variable expense that I was talking about that we've traded for capital expense. We can easily set up databases. We can easily automate our backups and have those backups stored in the cloud through that S3 storage that we're going to get into. Okay, so lots of benefits of going through AWS here. And it's also comprehensive and simple to use. Comprehensive meaning that there are hundreds and hundreds of services. It's going to be actually quite time consuming for you to just know what each service does in general, but you'll get there through your journey. It's all about sticking with it and learning something new every day, which is what Simplilearn is all about. Over here, we have infrastructure as a service, platform as a service, and software as a service. So these are three different types of distinctions we have in the cloud industry to basically cover what's going on here on the right hand side. So on premise, you're traditionally involved in everything from networking, which is you, for example, buying the switches, the routers, the cabling, everything all the way up the stack to deploying your application, and you see everything in between there. Okay, so this is a very time-consuming job. Not only that, but it costs a lot of money because you have to buy all these machines up front, and you have to have the individuals with the right knowledge to maintain all of this stack. All right, so different individuals in different teams maintaining this whole on-premise data center. You may also have different data centers deployed globally. So you can imagine the cost overhead of this. So everything in green is basically you're managing it. Now we can offset that and ask AWS to handle part of this stack over here. So on this second column over here, we see infrastructure as a service, which basically says, AWS, I want you to handle all the networking, my software-defined network. I want you to handle my storage, elasticity. I want you to handle my compute power, my virtual machines. I want you to handle even administrating those machines at a physical layer as well. And I want you to physically secure them. So this will allow you more time to focus on all the green up here. Of course, we can move up the stack and say, I even want AWS to take on more responsibility. And that would be more of a platform as a service where AWS would also install and maintain the operating system for you. So you can imagine things like new versions of operating systems, security patches, maintenance patches, all of the like, and any middleware or runtime that you have on top of that. Think of something like the Java virtual machine, perhaps, that needs to be updated. Now, you wouldn't be responsible for maintaining all of what's in orange over here. You would only be responsible for deploying your application and making sure that your data is saved and secured, right? So again, platform as a service is a more hands-off approach. So think of it as you wanted to set up a CI/CD deployment environment for your development team, and you want it to be very involved in just handling your application code and making sure that it was properly compiled, built, tested, and deployed, right? Well, this could be implemented as a platform as a service. Or you could take your code as a zip file and give it to AWS's service called Beanstalk, which would automatically deploy your code and make sure that it's highly available, scalable, and fault tolerant across all of the orange stack over here, right? So more of a hands-off approach. Of course, we can go all the way up the stack and tell AWS to take care of everything for us and just ask for a service, much like a utility, like electricity or water. We might want to say, we just want an email software service, and we're not really concerned about how the underlying operating system or servers or network are configured for that. We just want to use the software as a service. We don't want to administrate anything else. We just want to be sort of like an end user to it. So AWS will manage everything underneath the hood. So there are varying types of services. You pick and choose whichever one makes more sense for you and your team. So what is S3? S3 stands for Simple Storage Service, and it is an object storage service in Amazon. What this means is that it doesn't matter what kind of file you upload to S3, it will be treated as an abstraction, meaning an object. So you can upload a PDF file, you can upload a JPEG file, you can upload a database backup. It doesn't really matter. All that is abstracted away by the use of storing it within an object. We're going to talk more about what composes an object, but by doing so, what happens is S3 allows us to have industry leading scalability. So it doesn't matter if you're going to make a request for that database backup, let's say that object, 5 times or 10,000 times, that request, that demand will scale. The underlying infrastructure that is implemented behind the scenes is handled for you. So in a sense, it's kind of like a serverless service, a storage service, where you're not implicated in handling anything underneath the covers. You're just uploading your objects and accessing them later on. In terms of data availability, very powerful as well, because it takes those objects and will replicate them across at least 3 availability zones. Of course, these availability zones have 1 or more data centers attached to them. So you have lots and lots of copies of your objects distributed globally, or at least at a regional, in a regional area. You can do this as well globally if you enable global replication. And you will see that your level of durability will skyrocket, and you're just not going to worry about losing an S3 object. Data security, well, we can encrypt our data at rest, our objects at rest. We can encrypt it in transit. We can also come up with security policies at the bucket level, which we're going to talk about what a bucket is very soon. These are going to be implemented through what's called IAM policies, and you're going to be able to control who or what has access to your objects. And of course, because everything is handled underneath the covers, all the servers, all the storage nodes are cloud optimized for the best possible performance. So let's continue on our journey on what is S3. We're going to take a look at what is a bucket and what is an object. As you can see here, you have inside this bucket, which is a logical container for an unlimited amount of objects. You could have objects of different shapes and sizes. Like I said, you could have pictures, database backups, etc. So this is what's being represented here by different shapes. And you can think of a bucket really as almost like a folder where objects or files are placed within them. So there are many ways for us to place objects within a bucket. We can do this through the AWS console, which I'll be showing you very shortly. We can do this via the command line interface, or we can do this through a software development kit. At the end of the day, all those 3 options go through an API, right? So it's all about picking the right method that is best suited for whatever kind of end user or application that needs access to these buckets and to these objects. Now, once you've got the data or objects within this bucket, you can control pretty much how the data is accessed, how it's stored, whether you want it to be encrypted, and how it's even managed. So you can have organizations that have specific compliance needs. For example, any objects that are placed in, or perhaps some PDFs, are not to be modified or not to be touched for 90 days, let's say. We can imply object locks if we want to. We can imply security guards. We can also, for example, record all API actions that try to access, to list, to delete any kind of API operations on those objects at the bucket level or on the object level. We can record if that is some sort of organizational compliance need for auditing or for whatever internal auditing reason that you may have. So continuing on here, you can see that there are many organizations that use S3. One in point is Amazon itself. S3 is so popular and so durable that Amazon internally uses it to store its own data. You're guaranteed, almost that you're not going to lose any object in there because it has what we call 11 nines durability. Now, 11 nines durability is really an extreme amount of durability where it's mathematically almost impossible for you to lose an object once you place it in S3. You're in fact more liable to get hit by a meteorite than you are to lose an object in S3, statistically speaking, which is a pretty incredible statistic, but it's true. So if we continue here with the benefits of S3, some of these I've already described, but let's talk about the full picture here. We see the performance, scalability, availability, and durability of S3 are really first class in the industry. Again, durability, we were talking about that 11.9. So what that really means is 99.9999 in total. If you count all the nines, that's 11 of those nines. So most durable in the industry by far. And again, because everything is handled underneath the covers, it's a serverless service. They ensure the scalability and availability and the performance of the inner workings of that object level storage. Now, cost is of course always important, and S3 really shows up here with first class support again for cost. It's got very, very low cost. We can have object level storage for let's say 1 terabyte of object level storage for as little as $1 a month. So again, it will depend on the kind of storage class. We're going to have a discussion on different types of storage classes that we might want to transition or move over our objects from one storage class to the next, depending on how frequently accessed that data is. As you know, data over time seems to get less and less accessed as your needs shift from one place to another. We're going to talk about that coming up very soon. So we're going to want to really focus on that to reduce our end of the month costs for storage with S3. Of course, security is always at the forefront, and we want to make sure that we either simply secure by encrypting everything right off the bat, either at rest, in transit, or we want to put an object lock or just maintain security at the bucket level, maintaining, let's say, who or what has access to that data. Because by default, no one has access to the data unless we open up the door. And also we want to make sure that we don't give public access to our bucket for obvious reasons of giving away important information by mistake. So AWS makes it extremely difficult for you to accidentally do this. And I'm going to show this in a demonstration lab coming up very soon. And we can also query in place, which is very interesting. So you can imagine you putting, let's say, a file that's in CSV format or a JSON format or Parquet format, some sort of structured format or semi-structured format in S3, and you could actually use SQL queries on the spot to filter that data in place at the bucket level. You could also have other services that may want to extract some business intelligence from that data in your S3 bucket directly as well. So some other more advanced querying operations can take place at the S3 level. So this you will learn during your journey with Simplilearn as you're covering all the AWS technology stacks. And here, the most widely used storage cloud service in the industry. Because of all the points that we just covered, it really is the #1 storage or object level storage solution in the industry. Let's now take a look at objects and buckets in S3. So the objects are really the fundamental entities that are stored in S3, or the lowest common denominator, which means that we're not really interested in what kind of data is within the object at the layer of S3, because S3 doesn't have direct access to the data within an object. Like I said before, it's an abstraction of the data. So we don't know if it's a cat picture, if it's a backup of your database. It's just treated as a fundamental entity, aka the object. Now, every object is associated with metadata, so data about itself, things like what's the name of the object, what's the size, the time and date that the object was uploaded. Things of that nature are categorized as metadata. So S3 does have direct access to that. Now, the data within that object, of course, is accessible by other services. So it's not that once you've uploaded it, you've totally lost the data and it's only can be treated as an object. It's just that at this layer, it's simply just assigned metadata and a version ID, a unique version ID. And if you re-upload the exact same object a second or third time to S3, it will have its own version ID number, so a new unique version ID number will be generated. So really what buckets are their logical containers to store those objects. So of course, at an extremely high level, a bucket would be like your root file system, if you want to think about it like that. But that doesn't mean you can't go into this bucket and create separate folders. Now, when you create separate folders in a bucket, because you might want to logically organize all your objects, you might be fooled by the fact that you think this is a hierarchical storage system, when in fact it is not. And I'll talk about that in a second. So you cannot store an object without first storing it into a bucket. So of course, the first step would be for us to create a bucket and then upload objects within that bucket. So an object cannot exist without its container or its bucket. So there's no Windows Explorer view like we're used to in an operating system, because this is not a hierarchical view. No matter if you create folders within folders within folders, in fact, S3's internal architecture is a flat hierarchy. What we do instead is we assign prefixes which are treated as folders in order to logically organize our objects within our buckets. And I'm going to showcase a prefix in one of the demonstrations coming up very soon. So when you create, or when you're working with S3, first of all, you're working at a regional level. You're going to have to pick a region. For example, you might pick US East 1 region or US East 2 region, and the bucket that you're going to be creating will be replicated across several availability zones, but within that region. Also, that data, those objects, can be accessed globally because S3 uses the HTTP protocol. HTTP protocol is very permissive. Everybody knows how to administrate it and work with it. So we just need to give access to that object in terms of a permission policy and give it the proper URL, or give whoever needs access to it the proper URL, and they can access that via HTTP globally. So first, when you're creating a bucket, you have to select the region, and the object will live within that region, but that doesn't mean that it still can't be accessed globally. So let's now take a minute, go over to the AWS console, and actually let me showcase how to create objects and buckets. So for our first lab, we're going to be going and creating an S3 bucket and uploading an object to it. So we first have to log into the AWS console, which we have up here in the address bar. Let's click on either create free account if it's your very first time, or as is in my case, already have an account, and we're going to sign in here. You're going to have to pass in your IAM username, password, and your account ID, of course. Once you've logged in, you can search for the simple storage service S3 either by coming up here in the search box and typing S3, and you'll find it there. That's probably the easiest way. Or if you want, you can take a look at all the services and it'll be under storage over here, the first one. Okay, so pick whichever method you see best for yourself. Once we're here, we want to create our first bucket. Now I've already have a couple of buckets here, so we're going to go on and create a new bucket. The very first thing is you have to specify a bucket name. Now this bucket name has to be globally unique. If you take a look here at the region that we're in, it doesn't actually select a specific region. It selects the global option, which means that this bucket will become globally accessible. So that is why it needs to have a unique name, much like a DNS name has to be unique for your website, right? So I'm going to come up here and pick a name that I think is going to be unique. So I'm going to say Simplilearn S3 demo. All right, let's take a look at if that's going to work out. Of course, we have to pick a region, but it is globally accessible. So you either pick a region that's closest to your end users, or in our case, since we're just doing a demonstration, we can do whichever is closer to us right now. Okay, and we're going to skip these options for now. We're going to come back to them later on. We're just going to create the bucket. Now, hopefully that was a unique name and allowed me to create that, and it looks like it did. So if I scroll down, you can see that it clearly got created over here. Now, we're going to click on that, and we're going to start uploading objects to this bucket. So let me click on the upload button, and you can either select one or more files, or you can select an entire folder. So I'm going to just go and select a specific cat picture that I have here. Okay, and again, we'll go through some of those other options later on, and we'll just click upload. Now this should take no time at all because of the fact that it's a very small object or a file that's being uploaded. So it has succeeded. We can close this up. And we see now clearly that the object is in our bucket. If we go to properties, we can see the metadata associated with this bucket. We can see the region that it's in. We can see the ARN, which is the Amazon resource name, which uniquely identifies this resource, this bucket, across the globe. So if ever you needed to reference this, let's say in an IAM policy or whatever other service needed to communicate with S3, you would need this ARN. It's a very important piece of information. And of course, we have the creation date. Some high level metadata. So objects, as we have covered already, consist of not only the data itself, but the metadata. So there's lots of metadata, and there's a lot of other features that we can go here and enable very easily. And this will be the basis of the future demonstrations that I'm going to do. All right. So just to recap what we just did, we created a unique bucket, gave it a name of Simplilearn S3 demo, and uploaded our first object to it. So let's now take a look at the inner workings of the Amazon S3. When we upload an object into a bucket, we have to select which one of these storage classes the object will reside in. So you see I have 6 storage classes here at the bottom, and each have their own characteristics that we're going to get into. By default, if you don't specify anything, it'll get placed in what's called the S3 standard storage class, which is the most expensive out of all these storage classes. Once your object gets colder, and what I mean by colder is your access patterns diminish, meaning that you're accessing that file less and less over the course of time, so it gets colder, you will transition that object from one tier to the next, all the way to, for example, S3 Deep Archive. So again, Deep Archive signifies extremely cold, so maybe you're only referencing this data once a year, once every couple of years. And so you want to have the cheapest possible storage available. So right now you can get about 1 terabyte of storage per month for about $1 a month with S3 Glacier Deep Archive. So you are going to be very interested in knowing how to transition from one or more of these storage classes over time in order to save on your storage costs. That's really why we're doing this. So let's go through some of these storage classes. By default, like I said, whenever you upload an object, you automatically get placed into the standard storage class. So any files that you're working on frequently, daily, this is the best fit for it. You've got the highest level of accessibility and durability as well. Not that the others don't have the same level of durability. However, we'll see how when you transition from one storage tier to the next, some characteristics do change in order for you to save on some costs. We're going to go through some of those. Now, this would be considered hot data, right? Data that's used all the time, maybe just by you, maybe by everybody, right? So that's the perfect place to place it in the standard storage class. Now, over time, like I said, you may find yourself working less and less, perhaps on a document that was due by the end of the month. That document was submitted, and then afterwards you don't work on that document anymore. Perhaps you're only working on revisions based on feedback from your colleagues that are asking you to make some corrections or some amendments, and so only those corrections or amendments come in perhaps once a month. And so in that case, you might find yourself finding a justification for moving that document from the standard tier to the standard IA or infrequently accessed tier. Maybe any objects not modified for more than 30 days are a good fit for that. And that's really the criteria for IA, inactive access, is that S3 or AWS itself recommends to only put objects in there if they haven't been accessed for at least 30 days. So you get a price reduction, a rebate for putting objects that are not accessed frequently in here. Of course, if you remove objects, let's say before the 30-day limit, then you are charged a surcharge for retrieving an object that you said was infrequently accessed, but it really was not. So bear that in mind. If you're going to place objects in infrequent access, be somewhat reasonably assured that you're not going to be going there and accessing them. You can still access those files, no problem, just as quickly. They have the same level of accessibility and durability. However, like I said, anything less than 30 days, you'll get a price ding on that. If you want to have long-term storage, we're talking about Amazon Glacier. So this is more anything over 90 days that hasn't been modified, or 180 days. There's two subcategories of Amazon Glacier that we're going to get into. And this is the cheapest storage by far. And Amazon Glacier doesn't really operate through the AWS console as the same as the standard and the infrequent access. You can't really upload objects to Glacier via the console in the browser. You can only do so, let's say, through the command line interface or through an SDK. The only thing you can do on the web console with Glacier is actually create what's called a vault, which is a logical container for your archives. But then after that, you have to go through the CLI or the SDK to do the rest of the work there. If we continue on, there's some gray areas between the S3 standard and the Glacier. One is the one zone infrequently accessed storage class. So if we go back to the regular standard and IA storage class, all of these objects are stored across a minimum of 3 availability zones. If you want a further price reduction, you can store your objects in a one zone IA storage class, which means that instead of taking that object and replicating it across 3 or more availability zones, it will only store it in a single availability zone, therefore reducing the level of availability that you have to that object. So in this case here, if that single availability zone would go down, for example, you would not have access to that object. Once it would come back up, of course, you would. The other thing is if there was an immense catastrophe where the actual availability zone was destroyed, well, of course, then your object is also gone. So if that's something that doesn't worry you because you have already many copies of this object maybe lying around on premise, then this is a good option for you because it's data that you're willing to lose or lose access to for short periods of time if ever that single availability zone goes down. So it's about an extra 20% off the price from already the normal IA standard price. There is another one called the standard reduced redundancy storage. This one is kind of getting phased out as we speak because the same price for this storage class is about the same amount you're going to pay for the normal IA standard class. What this does is, again, is a good fit for your objects that you're not really worried about losing if there is some sort of catastrophe that happens in an availability zone. There's less copies of it that are stored, and so if that data center and that availability zone goes down, then you lose your object. So of course it offered at the time the highest price reduction possible, but now the difference between this one and the normal IA standard storage class is so small in terms of price that you're probably not going to migrate to or navigate to this storage class. But it is still there in the documentation, and it may very well come up still in the certification exam, so at least be aware of that. Let's now take a look at some individual features of S3, starting off with lifecycle management. So lifecycle management is very interesting because it allows us to come up with a predefined rule that will help us automate the transitioning of objects from one storage class to another without us having to manually copy things over. Of course, you could imagine how time consuming that would be if we had to do this manually. So we're going to see this very soon in a lab. However, let me discuss how this works. So once it's basically a graphical user interface. It's very, very simple to use once you come up with these lifecycle management rules. But you're going to define two things. You're going to define the transition action and the expiration action. So the transition action is going to be something like, well, I want to transition an object from, maybe it's all objects, or maybe it's just a specific type of object in a folder, example, that has a specific prefix, from one storage class, let's say standard, to standard inactive or infrequent access. Maybe only after 45 days, after at least a minimum of 30 days, like we spoke of before. And then maybe after 90 days, you want to transition the objects in IA to right away Glacier Deep Archive, or 180 days. You come up with whatever combination you see fit. Okay, it doesn't have to be sequential from S3 to IA to one zone, etc., because like we discussed before, it depends what kind of objects that you're interested in putting in one zone, objects that you don't really mind losing if that one availability zone goes down. So you're going to be deciding those rules. It ends up that this even is not a simple task because you have to monitor your usage patterns to see which data is hot, which data is cold, and what's the best kind of lifecycle management to implement to reap the benefits of the lowest cost. So you have to put somebody on this job and make the best informed decisions based on your access patterns, and that is something that you need to consistently monitor. So what we can do is we can instead opt for something called S3 Intelligent Tiering, which basically analyzes your workload using machine learning algorithms. And after about a good 30 days of analyzing your access patterns, we'll automatically be able to transition your objects from S3 standard to S3 standard infrequent access. Okay, it doesn't go past the IA one, it doesn't go after the Glacier and whatnot. Okay, so it can then offer you that at a reduced price overhead. So there is a monitoring fee that is introduced in order to implement this feature. It's a very nominal, very, very low monitoring fee. And the nice thing is if ever you take out an object out of the infrequent access before the 30-day limit, as we spoke of before, you will not be charged an overhead charge because of that. Why? Because you're using the intelligent tiering. You're already paying an overhead for the monitoring fee. So at least in that sense, the intelligent tiering will take the object out of IA and put it back into the S3 standard class if you need access to it before the 30 days. And in that case, you won't be charged that overhead. So that is something that is very good to do in order not to have to put somebody on that job. So yes, you're paying a little bit of overhead for that monitoring fee, but at the other side of the spectrum, you're not investing in somebody working many hours to monitor and put into place a system to monitor your data access patterns. So let's take a look at how to do this right now. Let's implement our own lifecycle management rules. So let's now create a lifecycle rule inside our bucket. First off, we're going to need to go to the management tab in the bucket that we just created. And right on the top, you see right away, lifecycle rule. We're going to create lifecycle rule and we're going to name it. So I'm just going to say something very simple, like simply learn lifecycle rule. And we have the option of creating this rule for every single object in the bucket, or we can limit the scope to a certain type of file, perhaps with a prefix like I could see one right now, something like logs. So anything that we categorize as a log file will transition from one storage tier to the next as per our instructions. We're doing this because we really want to save on costs, right? It's not so much of organizing what's your older data versus your newer data. It's more about reducing that storage cost as your objects get less and less used. So in this case, logs are a good fit because perhaps you're using your logs for the first 30 days, you're sifting through them, you're trying to get insights on them, but then you kind of move them out of the way because they become old data and you don't need them anymore. So we're going to see how we can transition them to another pricing tier, another storage tier. We could also do this with object tags, which is a very powerful feature. And in the lifecycle rules action, you have to at least pick one of these options. Now, since we haven't enabled versioning yet, what I'm going to do is just select transition the current version of the object between these storage classes. So as a reminder of what we already covered in the slides, our storage classes are right over here. So the one that's missing is obviously the default standard storage class, which all objects are placed in by default. So what we're going to say is this. We want our objects that are in the default standard storage class to go to the standard inactive access storage class after 30 days. And that'll give us a nice discount on those objects being stored. Then we want to add another transition. And let's say we want to transition them to Glacier after 90 days. And then as a big finale, we want to go to Glacier Deep Archive. You can see the rest are grayed out. Wouldn't make sense to go back. And maybe after 180 days, we want to go there. Okay. Now there's a little bit of a warning or a call to attention here. They're saying if you're going to store very small files into Glacier, not a great idea. There's an overhead in terms of metadata that's added, and also there's an additional cost associated with storing small files in Glacier. So we're just going to acknowledge that. Of course, for the demonstration, that's fine. In real life, you don't want to store very big tar files or zip files that had, one or more log files in there. Okay, that would bypass that surcharge that you would get. And over here, you have the timeline summary of everything we selected up above. So we have here after 30 days, the standard inactive access, after 90 days, Glacier, and after 180 days, Glacier Deep Archive. So let's go and create that rule. All right, so we see that the rule is already enabled, and at any time you could go back and disable this if ever you had a reason to do so. We can easily delete it as well, or view the details and edit it as well. So if we go back to our bucket, now what I've done is created that prefix with the /logs. Since we're not doing this from the command line, we're going to create a logs folder over here that will fit that prefix. So we're going to create logs, create a folder. And now we're going to upload our, let's say, Apache log files in here. So we're going to upload one demonstration Apache log file that I've created with just one line in there, of course, just for demonstration purposes. We're going to upload that. And now we have, we're going to just close that. And now we have our Apache log file in there. So what's going to happen, because we have that lifecycle rule in place, after 30 days, any file that has the logs prefix, or basically is placed inside this folder, will be transitioned as per that lifecycle rule policy that we just created. So congratulations, you just created your first S3 lifecycle rule policy. Let's now move over to bucket policies. So bucket policies are going to allow or deny access to not only the bucket itself, but the objects within those buckets to either specific users or other services that are inside the AWS network. Now, these policies fall under the category of IAM policy. So IAM stands for Identity and Access Management. And this is a whole other topic that deals with security at large. So there are no services in AWS which are allowed to access other services or data, for example, within S3 without you explicitly allowing it through these IAM policies. So one of the ways we do that is by attaching one of these policies which are written in a JSON format. So it's a text file that we write. At the end of the day, that's the artifact, and that's a good thing because we can use that artifact and we can configuration control it in our source control and version it and put it alongside our source code. So when we deploy everything, it is part of our deployment package. So in this case here, we have several ways of doing this. We can use what's called the policy generator, which is a graphical user interface that allows us to simply click and point and populate certain text boxes, which will then generate that JSON document that will allow us to attach that to our S3 bucket, and that will determine, like I said, which users or services have access to whatever API actions are available for that resource. So we might say we want certain users to be able just to list the contents of this bucket, not necessarily be able to delete or upload new objects into that bucket. So you can get very fine-grained permissions based on the kind of actions you want to allow on this resource. So in order to really bring this home, let's go and perform our very own lab on this. Let's now see how to create an S3 bucket policy. Going back to our bucket, we're now going to go into permissions. So the whole point of coming up with a bucket policy is that we want to control who or what, the what being other services, have access to our bucket and our objects within our bucket. So there are several ways we can go about doing this. Let's edit a bucket policy. One, we can go and look at a whole bunch of pre-canned examples, which is a good thing to do. Two, we could actually go in here and code the JSON document ourselves, which is much more difficult, of course. So what we're going to do is we're going to look at a policy generator, which is really a form-based graphical user interface that allows us to generate, through the answers that we're going to give here, the JSON document for us. First question is, we got to select the policy type. Of course, we're dealing with S3, so it makes sense for us to create an S3 bucket policy. The two options available to us are allowing or denying access to our S3 bucket. Now, in this case here, we could get really fine-grained and specify certain kinds of services or certain kinds of users. But for the demonstration, we're just going to select star, which means anything or anybody can access this S3 bucket. All right. Now, depending on also the actions that we're going to allow. So in this case here, we can get very fine-grained, and we have all these checkboxes that we can check off to give access to certain kind of API action. So we can say we want to give access to, just deleting the bucket, which obviously is something very powerful. But you can get more fine-grained. As you can see, you have more of the getters over here, and you have more of the listing and the putting new objects in there as well. So you can get very fine-grained. Now, for demonstration purposes, we're going to say all actions. So this is a very broad and wide-ranging permission, something that you really should think twice about before doing. We're basically saying we want to allow everybody and anything, any service, all API actions on this S3 bucket. So that's no small thing. We need to specify the Amazon resource name, the ARN of that bucket specifically. So what we're going to do is go back to our bucket, and you can see here the bucket ARN. Okay, so we're just going to copy this, paste it in this policy generator, and just say add statement. You can see here kind of a resume of what we just did, and we're going to say generate policy. And this is where it creates for us, and make this a little bit bigger for us, it creates that JSON document. So we're going to take this, we're going to copy it, and we're going to paste it into the generator. Okay. Now, of course, we could flip this and change this to a deny, right? Which would basically say we don't want anybody to have access, or anything, any other service to have access to this S3 bucket. We could even say /* to also encapsulate all the objects within that bucket. So if I save this right now, you have a very ironclad S3 bucket policy, which basically denies all access to this bucket and the objects within. Of course, this is on the other side of the spectrum, very, very secure. So we might want to, for example, host a static website through our S3 bucket. So in this case here, allowing access would make more sense, right? So if I save changes, you see that we get an error here saying that we don't have permissions to do this. And the reason for that is because it realizes that this is extremely permissive. So in order to give access to every single object within this bucket, as in the case that I was stating of a static website being hosted on your S3 bucket, it would be much better to also at first enable that option. So I'm just going to duplicate the tab here. And once you go back to the permissions tab, one of the first things that shows up is this block public access setting, right? Right now it's completely blocked, and that's what's stopping us from saving our policy. We would have to go in here, unblock it, and save it, right? And it's also kind of like a double clutch feature. You have to confirm that just so you don't do that by accident, right? So now what you've effectively done is you've really opened up the floodgates to have public access to this bucket. It's something that can't be accidentally done. It's kind of like having to perform these two actions before the public access can be granted. Now, historically, this was something that AWS was guilty of, was making it too easy to have public access. So now we have this double clutch. Now that this is enabled or turned off, we can now save our changes here successfully. And you can see here that now it's publicly accessible, which is a big red flag that perhaps this is not something that you're interested in doing. Now, if you're hosting a public website and you want everybody just to have read access to every single object in your bucket, yes, this is fine. However, please make sure that you pay very close attention to this type of access flagged over here on the console. So congratulations, you just got introduced to your first bucket policy, a permissive one, but at least now you know how to go through that graphical user interface through the policy generator and create them and paste them inside your S3 bucket policy pane. So let's continue on with data encryption. So any data that you place in S3 bucket can be encrypted at rest very easily using an AES 256 encryption key. So we can have server-side encryption. We could have AWS handle all the encryption for us, and the decryption will also be handled by AWS when we request our objects later on. But we could also have client-side encryption where we, the client that are uploading the object, have to be responsible for also passing over our own generated key that will eventually be used by AWS to then encrypt that object on the bucket side. Of course, once that happens, then the key is discarded, the client key is discarded, and you have to be very mindful that since you've decided to handle your own encryption, client-side encryption, that if ever you lose those keys, well, that data is not going to be recoverable in that bucket on the AWS network. So be very careful on that point. We can also have a very useful feature called versioning, which will allow you to have a history of all the changes of an object over time. So versioning sounds exactly how it's named. Every time you make a modification to a file and upload that new version to S3, it will have a brand new version ID associated with that. So over time, you get a sort of stack of a history of all the file changes over time. So you can see here at the bottom, you have an ID with all these ones, and then an ID with 121212. So eventually, if ever you wanted to revert back to a previous version, you could do so by accessing one of those previous versions. Of course, versioning is not an option that's enabled by default. You have to go ahead and enable that yourself. It is an extremely simple thing to do. And so there may be a situation where you already have objects within your buckets and you only then enable versioning. Well, versioning would only apply to the new objects that would get uploaded from the point that you enabled versioning. The objects that were there before that point will not get a specific version number attached. In fact, they will have a sort of null marker version number that will get attached to them. It's only after that you modify those objects later on and upload a new version that they will get their own version numbers. So right now, what we're going to be doing is a lab on actual versioning. So let's go ahead and do that right now. In this lab, we're going to see how to enable versioning in our buckets. Enable versioning is very easy. We're simply going to click on our bucket, go into properties, and there is going to be a bucket versioning section. We're going to click on edit and enable it. Once that's done, any new objects that are uploaded to that S3 bucket will now benefit from being tracked by a version number. So if you upload objects with the same file name after that, they'll each have a different version number. So you'll have version tracking, a history of the changes for that object. Let's actually go there and upload a new file. I'll upload one called index.html. So we're going to simulate a situation where we've decided we're going to use an S3 bucket as the source of our static website to deploy one. And in this index.html file, if you take a look right now, let's take a look at what's in there. You can see that we have welcome to my website and we're at version 2. Okay, so if I click on this file right now and I go to versions, I can clearly see that there's some version activity that's happening here. Okay, we have here at 1456, which is the latest one is on the top, the current version, we have a specific version ID. And then we have a sort of history of what's going on here. Now, I purposely enabled versioning before and then tried to delete versioning or disable versioning. But here's the thing with versioning. You cannot disable it fully once it's enabled. You can only suspend it. Right? Now, suspending means that whatever version numbers those objects had before you decided to suspend it will remain. So you can see I have an older version here that has an older version number. And at this point here, I decided to suspend versioning. And so what it does, instead of disabling the entire history, it puts what's called a delete marker. Okay? You could always roll back to that version if you want. Now, in the demonstration, when we started it together, I enabled it again. So you can see this is actually the brand new version number as we did it together, but you don't lose the history of previous versioning if ever you had suspended it before. So that's something to keep in mind, right? And it'll come up in the exam where they'll ask you, can you actually disable versioning once it's enabled? And the answer is no, you can only suspend it. And your history is still maintained. Now, we have that version there, and let's say I come to this file and I want to upgrade this, I don't know, I say version 3, right? And now what's going to happen is if I click on this version, just as the current one with version 2, and I open this, we should see version 2, which is fine. That's expected. If we go back to our bucket and upload that new version file, that has version 3 in there, the one I just modified, we should now see in that index.html file a brand new version that was created under the versions tab. And there you go, 1458, just 2 minutes after. You can see here we have a brand new version ID, right? And if I open this one, you can see version 3. So now you have a way to enable versioning very easily in your buckets. And you also have seen what happens when you want to suspend versioning, what happens to the history of those versions files before. Just to actually go back here to the properties where we enabled versioning in the first place, if I want to go back in here and disable it, like I said, you can't disable, you can only suspend. And that's where that delete marker gets placed, but all your previous versions retain their version ID. So don't forget that, because that will definitely be a question on your exam if you're interested in taking the certification exam. So congratulations, you just learned how to enable versioning. Let's move on to cross-region replication, or CRR as it is known. There will be many times when you find yourself with objects in a bucket and you want to share those objects with another bucket. Now that other bucket could be within the same account, could be within another account within the same region, or could be within a separate account in a different region. So there's varying levels of degree there. The good thing is all of those combinations are available. So CRR, if we're talking about cross-region replication, is really about replicating objects across regions. Something that is not enabled by default, because that will incur a replication charge because it's syncing objects across regions. Of course, you are spanning a very wide area network in that case, so there is a surcharge for that. Now, doing so is quite simple to do, but one of the things that we have to be mindful of is to give permissions for the source bucket, which has the originals, to allow for this copying of objects to the destination bucket. So if we're doing this across regions, of course, we would have to come up with IAM policies, and we would also have to exchange credentials in terms of IAM user credentials, in terms of account IDs and the such. We're going to be doing a demonstration in the same account, in the same region, but largely this would be the same steps if we were going to go cross region. So this is something you might find yourself doing if you want to share data with other entities in your company. Maybe you're a multinational and you want to have all your log files copied over to another bucket in another region for another team to analyze, to extract business insights from. Or it might just be that you want to aggregate data in a separate data lake in an S3 bucket in another region, or in like I said, it could be even in the same region or in the same account. So it's all about organizing, moving data around across objects, across these boundaries. And let's actually go through a demonstration and see how we can do CRR. Let's now see how we can perform cross-region replication. We're going to take all the new objects that are going to be uploaded in the Simplilearn S3 demo bucket, and we're going to replicate them into a destination bucket. So what we're first going to do is create a new bucket, okay? And we'll just tack on the number 2 here. And this will be our destination bucket where all those objects will be replicated to. We're going to demonstrate this within the same account, but it's the exact same steps when doing this across regions. One of the requirements when performing cross-region replication is to enable versioning. So if you don't do this, you can do it at a later time, but it is necessary to enable it at some point in time before coming up with a cross-region replication rule. All right, so let me create that bucket. And now after the bucket is created, I want to go to the source bucket and I want to configure under the management tab here a replication rule. So I'm going to create a replication rule, call it Simplilearn rep rule. And I'm going to enable this right off the bat. The source bucket, of course, is the Simplilearn S3 demo. We could apply this to all objects in the bucket or perform a filter once again. Let's keep it simple this time and apply to all objects in the bucket. Of course, caveat here, this will only now apply to any new objects that are uploaded into this source bucket and not the ones that are already pre-existing there. Okay. Now, in terms of a destination bucket, we want to select the one we just created. So we can choose a bucket in this account, or if we really want to go cross region or another account in another region, we could specify this and put in the account ID and the bucket name in that other account. So we're going to stay in the same account. We're going to browse and select the newly created bucket. And we're also going to need permissions for the source bucket to dump those objects into the destination bucket. So we can either create the role ahead of time, or we can ask this user interface to create a new role for us. So we'll opt for that, and we'll skip these additional features over here that we're not going to talk about in this demonstration. We're just going to save this. So that will create our replication rule that is automatically enabled for us right now. So let's take a look at the overview here. You can see it's been enabled. Just to double check, the destination bucket is the demo 2. We're talking about the same region. And again, here we could opt for additional parameters like different storage classes in the destination bucket that object is going to be deposited in, etc., etc. For now, we just created a simple rule. Now, if we go back to the original source bucket, which we're in right now, and we upload a new file, which will be a transactions file in a CSV format, once this is uploaded, that cross-region replication rule will kick in and will eventually, right, it's not immediate, but will eventually copy the file inside the demo 2 bucket. Now I know it's not there already, so what I'm going to do is pause the video and come back in 2 minutes, and when I click on this, the file should be in there. Okay, so let's now double check and make sure that object has been replicated. And there it is, been replicated as per our rule. So congratulations, you just learned how to perform your first same account S3 bucket region replication rule. Let's now take a look at transfer acceleration. So transfer acceleration is all about giving your end users the best possible experience when they're accessing information in your bucket. So you want to give them the lowest latency possible. You can imagine if you were serving a website and you wanted people to have the lowest latency possible. Of course, that's something that's very desirable. So in terms of traversing long distances, if you have your bucket that is in, for example, the US East 1 region in the United States, in the Virginia region, and you had users, let's say in London, that want to access those objects, of course, they would have to traverse a longer distance than users that were based in the United States. And so if you wanted to bring those objects closer to them in terms of latency, then we could take advantage of what's called the Amazon CloudFront Delivery Network, the CDN network, which extends the AWS backbone by providing what's called edge locations. So edge locations are really data centers that are placed in major city centers where our end users mostly are located, more densely populated areas, and your objects will be cached in those locations. So if we go back to the example of your end users being in London, well, they would be accessing a cached copy of those objects that were stored in the original bucket in the, for example, US East 1 region. Of course, you will get most likely a dramatic performance increase by enabling transfer acceleration. It's very simple to enable this. Just bear in mind that when you do so, that you will incur a charge for using this feature. The best thing to do is to show you how to go ahead and do this. So let's do that right now. Let's now take a look at how to enable transfer acceleration on our Simplilearn S3 demo bucket. By simply going to the Properties tab, we can scroll down and look for a heading called Transfer Acceleration over here, and very simply just enable it. So what does this do? This allows us to take advantage of what's called the Content Delivery Network, the CDN, which extends the AWS network backbone. The CDN network is strategically placed into more densely populated areas, for example, major city centers. And so if your end users are situated in these more densely populated areas, they will reap the benefits of having transfer acceleration enabled because the latency that they will experience will be severely decreased. So their performance is going to be enhanced. If we take a look at the speed comparison page for transfer acceleration, we can see that once the page is finished loading, it's going to do a comparison. It's going to perform, first of all, what's called a multi-part upload, and it's going to see how fast that upload was done with or without transfer acceleration enabled. Now, this is relative to where I am running this test. So right now I'm actually running it from Europe. So you can see that I'm getting very, very good results if I would enable transfer acceleration and my users were based in Virginia. So of course, now I have varying differences in percentage as I go closer or further away from my region where my bucket or my browser is being referenced. So you can see here, United States, I'm getting pretty good percentages. As I go closer to Europe, it gets lower, of course, but still very, very good. Frankfurt, again, this is about probably the worst I'm going to be getting here since I'm situated in Europe. And of course, as I go look more towards the Asian regions, you can see once again it kind of scales up in terms of better performance. So of course, this is an optional feature. Once you enable it, as I just showed over here, this is a feature that you pay additionally for. So bear that in mind. Make sure that you take a look at the pricing page in order to figure out how much this is going to cost you. So that is it. Congratulations. You just learned how to simply enable transfer acceleration to lower the latency from the end user's point of view. We're now ready to wrap things up in our conclusion and go over at a very high level what we just spoke about. So we talked about what S3 is, which is a core service, one of the original services published by AWS in order for us to have unlimited object storage in a secure, scalable, and durable fashion. We took a look at other aspects of S3 in terms of the benefits. We mainly focused on the cost savings that we can attain in S3 by looking at different storage classes. Now, of course, S3 is industry recognized as one of the cheapest object storage services out there that has the most features available. We saw what goes into the object storage in terms of creating first our buckets, which are our containers, high-level containers in order for us to store our objects in. Again, objects are really an abstraction of the type of data that are in there, as well as the metadata associated with those objects. We took a look at the different storage tiers, the default being the standard, all the way till the cheapest one, which is the Glacier, which are meant for long-term archived objects. For example, log files that you may hold on to for a couple of years, may not need to access routinely, and will have the cheapest pricing option by far. So we have many pricing tiers, and if you want to transition from one tier to the next, you would implement a lifecycle policy or use the intelligent tiering option that can do much of this for you. We took a look at some very interesting features, starting from the lifecycle management policies that we just talked about, all the way to versioning, cross-region replication, and transfer acceleration. So With this conclusion, you are now ready to at least start working with S3.
Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general, and then it uses a service called Docker, so we're going to understand what Docker is. And there are competitive services available for ECS. I mean, ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. I mean, each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying, you can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users, the end user could be in the internet, the end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment here. Most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, A lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up, and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that. Suddenly, if there is an increase in demand, how do you meet that demand? Right? Let's say you had like 1,000 users. Suddenly, the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster, and ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment the one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it, you're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right, so no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's a highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now, one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes, right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it. So to best use those resources in EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there. Right? This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers, because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already. And it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC, and this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, elastic network interface card, separate elastic network interface card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance, and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface Card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And these cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is an TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it, along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remind and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy a Docker container on ECS is, first we need to have an AWS account and then set up and run our first ECS cluster. So in our lab we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just one running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it a backup job? Is it a web application? Is it a data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and a bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate. And this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right. This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me. And it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it. And because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it. And I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location, so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now, right? So I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit, and the task CPU is 0.25 virtual CPU. Name of the service: is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's a security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer, and port 80 receives information on port 80 HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done, and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access these servers using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. Let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, IP of that container, and it says it's running, it was created at such and such time and started at such and such time, and this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo. And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here because remember, this is Fargate. You're not managing any ECS instance. So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Now this URL can be mapped to other services like DNS. This URL can be embedded in any of your application if you want to make that application connect with this container. Now using IP is not all that advisable because these containers can die and then a new container gets created, and when a new container gets created it gets a new IP, so hardcoding IP is not, hardcoding dynamic IPs are not advisable. So you would be using load balancer and putting that URL in that application that you want to make it interact with this container instance. It was a wonderful experience in walking you through this ECS topic, and in here we learned about what AWS is and why we're using ECS and what is ECS in general, what is Docker in specific, and we also learned about the advantages of ECS, the architecture, the different components of ECS, and how ECS works when they're all connected together. And we also looked at the companies that use ECS and their use cases, and finally a lab, how we can launch ECS Fargate through the portal.
So let's start with what is AWS EC2. In simple terms, AWS EC2 is a web service that lets you rent machines, also known as instances, to run your applications. Think of it as a renting powerful computer or server that you don't need to own or manage physically. You can choose the specification of machine like its processor, memory, and storage based on your requirements, and AWS takes care of all the maintenance, upgrades, and physical infrastructure behind the scenes. Before the cloud, if you wanted to run a web application or store data, you needed to buy physical servers. These servers took up space, required a lot of resources to manage, and had a fixed processing power. EC2 makes all that obsolete, providing scalable computing power at a fraction of a cost. Now, let us try to understand what is instance. Now, in the context of EC2, an instance refers to a virtual machine that runs on the AWS infrastructure. When you launch an EC2 instance, you are essentially spinning up a virtual server that can run software, handle data, and power applications just like physical server. Each instance can run an operating system such as Linux, Windows, or Mac OS and perform tasks like hosting a website, running a database, or supporting a web application. These instances have various configurations based on the amount of CPU, memory, or storage they provide, which is ideal for different use cases. Now, let us talk about what are the differences between instance and service. One point of confusion for beginners is understanding the difference between an EC2 service and an instance. So here's a simple way to think about it. Think of it EC2 service as an entire platform or offering provided by AWS, which gives you access to all the resources, tools, and capabilities needed to create and manage virtual machines or instances. If we talk about instance, an instance is an actual virtual machine that lets you create using your EC2 service. So EC2 is the tool and instance is the object you create with it. It's like going to a rental company like EC2 and renting a car instance. The company EC2 provides the vehicle you need to select on that it fits your needs. which is basically the instance. Now, you would be wondering why to choose AWS. So why should you use EC2 over traditional physical servers? The answer lies in the flexibility and cost effectiveness. In traditional computing, companies had to buy and maintain physical hardware. Scaling up or down meant by buying new servers and adding more resources manually. This could be expensive and time consuming. With EC2, you can scale up or down instantly. If you need more computing power, you can add more instances or switch to a higher performance instance type. If you need less, you can scale down just as easily. Now, if I talk about the next reason, that is pay only for what you use. So EC2 charges based on the amount of compute resources you use. You don't have to worry about an ideal servers paying for unused capacity. Think of it as like pay-as-you-go model, which makes EC2 highly cost-effective, especially for startups or small businesses. Next is, it also eliminates hardware management. AWS handles the hardware, so you don't need to worry about the server maintenance, replacements, or upgrades. Now, let us discuss about EC2 instance type, choosing the right fit. So, if I talk about AWS, it offers wide variety of EC2 instance types to cater to different use cases. Whether you are hosting a small website or running high-performance application, there's an instance type suited for your needs. So here are some of the common instance type. The first one is general purpose instances. These are balanced instances and that offer a mix of CPU, memory, and network performance. They are suitable for most applications such as web server, small databases. Compute optimized instances. These instances provide more CPU power, making them ideal for workloads that require heavy computation like scientific simulations or video rendering. Next one is memory optimized instances. If your application needs large amounts of RAM, then these instances are a good fit. They are perfect for memory-intensive tasks like in-memory caches or large-scale data processing. Now, let us discuss about the storage-optimized instances. These instances provide high input-output performance for applications that require large amount of fast storage, such as big data analytics and data warehousing. When choosing an instance, consider factors like CPU requirements, memory, and storage needs. AWS offers detailed specifications for each instance type, making it easy to find the right one. Now, let us discuss about burstable performance instances or low-cost flexibility and how these are incorporated. So if I talk about burstable performance instances such as T2 series, which are designed for workloads that don't require constant high performance, but occasionally needs bursts of power. These instances are cost-effective because they only use CPU power when necessary. When idle, they accumulate CPU credits that can be used when a spike in demand occurs. For example, a website that typically receives a small number of visitors but occasionally experiences traffic spikes during promotions can benefit from a burstable instance. This saves money while ensuring the website performs well when the traffic increases. Next, we have cluster networking instances or high-speed communication. Cluster networking instances are a special type of EC2 instance that are designed for workloads that require high-speed communication between multiple instances. This feature is particularly useful for the applications like high-performance computing or big data analysis, where data needs to move quickly between instances. Imagine running a large machine learning model on multiple EC2 instances. Using cluster networking, it ensures that these instances can communicate with each other without delays, making the entire process more efficient and faster. The next one that we have all over here are dedicated instances for increased isolation. If I talk about dedicated instances, then these are the EC2 instances that run on hardware physically isolated from other AWS customers. This means that no other customers' virtual machines are running on the same physical server as your instance, providing additional security and compliance for sensitive workloads. Dedicated instances are a great choice for businesses in industries like healthcare, finance, that needs to meet strict compliance requirements for data privacy and security. So these were some of the instances of EC2. Now, let us move ahead and try to understand how you can launch an EC2 instance. So guys, let's move ahead and try to understand how you can launch an EC2 instance. So the first step is you have to log into your AWS Management Console. So go to the AWS Management Console and navigate to the EC2 dashboard. So you can type all over here, AWS Management Console, login, and just right click all over here. And you could see a sign in button all over here. Just click on sign in and you'd be directed to your AWS Management Console. So you can see I've already logged in, so I'm at that page. Now, after that, all over here, you can see there are certain services. So now for our today's session, we'll be using the EC2 instance. So click all over here. Now, so after this, what you have to do, guys, you have to click on launch instance. So after right clicking all over here, then you have to configure your instance name. Like you can say name and tags. You can say, for example, it has written my web server, or suppose you are working onto a job portal application. So say job portal. Okay. Now, next you have to select an application image, which is an Amazon Machine Image or AMI. So it says that AMI is basically a template that contains software configuration, like what kind of operating system you want to use. So you can see all over here, it has Amazon Linux, macOS, Ubuntu, Windows, Red Hat, SUSE Linux, and Debian. So you can select all over here, Amazon Linux. Now, so I'm choosing the free tier version all over here. So if you are a beginner, if you want to learn it, go for a free tier. And the pricing for this is, it's free completely. Just only $1 will be held back from your credit card details. So that's one of the way. So just click on this and you can see also the description is also written all over here. And it says Amazon Linux 2023 is a modern general purpose Linux based operating system. So you have this 5 years long-term support. Now the architecture wise, it's 64-bit. Boot mode is UEFI preferred. Now it has its own AMI ID and it has its own username, which is EC2/user. Now I'm using t3.micro. Okay. Now next is you have to select the key pair login. So all over here, you can proceed with the default key pair value, or you can click on create a new key pair. So you can see all over here the key pair name. Okay. So inside the key pair name label, you can just enter my EC2 key. And I want to go for RSA or 825519. So I would prefer like 825519 algorithm. And the format you can use for OpenSSH if you want to use it. So use .pm file and just click on create key pair. So your key pair will be, downloaded all over here. And from here, you can just select, okay. So this is your key pair.pem file all over here. So, all your details are mentioned on this key pair file. Now, this is one of the thing and you have selected. So now this is your key pair login. Now let us go to the network settings. So you have to select the VPC all over here. Okay. So either what you can do, you can see all over here that you have this subnet preference. Okay. You have auto assign public IP. Okay. If you want to create any security group, like for firewall purposes, so basically these will be the set of rules that are going to control your traffic instance. These rule is going to allow you, only specific traffic to reach your instance. So these are very important security configuration. So you will always select, SSH traffic. So just right click all over here. And just for default purposes, we'll be using this. Now, after going from here, so you can see this is your configure storage. So it has, for root, it says 1x8 GIB and GP3. This is a root volume. But this is not encrypted. Okay. So for security purposes, I would say in production environments, this should be encrypted. Okay. And if you want to add a new volume, just click all over here and, just remove it. You can also click on advanced, just right click on advanced and you can see all over here. In this free tier, this something is written that in your free tier, it includes 750 hours of T2 micro or T3 micro regions. And it is also in certain regions, T2.micro is unavailable in. And the instance uses on free tier AMI per month is also mentioned. 750 hours of public IPv4 address, usage of month, 30 GIB of EBS storage, 2 million IOs input output, and 1 GB of snapshots and 100 GB bandwidth to the internet. So this is something that is coming with your EC2 instance. So these are very important thing. Okay, just because every based on your what kind of payment model you are going, because as I have already told you earlier that AWS EC2 goes with the pay as you go model. Okay, now after doing all these configuration, since we are done with our configuration, now click on launch instance. So you can see all over here it has started launching the instance. Now you can see we have successfully launched our instance, and you can just click all over here and you will be directed to your instance dashboard. So you can see job portal. This is your instance ID. This instance state is running. The type is T3 micro, and right now it is initializing. If you want to select an alarm status, you can select this. And now let us look at the availability zone. So for this, it is North 1B. You have public IPv4 DNS address. Okay. Now these IPs we have not given. Monitoring is disabled for this. Okay. Security group name launch wizard 1 is there. So your key name is mentioned. Your launch time is mentioned. And the platform that we have selected for this is Linux. Okay. This is not managed. Okay. So these are some of the configuration. I wouldn't say this is a perfect configuration for a production environment, but for a beginner, these things are pretty much fine to understand how you can launch EC2 instance.
Let me help you understand about AWS EC2, a compute service in the cloud, through this video. Somewhere far in the country, a scientist has a lab far in the woods, and at one day he stumbled on a calculation that he had trouble solving. And he was very certain that his computer can handle it. And he asked his computer to do the math or the calculation for him. And the computer thought about it for a while, then took a couple of hours in trying to process the data. And eventually, at one point, it gave up and died due to low memory. And this old scientist is now clueless about how he was going to finish the task and complete his invention and let the whole world know about it. And that's when he was introduced to this new friend AWS, as you see on the screen. AWS was very handy in replacing his old machines, and it was able to give him the service that he wanted at that moment. AWS has been around for a while, helping people with their computer needs, and now this new scientist friend in need is welcomed by the new and trendy IT technology AWS, and sure enough, his new AWS friend welcomed and walked him through the new way of computing. And this new happy-faced AWS friend talked to this scientist about AWS EC2 in specific, and walked him through about all the new innovations in IT and in cloud that he had been missing all these days. So his new friend AWS started the conversation about explaining how there is no need for any hardware units, no managing hardware or provisioning in AWS. And secondly, it explained increasing and decreasing the capacity as per the demand is just a click away. And the best part here is that there is no upfront commitment, and we only pay for what we have used, just like we pay electricity and water bills. And all this comes with complete control from our side. In other words, the whole key for this infrastructure is with us. And as if this was not enough, all this comes with enterprise-grade security that's beyond imagination in on-premises. And if this still does not excite you, then this definitely would. You can work from anywhere in the world. Now this really made the scientist to get excited, especially when he thought about working from home. Working from home, there is nothing like it, isn't it? Now this person, this scientist, is not tied up to a particular environment. He can work from home, work on the fly, work from anywhere. Still, the data and everything else in his IT environment is secure and safe. Now let's move to the next level of discussion. Let's talk about what is EC2 and some of the use cases of EC2. And this use case we're going to talk about, or this architecture we're going to talk about, it notifies a group of users about a new letter. And the components or resources this architecture would need be first EC2 instance, then SNS, a simple notification service, and coupling EC2 and S3 service together. That's all it would require to get an architecture that notifies a group of users about a new newsletter. And now I think it would be a good time to talk about what EC2 is. AWS offers plenty of services offered under different domains like compute, storage, database, migration, network, management tools, media services, security, business productivity, application integration, machine learning, game development, and a lot more coming up, out of which EC2 falls under the compute capacity. So what is EC2? EC2 is a web service which aims to make life easier for developers for providing secure and resizable compute capacity in the cloud. With EC2, it is very easy to scale up or scale down our infrastructure based on the demand. And not only that, this EC2 service can be integrated well with almost all the services in Amazon. And out of all this, the best part could be we only pay for what we use. Alright, let's talk about this use case. A use case here is that a successful business owner has a bunch of users and a successful product that's running, and now he has developed a few more products that he thinks will be very successful, that he thinks his customers are going to like. Now, how can he advertise his product to his new and prospective customers? Or the solution for this question can be addressed by AWS. In AWS, we can use services like Simple Notification Service, SNS, and EC2 for compute and S3 for storage. We can, in a way, integrate them all and achieve this business use case. And that sort of got this business owner very cheered up, and now he wants to use the service and he wants to get benefited from the service. He wants to advertise or he wants to notify his users every time the company creates a newsletter. Alright, so let's talk about what it would take to get this environment up and running, or what it would take to connect the environment and put the applications on top of it. Firstly, we would require an AWS account, and then for compute capacity, we would require an EC2 instance. And here's how we go about doing it. The first thing is to create an AMI, which is Amazon Mission Image. That's really the softwares and the application packages we would need to run our application. And the second is to choose the hardware. In here it's the instance type. Depending on the workload, we would be choosing the hardware, and depending on the intents of the workload, we will be choosing the size of the hardware. And finally, we would configure the instances. How many instances do I want? Which subnet do I want them in? And what's going to be the stop or terminate behavior of the instance, and do I want to update any patches when the instance starts running? All those pieces of information go in here when we configure the instance. And then the first three steps is really about the OS volume and the basic hardware. Now it's time to add additional storage to the EC2 instance. That would be step 4. Here we add additional storage to the EC2 instance. And then tags, we use tags, or we would configure tags to easily identify an EC2 instance at a later point. We give it some meaningful names so we can identify, like which team it belongs to, which billing department it belongs to, what's the purpose behind launching this instance, stuff like that. In an environment where we run 700 to 800 or even more instances, identifying an instance and trying to understand who owns the resource, for what purpose we created, it could be an full-time work. So tagging comes to our rescue at that time. After tagging, as step 6, we would configure the firewall, which is also called security group, for the EC2 instance. And this is where we would allow or deny connection from external world to this particular EC2 instance. Well, it works both ways, from outside and from inside out. This firewall blocks the connection based on port number and IP address. And finally, as step 7, we review all the configurations that you have done, and we make sure that the configurations is what we wanted, and finally click on submit. That's going to launch an EC2 instance. Alright, this was just an overview of how to create an EC2 instance. Now let's talk about each and every step in detail. So to begin with, let's talk about how to create an AMI. Well, the AMI is just a template that's used to create a new instance or a new computer or a new VM or a new machine based on the user requirement. The things that go into an AMI are the software, the operating system, the additional applications that get installed in it, stuff like that. The AMI will also contain software information. information about operating system, information about access permission, information about volumes. They all compact in the AMI. Again, the AMI is of two types. One is predefined AMIs, or called Amazon provided AMIs. The other one would be custom AMIs, the AMIs that we create. And if you're looking at a particular AMI that you don't want to create but still want to get it from Amazon, there is a place or a portal called AMI Marketplace. There we get like thousands of AMIs in there available for us to shop and use them on a pay-as-you-go business model, and use them as pay-as-you-go billing. So there you can search AMI that you're looking for. Most probably you'll be able to get it there. Now let's talk about choosing the instance type. The instance type is basically the hardware specification that's required for a machine that we're trying to build. And the instance types is categorized into 5 main families. They are, to begin with, it's compute optimized. Now compute optimized gives us lots of compute power or lots of processing power. So if my application is going to require a lot of processing power, I should be picking compute optimized instance. And the second one is memory optimized. Now this is very good for applications that require in-memory caching. There are some applications that performs well with cache or through cache, or the application would create a lot of data that it wants to keep in cache for rereading or for processing, for lengthy processing, stuff like that. For those type of application, this memory optimized instance that comes with in-memory cache is a very good use case. And the third one is the instance that comes with GPU, otherwise called GPU optimized. GPU stands for graphical process unit, and this is very good for application that deals with gaming. This is very good for application that's going to require large graphical requirements. And storage optimized is the fourth option. Just like the name says, this is a very good use case for storage servers. And the fifth family type is general purpose. Just like the name says, it's for general purpose. If you're not particular about the family, then you generally would end up picking the general purpose, because here the services are sort of equally balanced. You'll find a balance between the virtual CPU and the memory and the storage and the network performance. It's sort of balanced. All the components, all the features that needs to go in a computer are sort of balanced in general purpose. Now these instant types are fixed and they cannot be altered because it's hardware based. We buy hardware. We do not have much control on the hardware that's being used. Well, we have options, but we do not have control on the hardware. And these instant types are divided into 5 main families. They are compute optimized, memory optimized, GPU enabled, storage optimized, and general purpose. Then as third thing, we have to configure the instance. Now here is where I have a lot of options about purchasing. What type of purchasing do I want to do? Do I want to go for a spot instance? Do I want to go for a reserved instance? Do I want to go for an on-demand instance? These are different billing options available, and that's available under configure instance. Not only that, here's where I'm going to put the EC2 instance. Do I want an public IP address assigned to it? Do I want an IAM role attached to it? IAM role is authentication. What kind of authentication am I going to provide? And the shutdown behavior. The shutdown behaviors include, do I want to stop the instance when the user shuts down the machine from the desktop, or do I want to simply terminate the instance when the user shuts down the instance from the desktop? So those things go in here, just like the name says, configure instance. A lot of instance configuration options comes in here. That's the third step. And not only that, under the advanced details or advanced tab under configure instance, I can bootstrap the instance with some scripts. Now bootstrap is nothing but the scripts that you want to be run in the instance before it actually comes online. Let's say you're provisioning the instance for somebody else. Instead of you launching the instance and then logging in and running some commands and then handing it over to the other person, you can create bootstrap shell scripts and paste it in a console option available under configure instance, and Amazon is going to take those commands, run it on the instance before it hands over to the user that initially requested for that instance. Now it could be a different user or just you. It sort of automates software installation procedures in the instance that we will be launching. And not only that, there are multiple payment options available under configure instance. The user can pick an instance under normal price, and that instance would apply normal rates applied to it. And there are also options like reserved instance, where the user can pay for an instance upfront before a year or before months, for a span of year or a span of months, and that way they can pay less per hour for using that instance. Not only that, you can also go for spot instance, like bidding for those instances. Whoever bids more, they get the instance for that particular time. Well, these instances are a lot cheaper than on-demand instances. And through bidding and buying, you can keep the instance as long as your bid price doesn't exceed the price that Amazon is proposing. And as the fourth step, we will have to add storage to the instance that we are about to launch. And here we have a bunch of storage options. I can go for ephemeral storage, which is free, or I can go for an external elastic block storage, also called EBS, which is paid and it's a permanent storage, or else I can integrate my EC2 instance with S3 for its storage needs. And the best part about storage is free subscription users, they get to use 30 gigabit of SSD storage or magnetic storage for the whole year. In this page where we are ready to add storage, we will have to mention or provide the size in gigabit and the volume type. Is it going to be an provisioned volume? Is it going to be an general purpose volume? Is it going to be a magnetic volume? Stuff like that. They are volume types. And we also need to give inputs about where the disk will be mounted and whether this volume needs to be encrypted or not. So all these options or all these inputs are received from us under the adding storage section. And then the fifth option would be adding tags. Like we discussed some time back, tags are very helpful to identify a machine in an environment where we have 700 or 1000 VMs running. And security groups are the actual firewall that sits in front of EC2 instance, and it protects that EC2 instance from unintended inbound and outbound traffic. Now here is where I can fine tune the access to my EC2 instance based on port numbers and based on IP address from which it can be accessed. And finally, we get to review the whole changes or the whole configurations that we have made to find out whether they are intact with the requirement, and then click on submit. That's going to launch an EC2 instance. But hold on, we're not done yet. When we're about to launch, or before the Amazon console actually launches the EC2 instance, it's going to give us an option to create a key pair. Remember, I said it's key pair. Key pair is two things. One is public and private. The private key is downloaded by the user and is kept with the user, and the public key is used by Amazon to confirm the identity of the user. So just go ahead and download the private key and keep it for yourself. And this private key gets downloaded as a .pem file. It's a format of the file and it gets downloaded as .pem file. And our next step is to access the EC2 instance. And because the instance that we have launched in this example, let's assume it's a Linux instance, and that's going to require a tool called PuTTY to be able to access it. And this PuTTY tool is really needed when we are trying to access an Linux instance from Windows instance. Most of the time, Windows instance will have PuTTY installed in them, but in some rare cases, they do not come with PuTTY. In those cases, we can go ahead and download PuTTY and PuTTY generator, and we can start using it to access the Linux instance. Now you might ask, well, I understand PuTTY, what's PuTTY generator? Now the file that we have downloaded is in .pem format, but unfortunately PuTTY does not accept .pem format as input. It has to be converted into a different format called PPK. And PuTTY gen is a tool that helps us to convert the .pem file into PPK file. So the quick way to do it is download generator, open it up, click on conversion and insert the .pem key that we have downloaded and save the private key. And this, when we save the private key, it gets saved as a .ppk type private key. And when that's done, the next very step is to open PuTTY and try to log in. And the way to log in is to open PuTTY, put that IP address here, and then click on auth this is where we would input the file that we have created. So click on auth and then click on browse and find the .ppk file that we have converted and stored, browse it and upload it, and then click on open. Now that's going to open up a login screen for us. And the AMIs comes with a default username. Depending on the AMI that we have picked, the username might differ. In our case, we have picked an AMI for which the username is ec2-user, and this is the default, by the way. Let's put the username ec2-user and hit enter, and that's going to open up the Linux instance using CLI. There are a few other things that we can do with the terminal that we'll explain it a little later. Alright, so we have successfully launched an EC2 instance, and yeah, give yourself a pat on your back. Launching an instance was just one part of the solution. So let's actually talk about how we can notify our customers. SNS, or Simple Notification Service, is a service or a product in Amazon that helps us to notify customers through email. So navigate to SNS in your account and create a topic, and we're going to use this topic for public notification. So let's make it public and then add subscribers to it. Now these subscribers are the people who you want to be notified about the newsletter. So we already have the email database in there. Add them to the subscribers list, and then they will start getting new newsletters as and when we post them to the topic. And as next step, create a bucket in S3 where you can store content, and in that bucket create an event that triggers a notification to Simple Notification Service. So this is how it will be set up. A notification will be sent to our subscribers anytime we put something in our S3 bucket. So S3 bucket is going to create an event for the notification, and the notification is going to make sure that it's delivered to your end customer because they're already subscribed to the topic as subscribers. And finally, let's connect the S3 with EC2 so the bucket and the AWS instance are in sync. So we put some content in the S3 bucket, our email system notifies our customers, and the customers can go online to a website that's hosted in EC2, and because S3 and EC2 are in sync, the items that we put in S3 will also show up in EC2. See how this is all connected and it's working together. And once this is all connected, our subscribers will regularly be informed anytime we put new content in the S3 bucket, and the same content will be made available in EC2 instance through the website.
Before starting this tutorial, make sure that you like our channel and also subscribe our channel. The link, you can find it just below at the right side of this video. Let's look into what we have today in the CloudFront. So what's in it for you? We would be covering up the concept of what is AWS, what was earlier before AWS CloudFront, after AWS CloudFront, what were the services that were introduced, how it benefited, what do we mean by AWS CloudFront, benefits of the using AWS CloudFront, and how AWS CloudFront actually is known as a content delivery service, the name of the companies that are using AWS CloudFront, and we would be covering up one live demo. Now, AWS is the Amazon Web Services. It's a cloud service provider that basically offers a multiple services, variety of services, such as compute power, database storage, networking, and other resources, so that you can create your solutions on the cloud and help the business grow. Now, with AWS, you only pay for whatever the services you use. So for example, if you're using a service for a couple of hours, then you pay for only that many hours that you have used that service. Before AWS CloudFront, so there is an example that we are going to talk, and that is you must be aware of an application called Spotify. So when you used to access Spotify, and when you click on it, it kept on loading, and at the end you used to get the error, and the error was that the connection failed. And why you received that error? Because of a latency issue, probably a network error. Right? So how you can solve these kind of a latency issues, and that is also going to, these kind of an issues are also going to impact the performance of an application. So with the introduction of AWS CloudFront, this problem of loading the application got resolved. So after AWS CloudFront, with the help of AWS CloudFront, Spotify gives the facility of updating new features, access to million songs that you can access instantly. So with the use of AWS CloudFront, the latency issues were solved and successfully you can basically access your application. Now, what we mean by AWS CloudFront? So AWS CloudFront is a globally distributed network that is offered by AWS, Amazon Web Services, which securely delivers content to the end users across any geography with a higher transfer speed and an improved or a low latency. Now, what are the benefits of AWS CloudFront? There are multiple benefits. One is the cost effective. So it helps you to do the cost optimization when you use the CloudFront. It is time saving. So it is implemented easily, and also a lot of issues with respect to accessing the application with respect to latency and all can be resolved. Content privacy. So the content is placed to the end users and also to the CloudFront servers in a secured manner, in a secured way. It is highly programmable and you can make the changes, amend the changes on the fly, and you can target any location, any geography across the globe. Along with that, it helps you to get the content deliver quickly. Now, how AWS CloudFront delivers the content? Let's look into the architecture. So this is a flow, and the flow is with respect to how the user is going to get a content from the CloudFront. Now, the client first access a website by typing a URL on the browser, and in the step 1, it tries to access the application. Then the client requests, when the website is open, the client requests for an object to download, such as, for example, a particular file. Now, at that time, the DNS routes user request to download that file to AWS CloudFront. The AWS CloudFront connects to the nearest edge locations. Edge locations are basically the servers where it caches the files, documents, and the web codes. AWS CloudFront connects to its nearest edge location in order to serve the user the request. At edge location, AWS CloudFront looks for its requested cache file. Once the file is found, let's say if the file is available in the cache of an edge location, AWS CloudFront then sends the file to the user. Otherwise, if the file is not found in the cache memory of an edge location, AWS CloudFront compares the requirement with the specification and share it with a respected server. That means a web server or a server where the file is actually available. The web server, responds to the edge location by sending the file back to the CloudFront edge location. And then as soon as the AWS CloudFront receives the file, it shares with the client, also adds the file to the cache of an edge location for a future reference. This is how the flow of a CloudFront is. Now, the name of the companies that are using the AWS CloudFront. So one of them is Geo7 app, which is a very popular app. So it uses Amazon CloudFront to deliver 15 petabytes of audio and video to its subscribers globally, which is a huge data. Sky News, it uses the service in order to unify the content for faster distribution to subscribers. The Discovery Communications also uses the CloudFront. It uses the service for delivering API, static asset, and also the dynamic content. And then the TV1 EU, Streaming Europe, is basically also uses the CloudFront service that helps in improving latency and performance that results in fastest delivery of content. Now let's look into the demo how to use CloudFront to serve private S3 bucket as a website. Now I'm going to run a CloudFront distribution demo on the AWS console, and we'll basically try to deliver the content from a private S3 bucket and then map that with the domain name using the Route 53 service. So what we need for this demo, we would need a domain URL, we would need a Route 53 service, we would need CloudFront, we have to create a CloudFront distribution, and that will be linked with our S3 bucket, the private S3 bucket, right? And in the S3 bucket, we would have one HTML file, the index.html file. So let's move into AWS console. So right now I have opened up the CloudFront distribution, and here you can see that couple of distributions have already been created. So what I'm going to do, I'm going to create a distribution. Now there are two types of delivery method for your content. One is the web distribution and the other one is RTMP. RTMP stands for real-time audio or video distribution. It's basically used for distribution of a media content or a media file which are available in the S3 bucket. Here we are going to select a web distribution because primarily we will be using files which uses protocols HTTP or the HTTPS. So you have to click on get started, and in the origin domain name you have to specify the bucket where your code is available. So I have a bucket already created. Here you can see, and what you need to do is you have to create a bucket with the URL name or the domain name which you would be mapping with the Route 53 service. So this is a bucket that has already been created. Let me show you in a new tab. So here you have to go to the storage. Under the storage you have to select the S3 bucket. Let's open the link in the new tab and let's look into how we can create the S3 buckets. Now here are a couple of buckets already created. I have created one bucket with the domain name that I'm going to use and map it with the Route 53 service. So that is basically mapped to a region which is in Ohio. And if you open up this bucket, here you will find an HTML web page. The index.html has been already added, right? So similarly, you have to create a bucket with a domain and an index.html page needs to be uploaded there. Now again we'll go to the CloudFront. We'll try to create a distribution. Just have to click on create distribution, select a web delivery method, select an origin domain which is sunshinelearning.in, and origin path you don't have to specify. Origin ID is this one. So basically when you define an origin domain name, automatically the origin ID appears. You can customize this origin ID as per your requirement also. So rest of the things primarily we keep it as a default settings only until and unless if we require some customized settings to be done. So let's say if you have to change the cache behavior settings, you can do that. Otherwise we'll keep it as default. Now in the distribution setting, you can either select use all edge locations for the best performance. So what does AWS basically do here? It uses all the edge locations which are associated with AWS across the globe. Otherwise you can specify based on the regions also, right? Apart from that, if you want to enable firewalls or the access control list, you can specify here. And then what you need to do is in the default root object, here you have to specify your index.html page which is in the S3 bucket. The distribution state has to be enabled, and if you want to use IP version 6 as well, you need to enable it. Click on create a distribution. Now you can see here a distribution has been created. It's in progress and it is enabled, and it takes around 15 to 20 minutes to get that distribution completed. The reason is that the web codes, the web pages will be distributed across all the edge locations across the globe, so hence it takes time to get that done, right? Well, let's move on to Route 53 service, and let's create the hosted zones. So we'll type Route 53 here, scalable DNS and domain name registration. And what we are going to do here is we are going to map our URL, the domains pointed to the name servers that will be provided by the Route 53. So we have to create a hosted zone. Let's wait for it. So now the Route 53 dashboard is open, and you can see one hosted zone is already created. So just click on the hosted zone, and in order to point the traffic from the external domains towards the AWS, you have to first point the domains traffic to the hosted zone in the Route 53. So I'll click on create hosted zone, but before that I will first delete the existing one, and then I'll create another record, another hosted zone. Right. Put your domain name. Let's say I put as sunshinelearning.in, and it is acting as a public hosted zone. Rest of the things will be default. Click on create hosted zone. Now it gives you 4 name servers, and these 4 name servers has to be updated in the domain. So you have to update these name servers in a platform from where you have purchased the domain, right? So this is half of the work done. Then what you need to do is you have to go and create records. Now in the records you can select a routing policy. So right now what we are targeting basically that the traffic from the domain should be pointed directly towards the CloudFront distribution. Hence we are going with a simple routing right now. Click on next. Here you have to specify the record sets. So we are going to create the records. Just click on default simple record. Put here as World Wide Web. And you have to select an endpoint. So endpoint we are selecting for the CloudFront distribution. So we have to specify alias for the CloudFront distribution. Now here we are going to put the CloudFront distribution URL, and then we are going to define the simple record set. So what we need is we need a CloudFront distribution URL, which you can find it from the CloudFront service itself, and you can find the domain name here itself. You just have to copy that and then paste it here in the distribution, and then just click on define simple records. Again click on create records, and here you can see the record set has been updated. Now this domain is basically pointed towards these name servers, which are further pointed towards the CloudFront distribution, right? Now the only thing which is left is that within the domain, from wherever you have purchased the domain, you should update these 4 name servers, and then you can see the live traffic coming on this domain will have an output from the CloudFront distribution.
In this section, we're going to learn about why we need a solution called CloudFormation, or why we need a product called CloudFormation. And we're going to talk in detail about what is CloudFormation, and then how CloudFormation works and the concepts involved in CloudFormation, like templates and stacks. There are some concepts involved in CloudFormation. We're going to talk about that. And how do we maintain access control over CloudFormation? We're going to talk about that as well in this video. And then we're going to go through a demo or a lab where we create an LAMP stack environment from a template through CloudFormation. And then we're going to talk about some use cases, one of which include being able to create an redeployable template using CloudFormation. That's a very good use case. We're going to talk about that in this video. So let's talk about why CloudFormation. So when the number of products and services grow more, and managing them and maintaining them becomes an tedious work, and CloudFormation, it sort of eases that environment. Now CloudFormation is really an infrastructure as a code, and it sort of solves all the problem that we discussed some time back. And with CloudFormation, we can actually create a perfect clone of the server configuration at any point in time. And we can also manage the configuration changes With CloudFormation, we can manage the configuration changes across the environment. And not only that, we can easily embed in the ad hoc changes to our existing environment. So one might ask, why use CloudFormation? Let's look at the current problem that we have. Creating and managing multiple AWS resources in the portal is a big task, especially when you need to replace some services. It becomes a bigger task. Now, CloudFormation eases that work. Let me explain it in detail. Now, at the moment, without the CloudFormation, or environments that don't use CloudFormation have this problem. That is, a lot of time is being spent on building the infrastructure, and less focus and less time at the moment is being given on developing that application that runs on that environment. environment. That's because majority of the time is consumed by building the environment. And if we need to redeploy the same environment again and again, the same happens in a cycle. Again, in a new environment, we start from the scratch, build the environment, and then put application on top of it. Now that can be avoided using CloudFormation. Now without CloudFormation, it still is a problem because the resource or the bandwidth that is needed for the application development is not provided because that's taken by developing the infrastructure. And to solve that problem, we can use CloudFormation. Now that leads to a discussion about what is CloudFormation. So let's talk about, or let's try understanding what CloudFormation is. CloudFormation is a service that provides users a simple way to create and manage collection of AWS resources by provisioning and updating them in a very orderly and in a predictable way. If I need to expand explanation of CloudFormation, CloudFormation is a service that really helps us to model and set up our Amazon Web Services or resources so we can spend less time on managing the resources and show more focus on the application that runs on top of it. We can simply create a template for an EC2 instance or for an RDS instance and upload it in the CloudFormation portal, and CloudFormation will provision and configure those resources based on the template that we define. We really don't have to sort out the complexities in dependency between those applications. Once the template is vetted and validated, CloudFormation takes the responsibility of handling the dependencies between the application in an orderly and a predictable way. It creates those services and makes it available for us once the template is fully run. So in short, the CloudFormation, it allows us to create and model our infrastructure and applications without we having to perform the manual action. For example, the well-known company called Expedia is able to easily manage and run its entire front and back-end resources they run on AWS in CloudFront. What does that mean? They are spending less time on managing the infrastructure and more time on the core business and the application that runs on top of it. And we're still talking about what CloudFormation is. With CloudFormation, it enables us to manage our complete infrastructure or AWS resource in a text file. Now we're going to see that in a moment. It's either a JSON or an YAML file, and that file is called as the template to begin with. The resources the template provision is called the stack. All right, so the abstract of the code is called the template, and the resource that it provisions is called the stack. And this stack can be, it's going to run resources, obviously, and those resources can be updated as well. It's not like once you create a stack, it's done. If you need a change, you need to go create another resource. That's not needed. This stack is an updatable stack. Let's say if I'm including 2 more servers, if I'm sort of extending my environment, it's branching out to another application. Now I'm including another functionality in my environment. All those can be embedded in the update and can be updated. So like I said, the stack is an updatable one. Now let's talk about what the template can do, or some features and functionality of the template. Now, using a template, we can almost include all the application and resources that a user might require. Let's say, after the EC2 instance is provisioned, running an application on top of it, and you want to templatize that and include that in the template, that's possible as well. And these templates are portable ones, meaning I can use the template in one region and I can use the same template in another region, and that's going to build a very similar environment in another region. I can also share that with the customer, and when they run it, it's going to run an environment from the portable template in their account, in their environment. Of course, all the security is taken care. I'm just saying that if we need to build a resource, if we need to build an architecture, if we need to build an environment which looks very similar to the other environment, that is possible. And these templates are reusable by the use of some sections in the template, like the parameter section, the mapping section, the condition section within the template is what makes the templates reusable. And we will talk about parameters, mapping, and conditions down the line. We're still talking about AWS, how AWS CloudFormation works, and we're going to talk about how a template becomes an infrastructure. Right? So to begin with, one requires a template, and the template would be in JSON or YAML format. So one would develop a template based on the requirement, based on number of EC2 instances, based on whether they want a load balancer, based on whether they want a Windows server, based on whether they want an database server in that environment, and then based on the applications that will be running on top of it that can be templatized in the code itself. So one creates a code, and then the code is saved locally, or they can be put in an S3 bucket from which the CloudFormation will call the template and provision the resource. Right. So we use CloudFormation to create a stack or create the resource defined in the template. And CloudFormation analyzes the template first, validates the template, and then it identifies the dependencies between them, and then it starts provisioning the resource one after the other. For example, if you need 5 servers in a new VPC, obviously it's going to create the VPC first and servers second and stack. All right, let's understand the two major components in CloudFormation. By now you might have guessed it. The two major components are the template and the stack. Together they aid or they complement CloudFormation, and that's how the resources are provisioned, that's how the resources are managed, and that eases the job of the administrator who's managing the environment. So let's talk about template first. A template in CloudFormation is an text file or a formatted text file in JSON or YAML language, and that the code or the template or the text file that actually describes how your infrastructure looks like or will look like once provisioned. And for us to create the template or for us to modify an existing template, we can use a tool available called CloudFormation Designer from the console or any text editing tool that's available. But I would recommend the CloudFormation Designer though, that has rich graphics in it. And these templates are built off, or they consist of 9 main objects. The first of which is the format version, and this really identifies the capabilities of the template based on the version number. And then the second object in a template would be description, and this helps us to include any arbitrary comments about the template. For what reason are we building this template? What's the purpose of it? Stuff like that. And then we have the object called metadata in a template, and that includes details about the template, details of the resources in the template. And then we have the optional parameters section. This really helps us to customize our template. Now, parameters enable us to input custom values to our template each time we create or update and stack. And the mapping object, it helps us to match a key to a corresponding set of named values. For example, if you want to set a value based on region, then we get to create a mapping that uses region name as the key, and then the value that we want to specify for each specific regions. And then we have conditions object. This is again an optional object. With this, we can include statements that define when a resource is created or when a property is defined. For example, we can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create additional resources. And then the object called transform. It's an optional object as well, and this transform section specifies one or more transforms that we can use in our CloudFormation template. For example, AWS CloudFormation transforms helps simplify template authoring by condensing the expression of the AWS infrastructure as a code or the CloudFormation template, and it enables reuse of template components. For example, we can condense multiple line resources, declaring it into a single line in our template. Now we will talk about all these examples in the upcoming slides. And then we have the required section called resource that declares the AWS resource that you want to include in the stack. For example, if you want to include an EC2 instance, if you want to include an S3 bucket, we would be using the resource object in our stack. And then we have object called output. This output object, it's an optional object in the template, and it helps us to sort of declare the outputs that we can import into other stacks, or we can actually show it on the CloudFormation console. For example, if you want the output of the name of the S3 bucket that got created in response to a CloudFormation template. Now we can have that outputted into an output section in the CloudFormation console itself. So it's sort of easy for us to identify the resources that the template provisioned. So with all of those objects put together, this is how a full-blown CloudFormation template with all the objects included is going to look like. Now this includes optional and mandatory objects. Let's talk about those objects in detail in the upcoming section. Alright, let's now discuss each and every object of this template structure. And let's begin our discussion with the format version. The format version, it really defines the capabilities of the template. The latest version, format version as of now, is the one that was updated on 2010. Now the value of the template format version, it has to be an string. And if we really don't specify the format version, CloudFormation automatically assumes the latest version. Talking about descriptions are really any comments that help ourselves that we want to embed in the template itself. That can be a description. And this description in a template, it has to be an string. The length of the string can be between 0 to 124 bytes in length. The metadata are really used in the template to provide any additional information using the JSON and YAML objects. And metadata holds some implementation details of a specific resource. And parameters are really a way to customize the template. Each time we create or update our stack, these parameters are the ones that helps us to give some custom value to the template during runtime. In the example shown below, the parameter named instance type parameter, it lets us to specify the EC2 instance type for the stacks to use when creating or updating the stack. By default, as we see, it's picking T2 micro, and this is the value that will get picked if we don't provision another value to it. And mapping really enables us to map a key to a corresponding named value that we specify in a conditional parameter. And also we can retrieve the map or retrieve the values in the map using the function findInMapInStrict function. Let's take this example. Let's say based on a region, if we want to set values in a template, we can create a mapping that uses a key and holds the value that you want to specify for each region. And the object conditions can be used when we want to reuse the templates by creating resources in a totally different context. For example, in a template, during stack creation, all the conditions that we mention in the template are evaluated, and any resources that are associated and that come up to be true are created, and any condition that fails or invalid are kind of ignored automatically, and the check moves forward to the next condition. And conditional is an optional object, and it includes statements that define when a resource is created or when a property is actually defined. For example, you can you can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create resources. If you have multiple conditions, then they are generally separated with commas. Sometimes conditions are very helpful when we want to create templates and we want to reuse those templates which was created for one environment to another environment. For example, if you want to use a template that was created in a test environment in a dev environment, conditions could be helpful. For example, in a production environment, we might want to include instances with certain capabilities, and in a test environment, we might want to include instances with some reduced capability in them for saving money. And condition helps us to create resources based on the environment it will be used in. We can also use intrinsic functions to define conditions like equals. We can also use OR conditions. We can use not functions, intrinsic functions in a condition. And when put together, the syntax is going to look like the one that you see on the screen. Now, the optional object called transform, it specifies one or more transforms that the CloudFormation uses to process our template. Now, these transform sections are built on a simple declarative language of AWS CloudFormation with a powerful macro system that helps us to reuse the templates or the template components. And they really help us to condense or simplify our codes by enabling reuse of the template components. For example, condense a multiple line resource declaration into a single line in our template. The resource section, it really declares the AWS resource that you want to include in the stack, such as EC2 instance, such as S3 bucket. And some of the resource fields are the logical ID, the resource type, and the properties. Let's talk about them in brief. The logical ID is unique within the template, and the logical ID name, it actually references the resource in other parts of the template. In this case, it's my bucket. For example, if you want to map an elastic block store volume, or if you want to map an name of the bucket in another place in the template, then we would use the logical ID. And again, in this case, it is my bucket. A logical name has the physical ID with which we actually assign the resource. For example, in this case, my S3 bucket was named as my bucket to begin with. And the resource type in the template, it identifies that the type of the resource is an S3 bucket. And the properties are the additional optional information that we can specify to our resource. For example, if it is an EC2 instance, let's say we would like to know which AMI it used, then property section really defines the AMI that was used, or AMI as the property of the instance. So this section describes the output value that needs to be imported to other stacks, or the output value that needs to be shown in the console for the user to easily navigate to the resource that are being created. For example, for a S3 bucket name, we can declare an output, and once the bucket is created, we can actually declare the output and sort of import the name of the bucket in a different place in the console, so it's easy to view instead of the user getting confused and going to S3 and searching for the bucket name. This can be made available in the CloudFormation console itself. And the output fields, it can include some of these followings, like the logical ID. It's actually the identifier of the current output, and it's very unique within the template. And it can also include a description. Description is really a string type that describes the output value, and it can also include value, and value is the property that was returned by the AWS CloudFormation describe stacks command. All right, let's talk about the template resource attribute. In this section, we're going to talk about attributes that you can add to a resource to control additional behavior and relationships. So let's talk. There are many resource attributes available, out of which we have if we need to name them, we have a creation policy, and then we have deletion policy. It depends on metadata attribute, update policy attribute. Let's talk about each of them separately. When we associate the create policy attribute with the resource, it actually delays the resource configuration actions before proceeding with the stack creation. The attribute stack creation is delayed till the time the CloudFormation receives some number of success signals back. This is a very good use case when we do auto-scaling. And this creation policy can be used only with a limited number of services like auto-scaling and EC2 instances. Some of the use cases would be if you want to install a software application on an EC2 instance, you might want the applications to be running before it proceeds further. So in this case, we would use the creation policy attribute to the instance and then send the success signal after the applications are installed and configured. Then CloudFormation goes to the next step. Here in the syntax that we're looking at, the auto-scaling creation policy and the minimum successful instance percentage, it's actually a number of signals that it will have to reply back before it can move forward. Using deletion policy, it preserves backing up of resources when the stack is getting deleted. And by default, if you don't have a delete policy, the data gets deleted just like that. But if we use an deletion policy, we would be able to preserve the data by taking a snapshot of it, or just letting the resource and moving on with deleting the other resources in the stack. And we specify the delete policy attribute for each resource specifically that we want to control. And if there are no deletion policy mentioned for a particular resource, the CloudFormation simply deletes the resources as that's its default behavior. And if you want to keep the resource when the stack is deleted, we mention retain in the delete policy, and that simply retains the resource from getting deleted. So in this example, we're actually retaining an DynamoDB table. Rest of the resources in the stack will get deleted. And using the depends on attribute, we actually create an order in which the resource gets deleted. For example, if I map one resource to another resource and say that this resource depends on the other resource gets created first, then followed by this instance or this resource. So with the depends on attribute, we can specify that the creation of specific resource is actually followed by another. When we add the depends on attribute to a resource, the resource is created only after the creation of the resource specified by the depends on attribute. Let's take this example. In this example, we're saying that the resource X depends on Y. We've said that X depends on Y. So in this case, when CloudFormation is executing, it's going to deploy Y first because it has some resources that depends on it. So it's going to create Y first, and then it's going to create the resource called X. On the same context, let's say in the template, we say that an EC2 is going to depend on S3, and when the CloudFormation is executing, it's going to create an S3 bucket first, and then the EC2 instance. That's probably because the codes needed for the EC2 instance are stored in the S3 bucket. And what we're looking at is the syntax of how the depends on template resource attribute will look like. This is how it actually will look like when we put it in the CloudFormation. The instance depends on the bucket. The other template resource attribute is metadata. Metadatas are the one that really helps us to associate our resources with the structured data. And by including this attribute in our template, or by including this attribute to a resource, we can specify the data in JSON or in YAML language. For example, in this section of the template, we're creating a VPC, and the metadata explains, or metadata defines, that the VPC is part of the region US East 1. And the update policy template resource attribute in CloudFormation, we can manage and replace the updates of the instance in an autoscaling group. For example, you're looking at this sample where it says that the update policy, will it replace the instance in an autoscaling group or not? So depending on what the value is for the will replace section, whether it's true or false, depending on that, the update policy will replace the instance or will replace the autoscaling group itself when it's doing a rolling deployment. Now that we've discussed about templates, let's talk about AWS stacks as well. Now we know that AWS stacks are the actual resources that gets generated or that gets created because we ran a template, right? So stack is a collection of AWS resource that we can manage in a single unit. In other words, we can create a stack, update a stack, or delete a stack, and that would actually create, update, delete the collection of resources within the stack. And all the resources in the stack are really defined by the CloudFormation template. And a stack, for instance, can include all the resources required to run a web application, such as a web server, a database server, and some networking rules that come along with it. All that gets embedded in a stack. And let's say if we want to delete all the resources that were created by template that is in a separate stack, we can simply delete the stack, and that would sort of delete all the resources that is in the stack. So it sort of helps us to manage all the resources in a single unit or as a single unit. So to summarize, stack is a collection of AWS resource, and it can be managed as a single unit. And the CloudFormation's template defines a stack in which the resource can be created, deleted, or updated in a very predictable way. And a stack can have all the resources like web server, database server, VPC, the network and the security configurations in a VPC, all that is required to run a web or a database application. Now, stack could be nested as well. With CloudFormation, we can actually nest a stack with another stack, and that's going to create a hierarchy of the stacks. For example, there's a very good picture that explains how the stacks are nested in a hierarchical way. Let's say stack P is the root stack, and that could be a parent stack for the stack called R and the stack called Q. And the same way, the stack called R is a parent stack for the stack S, and the stack S is the parent stack for T and Q. You get that, right? So stacks can always be nested. It's possible. CloudFormation allows us to create a Microsoft Windows stack based on Amazon EC2 Windows AMIs, and provide us with the ability to install software and use remote desktop to access our stack and update the configuration of our stack. And these stacks can be run on Windows Server instances. There are a number of pre-configured templates available, and it's directly available to use from the AWS website itself. To name a few, we have templates available for SharePoint running on an Windows Server 2008 R2. We also have templates that create a single server installation of Active Directory running on a Windows Server. And in fact, we have templates available for Elastic Beanstalk and some sample applications that runs from an Windows Server 2008 R2. Let's talk about stack sets. Stack sets actually has taken the stack level implementation to the next level. Using the AWS CloudFormation template, we can define a stack set that lets us to create stack in AWS account across the globe by using just a single template. And after we create the stack, or after the stack set is defined, creating, updating or deleting the stack in the target account and the regions can also be specified by us. So the stack set, it really extends the functionality of the stacks by allowing us to create, update and delete stack across multiple accounts, regions in just a single operation. And using an administrator account, we can define and manage an AWS CloudFormation template and use the template as the basis for provisioning stacks into some selected target accounts across a specified region. Let's talk about CloudFormation access control. With IAM, I can specify the list of users or list of privileged users who would have access to the CloudFormation template, who can create, update and delete stacks. So that's how IAM helps me with having or putting a layer of control over the CloudFormation service. And we can also use service roles. Service roles are the one that allows AWS CloudFormation to make a call to a resource in a stack on the user's behalf. And I can also have stack policies, and these stack policies are applied to the users who already have access to the CloudFormation service. And these policies are the ones that help the users who attempt to update the stack. All right, let's do a quick lab on creating an LAMP stack on an EC2 instance with a local MySQL database for storage. Now, we can do the other way as well. I can pick an EC2 instance and install the servers one top of the other. That can be done as well, but that's going to take a lot of time. Now, we're talking about automating it. We're talking about, provisioning an infrastructure using a code, and CloudFormation helps us to do that. So this is what we're going to do. We're going to create, or we have a CloudFormation template already, and we're going to use that template to provision a web instance, and that is going to have, look at that, that's going to have MySQL installed in it, that's going to have PHP, that's going to have HTTPD service installed in it and running. And it's also going to have a PHP website running from it. So that's going to receive information from the website, and that's going to store that information in the database that's very local to it. This is the template that defines that environment. All right, this is a very simple provisioning. So let's provision this environment. Let's create a stack. We're going to give a stack name and a database password. Right, and which region is it? This is in California, is it? All right. Now let me do one thing. Let me switch to the Mumbai region, or let me switch to North Virginia region. North Virginia, and from here, actually, let me switch to Mumbai region. Right, just to be sure, it's the same template that we're provisioning. Right, that's the same template that we are provisioning. Right, let's give this name. So it can be great. This could be Simplilearn. Simplilearn LAMP stack, and what could be the DB password? And DB root password, and what could be the DB user. I'm going to keep the rest as defaults, and I'm going to launch. All right, so there's an issue with the password. password should only have alpha numeric characters. Get that? So let's go back and create a new password. Right, it also needs to have 8 characters. So what can be our password? Look at that. The template is actually creating the resources. And here in the screen, we can see the template that we used to deploy the environment. If you remember, we discussed about instant types in parameters, right? The default instance type is T2 small, but these are also allowed to run. All right, parameter section is the one that was used to receive information from us, like the DB name, the DB password, the DB root password, DB user instance type, key name, and the SSH locations. All right, now this resource section is showing us the resource that it actually created. Right, looks like it's rolling back. Why would that be? Give me a moment. All right, this is one live example. Anytime it could not provision, or if there is an interruption that it could not proceed, it would simply roll back and delete all the resources that it had provisioned, and that's what it did. Now let me fix this. All right, as a fix, I have switched the region because I had some issue with the VPC. That's going to take time for me to analyze and fix it. So here we're going to understand about CloudFormation. So I thought I'll run the CloudFormation from another VPC that I know is working fine. That's in North Virginia. All right, let's provision a LAMP server which is running out of Linux, which has Apache installed in it, which has PHP and MySQL already installed in it. So one server going to act as web and DB server. All right, so I'm going to create a stack, and from here I'm going to pick a sample stack. If we look at it in the designer, it's going to provision one LAMP server and a security group attached to it. There you go. Right, so let's go ahead and create a stack. All right, parameters are used to receive input from us. What could be the DB password and the DB user, and let's select the key name. Right, I'm going to keep the rest as defaults, and I'm going to create a stack. All right, so our stack that we ran from the template, at the moment it's getting created, it's in progress. From here I can watch the events as to what is getting created at the moment. Like I said, a lot of these would have already sorted out their dependencies, which one needs to get created first, which one needs to get created second. All that is sorted out by CloudFormation itself. And parameters are the values that we have inputted, and resource tab is a section where we can find what resources are being provisioned at the moment. So to begin with, it created a security group. At the moment it's creating an instance, and output, it's empty as of now. We're going to come back and see it. Now output is where we can get outputs of a finished job. Let's say here I wanted an URL of the server that got created. So instead of me going to a couple of other places within the console and find the output of the URL or the output of the resource that was created, I can simply get it from here. Well, this needs to be defined in the templates first. Once we define it in the template, it's going to be made available like here, right? So I can open it up, and so there you go. So it already has a database locally installed, and it's connected to it. If I launch an application on top of it, that will get connected to the database, which is very local, and my single server with web and database in it is ready for production. Now, while we're talking about a LAMP server, a single LAMP server, let's talk about creating an environment like this, which has Elastic Load Balancer, a VPC, a server running in an auto-scaling group, and putting some restrictions that nobody will be able to access the EC2 instance directly, but they should be able to access the EC2 instance or the data only through the Elastic Load Balancer. This is a bit complicated than the environment that we've already created. Let's see how this is done. All right, in this lab, we're going to create Elastic Load Balanced auto-scaling group, which is going to create a load balancer and an auto-scaling group, and that auto-scaling group receives traffic only from the load balancer. So here's the template, and here's the architecture that we're going to provision. Let me call it right, and the key pair it's going to use is Simplilearn key pair. Now this is where the problem was. Now we were selecting few subnets. So now if I provision it, now this is going to take its short time to provision the resources. So through parameters, we can see the values that we have inputted, and the events look good. No rollback, no deletes, and the resource section shows the resource that it is creating. So previously it created a target group, now it's creating the application load balancer itself. All right, so it created a load balancer, and then it created a security group. It created a launch configuration. At the moment it's creating a web server group. And the events look good with all green and yellow. Green ones are completed, yellow ones are in progress. We don't have any red delete or rollback errors, so it looks good. All right, it took a while, and the resources have been created. Some of them show that they are in progress, but the status of the stack is complete. All resources have been created, and we do have an output to access the URL. There you go. And remember, there was another feature of the CloudFormation that was it should restrict access, direct access to EC2 instance. Let's see if that has been done. If I try to access using the load balancer, it lets me access. But if I try to access it using the EC2 instance IP or the DNS name, my connection won't go through because it's blocked through the security group. But direct access through the load balancer is allowed, and that's what we wanted to achieve through that template. Hi there, I'm Sam from Simplilearn, and I'm very glad to walk you through this lesson about Route 53. So in this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53. And then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, the different ways, the different methods you can access Route 53. And finally, we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services, such as a variety of IT services or infrastructure services, such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot. Meaning, you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years. Right, and then you will gradually be, utilizing it from, 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application? You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy and he comes up with an idea and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com. You want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53. It's highly scalable, meaning suddenly, let's say, the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable. Right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without the users, without you interacting, without the user who bought it interact with it. You don't have to scale up. When you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access, or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server, to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And these records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level, you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency based routing. Just like the name says, we use latency based routing if we have resources in multiple AWS regions, and if we want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency based routing. And for using latency based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of order sources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy. It will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you are doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you have launched, new version or new application that you have launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can access it we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability, otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these sites, these companies are very critical, they're being highly available, their page, their site being highly available, and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources, so their resources are properly used with all the weighted routing. The resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, right? We'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-Route 53. Let's check its availability. It is available for $12, so let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out, and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal. And I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me. Right, click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names, right? All that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting, right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly. Right, it's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created, and my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket. Static website hosting enabled S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple and pretty straight. So in this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53, and then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, the different ways, the different methods you can access Route 53, and finally we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services such as a variety of IT services or infrastructure services such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot. Meaning, you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years. Right, and then you will gradually be, utilizing it from, 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application? You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy and he comes up with an idea and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. Alright, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com, you want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application, or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser, or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53. It's highly scalable, meaning suddenly, let's say, the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable. Right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without the users, without you interacting, without the user who bought it interact with it. You don't have to scale up. When you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access, or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example web server, to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And this records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level, you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing, that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency based routing. Just like the name says, we use latency based routing if we have resources in multiple AWS regions, and if you want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency based routing. And for using latency based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of order sources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy, it will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you're doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you have launched, new version or new application that you have launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can access it we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability, otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these sites, these companies are very critical, they're being highly available, their page, their site being highly available and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources so their resources are properly used with all the weighted routing. Their resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, we'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-Route 53. Let's check its availability. It is available for $12, so let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out, and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal, and I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me, right? Click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names, right? All that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting, right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly, right? It's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created, and my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket. Static website hosting enabled S3 bucket, and this is the URL for that static website hosting, and then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple and pretty straightforward. Hello everyone, let me welcome you to this new video learning where we're going to learn about Lambda, and I'm Samuel from Simplilearn, and I'm very glad that you're watching this AWS Lambda tutorial now. One day at office in a growing company, there was discussion going on between two IT personnel. It was about the new role that his colleague Jessica has taken. Benjamin, the guy standing here, wants to know about it. And Jessica's job is new, different, and dynamic and interesting too. She scale and manage servers and operating systems and apply security patches onto them and monitor all of these at the same time to ensure the best quality for application is given to the users. And Benjamin was awestruck with the amount of work Jessica is doing and with the time it would take to complete all of them. But Jessica, being a very dynamic person, very suitable for the job, said it was easy for her to handle all of it and even more. But that easiness on the job did not last longer. As the environment grew more and more, it being a startup company, Jessica was getting drained and was not really happy about all her job as she used to be. Jessica's manual way of scaling an environment did not last long, and she was also finding out that she missed to scale down some of the resources and it's costing her a lot. She needs to pay for the service that she was not at all using. She sort of felt that she was at the end of the road and there was no way out from this manual task. She was very desperate. And that's when Benjamin suggested something, and that brought back the peace and joy Jessica initially had. Benjamin suggested about a service called Lambda that can ease the work that Jessica is doing at the moment. And Lambda, as happy as it looks like, it's a solution that solves the manual, repetitive work and lot more. And Lambda introduced itself as the problem solver and started to explain the following things, the very same thing that we're going to learn about in this series. So in this section, we're going to learn about the features of AWS Lambda, and we're going to talk about what Lambda is, and then we're going to talk about where Lambda is being used in the IT or in the cloud environment as we speak, and then we're going to talk about how Lambda works and some use cases of Lambda, and we're going to be particularly discussing about the use case about automatically backing up the data that's put in the cloud storage. Let's talk about Lambda in detail. Lambda automatically runs our code without requiring us to provision or manage servers. Just write the code and upload it to Lambda, and Lambda will take care of it. That means that we don't require any server to run or to manage, and all you need to do is write the code and upload it to Lambda, and Lambda will take care of it. Which also means that we can stop worrying about provisioning and managing servers. The only thing Lambda expects from you is a code that's working. AWS Lambda also automatically scales our application by running code in response to each trigger. Our code runs in parallel and processes each triggers individually, scaling precisely with the size of the workload. Scaling here is done automatically based on the size of the workload. Lambda can scale the application running the code in response to each and every trigger that it receives. Billing in Lambda is metered on the seconds. We only pay for the amount of time that our code is running, which means that we're not charged for any of the servers. The only payment required is for the amount of time the code is computed. With AWS Lambda, we are charged for every 100 milliseconds. We are actually charged for 100 milliseconds our code executes and the number of times our code is triggered. And we don't pay anything when the code is not running. Let's talk about what is AWS Lambda. Now, Lambda is one of the services that falls under the compute section or the compute domain of services that AWS provides. Along with EC2, EBS, Elastic Load Balancer, Lambda is also a service that comes under the bigger umbrella of compute services in AWS. And Lambda allows us to execute code for any type of application. With AWS Lambda, we can run code for virtually any type of application or backend services. All we need to do is supply our code in one of the languages that AWS Lambda supports. As we speak, the languages that are supported by AWS Lambda are Node.js, Java, C#, Go, and Python. And Lambda can be used to run code in response to certain events from other services. And based on the event, it can run functions, and those functions can be of Node.js, Java, C#, etc. Now let's talk about where is Lambda used. There are a huge number of use cases for Lambda, and there are many ways AWS Lambda is used specifically in the business world. Let's talk about some of them. One use case is AWS Lambda is used to process images when it is uploaded in an S3 bucket. Let's say the object gets uploaded in an S3 bucket in a format that we don't expect it to be, which means the file needs to be formatted. So it gets uploaded in a raw format, and AWS Lambda is triggered anytime a new object is added to the bucket, and the images are processed and converted into thumbnails based on the devices. The other end device that would be reading the data, it could be an PC, it could be an Apple machine, it could be an Android phone, it could be an Apple phone, it could be a tablet, whatnot. So based on the devices, different formats, Lambda can get triggered and convert the video or convert the picture into the different format that it requires. Another use case for Lambda is to analyze the social media data. Let's say we're collecting the hashtag trending data, and the data is received and it's added into the Kinesis stream to feed into the Amazon environment, and Lambda action get triggered and it receives the data, and then the data is stored into the database, which can be used by businesses for later analysis. And some of the companies that have gotten tremendous benefit using Lambda are Thomson Reuters, Benchlinks, Nordstorm, Coca-Cola, Robot are some of the companies to name at the moment that have received tremendous amount of benefit by using Lambda. Let's look at how Lambda works. In other words, let's look at how the complicated function behind the scenes work in a simple and in a seamless way. So here clients send data. Now clients send data to Lambda, and clients could be anyone who's sending request to AWS Lambda. It could be an application or other Amazon Web Services that's sending data to the Lambda. And Lambda receives the request, and depending on the size of the data or depending on the amount or volume of the data, it runs on the defined number of containers. If it is a single request or if it is less request, it runs on a single container. So the requests are given to the container to handle, and the container which contains the code the user has provided to satisfy the query would run. And if you're sort of new to containers, then let me pause here for a while and explain to you what container is. Now, container image is a lightweight, standalone, executable package of a piece of software that includes everything needs to run it, like the codes, the runtimes, the system tools, the system libraries, and any other settings needed. And it is at the moment available both on Linux and Windows based application, and containerized software will always run the same regardless of the environment it's running on. And containers isolate software from its surrounding. For example, there could be difference between a development and staging environment, so that's sort of isolated, and this helps in reducing the conflict between the teams running different software on the same infrastructure. Alright, now that we know containers needed to understand Lambda, so if there are few requests, it sends to a single container, but as and when the request grows, it actually creates multiple containers, shares the multiple requests to the different containers there. And depending on the volume, depending on the size, depending on the number of sessions, the more number of containers are provisioned so to handle those requests. And when the requests reduce, the number of containers reduce as well, and that helps in saving costs. We're not running any resources and paying for it when we're not using them. And in fact, we're not at all paying for the resources. We're only charged for the amount of time a function is running inside these containers. Now consider a situation where you have to set up a temporary storage and as a system to back up the data as soon as the data is uploaded, which is a near real-time backup. Now, a near real-time manual backups are nearly impossible, and they're not that efficient too. A near real-time manual backups, that's what the business demands, but that's not near real-time backup, that too a manual one, that's not at all efficient. Even if we come up with a solution of manually backing up close to near real time, that's not going to be efficient looking at the amount of data that will be put in and looking at the random times the data will be put into the source bucket. And there is no way we can do a manual backup and keep it as real as possible. But if that's still your requirement, we can use AWS Lambda and set things up so AWS Lambda manually handles the backup. In other words, for an impossible or a difficult situation like that, AWS Lambda comes for the rescue. And this is what we do. Create a two S3 bucket. One would be the source bucket where the data will be uploaded, and the other one is a destination bucket where the data will be backed up from the source bucket. And for these buckets to talk to themselves, it's going to require an IAM role. And then for the automatic copy, it's going to require an Lambda function to copy the files from the source bucket to the destination bucket. And what triggers the Lambda function? The Lambda function is triggered every time there's a change in the metadata for the bucket, and this data is then uploaded into the destination bucket. And after setting all this up, we can literally test it by putting a data in the source bucket that's going to automatically replicate, or that's going to automatically copy the data from the source bucket to the destination bucket. All right, let's see how we can replicate data between two buckets. Well, we have a feature to cross-region replicate in S3. That's a feature that comes along with S3. What if you want to replicate between two different buckets in two different accounts? In those cases, we can use Lambda to replicate the data between the buckets. So you put one data, or you put data in the source bucket, and that data gets replicated to the destination bucket. And let's see how that's done. The procedure here would be to have two buckets to begin with, and then create an IAM role that lets you access to pull data from the source bucket and put data on the destination bucket, and then create Lambda files or Lambda event or triggers to actually look for event in the source bucket, and anytime a new data gets added, Lambda gets triggered, copies the data from the source bucket and moves the data to the destination bucket, and it uses the IAM role and policy for the needed permissions. And in just a couple of clicks, we have set up a temporary backup system that can run seamlessly without any manual intervention, and that can be as near real time as possible. Alright, that's the concept, and let's see how it is done real time through this lab. So to begin with, we need two buckets. So I have here a source bucket and a destination bucket, and the source bucket as of now do not have any data in it, so as the destination bucket. Alright, so that's one down. The second would be to create an IAM role. Alright, so let me create an IAM role, and the role is going to have this policy in it. A policy that's allowing get object on the source bucket, and a policy that's allowing put object on the destination bucket. And here I'm going to use, or I'm going to paste my source and destination buckets ARN. Alright, go to services, go to S3, source bucket. Alright, click on the source bucket and copy the bucket ARN. So that would be the source bucket ARN. Alright, on the destination bucket, copy the destination bucket ARN. and this is going to be my destination bucket ARN. So with this, I'm going to create a policy. All right, go to IAM and create a policy. Now I have already created a policy with the same information. All right, destination bucket ARN, and a policy is available with the name S3 bucket copy Lambda. Attach the policy to the role. Right, go to roles, create a role. Lambda is the service that's going to use it. In here, attach the policy that we have created. Right, give it a name and then create a role. Now I have a role created as well. Right, copy Lambda, and that's having the policy that we have created sometime back. Now create a Lambda function. Right, so go to Lambda, create a function, give it a name like S3 bucket copy. Right, choose the role that we want to use. Right, that's the role that we want to use. Copy 1, 2, create a function. All right, and in here we're going to use Node.js code. Right, I have a sample code. This can be used as template. In here, replace the source bucket with the name of the source bucket and the destination bucket with the name of the destination bucket. This is a Node.js code that gets run when an event gets triggered. Now what's an event? Anytime there is a new object placed in the S3 bucket, it creates an event, and the event triggers Lambda, and Lambda checks the source S3 bucket, picks the data, puts it in the destination bucket. All right, paste it here. Paste it here and click on save. All right, now before you click on save, just ensure that you have the appropriate roles defined. That's all you got to do. Click on save. All right, now I already have created a Lambda function, all right, which is the same thing, same code, and the role is attached to it. Now it's running, it's active. Now let's put this to test. Go to S3, pick the source bucket, put some data in it, all right, and in theory those data should be present in the destination bucket as well. There you go. It's all done by Lambda.
So the first thing we will explore is understanding the AWS step function challenges. So before we get into the specifics of AWS step functions, let's understand the problem it addresses. As you build larger applications with many different parts, managing and coordinating them can become quite tricky. Absolutely. Imagine you have a bunch of different tasks that need to happen in a specific order to complete a big project. For example, if you want to build a house, you need to follow a specific sequence of steps like laying the foundation, building the walls, putting on the roof, and so on. But what if something goes wrong in the middle of the process? Like the wall building part doesn't work correctly or you run out of bricks. That's where the challenge lies. With traditional methods, handling these errors and coordinating everything can become a nightmare. And here comes the AWS step functions. Now we'll have an introduction to AWS step functions. So here AWS step function comes to rescue with these challenges. So AWS step functions are like having a master conductor who organizes and orchestrates all the tasks in your application. It helps you build workflows as a series of steps or tasks, making it easier to manage the entire process. That's right, just like a conductor guides the musicians in an orchestra to play their instruments at the right time, AWS step functions guides you different services and functions to work together harmoniously. It does this by using something called state machines. So a state machine is like a big map that shows all the different steps your application needs to take to finish its work. Each step in the state machine is a specific task that your application needs to do. It could be running a piece of code, processing some data, or even making decisions based on certain conditions. And now we'll see the components of AWS step functions. Now that we have basic understanding, let's talk about the key components of AWS step functions. The first and most important component is the state. Each state represents a single task or a step in your workflow, and there are different types of states like task, choice, and parallel. A task state does a specific job like running a Lambda function or an activity. A choice state makes decisions based on conditions, and a parallel state lets you do multiple tasks at once. That's right. And what's really cool is that AWS step functions automatically manages the flow between these states. It makes sure that each task happens in the right order, just like following the steps to build a house. And here's the best part. If something goes wrong during one of the tasks, AWS step functions can handle it. It can retry the task a few times or even go to different part of the workflow to deal with the problem. And now you can see the state machine diagram on the screen. So this state machine starts with the start state, which represents the beginning of the workflow. From the start state, it goes to the check item stock, that is a state, which is a task state that checks if the requested item is available in the store's inventory. After completing the check item stock task, the state machine proceeds to process payment state, another task state that processes the customer's payment based on their chosen payment method. The notify method state is a choice state that evaluates whether the customer prefers to be notified via email or SMS. If the customer prefers email, the state machine goes to notify customer email state, which is a task state that sends an order confirmation email to the customer. If the customer prefers SMS, the state machine goes to notify customer SMS state, which another task state, which is another task state that sends an order confirmation SMS to the customer. The parallel state is responsible for running both notify customer email and notify customer SMS tasks simultaneously. Once the tasks in the parallel state are completed, the state machine reaches the end state, which marks the end of the workflow. The visual representation of the state machine provides a clear overview of how AWS step functions coordinate in the different tasks and branches in the workflow. It helps in understanding the flow and logic of the serverless application and enables developers to manage and modify the workflow efficiently. And now we'll see how AWS step functions work. And now let's see how they will work. Imagine you are a chef and you want to bake a cake. You have different steps like mixing the ingredients, putting the batter in the oven, and decorating the cake. With AWS step functions, you can define a state machine for baking a cake. The state machine will list all these steps and the order they need to happen in. So when you start the state machine, it will take you through each step one by one, just like following a recipe. And if you accidentally put too much sugar in the batter, AWS step functions can handle that. It can go back and give you another chance to mix the right amount of sugar. Or if the oven suddenly stops working, AWS step functions can pause the baking process and wait for the oven to be fixed before continuing. And now we'll see the benefits of AWS step functions. AWS step functions offer several benefits. Let's highlight a few of them. First, they make your application more reliable. With built-in error handling and automatic retries, you can be confident that your workflows will work smoothly even if something goes wrong. Absolutely. And AWS step functions also make your life as a developer easier. The visual workflow designer in the AWS Management Console allows you to see and modify your workflows graphically. Plus, it's highly scalable. As your application grows, AWS step functions can handle more and more complex workflows without a hitch. And let's not forget about cost effectiveness. You only pay for the state transitions and the time your workflows are running, which means you can save money while building powerful applications. So these were the benefits of AWS step functions. Now we'll see the real world use cases. AWS step functions are incredibly versatile and can be used in many real world scenarios. For example, if you have a big online store, you can use AWS step functions to handle the entire order process, from receiving the order to receiving the payment, checking the inventory, and finally shipping the products. And let's not forget about data processing. AWS step functions are perfect for automating data pipelines, where you need to extract, transform, and load data from one place to another. It's also a great tool for managing microservices. If you have different parts of your application running independently, AWS step functions can help you coordinate their interactions. And now we conclude this topic, that is AWS step functions. So to wrap things up, AWS step functions are like having a magical conductor for your applications. They make it easier to manage and coordinate all the different tasks in your serverless workflows. With AWS step functions, you get reliability, simplicity, scalability, and cost effectiveness all in one package. So if you are working on AWS and want to simplify your serverless architecture, give AWS step functions a try.
Hello everybody, my name is Kent, and today we're going to be covering AWS Identity and Access Management, also known as IAM Tutorial by Simplilearn. So these are the topics which we'll be covering today. We'll be defining what AWS security is, the different types of security in AWS, what exactly is identity and access management, the benefits of identity and access management, how IAM works, its components, its features, and at the end, we're going to do a great demo on IAM with multi-factor authentication and users and groups. So without any further ado, let's get started. So let's get started with what is AWS security. Your organization may span many regions or many accounts, and you may encompass hundreds if not thousands of different types of resources that need to be secured. And therefore, you're going to need a way to secure all that sensitive data in a consistent way across all those accounts in your organization while meeting any compliancy and confidentiality standards that have to be met. So for example, if you're dealing with healthcare data or credit card information or personal identification information like addresses, this is something that needs to be thought out across your organization. So of course we have individual services in AWS, which we will explore in this video. However, in order to govern the whole process at an organizational level, we have AWS Security Hub. Now, AWS Security Hub is known as a CSPM, which stands for a Cloud Security Posture Management Tool. So what does that really mean? Well, it's going to encompass, like I said, all these tools underneath the hood in order to bring a streamlined way for you to organize and adhere to these standards across your organization. It'll identify any misconfiguration issues and compliance risks by continuously monitoring your cloud infrastructure for the gaps in your security policy enforcements. Now, why is that important? Well, these misconfigurations can lead to unwanted data breaches and also data leakages. So in order to govern this at a very high level, like I said, we need to incorporate AWS Security Hub that will automate and manage all these underlying services for us in order to perhaps take automated action. We call that remediary actions. And you can approve these actions manually, or you can automate those actions as you see fit across your organization. So let's delve a little bit deeper into what is AWS security, and then we'll start looking individually at some of these services. And so our organization has special needs across different projects and environments. So of course, the production, development, test environments, all are going to have their own unique needs. However, it doesn't matter which project or which business unit we're talking about and what are their storage backups needs. They should all be implemented in a concise, standardized way across your organization to meet that compliancy we were just talking about. So we want to automate all these tedious manual tasks that we've been doing, like ensuring that perhaps our buckets in S3 are all encrypted or all our EBS volumes are encrypted. And we want to have an automated process in place in order to give us time on other aspects of our business, perhaps our application development, to bring better business value. And that allows us to grow and innovate the company in a way that's best suited for it. So let's take a look at the different types of AWS security. Now, there are many different types of security services out there. However, we're going to concentrate primarily on IAM in this video tutorial. So I like to think of IAM as the glue between all AWS services, because by default, we don't have permission for any one service to communicate with another. So let's just take, for example, an EC2 instance that wants to retrieve an object from S3. Well, those two services could not interact unless we interacted with IAM. So something that's extremely important to learn. And by the end of this video tutorial, you'll be able to understand what IAM is. We have Amazon Guard Duty here, which is all about logs. Basically aggregates all logs from, example, CloudTrail, which we still haven't talked about. It's at the end of this list over here. But instead of looking at CloudTrail individually, Guard Duty will actually take a look at CloudTrail will take a look at your VPC flow logs, and will take a look at your DNS logs and monitor that account and your network and your data access via machine learning algorithms. And it'll ID any threat where you can automatically remediate the workflow that you've approved. So for example, if you know of a malicious IP address that's making API calls, well, those API calls are registered in CloudTrail, right? So this machine learning algorithm will be able to detect that and take action. So this is really governed at a higher level than you having to individually inspect all your DNS logs, flow logs, and CloudTrails individually and take action through some scripting fashion that you've come up with. So Guard Duty manages all that. We have Amazon Macie, which once again uses machine learning, but also uses pattern matching. Pattern matching can be used with matching kind of libraries that are already in place, or you can come up with your own pattern matching, and that's used to discover and protect your sensitive data. So for example, if you had healthcare data, also known as HIPAA compliancy, or credit card data that's lying around, well, Macie will discover it and will protect it. So as your data grows across your organization, that might be harder and harder to do in your own way. So Macie really facilitates discovering and protecting that, so you can concentrate on other things. AWS Config is something that kind of works in tandem with all the other services. It's able to continuously monitor your resources configurations and ensure that they match your desired configuration. So for example, maybe you state that your S3 buckets should be encrypted by default, all of them, or you want to make sure that your IAM user access keys are rotated. And if they're not, then take remediary action. So a lot of these automated remediary actions, right, are basically executed via AWS config. So you'll see the AWS config actually used by other services underneath the hood. And then you have CloudTrail. CloudTrail is all about logging every single type of API call that's made. So it'll always record the API call, who made it, from what source IP, the parameters that were sent with the API, the response, all that data, which is really a gold mine for you to investigate if there's any security threat. And again, this trail over here, and there can be many, and there's lots and lots of data generated by these trails, can be analyzed by these other services, specifically Guard Duty here, that automates that process so you don't have to. So let's get to the next one, which is, what is identity and access management? So what is IAM? Like I said, IAM is the glue between all AWS services. It will allow those services to communicate with each other once you put IAM into place. The other thing is it allows us to manage our AWS users, which are known as IAM users, and group them together into groups to facilitate assigning and retrieving or removing permissions from them instead of doing it on an individual scale. So of course, if you had 200 IAM users and you wanted in one shot to add a permission to a group that contained 200 IAM users, well, you can do that in one operation instead of 200. Now we do have a distinction between IAM users and end users. End users use applications online, whereas IAM users are your employees in your organization that are interacting directly with AWS resources. So for example, an EC2 instance would be a resource that, let's say, a developer would be interacting with. And traditionally, those are resources that are used full-time, from 9 to 5, let's say, 5 days a week, 365 days a year, okay? Now, sometimes those users have to have elevated permissions for a temporary amount of time, and that is more suited for a role. And that'll eliminate the need to create separate accounts just for, type of actions that are needed for, let's say, an hour a month or 2 hours a week or something like that. Something like backing up an EC2 instance, removing some files, doing some cleanups. Traditionally, you don't have those permissions as a developer, but you can be given temporary permissions to assume this role. So it's kind of like putting a hat on your head and pretending you're somebody that you're usually not for a temporary amount of time. Once you take off the hat, you go back to being your old boring IAM user self, which doesn't have access to performing backups or cleanups and stuff like that. So the roles interact with a service called a secure token service, which gives us specific keys, specifically an access key, a secret key, much like a username and password. And then we have a token key, which only gives you access to this role, this elevated permission, for 1 to 12 hours. So we'll talk more about roles as we go on through this video tutorial, but it's important that you at least remember at this point, even if you don't know all the details, that roles have to do with temporary permissions, elevated permissions. So what are the benefits of IAM? Well, across our organization, we are going to have many accounts, and like I said, hundreds if not thousands of resources. So scalability is going to be an issue if we don't have a very high level visibility and control over the entire security process. And once we have a tool like, for example, Security Hub, which we saw on the first slide, we can continuously monitor and maintain a standard across our organization. So very, very important to have that visibility. And we do when we integrate with AWS security. Now, we also need to eliminate the human factor, right? So we don't want to manually put out fires every single time. Of course, there will be times when something new occurs that we've never seen before that will be needed. However, once an occurrence happens and reoccurs, we can obviously come up with a plan to remediate the action. So once we automate, we can definitely reduce the time to fix that reoccurring error, or it could be a new error that we don't have to interact with because we're using machine learning algorithm services like I was talking about, like GuardDuty or Macy. And we can really reduce the risk of security intrusions and data leakage and such by using IAM to facilitate this. Of course, you may have many compliance needs. You may be dealing with applications that use healthcare data or credit card information for payments, or you might be dealing with a government agency, let's say in the US, that has certain compliancy requirements that needs assurances that if their data is stored on the cloud, that you're still following the same compliance controls that you were, let's say, on premise. So we have a very, very long list of compliance requirements that each AWS service adheres to. And you can go on the AWS documentation online and you could figure out if, for example, DynamoDB is compliant with HIPAA compliancy. And it is. And so you can be sure that you can use that. So AWS itself has to constantly maintain these compliancy controls in place, and they themselves have to pass all these certifications, and that gets passed on to us. So much less work for us to implement these compliance controls. We can just inherit them by using AWS's security model by IAM. And last but not least, we can build the highest standards for privacy and data security. Now, having all this on our own on-premise data center poses security challenges, especially physical security challenges. You have to physically secure the data center. You might have security personnel that you need to hire, 24/7 camera surveillance, et cetera, et cetera. So just by migrating to the cloud, we can take advantage of AWS's global infrastructure. They're very, very good at building data centers. That's part of their business, and securing them. So of course we have a shared security model in place. However, you can rest assured that at least as the lowest common denominator, physical security has been put into place for us. Again, as other services are used, more managed services or more higher end services used in AWS, more and more of that security model will be AWS's responsibility and less yours. We will always have a certain type of responsibility for our applications, but we can again use these high-level services to ensure that our ability to encrypt the data at rest and in transit are always maintained by coming up with specific rules that need to be adhered to. And if those rules are not adhered to, then we have remediary actions that take place in order to maintain, again, that cross-account or organizational-wide security control. Okay, so lots of benefits of using IAM. And let's now take a look at exactly how IAM works and delve deeper into authentication and authorization. So there are certain terms here that we need to know about. One of them is principal. Now, principal is nothing more than an entity that is trying to interact with an AWS service, for example, an EC2 instance or an S3 bucket. Now, that could be a user, an IAM user. It could be even a service, or it could be a role. So we're going to take a look how principals need to be specified inside IAM policies. Authentication. So authentication is exactly how it sounds. Who are you? Could be something as simple as username and password, or it could involve an email address. Example, if you're the root user of the account when you're creating the account for the very first time. Other normal users will not need to log in with their user email. It'll only be the root user that needs that. You could also have developer type access, which needs access, let's say, via command line interface or a software development kit, also known as an SDK. Now, for those kind of access points, we're going to need access keys and secret keys, or public-private keys, let's say, if you want to even authenticate and log in through SSH to an EC2 instance. So there are many different types of authentication that we could set up when creating IAM users based on what kind of access they need. Do they just need access to the console? Do they need access to just services in terms of as a programmatic need? So those are different types of authentication. And then we have the actual request. Now, we could make a request in AWS through various ways. We're going to be exploring that via the console, the AWS console. However, every button you click, every drop-down list you select, that invokes an API call behind the scenes. So everything goes behind a centralized, well-documented API. Every service has an API. So if you're dealing with Lambda, let's say, well, Lambda has an API. If you're dealing with EC2, EC2 has an API. Now, you could interact with that API, like I said, via the console indirectly. You could use a command line interface. You can use an SDK for your favorite programming language like Python. So all of them get funneled through, all your requests get funneled through an API. But that doesn't mean you're allowed to do everything just because we know who you are and you have access to some keys, let's say, to make some API calls. You have to be authorized in order to perform certain actions. So maybe you're only authorized to communicate with DynamoDB, and also maybe you're only authorized to perform reads and not writes. So we can get some very fine-grained authorization through some IAM policies in order to control not only who has access to our AWS, but what they're allowed to do. So very fine-grained actions, read actions, write actions, both, maybe just describe or list some buckets. So depending on the AWS user that's logged in, we can control exactly what actions, because every API has fine-grained actions that we can control through IAM. And of course, many, many different types of resource. When we're coming up with these policies, all these actions can be grouped into resources. So perhaps we can say, well, this user only has access or read-only access to S3, specifically these buckets, and can write to a DynamoDB table, but cannot terminate or shut down an EC2 instance. So all these kind of actions can be grouped into resources on a per resource basis based on the kind of role you have in the projects or in the company. So now let's take a look at the components of IAM. We've already seen that we can create IAM users and that how they are different than your normal end users. Now those entities represent a person that's working for an organization that can interact with AWS services. And some of those permissions that we assign through what's called identity-based policies to such a user will have permissions, for example, that are always necessary every time that they're logged in. So perhaps this user Tom always needs access to the following services over here, for example, an RDS instance or an S3 bucket, etc., etc. And sometimes they will need temporary access to other services, for example, DynamoDB. So in those cases, there would be a combination of normal IAM policies assigned to the user and certain assume role calls done at runtime in order to acquire this temporary credential, elevated permission. There is also the root user, which is different than your typical super user administrator access. There are some things that a root user can do that an administrator access cannot. For example, a root user, first of all, logs in with their email address and can also have the option to change that email address, something that is very tightly coupled to the AWS account. So you cannot change the email address with an administrator account. The other thing a root user can do is they can change the support contract. They can also view billing information or taxes information, VAT information, for example. So the best thing to do, the best practice is that once you've created your AWS account, you are obviously the root user. The best thing to do is to enable multi-factor authentication, store away those keys in a secure location, and your first administrative task should be to create an administrator super user, from which that point on you will log in as only an administrative user, and you will create other type of administrative users, and those administrative users will create other IAM users. So never log into your AWS account as a root user unless you need to access that specific functionality that I said that is over and above a super user administrator account. So here we have a set of IAM users, and we could assign to them directly IAM policies, which give them access to certain services. However, the best practice is to create groups, which is just a collection of IAM users. And suppose we have a developer group and a group of security administrators. Of course, we could assign different types of policies to that group, and every user that is assigned to the developer group will inherit those IAM permissions. Makes it much easier to manage your IAM users this way. And for the fact that also you can have users that can be assigned to groups, as you can see here, but what's not shown here that is possible as well is you could have a user that is part of two groups at the same time. The thing that you cannot have, though, is the notion of subgroup. So I can't extend this group and create a smaller group of developers out of this big group here. So we don't have hierarchical groups, but we do allow users to partake in different groups at the same time. So they will inherit those permissions, those IAM policy permissions from, for example, if user A was part of developers and user A was part of security, they would inherit these two policy statements over here. Now, there is another type of IAM policy, and that is called a resource-based policy. So resource-based policies are not attached directly to, for example, users, but they're attached more to resources like an S3 bucket, for example. And so when you have such a case, a user group can't be designated as a principal to a group. That's just one of the restrictions. However, there are other ways to get around that. As I said, when you think of an IAM role, I want you to think that these are temporary credentials that are acquired at runtime and are only good for a specific amount of time. Now, an IAM role is really made up of two components. We have what's called a trust policy. So who do you trust to assume this role? Who do you trust to even make an API call to assume the role? After that, we have an IAM policy. Once you've been trusted to assume the role and you get those temporary tokens, what are you allowed to do? Maybe you're allowed to have read-write access to the DynamoDB. So here we have no long-term credentials that are connected to role. You do not assign a role to a user. The user or service will assume the role via API call via the Secure Token Service, STS. And with those temporary credentials, we'll then be able to access, for example, an EC2 instance if the IAM policy attached to the IAM role says that you can do so. So your users and your applications perhaps running on an EC2 instance and the AWS services themselves don't normally have access to the AWS resources, but through assuming a role, they can dynamically attain those permissions at runtime. So it's a very flexible model that'll allow you to bypass the need to embed security credentials all over the place and then have to maintain those credentials and make sure they're rotated and they're not acquired by anybody trying to find a security hole in your system. So from a maintenance point of view, they're really an excellent tool to use in your toolbox, your security toolbox. So let's take a look at the components of IAM. We have the IAM policy over here, which is really just a JSON document. And that JSON document will describe what this user can do if it's attached directly to it, or if the IAM policy is attached to the group, whatever user is attached to that group will also have the same policy inherited. So these are more long-term credentials in terms of, or permissions rather, that are attached to your login for the duration of your login, whereas roles are, as we've already stated, temporary. And again, once you've established a trust relationship, then we can assign a policy, for example, a policy that gives you only read-only access to a CloudTrail to a role. Now, it's up to the user to assume that role either through the console or through some programmatic means. Whichever way is performed, the user will have to make a direct or indirect call to STS for the assume role call. Now, these permissions are examined by AWS when a user submits a request. So this all happens at runtime dynamically. So when you change a policy, it will take effect pretty much immediately as soon as the user makes the next request. That new security policy, whether you've just added or removed the permission, will take immediate effect. So what we're going to do now is just really quickly go to the AWS console and actually show you how an IAM policy looks like. So I've just logged into my AWS Management Console, and if I search for Identity and Access Management, it should be the first one to show up. I'll just click on that. And I want to show you actually how these IAM policies look like. If you go to the left-hand side here, there's an entry for policies. And there are different types of policies that we can filter out. So let's filter them out by type. We have customer managed, we have AWS managed, and more in line with job functions that AWS managed also. So we're going to take a look at AWS managed. All that means is that AWS has created and will actually update, maintain these pre-established and already vetted identity policies, IAM identity policies. So I could add further down, maybe look at all the S3 policies that are available, and we can see there are some that allows only read-only access. There are some that will give us full access. And there are, of course, other types here that we're not all going to explore, but let's just easily kind of take a look here at the full access. You can see it's just a JSON document. And of course, you cannot modify it since this is a managed policy. However, you can copy it and modify it. And in that case, it will become your own version of it. And so it'll be customer defined. And so when you go here and you do a filter, you can filter on your own customer managed policies. So over here, we are simply allowing certain actions, right? We talked about actions before that were based on API. So here we have an API that starts with S3. So this is for the S3 API. And instead of filtering out exactly specifically what API calls are there, we're basically saying all API calls. So star representing all API actions. And again, there is another category of S3 which deals with object Lambda and we are allowing all operations on that specific API as well. We could, if this was our own customer managed policy, actually scale down on which resource, which bucket, let's say, or which folder in a bucket this would apply to. But in this case, since this is a full access, we're basically being given permission to execute every single API action under S3 for all buckets. We're going to see in the lab or the demonstration at the end of this tutorial that I'm going to show you how to scale that down. Okay, so that's how an IAM policy looks like. And if you want to assign an IAM policy to a user, well, stay tuned for the demonstration at the end of the video tutorial. What's not at the end of the video tutorial is really how to create a role. So I'll show you what a role is here. Again, there's a whole bunch of roles already set up that we can go and take a look at here. But we can go and create our own role as well. And I might create a role, for example, that gives in EC2, let's choose EC2, access to S3. So if I click EC2 and click Next Permissions, I can actually assign the S3 permission right over here. It's just a policy, just like we took a look at. Obviously assign it a tag and review it. And I'm just going to call this my EC2 role to S3. Create the role. And because I selected EC2 as a service, it automatically will include that in the trust policy. So now when I go and I create an EC2 instance, I can attach this role to that EC2 instance, and that EC2 instance will automatically be able to, if we're using the Linux 2AMI, let's say, have access to, or full admin access to, any S3 bucket in the AWS account. So let's go take a look at where we would actually attach that role on the EC2. So when you're creating an EC2, let's just say we go here, we say launch an EC2 instance, and we'll pick this AMI over here because it'll already include the packages necessary to perform the assume role call to STS for us, so we won't have to code that. And we don't have to embed any credential keys in order to get this running, which is really good, which is the whole point of what I'm doing, because by assuming a role, I don't have to manage that. And I'm just going to pick the free T2 micro. And it is here, once you pick whatever you need, whatever VPC and whatnot, that you come to the IAM role and you select the role to be assumed dynamically. Now I have a whole bunch of them here, but this is the one that I had created here, my EC2 role to S3. And if I go and I launch this EC2 instance, and then I had an application, let's say, that needed to contact S3, or even if I went on the command line of the EC2 instance, I would be able now to communicate with the S3 service, because they being AWS, would actually use this role to perform an assume role call to get those temporary STS tokens for me, which will then allow me to access my IAM policy, which gives me full access to S3, and off I go. So this is a great way, like I said, to avoid having to administrate any embedded keys in this EC2 instance. And I could take this role away at any time as well. So there you have it, a little demonstration on how to create a role, how to attach it to an EC2 instance, and also how managed and customer managed policies look like in IAM. Of course, there is also the fact that we have multiple accounts, and so we could assign a policy that will also allow a user in another account access to our account. So cross-account access is something that's very well needed, and also is a feature of IAM. So when you need to share access to resources from one account to another in your organization, we are in need of an IAM policy to facilitate that. So also roles can come into play here for that. By also assigning granular permissions, we can make sure that we implement the concept or the best practice of the least privilege access. And also we have secure access to AWS resources, because by default, again, we have the principle of least privilege, and no service can communicate with another until we enable it via IAM. So very, very secure out of the box. Of course, if you want to add an additional layer of authentication, of security, we have multi-factor authentication rather, and that'll allow you to ensure through a hardware device, perhaps let's say a hardware token device or your cell phone that has some software that generates a code, that will allow it to identify you are actually the person that is typing the username and password, and not somebody who's actually stolen your username and password. So at the end of this video tutorial, we will show you, or I will show you how to enable that. And of course, identity federation is a big thing, where your users may have been defined outside of AWS. You may have thousands of users that you've already defined, let's say in an Active Directory or in an LDAP environment on-prem, and you don't want to recreate all those users again in AWS as IAM users. So we can tie in, we can link the users, your user database that's on-prem, or even users that have been your user account that's been defined, let's say on a social site like Facebook or Twitter or Google, and tie that into your AWS account. And though there is an exchange of information, there is a setup to do, but at the end of the day, it is either a role in combination with an IAM policy that will allow to map what you're allowed to do once you've been authenticated by an external system. So this has to do with perhaps, like I said, LDAP or Active Directory, and you can tie that in with AWS SSO. There are many different services here that can be leveraged to facilitate what we call identity federation. And of course, IAM itself is free. So it's not a service per API request. AWS is very concerned to put security first, and so IAM is free. It's just the services that you use. For example, if you're securing an EC2, of course, that EC2 instance falls under the current pricing plan. So of course, compliance, like I mentioned, is extremely important, making sure that it's business as usual in the cloud. And so, for example, if you were using the payment card industry data security standard to make sure that you're storing and processing and transmitting credit card information appropriately in order to do your business, well, you can be assured that the services you use in AWS are PCI DSS compliance. And there's many, many other types of compliance that AWS adheres to as well. So password policies, of course, are important. By default, we do have a password policy in place, but when you go to the IAM console, you're free to update that password policy, make it more restrictive based on whatever policy you have at your company. So many features. And so I think we're ready now to go into a full demonstration, and I will show you how to incorporate IAM users, groups, and also multi-factor authentication. So get ready, let's do it. I'm going to demonstrate now how to attach an S3 bucket policy via IAM. I've already created a bucket called Simplilearn S3 IAM demo. And what we're going to do is we're going to attach a bucket policy right over here. We're going to have to edit it, of course. And the basis of the demonstration will be to allow a user that has MFA, so multi-factor authentication, set up to have access to the contents of a folder within this bucket. So of course, now I have to create a folder. Just simply call it folder 1. Create that folder. And now I'm going to go into that folder and upload a file so that we can actually see this in action. So I'm going to select a demo file that I prepared in advance called demo file user2 MFA. I'm going to upload that. All right, and now what's going to happen is eventually when I create our 2 IAM users, one will have access to view the contents of this file, which should look like something very simple. If I open this up within the console, you'll be able to see, well, it's pretty small right now. I'll make this a little bit bigger, of course. it says this is a demo file which user2-mfa should only be able to have access to. So what's left to do now is to create two users, one called user1 and one called user2-mfa, and that's what we're going to do right now. Let's head over to IAM, Identity and Access Management. And on the left-hand side here, we're going to click on users. You can see here I don't have much going on. I just got an administrator user, so I want to create two new users. We'll start with one at a time. So one called user1. Now by default, we have the principle of least privilege, which means this user is not allowed to do anything unless we give them access to either the console right over here, which I will do right now. And also if they were a kind of programmatic user that needed access to specific keys in order to interact with the APIs via the command line interface or the software development kit, for example, if you were a Java developer. So in this case, that is not what I want. So I'm just going to assign console access, and I'm also going to create a default password for this user, but I will not allow them to reset it on the first login, just for demonstration purposes. Now over here, we have the chance to add the user straight to a group, but I'll only do that later on at the end of the demonstration. For now, I want to show you how to attach to this user an IAM policy, which will give them access to specific services. So if I type in S3 full access here, this is an administrative access to an S3 bucket. If you take a look at the JSON document attached or representing that IAM policy, you can see that it is allowing all API actions across S3, star, and also object Lambda across all buckets. And I say all buckets because the star represents all buckets. So it is a very broad permission, so be very careful when you're actually assigning this to one of your users. Make sure that they deserve to have such a permission. So I'm not going to assign any tags here, but I'm just going to review what I've done. You can see here I've just attached an S3 full access permission to this one user, and I'm going to create that user now. Of course, now's the time for me to download the CSV file, which will contain those credentials. If I don't do it now, I will not have a second chance to do this. And also to send an email to this user in order for them to have a link to the console and also some instructions. I'm not going to bother with that. I'm just going to say close. And now I have my user one. You can see here that it says none for multi-factor authentication. So I have not set anything up right now for them. And that's what I want to do for this second user that I want to create, called user2-MFA, or MFA rather. All right. So now I want to do the same exact thing as before. I'm going to assign a custom password. And I'm going to go through the same steps as we saw before. I'm going to attach an existing managed policy that AWS has already vetted for us. Review, create. Now, right now, they're exactly the same. So I have to go back to user 2 and set up multi-factor authentication. And to do that, you have to go in the Security Credentials tab. And you'll see here, assigned MFA device. We have not assigned any yet, so we're going to manage that right now. And we have the option to order and get an actual physical device that's uniquely made for performing multi-factor authentication. However, we're going to opt for the virtual MFA device, which is a software that we're going to install on our cell phones, let's say. So I can actually open this link just to show you the very many options that we have for that. They're right over here. I'm going to go with Google Authenticator. So go to the App Store on your Android device and you can download that. Of course, if you have an Android device. If not, you have other options for iPhone and other softwares for each one of those. So I'll let you do that. Once you've installed that software on your cell phone, you can come here and show the QR code. Now what that is going to do is you're going to need to go to your phone now, and I'm going to my phone right now as we speak, and I'm going to open up that MFA software, in this case the Google Authenticator, and I'm going to say there's a little plus sign at the bottom. I'm going to say scan QR code. I'm going to point my phone to this square code here, this QR code, and it's going to pick it up. I'm going to say add account. There's a little button there, add account, and it's going to give me a code. So I'm going to enter that code right now. So once I've entered the code, I have to wait for a second code, and that's because this code on the screen of my cell phone is going to expire. It's only there for about 20 to 30 seconds. Once that token expires, it refreshes the display with another token. So I have another token now. That's only good for a couple of seconds again. And now I'm going to say assign MFA. What this does is it completes the link between my personal cell phone and this user right now. So now that this has been set up, we can see we actually have an ARN to this device, which we are going to possibly need depending on how we write our policies. In our case here, I'm going to show you a way to kind of bypass having to put that. So now we've got those two users, one with an MFA device and another one without. Okay, so now the lab is going to be, or the demonstration rather, is going to be how do we allow user 2 MFA access to this file in folder 1 and not allow user 1. The distinguishing factor will be that user 2 has an MFA set up and user 1 doesn't. So based off of just that condition, that'll be the determining factor if they can view the file or not. So let's get back to S3 and actually create this IAM bucket policy and see how it's done. So back we are in our bucket, and now we have to go to permissions in order to set up this bucket policy. We're going to click on edit over here, and we're going to click on policy generator to help us generate that JSON file through a user interface. Of course, we're dealing with an S3 bucket policy. Now, what we're going to do is we're going to deny all users and services, so star. S3 is grayed out here because we selected S3 up here. We want to deny all S3 API actions. We're not going to go and selectively go down the list. The specific bucket and the folder. So in this case here, we're missing the Amazon resource name. So we have to go back here and we have to copy the ARN of our bucket, right? So we're going to copy that, come back, Control V, and we're going to, of course, have to specify the folder as well. So I'm going to just do slash folder 1, and then I'm also going to do slash star for all the objects in that folder. Okay, so here's the MFA condition that I want to add though, because we cannot assign the MFA condition up here. We have to say add conditions. Very powerful feature here. That's optional, but very powerful. We want to look for a condition that says Boolean if exists, or bool if exists. All right, so there's got to be a key value pair that exists. And there are many, but we're going to look for one that is specifically known as multi-factor authentication present. And we want to make sure that value is equal to false. So I'm going to add that condition, and then I'm going to add that statement. And I want to generate the policy just to show you now how that user interface has generated this JSON document for us that we're going to attach to our S3 bucket. What I want to do is I want to take this in its entirety, copy it, and go back to our S3 bucket that's just waiting for us to paste our policy in here. Okay, so let's see what's actually going on here. We've created a policy. Again, this policy could have any ID. It's just an ID that was given by the user interface. You could name that whatever you want. Of course, something that makes total sense. And then we have one or more statements, and then we only have actually one statement. And again, you can select any ID here. That was just auto-generated by the IDE. We're saying that all actions on the simple storage service, I say all again because of the star, are denied specifically on this resource, which is our bucket and the folder named folder 1 and all the objects within that folder under the certain conditions. So the condition is if you have a Boolean value of false associated with a key called multi-factor authentication present, and it has to exist, okay? Then if that value is equal to false, you don't have access to the objects in this folder, which means that if you do have MFA set up, you will be allowed access to the contents of this folder. So if we assign this and apply this to all principals, which would encompass user1 and user2-MFA, then, let me just apply this, that would mean that user 1 would not be able to see the contents of our object inside folder 1, and user 2-MFA would. So let's go take a look and log into, let's log out first, and then when we're going to log back in, we're going to log in as the individual user 1 and user 2-MFA and prove this is actually the case. So I am now logging back in as user 1 that we created moments ago. And of course, if I, for example, go see a service like EC2, we don't have access to EC2. We've just given ourselves access to S3. So this makes total sense. We're just going to go see what we have access to, which is S3. Should be able to list and describe all the buckets there because we've been given pretty much administrative access. Now, if we go here to our created bucket and go inside folder 1 and want to actually open up this document, we can see now that that's not happening, okay? And that's because of that condition that is checking if we actually have a value of true for that MFA key that we specified, okay? So this is expected and this is exactly what we wanted. Now what we're going to do is we're going to log out once again, and we're going to do the same thing, but with user2-MFA. Let me log back in. And then specify the new password we created. Now, of course, now I have an MFA code, right? Because I've set that up for user 2. So back on my cell phone I go. I am opening up the Google Authenticator application, and I have in front of me a new Amazon Web Services code that is only good for, like I said, maybe 20 seconds. So it's a little nerve-wracking. If you're not good under pressure, you're going to choke. So I've just entered the code, and I have to wait for that to actually work. Now, it looks like I actually didn't check off not to recreate the password. So unfortunately, I must have missed that check mark. So I wanted to kind of avoid this here. So I'm going to start over and create a brand new password. A little painful for demonstrations, but it's good for you guys to see how that actually looks like. So because I've set up my MFA device properly, I am able to log in after I enter that MFA code. And once again, if I go to EC2, now I haven't been given the permissions for EC2. I've only been given the permissions for S3. So nothing changes here. I'm going to go to S3. And I'm going to go into folder 1 of our bucket in question. And I'm going to see if I have access now to opening up and seeing the contents. And here I have the contents. This is a demo file, which user 2MFA should only be able to have access to. So that worked. So now you guys know how to create a bucket permission policy that is also known as a resource policy because it's assigned to the resource, it's assigned to the bucket. And let me actually show it to you one last time. Here it is. And that'll only allow us to have access to the contents of folder 1 if we have multi-factor authentication set up in our account. So that's really good. The last thing I want to show you now is how to maybe create IAM users in a better way in terms of not having to assign over and over again the same permissions like you saw me do for user 1 and user 2 Of course, now I cannot do anything IAM. Why? Because I'm user 2. I don't have access to IAM. So once again, I'm logging out, and we're going to actually see the best practice in terms of how do I assign IAM policies to a group and then assign users to that group in order to inherit those permission policies. So let's get to it. Let's sign out first. So let us go back to IAM, and we're going to be creating our first group. We're going to simply create the button, or click on the button create group, and we'll come up with a group called testers. We have the ability to add existing users to this group. So we will add, for example, user 1 only to the testers group. And we can also add permissions to this group. So we're going to go here and add, for example, the EC2 full permissions, create group. And what's going to happen now, if we go take a look at testers, we can see we have that one user that we added, and we also have the permissions associated with that group. So this means now that any new users we create will automatically inherit whatever permissions the group has, which is really good for maintainability. So for example, let's say we were to create many new testers. So let's say user 3 over here. Now, of course, I'm going to have to go in this case through the same steps as I did before. I'm just going to remember this time not to forget to uncheck that. And instead of attaching policies directly, I'm going to say, well, I want to inherit the policy permissions that were assigned to the group. So I'm going to say this user is going to be part of the testers group. And of course, I'm just going to skip through the remaining repetitive tasks that I've already described. And this user 3 now is already going to have the permissions to access EC2 that they've gained through the group testers. Whereas if we go back to user 1, this user also has the permissions from the group, but has a unique permission added to itself. So in this case, you do have the option of doing that. You have the option of adding a permission over and above that is assigned to the group to yourself directly. So this is really good, adding permissions to groups when you have, of course, lots of users in your company, in your organization. And instead of going to them and adding permissions after permission, you can centrally access this in one, or manage this in one place. So for example, if I go back to my roles, groups rather, in my testers, and let's say I forgot to add a permission to all the users in this group. So let's say there was 20 users attached to this group. Okay, I'm not going to bore you with creating 20 users. we have 2 now. That's good enough to show the demonstration. And let's say now I need to add another permission, right? So in this case here, I'm going to add a permission, for example, let's say based on DynamoDB, right? So I'm going to get full access to DynamoDB. I'm going to add that permission. And what's going to happen now is if I go back to my users, for example, user 3, I'm going to see that user 3 automatically has inherited that permission, and so has user 1. All right, show 2 more, and there they are. So in this case, it really allows for you to easily manage a lot of users in that group, because you can simply go to one place, which is the group, and add and remove policies as you see fit, and the whole team will inherit that. So it saves you lots of work, and that is the best practice. So there you have it, guys. You have learned in this demonstration how to create users, how to create groups, how to add users to groups and manage their policies in terms of best practice. And you've also learned how to attach to an S3 bucket a policy that allows you to permit access based off of if a user has multi-factor authentication set up. And we showed you how to actually set that up when creating an IAM user. So again, permissions tab is where this all happens. Hope you enjoyed that, put that to good use, and I'll see you in the next demonstration. So I hope you enjoyed that demonstration. We're just going to wrap things up in a summary and kind of see what was looked at throughout the tutorial. We first started with what is AWS security. We took a look at how important it was across our organization to maintain best practice and also standardize that practice across the accounts organization. We took a look at the topmost services, in which we concentrated then after on IAM. And we took a look at what IAM was in terms of IAM users, groups, long-term credentials that are applied as IAM policies, and then the concept of a role. We took a look at the benefits of IAM and the actual terminology used with working with IAM. Of course, principal being an entity that is either a user or a service itself that can gain access to an AWS resources. And we actually saw the different types of authentication and what we can do to implement authorization via IAM policies and also through the use of roles. So we took a look how to organize our users into groups and what actually goes into acquiring a role through a demonstration. We took a look at how to actually create a role and attach that role to an EC2 instance. And then we took a look at the high-level features of IAM, which allowed us to either grant access to another IAM user from another group, implement multi-factor authentication like we just did in the demonstration, or ensure ourselves that we are following all the compliancy standards that have been adhered to by whatever project we're working on, and that AWS is there to support us.
Hi guys, this is Akhil, and today we are going to discuss about Amazon Redshift, which is one of the data warehouse service on the AWS. But before starting up with the Amazon Redshift, I would request you guys to subscribe our channel. You can find the link just below this video at the right side. So let's begin with Amazon Redshift and let's see what we have for today's session. So what's in it for you today? We'll see what is AWS, why we require Amazon Redshift. What do we mean by Amazon Redshift? The advantages of Amazon Redshift, the architecture of Amazon Redshift, some of the additional concepts associated with the Redshift, and the companies that are using the Amazon Redshift. And finally, we'll cover up one demo which will show you the practical example that how you can actually use the Redshift service. Now, what is AWS? As we know that AWS stands for Amazon Web Service. It's one of the largest cloud providers in the market, and it's basically a secure cloud service platform provided from the Amazon. Also, on the AWS, you can create and deploy the applications using the AWS service. Along with that, you can access the services provided by the AWS over the public network, that is, over the internet. They are accessible. Plus, you pay only whatever the service you use for. Now let's understand why we require Amazon Redshift. So earlier, before Amazon Redshift, what used to happen that the people used to, or the developers used to fetch the data from the data warehouse. So data warehouse is basically a terminology which is basically represents the collection of the data. So a repository where the data is stored is generally called as a data warehouse. Now, fetching data from the data warehouse was a complicated task because might be a possibility that the developer is located at a different geography and the data warehouse is at a different location, and probably there is not that much network connectivity or some networking challenges, internet connectivity challenges, security challenges might be, and a lot of maintenance was required to manage the data warehouses. So what were the cons of the traditional data warehouse services? It was time consuming to download or get the data from the data warehouse. Maintenance cost was high, and there was the possibility of loss of information in between the downloading of the data, and the data rigidity was an issue. Now, how these problems could overcome, and this was basically solved with the introduction of Amazon Redshift over the cloud platform. Now, we say that Amazon Redshift has solved traditional data warehouse problems that the developers were facing, but how? What is Amazon Redshift actually is. So what is Amazon Redshift? It is one of the services over the AWS, Amazon Web Services, which is called as a data warehouse service. So Amazon Redshift is a cloud-based service or a data warehouse service that is primarily used for collecting and storing the large chunk of data. So it also helps you to get or extract the data, analyze the data using some of the BI tools. So business intelligence tools you can use and get the data from the Redshift and process that. And hence it simplifies the process of handling the large scale data sets. So this is the symbol for the Amazon Redshift over the AWS. Now let's discuss about one of the use case. So DNA is basically a telecommunication company, and they were facing an issue with managing their website and also the Amazon S3 data, which led down to slow process of their applications. Now, how could they overcome this problem? Let's see that. So they overcome this issue by using the Amazon Redshift, and all the company noticed that there was a 52% increase in the application performance. Now, did you know that Amazon Redshift is basically cost less to operate than any other cloud data warehouse service available on the cloud computing platforms? And also the performance of an Amazon Redshift is the fastest data warehouse, we can say that is available as of now. So in both cases, one is that it saves the cost as compared to the traditional data warehouses, and also the performance of this Redshift service or a data warehouse service, the fastest available on the cloud platforms. And more than 15,000 customers presently they are using the Amazon Redshift service. Now let's understand some of the advantages of Amazon Redshift. First of all, as we saw that it is one of the fastest available data warehouse service, so it has the high performance. Second is, it is a low cost service. So you can have a large scale of data warehouse or the databases combined in a data warehouse at a very low cost. So whatever you use, you pay for that only. Scalability. Now, in case if you wanted to increase the nodes of the databases in your Redshift, you can actually increase that based on your requirement, and that is on the fly. So you don't have to wait for the procurement of any kind of a hardware or the infrastructure. It is whenever you require, you can scale up or scale down the resources. So the scalability is again one of the advantage of the Amazon Redshift. Availability, since it's available across multiple availability zones, so it makes this service as a highly available service. Security. So whenever you access Redshift, you create a clusters in the Redshift, and the clusters are created you can define a specific virtual private cloud for your cluster, and you can create your own security groups and attach it to your cluster. So you can design the security parameters based on your requirement, and you can get your data warehouse or the data items in a secured place. Flexibility, and you can remove the clusters, you can create another clusters. If you are deleting a cluster, you can take a snapshot of it and you can move those snapshots to different regions. So that much flexibility is available on the AWS for the service. And the other advantage is that it is basically a very simple way to do a database migration. So if you're planning that you wanted to migrate your databases from the traditional data center over the cloud on the Redshift, it is basically very simple to do a database migration. You can have some of the inbuilt tools available on the AWS, you can connect them with your traditional data center and get that data migrated directly to the Redshift. Now let's understand the architecture of the Amazon Redshift. So architecture of an Amazon Redshift is basically it combines of a cluster, and that we call it as a data warehouse cluster. In this picture, you can see that this is a data warehouse cluster and this is a representation of a Amazon Redshift. So it has some of the compute nodes which does the data processing, and a leader node which gives the instructions to these compute nodes. And also the leader node basically manages the client applications that require the data from the Redshift. So let's understand about the components of the Redshift. The client application of Amazon Redshift basically interact with the leader node using JDBC or the ODBC. Now what is JDBC? It's a Java database connectivity, and the ODBC stands for Open Database Connectivity. The Amazon Redshift service using a JDBC connector can monitor the connections from the other client applications. So the leader node can actually have a check on the client applications using the JDBC connections. Whereas the ODBC allows a leader node to have a direct interaction or to have a live interaction with the Amazon Redshift. So ODBC allows a user to interact with live data of Amazon Redshift. So it has a direct connectivity, direct access of the applications, as well as the leader node can get the information from the compute nodes. Now, what are these compute nodes? These are basically kind of a databases which does the processing. So Amazon Redshift has a set of computing resources which we call it as a nodes, and the nodes, when they are combined together, they are called it as a clusters. Now, a cluster, a set of computing resources which are called as nodes, and this gathers into a group which we call it as a data warehouse cluster. So you can have a compute node starting from 1 to n number of nodes, and that's why we call that the Redshift is a scalable service, because we can scale up the compute nodes whenever we require. Now, the data warehouse cluster, or each cluster, has one or more databases in the form of a nodes. Now, what is a leader node? This node basically manages the interaction between the client application and the compute node. So it acts as a bridge between the client application and the compute nodes. Also, it analyzes and develops designs in order to carry out any kind of a database operations. So leader node basically sends out the instructions to the compute nodes, basically perform or execute that instruction and give that output to the leader node. So that is what we are going to see in the next slide, that the leader node runs the program and assign the code to individual compute nodes, and the compute nodes execute the program and share the result back to the leader node for the final aggregation, and then it is delivered to the client application for analytics or whatever the client application is created for. So compute nodes are basically categorized into slices, and each node slice is allotted with specific memory space, or you can say a storage space, where the data is processed. These node slices works in parallel in order to finish their work, and hence when we talk about a Redshift as a faster processing capability as compared to other data warehouses or traditional data warehouses, this is because that these node slices work in a parallel operation that makes it more faster. Now, the additional concept associated with Amazon Redshift is there are two additional concepts associated with the Redshift. One is called as the column storage and the other one is called as the compression. Let's see what is the column storage. As the name suggests, column storage is basically kind of a data storage in the form of a column, so that whenever we run a query, it becomes easier to pull out the data from the columns. So column storage is an essential factor in optimizing query performance and resulting in quicker output. So one of the examples are mentioned here. So below example show how database tables store record into disk block by row. So here you can see that if we wanted to pull out some kind of an information based on the city, address, age, we can basically create a filter, and from there we can put out the details that we require, and that is going to fetch out the details based on the column storage. So that makes data more structured, more streamlined, and it becomes very easier to run a query and get that output. Now the compression is basically to save the column storage, we can use a compression as an attribute. So compression is a column level operation which decreases the storage requirement, and hence it improves the query performance. And this is one of the syntax for the column compression. Now the companies that are using Amazon Redshift, one is LYA, the other one is Equinox, the third one is the Pfizer, which is one of the famous pharmaceuticals company, McDonald's, one of the burger chains across the globe, and Philips, it's an electronic company. So these are one of the biggest companies that are basically relying and they are putting their data on the Redshift data warehouse service. Now in another video, we'll see the demo for using the Amazon Redshift. Let's look into the Amazon Redshift demo. So these are the steps that we need to follow for creating the Amazon Redshift cluster. And in this demo, what we'll be doing is that we'll be creating an IAM role for the Redshift so that the Redshift can call the services, and specifically we'll be using the S3 service. So the role that we'll be creating, we'll be giving the permission to Redshift to have an access of an S3 in the read-only format. So in the step one, what we require, we'll check the prerequisites, and what you need to have is the AWS credentials. If you don't have that, you need to create your own credentials, and you can use your credit and the debit card. And then in the step two, we'll proceed with the IAM role for the Amazon Redshift. Once the role is created, we'll launch a sample Amazon Redshift cluster mentioned in the step 3, and then we'll assign a VPC security groups to our cluster. Now you can create it in the default VPC also, you can create a default security groups also, otherwise you can customize the security groups based on your requirement. Now to connect to the sample cluster, you need to run the queries, and you can connect to your cluster and run queries on the AWS Management Console query editor, which you will find it in the Redshift only. Or if you use the query editor, you don't have to download and set up a SQL client application separately. And in the step 6, what you can do is you can copy the data from the S3 and upload that in the Redshift, because the Redshift would have an access, a read-only access for the S3, as that will be created in the IAM role. So let's see how we can actually use the Redshift on the AWS. So I am already logged in into my account. I am in North Virginia region. I'll search for Redshift service, and here I find Amazon Redshift. So just click on it. Let's wait for the Redshift to come. Now this is a Redshift dashboard, and from here itself you have to run the cluster. So to launch a cluster, you just have to click on this launch cluster, and once the cluster is created, and if you wanted to run queries, you can open query editor, or you can basically create queries and access the data from the Redshift. So that's what it was mentioned in the steps also, that you don't require a separate SQL client application to get the queries run on the data warehouse. Now, before creating a cluster, we need to create the role. So what we'll do is we'll click on the services and we'll move to IAM role section. So IAM role I can find here under the security, identity and compliance. So just click on the identity access management and then click on create roles. So let's wait for IAM page to open. So here in the IAM dashboard, you just have to click on the roles. I already have the role created. So what I'll do is I'll delete this role and I'll create it separately. So just click on a create role, and under the AWS services, you have to select for the Redshift, because now the Redshift will be calling the other services, and that's why we are creating the role. Now, which other services that the Redshift will be having an access of? S3. Why? Because we'll be putting up the data on the S3, and that is something which needs to be uploaded on the Redshift. So we'll just search for the Redshift service, and we can find it here. So just click on it and then click on Redshift customizable in the use case. Now click on next permissions, and here in the permissions, give the access to this role, assign the permissions to this role in the form of an S3 read-only access. So you can search here for the S3 also. Let's wait for the policies to come in. Here it is. Let's type S3. And here we can find Amazon S3 read-only access. So just click on it and assign the permissions to this role. Tags, you can leave them blank. Click on next review. Put a name to your role. Let's put my Redshift role and click on a create role. Now you can see that your role has been created. Now the next step is that we'll move to Redshift service and we'll create one cluster. So click on the services. Click on Amazon Redshift. You can find that in the history section since we browsed it just now. And from here, we are going to create a sample cluster. Now, to launch a cluster, you just have to click on launch this cluster. Whatever the uncompressed data size you want in the form of a gigabyte, terabyte, or petabyte, you can select that. And let's say if you select in the form of GB, how much GB memory you want, you can define it here itself. This also gives you the information about the costing. On demand is basically pay as you use. So they are going to charge you $0.5 per hour for using the 2 node slices. So let's click on launch this cluster, and this will be a DC2.large kind of an instance that will be given to you. It would be in the form of a solid state drive, SSDs, which is one of the fastest way of storing the information. And the nodes 2 are mentioned by default. That means there will be 2 node slices that will be created in a cluster. You can increase them also. Let's say if I put 3 node slices, so it is going to give us 3 into 0.16 TB per node storage. Now here you have to define the master username password for your Redshift cluster, and you have to follow the password instructions. So I would put a password to this cluster, and if it accepts, that means it does not give you any kind of a warning. Otherwise it is going to tell you about you have to use the ASCII characters and all. And here you have to assign this cluster the role that we created recently. So in the available IAM roles, you just have to click on my Redshift role, and then you have to launch the cluster. If you wanted to change something with respect to the default settings, let's say if you wanted to change the VPC from default VPC to your custom VPC, and you wanted to change the default security groups to your own security groups, so you can switch to advanced settings and do that modification. Now let's launch the cluster, and here you can see the Redshift cluster is being created. Now, if you wanted to run queries on this Redshift cluster, so you don't require a separate SQL client, you just have to follow the simple steps to run a query editor. And the query editor, you will find it on the dashboard. So let's click on the cluster, and here you would see that the Redshift cluster would be created with the 3 nodes in the US East 1B availability zone. So we have created the Redshift cluster in the Ohio region. And now what we'll do is we'll see how we can create the tables inside the Redshift, and we'll see how we can use the copy command so that we can directly move the data uploaded on the S3 bucket to the Redshift database tables. And then we'll query the results of a table as well. So how we can do that? First of all, after creating the Redshift cluster, we have to install SQL Workbench /J. This is not a MySQL, which is managed by Oracle, and you can find this on the Google. You can download it from there. And then you have to connect this client with the Redshift database. How you can do? Click on File, click on Connect Window, and after connecting a window, you have to paste the URL, which is a JDBC driver. This driver link, you can find it onto the AWS console. So if you open up a Redshift cluster, there you would find the JDBC driver link. Let's wait for it. So this is our cluster created. Let's open it. And here you can find this JDBC URL. And also make sure that in the security groups of a Redshift, you have the port 5439 open for the traffic, incoming traffic. You also need to have the Amazon Redshift driver, and this is the link where you can download the driver and specify the path. Once you are done with that, you provide the username and the password that you created while creating the Redshift cluster. Click on OK. So this connects with the database, and now the database connection is almost completed. Now what we will be doing in the SQL Workbench, we'll be first creating the sales table, and then in the sales table, we'll be adding up the entries copied from the S3 bucket, and then move it to the Redshift database. And after that, we'll query the results in the sales table. Now, whatever the values you are creating in the table, the same values needs to be in the data file. And I have taken up this sample data file from this link, which is docs.aws.amazon.com, Redshift, sample database creation. And here you can find a download file, ticketdb.zip file. This folder has basically multiple data files, sample data files, which you can actually use it to practice uploading the data on the Redshift cluster. So I have extracted one of the files from this folder, and then I have uploaded that file in the S3 bucket. Now we'll move into the S3 bucket. Let's look for the file that has been uploaded on the S3 bucket. So this is the bucket sample, and sales_tab.txt is the file that I have uploaded. This has the entries, data entries that will be uploaded using a copy command onto the Redshift cluster. Now, after putting up the command for creating up the table, then we'll use a copy command. And copy command, we have to define the table name. The table name is sales, and we have to define the path from where the data would be copied over to the sales table in the Redshift. Now, path is the S3 bucket, and this is the Redshift bucket sample, and it has to look for the data inside the sales_tab.txt file. Also, we have to define the role ARN that was created previously. And once it is done, then the third step is to query the results inside the sales table to check whether our data has been uploaded correctly on the table or not. Now what we'll do is we'll execute all these three syntax. It gives us the error because we have to connect it again to the database. Let's wait for it. Execute it. It again gives us the error. Let's look into the name of the bucket. It's Redshift bucket sample. So we have 2 T's mentioned here. Right. Let's connect with the database again and now execute it. So table sales created, and we got the error. The specified bucket does not exist. Redshift bucket sample. Let's view the bucket name, Redshift bucket sample. Let's copy that, put it here, connect to the window, connect back to the database. Right, and now execute it. So table sales created, the data in the table has been copied from the S3 bucket to sales_tab.text to the Redshift, and then the query of the results. The results from the table has been queried. So today's session is on AWS Elastic Beanstalk. So what's in it for you today? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now, what happened earlier and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now, one developer creates a module that has to be shared with another developer, and if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about the scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now coming to the simplifies operations as an advantage. Now once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you're deploying any kind of an application or a solution on the on-prem servers. Now, there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now, what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. For if you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now generally there are 2 types of environment tier. One is the web and the other one is the worker node, and that's something which we'll be discussing later as well. Now let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons, that's it, nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now what happens in that case is when you launch an environment in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise, you can view those statistics in the CloudWatch logs as well. Now in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the auto-scaling, for example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC. You don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitor, provided capacity provisioning, load balancing, autoscaling, and then monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are two types of environments that you have to select. You can select. One is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you two different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the client should be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the client. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now in the web server environment, let's say if we select a web server environment, and it says that if the application receives client requests, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now obviously we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client facing environment. Now if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service and you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now here in the diagram you can see that there are two web server environments and they are created in the autoscaling group. That means there is some kind of scaling options that are defined as well, and these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now what happens in that case is if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances or n number of EC2 instances running in the availability zone. Now in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the autoscaling group. So that's something which we have discussed already. Now, this autoscaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now what does autoscaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the autoscaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the autoscaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the autoscaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk, and with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group, Autoscaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of security is also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now, understanding the worker environment, what happens is that the client, the web server environment is the client facing. The client sends a request for an access to the web server. And in this diagram, the web server further sends it to the SQS, which is a simple queue service. And the queue service sends it to the worker environment. And then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with the worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service, and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now what we have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a New Application. Put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed, that there are two types of environments. One is the web server and the other one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now, the usability of a worker environment can be anything. Now, we'll do a demo for creating a web server environment. So just click on select, and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability. XYZ ABC, and it says yes, it is available. Now once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description, it's a demo app that we are creating, and then you have to define a platform as well. Now these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now, either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on configure more options. So let's click on configure more options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy your applications over it. If you wanted to modify, just click on a modify button, and here you can modify your instances with respect to the storage as well. Now, apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now, if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated, and that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now, in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the Elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created, and we have that environment colored in green. We'll access the environment, and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI, and it's a sample application. Health status is OK. Now the other thing is that if you do not want to use the web console, the management console, to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface, and then you have the command references, CLI command references, that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is OK. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups or HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here, and after that you just have to upload and deploy your application, and then from that URL you can get the output. Now this URL you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL, and from there it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So it's in the, so we have this bundle logs in the zip file. Alright, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
In this topic, we will learn about Amazon Glacier. Amazon Glacier is an economical storage solution to store data that would remain forever, but rarely accessed. It is an ideal choice for data backup and archiving, provides data security of the highest level, and offers flexibility in both storing and retrieving data. AWS bills you for only the used data or storage, and current least price for storing data in Amazon Glacier is 0.007 cents per gigabyte per month. Maintaining historical data can be a grief, as it is added to the administrative liability of managing the scaling storage. Amazon Glacier eases this hardship by providing features such as capacity planning, hardware provisioning, detecting and repairing hardware failure, data replication, and hardware migrations. When you preserve data in Amazon Glacier, it is stored as archives. This enables a user to store a single file or a combination of several files. Archives are arranged in vaults, which can be accessed using the AWS IAM service. Amazon Glacier stores data in transit via SSL and uses the 256-bit advanced encryption system. AWS enables organizations to store data in a location that is convenient for their businesses, and organizations tend to utilize Amazon Glacier to support the following use cases: archiving off-site enterprise information, backing up media assets, storing research and scientific data, preserving digital data, and replacing magnetic tapes. The Amazon Glacier Archives offers an average annual resilience of 99.999999999%. The archiving service maintains resilience by continuously utilizing several facilities and devices within each facility to store the data. The task continues till the service returns success on the uploading archives.
Any individual object archived into Amazon Glacier, such as a document, video, or any other type of file, is referred to as an archive. Each archive has a unique ID assigned to it by AWS. The archives are stored in vaults. A vault is addressed by a unique name assigned to it by its creator. A given AWS account may create up to 1,000 vaults in Amazon Glacier. You can refer to an archive in Amazon Glacier via a URL that points to the Glacier service and consists of the following three components: the account ID of your AWS master account, the name of the vault, the ID of the individual archive. Data stored in Amazon Glacier by Amazon S3 cannot be retrieved using the Amazon Glacier API. This is the data that Amazon S3 manages on your behalf, and it does not show up as a vault or archive. Amazon S3 archived files can be restored using the S3 Management Console interface or using the Amazon S3 API. Files added directly to Amazon Glacier using the Amazon Glacier API can be retrieved using the Glacier API. Retrieval requests can be any one of the following: direct retrieval of a single archive object by archive ID, filter by archive creation date, ranged archive retrieval, retrieve only a specific range of bytes from a specific archive. You can poll for job completion using the Describe Job API function. Amazon Glacier completion notifications can also be sent using Amazon Simple Notification Service, or SNS. Once an Amazon Glacier job has finished executing, the user can request a download of their thawed data. In this demonstration, you'll learn how to configure Amazon S3 buckets for archiving in Amazon Glacier, which is a lost-cost storage service. First, you need to go to S3 under the Storage and Content Delivery section. Select your required bucket. For this demonstration, we'll select the Test 11 October bucket. Click the Life Cycle option. Click Add Rule. Select the Whole Bucket option. Click the Configuration Rule button. Select the Archive to the Glacier Storage class option. State the number of days after the completion of which you want the data in your S3 bucket to move to the Glacier. For this demonstration, we'll provide 30 days. As you can see in the example provided, the objects in S3 bucket will move to Glacier after the completion of 30 days. Acknowledge the message that you are aware that setting up this particular rule will likely increase your storage costs. Click Review. Provide a rule name. You can review your rule on this page. Click Create and activate rule.
Amazon CloudWatch is a monitoring service for AWS cloud resources and the applications you run on AWS. CloudWatch enables monitoring for EC2 and other Amazon Cloud services, so you can get alerts when things go wrong. You can use Amazon CloudWatch to collect and track metrics, so you can get system-wide visibility into resource utilization, application performance, and overall operational health. And you can use these insights to react and keep your applications running smoothly. CloudWatch offers two types of monitoring. There's basic monitoring, which is included free of charge and polls every 5 minutes and gives you 10 metrics, 5 GB of data ingestion, and 5 GB of data storage. Then there's detailed monitoring, and this costs more. There's a price per instance per month, but it polls every minute, so if you want more detailed monitoring, then you can pay for it. AWS CloudWatch allows you to record metrics for services such as EBS, EC2, Elastic Load Balancer, and Amazon S3. And using these metrics, you can add them to dashboards to give visual or text-based notifications of what's going on. And this is a diagram of a dashboard in Amazon CloudWatch. Metrics are at the hypervisor level, so you can get things like CPU, disk, network, but you cannot see memory usage. Metrics appear as you add more resources to your AWS account. You can create events based on your CloudWatch monitoring, for example triggering Lambda functions. So perhaps if your EBS volume fills up, you could trigger an event so that data is removed and archived from the volume, or a new volume is created. So there's many things you can do. You can install CloudWatch agents on EC2 instances, and this will send monitoring data about the instance to CloudWatch. So you can monitor things like HTTP response codes in Apache, or you can count exceptions in application logs. You can set alarms to warn based on resource usage. For example, if CPU utilization is too high, then it could send a notification. It can also auto-scale, so if your CPU is maxed out, you can get another instance launched to take care of some of the load. Or you can send CloudWatch monitoring alarms to EC2 actions to, say, recover an instance or reboot an instance if something happens. You can also use alarms to shut down instances. It isn't just used for starting them up. So if you have idle instances, you can get CloudWatch to shut them down for you. In this demonstration, we're going to take a look at AWS CloudWatch and how we can use it to shut down idle instances. So before I started this demonstration, I launched an Amazon Linux instance and let it run for 10 minutes, just so we'd have some data. So now I'm going to go to Management Tools and click on CloudWatch. And this brings us to the CloudWatch dashboard. So what we're going to do is we're going to create a new dashboard, and we'll click on Create Dashboard so that we can have a look at the monitoring statistics for our new instance. So let's just give it a name and we'll call it just Simplilearn, just for a change. Okay, so it says Create Dashboard. And now we get the option, do we want to put text-based or metric graphs widgets to our dashboard? And we're going to select metric graphs. So we'll click on Configure. And then we're presented with all the CloudWatch metrics that I have available in my AWS account. So obviously I've just launched an EC2 instance, so I'm going to click on EC2 metrics. And my new server is called Simplilearn CloudWatch Demo. So I want to add CPU utilization. So let's click on that. So let me create this widget. And then that now appears on our dashboard. So we can add more. So we click on Add Widget. We'll do another metric graph. We'll go another per instance metric. And let's choose Network In and Network Out. And we'll create the widget. Now, as you can see, there's not a lot happening here because I just launched this instance and I haven't really done anything on it. But this is how you would create a dashboard. And it's quite useful and very easy to see. So you can create a dashboard for your instance types. So what we're also going to do is set up an alarm. So let's go to Alarms. So now we want to create an alarm. So we click on Create Alarm, and we get to choose the metric we want to base the alarm on. Now, obviously we have an EC2 instance, so we're going to choose that option. And we're going to do it based on CPU utilization of our Simplilearn CloudWatch demo instance. So we'll click on that, and we'll click Next. So now we get to give our alarm a name. So just going to call it Simplilearn _ alarm. Just for the purposes of this demo, we can give it a description, and now we get to set the alarm threshold. So we're saying whenever CPU utilization is, and we're going to say less than or equal to 50% for one consecutive period, and remember a period is 5 minutes in basic monitoring, we want this alarm to fire. So why would you do this? Well, imagine if you had a really high powered server that you're using every night to do some highly intensive computations. So you might know that it runs for a couple of hours and it's charging you quite a lot of money per hour to run, but when the CPU utilization drops below, say 50% or 10%, you know the job is complete. So then you can get an alarm to fire and an action to happen. So you could set a notification, so we could get it to send an email when this alarm fires. We're not going to do that in this demonstration, but we can do an EC2 action. So whenever this state is in alarm, I want it to stop this instance. So this instance is going to be stopped whenever the CPU utilization is less than 50% for 5 minutes. And it's just telling us that there. So now if I click on Create Alarm, and here is our alarm. So it's just so it's telling us we're in alarm already because this instance has been up and running. It has monitoring data for the last 5 minutes, and it's saying the alarm has fired. So let me click on it and we'll see why. It says state changed to alarm, reason threshold crossed. One data point, 0.0034, was less than or equal to the threshold of 50%. And it says when it's in alarm, it's going to stop the instance. So if we go to the EC2 dashboard, and here we can see that the Simplilearn CloudWatch demo instance has been stopped, and it's in a status of alarm. So it's telling us that our alarm fired and it took it straight down. Now, obviously that's a pretty dramatic example. You wouldn't expect anything like that to happen in a real world, but it's a good way of seeing how alarms work.
Security is one of the key concerns for all those who would want to come onto the cloud. It could be an enterprise, it could be a startup, it could be a small business, and they all worry about that data. How secure is the data? So let's spend some time talking about security on AWS. Security at AWS is job zero. That is what AWS talks about. That is everybody's responsibility. And it starts right from the infrastructure. We spoke about regions. We spoke about availability zones. So availability zones are the physical data centers, and they are designed to be fault tolerant. They are designed to be highly available. So they are always in a group of 2 or more. So that way, if one goes down for any reason, we will still have the services running from the second data center. AWS has something called a shared security responsibility model, where they say that whatever happens to the underlying infrastructure, they are responsible for securing that infrastructure, such as the regions, the availability zones, the edge location. They are responsible for that underlying infrastructure. The customers are responsible for everything that they put on top of that infrastructure. So the data, the application, the access, the firewall rules. The customer is responsible for configuring access to anybody on that infrastructure. By default, AWS provides all the tools, and they do not provide any access to firewalls that we create, any user that we create, or any object that we upload to the cloud. By default, it will be private, so we have to explicitly make it public for any user. We have to give them permission to do something. Otherwise, they will not be able to do anything. Whenever we add any data, then it is addressed. We have to tell them who can access it. AWS gives you a whole set of services to secure your data, to secure your applications, to secure your resources, such as servers in the cloud. We will also talk a little bit about the compliance that you need for your application to be PCI DSS compliant, or if your application deals with the healthcare industry and must be HIPAA compliant. And you need all those documents that say that your infrastructure is HIPAA compliant. There's a place to go, and it's a shared service. So you go, and you request something, and you get it. Take a look at all that AWS has to offer when it comes to security. It all starts from the identity and access management. At the heart of it, you would have who is accessing your system, and then what they are allowed to do in that system. So we are talking about authentication, and we are talking about authorization. So AWS gives you so many options to create users. You can create rules, you can manage the credentials on your own, or you can have something called identity federation. So you don't have to create a login for everybody if you already have their credentials in your Active Directory. Or if you want to have them connect with Facebook ID, or Gmail ID, or LinkedIn ID, or Twitter ID, they should be able to do that. This is known as identity federation, and it allows you to do just that. They also have something called roles, where the credentials are managed by AWS and they are rotated internally, so you don't have to worry about managing credentials or storing them in the servers or passing them to the API request. They also have something called security tokens, which are nothing but temporary credentials, and you can allow somebody to access your application or system for a few minutes, maybe 60 minutes, maybe up to a few hours, and then these tokens would automatically expire. They also have something called multi-factor authentication. You can have all your users use this hardware or software device to authenticate themselves. You can have the MFA set up on their phones, and you'll be sure that anybody who is logging in should be in possession of that phone in order to log in. Similarly, for your application, they have something called AWS WAF. That is a web application firewall, and it's simply to protect your application. You can configure it to the best of your choices, and it will simply protect you from any unwanted traffic that you don't want to hit your application. In similar fashion, they have something called AWS Shield. That is the service to mitigate all DDoS attacks. It comes in two versions, a standard version and an advanced version, and the standard version is free of cost. So, it will block most known DDoS and other attacks, and you can configure it to protect your hardware or your resources from any known attacks. Let's say you know you have a lot of resources in the cloud, and you want to monitor them continuously against any security threat. There's a service called Amazon Inspector, where you simply install an agent, and this agent will keep running, will keep producing reports for you on a monthly basis. So the bill is per agent per month, and it is really very economical when you compare it with other services, which are either paid or open source and not managed. And there's something called AWS Certificate Manager. That is a service that simply manages your SSL and TLS certificate. So you can bring your own certificate and upload it, or you can buy that certificate from AWS. And in both ways, you can simply manage those certificates in one location. AWS gives you that capacity, so you don't have this hassle of managing those services. Now this is a very interesting AWS artifact that we spoke about. So, let's say you need a compliance certificate that says that the infrastructure that you're running on is PCI certified because you are running an application that takes credit card information or it does some credit card transactions. You could simply come here, and then you can request the artifact that you want. So you have something like FedRAMP Partner Package, you have ISO certification, and you can simply request that certification, and you are going to get that certification over here. So these are the suite of services that AWS has to offer for security. Apart from that, there are firewalls at your instance level, at your server level, firewalls at your subnet level. There are encryption services. You can ask AWS to do their own encryption, or you can run your own encryption algorithms. There are several kinds of credentials for accessing different services, and I like to think about it like this. There was once a time when people would not go on the cloud because of security. And now, people, organizations, banks, government agencies, they're moving towards cloud because their data, their network, is much more secure than what they could have on their own data set.
Hello everyone. In today's session, we are going to talk about AWS best practices. So this is the agenda for today. We will talk about billing best practices. We will have a look at best practices for EC2, which is the Amazon Elastic Computer Cloud. We will walk through best practices for IAM, which is Identity and Access Management. Then we will walk through the best practices for S3, which is Simple Storage Service. And then we will have a general look at the security best practices from the Amazon account perspective, as well as from the general Amazon Web Services perspective. Now let's start with billing best practices. So billing essentially is the core of every company. Every company wants to keep billing to the minimum and cost to the lower side. So one of the best things about Amazon is that it gives you a good way of controlling your costs. So from the billing specific side, from the billing console side, there are a lot of things you can do as a best practice and also reduce cost. So Amazon gives you something called billing budgets. Now this is interesting. So they give you an option to actually create a budget kind of thing wherein you specify you want X amount of dollars for the next budget. Now whenever you hit that budget, let's say it's $200, you get an email notification. Now these budgets can be service specific. They can be specific to some service like EC2. So if you want to have a billing alert when the EC2 instances of the account hit almost $200, you can create that. One of the other best practices from Amazon billing side is to give limited access to IAM account users to billing. So by default, Amazon does not allow billing access to IAM users. But you can specifically allow them if you have got some users who look at the billing perspective of your account. Now, if you have a bill which crosses $10 to $15 and it's not possible to pay using a single credit card or debit card, Amazon gives you an option to pay using multiple credit cards. So as a best practice, if your bill has crossed a big amount and you are not able to pay using a single credit card, if you are a good enterprise, it's always good to have 2 or 3 credit cards added to your account, so that even in the case when your one card can't fulfill the bill, you can have another account which automatically lets you pay the bill. So that way you don't risk your infrastructure. Your infrastructure is always safe. Now, one of the other best practices is to have regional taxation enabled in your account. For every country, there's a different taxation regime, and the tax methodology and tax rates are different. So instead of getting a notice from your income tax department, or to avoid being non-compliant to taxes, it's the best practice to have the billing number. So every country has the specific unique billing number, which you can put into the Amazon account, and then it automatically charges that or files taxes from Amazon's behalf on that number. So at the end of the year, when you are doing tax filing, you can easily show that you have paid X amount of money from Amazon. So you don't have to repay that, or if in your country the tax is collected at the end of the year in a consolidated way, you are more compliant. Now let's say that an enterprise which has got multiple accounts in Amazon Web Services. So let's say for Project A you have a different account. For Project B you have a different account. So you can consolidate the billing of those if you don't want to have a headache of having multiple account billing. You don't want to have to separate credit cards for every account. So what you can do is you can consolidate the billing of each and every account into a single account. That would essentially give you a single consolidated bill. So you can also consolidate your taxes there. In that case, you can have a single cooperate credit card, which can have a lot of limit. There are credit cards which give you no limit virtually, so you can use those kind of credit cards. Now, coming to EC2 best practices. One of the best practices from EC2 side is AMI hardening. So Amazon gives you Amazon machine images, which are exact snapshots of servers. Now, these machine images are used to spin up new machines. So these are like seat files for new servers. Now you just can't have a stock OS image and use that as a base for your entire infrastructure. You need to have a hardened AMI. Now when I say a hardened AMI,
What I exactly mean is to have an AMI which has got all the security practices implemented into it. Now, as far as the Linux OS is concerned, an AMI which is hardened would have the SSH port changed, SSH password-based logins disabled, security enhanced Linux set to enabled if it's CentOS. If it's Ubuntu, maybe you can enable the firewall and only allow port 22. The next thing is VPC port lockdown. So apart from the instant level firewall port lockdown, you should also lock down ports specifically to IP addresses. If not possible to IP addresses, then at least you should make sure that in your VPC, all the security groups have got only the specific ports which are required by that server or application open to specific IP addresses. If you have to open something up to the entire world, make sure that you have got adequate checks PPP inside your application, so you don't have a malware user trying to do DDoS service attack. Although Amazon has got a required hardware in place to check the DDoS attack. But yes, there can be still valid amounts of attacks that go into your application if you don't plan the application correctly. One of the other things you should take care when you are running instances on EC2 is that you have private subnets for everything other than the load balancer or the web application tier. Now, this is important because you don't want anyone to be directly able to access your rediff, CCC, your database, or your internal backend systems. Because most of these systems, for example, let's say rediff, don't have authentication built into them. So if you have the port exposed, anyone can go in and pull all the keys. Now, from an application division perspective, you should make sure that the application is divided into small microservices. So it used to be known as Service-Oriented Architecture, SOA. Now the term has changed and people call it microservice architecture. So the basic idea behind microservice architecture is that big monolithic applications are divided into small chunks of application, which are exposed over as a service to the internet to the end users. Now, this helps you to scale them individually, and one of the best advantages you get out of such a microservice architecture is that even if one of the applications is down, the others can actually still function without affecting this one. Now, this is very important because in today's e-commerce world, a single minute of downtime can cost millions of dollars of loss. So when you have microservice architecture, you can scale vertically or horizontally each microservice without worrying about downtime. You should take care while designing microservice architecture so that the microservice architecture is independent at every level. One of the mistakes which happens is that you have a microservice architecture at the web server or the application server layer, but then you have a common database. So how is it going to affect the microservice architecture in any way? I understand that it's very difficult to have independent database microservice architecture. But yes, there are companies who do sync ups of databases just to make sure they have totally independent microservices. Now, in such a scenario, even if the backend database of a particular microservice is down, the other functionality can work. Take an example. Let's say there is login functionality which talks to the backend database and gets to data from there. Let's say there is another functionality which lets you buy stuff. Both of them should have independent databases, and there should be a sync up every minute. Or there should be push-based mechanism where there's sync up only when they're in one of the DBs. Now, if you have both these microservices having independent databases, your logins will still work even if your payments are down, or your payments will still work if your login functionality is experiencing some degraded performance. You have stock images on Amazon, that Amazon provides you environment-based key or keys which are there for every instance. So every machine you launch on Amazon has got a key. You can't just use the username and password to log in. Now, the advantage of key is that you don't have to provide clear text passwords, but you have to make sure that for every environment, so let's say you got a production environment QA test environment, make sure every environment has got a different key. The reason is if you have a single key across all the environments, and let's say you give a developer access to one of the environments, he can automatically gain access to each and every environment. So that's not a good thing, right? You don't want developers to access production environments. Now, if you have 100 EC2 instances and you have users to manage, let's say you should make 10 users are there on every machine, which are 10 members of your dev team. So it's very difficult to create manually. Let's say you also want to do password expiry and a lot of intelligent stuff on these users. You can actually use something called LDAP. This LDAP is basically centralized authentication system, which lets you authenticate users across machines. So you can change the password for a user on one LDAP server, and it's reflected across all the machines. So let's have a look at IAM best practices. So IAM is Identity and Access Management Service of Amazon, and it allows you to have fine-grained controls over the access. Now, as a best practice for your teams, you should have various roles defined. Each of those roles should be specific to what each member is doing. Let's say you have a read-only dev role assigned to your developers. You can also have DevOps engineer role, which you assign to your DevOps engineering team members. You can assign roles to the finance team, which has billing access. Now this gives you the flexibility to easily assign policies or attach policies to various users without having to manually do them. This is useful in a scenario wherein you have a custom role, wherein you have a reporting engineer which needs access to billing to create reports of CPU utilization. Now, you can give them a specific access by assigning specific policies. You can have new joinees or freshers who have joined your team have a read-only access, so that way they don't mess up the account, and they also have got full access to the account. So they can go and they can see what the environment's like. They can read, but they can't change anything. So that way, you safeguard your account by any accidental mistakes by those freshers or new joinees. You can have service-specific access. So let's say you have an EC2 instance, which requires access to S3 buckets, so you actually create a role in IAM and assign that specific role to EC2 instances. You can also have special service-specific roles. Now, these service-specific roles have got access to specific service of Amazon. And you can use this, let's say, in case you want to give some developer access to some dev environment of Elastic Beanstalk. So you can create a role which has the access and the policies attached for Elastic Beanstalk read-only access to that specific region. So that way, you can control a specific service and specific action. Now, let's have a look at S3 best practices. S3 is Simple Storage Service, and it's one of Amazon's most important services. It's one of the most used services as well. Now, in case of S3, you should make sure that you have context-specific names. Now, these names can be the type of function that S3 bucket is performing. So let's say images, and then -dev, and then -region, and then -top-level domain. So you have a unique name. So Amazon has a policy wherein they have a single namespace for all the S3 buckets of the world, which in other words means that if you have a name which is already chosen by someone in the world of an S3 bucket, you will not get that name. So obviously you will have to have long names since all shorter names would have been taken. In order to make that long name meaningful, make sure you break that into a specific context so that when you look at that bucket, you already know this is what this bucket is doing. You should make sure you have bucket policies for buckets, which are accessible by other users. These policies can be generated in the policy generator, or you can create fine-grained self-made policies. For buckets which are very much live and large and have got tons of data, you should archive them to Glacier, because Glacier gives you very cheap storage, although there is a retrieval time associated with that. But yes, you should make sure to archive the buckets. So if you've got some critical objects in a bucket, you should make sure that you also save a version of your object, because you can go back to a previous version of that same object. Now in this case, you don't actually lose any version of that file. You always have the important version of that object. From security best practices, never share your root account details with anyone. Because if someone has got root account details of your account, he can actually do anything. Make sure people who leave your organization, you remove their access and you don't keep them as stale accounts. You should also enable two-factor authentication, either with Google Authenticator or some hardware device access token, which flashes a 6 or 4-digit random number, so that it can be added as an added layer of security. You also should enable IAM login. Don't give root access to even trusted users. So in IAM, you have a name and an ID, which shows you that this guy did this at this time.
I'm Samuel, and I'm here to walk you through some of the AWS interview questions which we find are important. And our hope is that you would use this material in your interview preparation and be able to crack that cloud interview and step into your dream cloud job. By the way, I'm a cloud technical architect, trainer, and an interview panelist for cloud, network, and DevOps. So as you progress in watching, you're going to see that these questions are practical scenario-based questions that tests the depth of the knowledge of a person in a particular AWS product or in a particular AWS architecture. So why wait? Let's move on. All right, so in an interview, you would find yourself with a question that might ask you, define and explain the 3 basic types of cloud services and the AWS products that are built based on them. See, here, it's a very straightforward question. Just explain 3 basic types of cloud service. And when we talk about basic type of cloud service, it's compute, obviously, that's a very basic service. Storage, obviously, because you need to store your data somewhere, and networking that actually connects a couple of other services to your application. These basic will not include monitoring. These basic will not include analytics because they are considered as optional. They are considered as advanced services. You could choose a non-cloud service or a product for monitoring and for analytics. So they're not considered as basic. So when we talk about basics, they are compute, storage, and networking. And the second part of the question says, explain some of the AWS products that are built based on them. Of course, compute EC2 is a major one. That's the major share of the compute resource. And then we have platform as a service, which is Elastic Beanstalk. And then function as a service, which is Lambda. Autoscaling and Lightsail are also part of compute services. So the compute domain, it really helps us to run any application, and the compute service helps us in managing the scaling and deployment of an application. Again, Lambda is a compute service, so the compute service also helps in running event initiated stateless applications. The next one was storage. A lot of emphasis is on storage these days, because if there's one thing that grows in a network on a daily basis, that's storage. Every new day we have new data to store, process, manage. So storage is again a basic and an important cloud service. And the products that are built based on the storage services are S3, object storage, Glacier for archiving, EBS, Elastic Block Storage as a drive attachment for the EC2 instances, and EFS, file share for the EC2 instances. So the storage domain helps in the following aspects. It holds all the information that the application uses, so it's the application data. And we can also archive old data using storage, which would be Glacier, and any object files and any requirement for block storage can be met through Elastic Block Store and S3, which is again an object storage. Talking about networks, it's just not important to answer the question with the name of the services and the name of the product. It'll also be good if you could go in depth and explain how they can be used, right? So that actually proves you to be a person knowledgeable enough in that particular service or product. So talking about networking domain, VPC, networking, can't imagine networking without VPC in a cloud environment, especially in AWS cloud environment. And then we have Route 53 for domain resolution or for DNS. And then we have CloudFront, which is an edge caching service that helps customers to read their application with low latency. So networking domain helps with some of the following use cases. It controls and manages the connectivity of the AWS services within our account. And we can also pick an IP address range. If you're a network engineer, or if you are somebody who works in networks or are planning to work in network, you will soon realize the importance of choosing your own IP address for easy remembering. So having an option to have your own IP address in the cloud, own range of IP address in the cloud, it really helps, really helps in cloud networking. The other question that get asked would be the difference between the availability zone and the region. Actually, the question generally gets asked so to test how well you can actually differentiate and also correlate the availability zone and the region relationship. Right? So a region is a separate geographic area like the US West 1, which represents North California, or the AP South, which represents Mumbai. So regions are a separate geographic area. On the contrary, availability zone resides inside the region. You shouldn't stop there, you should go further and explain about availability zones. And availability zones are isolated from each other, and some of the services will replicate themselves within the availability zone. So availability zone does replication within them, but regions, they don't generally do replication between them. The other question you could be asked is, what is autoscaling? What do we achieve by autoscaling? So in short, autoscaling, it helps us to automatically provision and launch new instances whenever there is an demand. It not only helps us meeting the increasing demand, it also helps in reducing the resource usage when there is low demand. So autoscaling also allows us to decrease the resources or resource capacity as per the need of that particular hour. Now, this helps business in not worrying about putting more effort in managing or continuously monitoring the server to see if they have the needed resource or not, because autoscaling is going to handle it for us. So business does not need to worry about it. And autoscaling is one big reason why people would want to go and pick a cloud service, especially an AWS service. The ability to increase and shrink based on the need of that hour. That's how powerful is autoscaling. The other question you could get asked is, what's geo-targeting in CloudFront? Now we know that CloudFront is caching, and it caches content globally in the Amazon caching service global wide. The whole point is to provide users worldwide access to the data from a very nearest server possible. That's the whole point in using or going for CloudFront. Then what do you mean by geo-targeting? Geo-targeting is showing customer and specific content. Based on language, we can customize the content. Based on what's popular in that place, we can actually customize the content. The URL is the same, but we could actually change the content a little bit. Not the whole content, otherwise it would be dynamic, but we can change the content a little bit, a specific file or a picture or a particular link in a website, and show customized content to users who will be in different parts of the globe. So how does it happen? CloudFront will detect the country where the viewers are located, and it will forward the country code to the origin server. And once the origin server gets the specialized or a specific country code, it will change the content and it will send to the caching server, and it gets cached there forever. And the user gets to view a content which is personalized for them for the country they are in. The other question you could get asked is the steps involved in using CloudFormation or creating a CloudFormation or backing up an environment with a CloudFormation template. We all know that if there is a template, we can simply run it and it provisions the environment, but there is a lot more going into it. So the first step in moving towards infrastructure as a code is to create the CloudFormation template, which as of now supports JSON and YAML file format. So first create the CloudFormation template and then save the code in an S3 bucket. S3 bucket serves as the repository for our code, and then from the CloudFormation call the file in the S3 bucket and create a stack. And now CloudFormation uses the file, reads the file, understands services that are being called, understands the order, understands how they are connected with each other, CloudFormation is actually an intelligent service. It understands the relation. Based on the code, it would understand the relationship between the different services, and it would set an order for itself and then would provision the services one after the other. Let's say a service has a dependency, and the dependent service, the other service which this service, let's say service A and B, service B is dependent on service A, let's say. CloudFormation is an intelligent service. It would provision the resource A first and then would provision resource B. What happens if we inverse the order? If we inverse the order, resource B first gets provision, and because it does not have dependency, chances that the CloudFormation's default behavior is that if something is not provisioned properly, if something is not healthy, it would roll back. Chances that the environment provisioning will roll back. So to avoid that, CloudFormation first provisions all the services that has or that's dependent on, that's depended by another service. So it provisions those services first and then provisions the services that has dependencies. And if you're being hired for a DevOps, or if the interviewer wanted to test your skill on systems side, this definitely would be a question in his list. How do you upgrade or downgrade a system with near zero downtime? Now everybody's moving towards zero downtime or near zero downtime. All of them want their application to be highly available. So the question would be, how do you actually upgrade or downgrade a system with near zero downtime? Now we all know that I can upgrade an EC2 instance to a better EC2 instance by changing the instance type, stopping and starting. But stopping and starting is going to cause a downtime, right? So you should be answering, or you should be thinking in those terms, because that's a wrong answer. Specifically, the interviewer wants to know, how do you upgrade a system with zero downtime? So upgrading system with zero downtime, it includes launching another system parallelly with the bigger EC2 instance type or with the bigger capacity, and install all that's needed. If you're going to use an AMI of the old machine, well and good. You don't have to go through installing all the updates and installing all the application. From the AMI, once you've launched it in a bigger instance, locally test the application to see if it is working. Don't put it on production yet. Test the application to see if it is working. And if the application works, we can actually swap. If your server is behind Route 53, let's say, all that you could do is go to Route 53, update the information with the new IP address of the new server, and that's going to send traffic to the new server now. So the cutover is handled. Or if you're using static IP, you can actually remove the static IP from the old machine and assign it to the new machine. That's one way of doing it. Or if you are using elastic NIC card, you can actually remove the NIC card from the old machine and attach the NIC card to the new machine. So that way we would get near zero downtime. If you're hired for an architect level, you should be worrying about cost as well, along with the technology. And this question would test how well you manage cost. So what are the tools and techniques we can use in AWS to identify and know that we are paying the correct amount for the resources that we are using? Or how do you get a visibility of your AWS resources running? One way is to check the billing. There's a place where you can check the top services that were utilized. It could be free and it could be paid service as well. Top services that can be utilized. It's actually in the dashboard of the cost management console. So that table here shows the top 5 most used services. So looking at it, you can get it. All right, so I'm using a lot of storage. I'm using a lot of EC2. Why is storage high? You can go ahead and try to justify that, and you will find if you are storing things that shouldn't be storing, and then clean it up. Why is compute capacity so high? Why is data transfer so high? So if you start thinking in those levels, you'll be able to dig in and clean up unnecessary and be able to save your bill. And there are cost explorer services available which will help you to view your usage pattern or view your spending for the past 13 months or so, and it will also forecast for the next 3 months. Now, how much will you be using if your pattern is like this? So that will actually help and will give you a visibility on how much you have spent, how much you will be spending if the trend continues. Budgets are another excellent way to control cost. You can actually set a budget. Alright, this is how much I am willing to spend for this application, for this team, or for this month, for this particular resource. So you can actually put a budget mark, and anytime it exceeds, anytime it's nearing, you would get an alarm saying that, well, we're about to reach the allocated budget amount, stuff like that. That way you can go back and know, and you know that how much the bill is going to be for that month, or you can take steps to control bill amount for that particular month. So AWS budget is another very good tool that you could use. Cost allocation tags helps in identifying which team or which resource has spent more in that particular month. Instead of looking at the bill as one list with no specifications into it and looking at it as an expenditure list, you can actually break it down and tag the expenditure to the teams with cost allocation tags. The dev team has spent so much. The production team has spent so much. The training team has spent more than the dev and the production team. Why is that? Now, you'll be able to think in those levels only if you have cost allocation tags. Now, cost allocation tags are nothing but the tags that you would put when you create a resource. So for production services, you would put as a production tag, you would create a production tag and you would associate that resources to it. And at a later point, when you actually pull up your bill, that's going to show a detailed list of this is the owner, this is the group, and this is how much they have used in the last month. And you can move forward with your investigation and encourage or stop users from using more services with the cost allocation tags. The other famous question is, are there any other tools or is there any other way of accessing AWS resource other than the console? Console is GUI, right? So in other words, other than GUI, how would you use the AWS resource and how familiar are you with those tools and technologies? The other tools that are available that we can leverage and access the AWS resource are, of course, PuTTY. You can configure PuTTY to access the AWS resources, like log into an EC2 instance. An EC2 instance does not always have to be logged in through the console. You could use PuTTY to log into an EC2 instance, and like the jump box, like the proxy machine, and like the gateway machine, and from there you can actually access the rest of the resources. So this is an alternative to the console. And of course, we have the AWS CLI in any of the Linux machines or Windows machines. We can install, so that's point 2, 3, and 4. We can install AWS CLI for Linux, Windows, also for Mac. So we can install them, and from there, from your local machine, we can access, run AWS commands and access, provision, monitor the AWS resources. The other ones are, we can access the AWS resource programmatically using AWS SDK and Eclipse. So these are a bunch of options we have to use the AWS resource other than the console. If you're interviewed in a company or by a company that focuses more on security and want to use AWS native services for their security, then you would come across this question. What services can be used to create a centralized logging solution? The basic services we could use are CloudWatch logs, store them in S3, and then use Elasticsearch to visualize them, and use Kinesis to move the data from S3 to Elasticsearch. Right? So log management, it actually helps organizations to track the relationship between operational and security changes and the events that got triggered based on those logs. Instead of logging into an instance or instead of logging into the environment and checking the resources physically, I can come to a fair conclusion by just looking at the logs. Every time there's a change, the system will scream and it gets tracked in the CloudWatch, and then CloudWatch pushes it to S3. Kinesis pushes the data from S3 to Elasticsearch, and I can do a time-based filter, and I would get a fair understanding of what was going on in the environment for the past 1 hour or whatever the time window that I wanted to look at. So it helps in getting a good understanding of the infrastructure as a whole. All the logs are getting saved in one place, so all the infrastructure logs are getting saved in one place, so it's easy for me to look at it in an infrastructure perspective. So we know the services that can be used, and here are some of the services and how they actually connect to each other. It could be logs that belongs to one account, it could be logs that belongs to multiple accounts. doesn't matter. Those three services are going to work fairly good, and they're going to inject, or they're going to like suck logs from the other accounts, put it in one place and help us to monitor. So as you see, you have CloudWatch here that actually tracks the metrics. You can also use CloudTrail if you want to log API calls as well, push them in an S3 bucket. So there are different types of log. Flow logs are getting captured in an instance. Application logs are getting captured from the same VPC, from a different VPC, from the same account, from a different account. And all of them are analyzed using Elasticsearch using the Kibana client. So step 1 is to deploy the ECS cluster. Step 2 is to restrict access to the ECS cluster because it's valid data. You don't want anybody to put their hands and access their data. So restrict access to the ECS dashboard. And we could use Lambda also to push the data from CloudWatch to the Elasticsearch domain. And then Kibana is actually the graphical tool that helps us to visualize the logs instead of looking at log as just statements or in a bunch of characters, a bunch of files. Kibana helps us to analyze the logs in a graphical or a chart or a bar diagram format. Again, in an interview, the interviewer is more concerned about testing your knowledge on AWS security products, especially on the logging, monitoring, event management, or incident management. Then you could have a question like this: what are the native AWS security logging capabilities? Now, most of the services have their own logging in them, like S3. S3 has its own login, and CloudFront has its own logging. DS has its own logging. VPC has its own logging. In addition, there are account level logins like CloudTrail and AWS Config Services. So there are a variety of logging options available in the AWS, like CloudTrail, Config, CloudFront, Redshift logging, RDS logging, VPC flow logs, S3 object logging, S3 access logging, stuff like that. So we're going to look at two servers in specific. CloudTrail. Now this CloudTrail, the very first product in that picture we just saw, the CloudTrail provides an very high level history of the API calls for all the accounts. And with that, we can actually perform a very good security analysis of our account. And these logs are actually delivered to, you can configure it, they can be delivered to S3 for long time archivals. And based on a particular event, it can also send an email notification to us saying, hey, just got this error, thought I'll let you know, stuff like that. The other one is config service. Now, config service helps us to understand the configuration changes that happened in our environment, and we can also set up notifications based on the configuration changes. So it records the cumulative changes that are made in a short period of time. So if you want to go through the lifetime of a particular resource, what are the things that happened? What are the things it went through? They can be looked at using AWS config. All right. The other question you could get asked is if your role includes taking care of cloud security as well. Then the other question you could get asked is the native services that Amazon provides to mitigate DDoS, which is denial of service. Now, not all companies would go with Amazon native services, but there are some companies which want to stick with Amazon native services just to save them from the headache of managing the other softwares or bringing in another tool, a third-party tool, into managing DDoS. They simply want to stick with Amazon proprietary Amazon native services, and a lot of companies are using Amazon service to prevent DDoS, denial of service. Now, denial of service is, if you already know what denial of service is, well and good. If you do not know, then let's know it now. Denial of service is a user trying to or maliciously making attempt to access a website or an application. The user would actually create multiple sessions and he would occupy all the sessions, and he would not let legitimate users access the service. So he's in turn denying the service for the user. A quick picture review of what denial of service is. Now look at it. These users, instead of making one connection, they are making multiple connections, and there are cheap software programs available that would actually trigger connections from different computers in the internet with different MAC addresses, so everything kind of looks legitimate for the server, and it would accept those connections and it would keep the sessions open. The actual users won't be able to use them, so that's denying the service for the actual users, denial of service. All right, and distributed denial of service is generating attacks from multiple places, from a distributed environment. So that's distributed denial of service. So the tools, the native tools that helps us to prevent the denial of service attacks in AWS is Cloud Shield and Web Access Firewall, AWS WAF. Now they are the major ones. They are designed to mitigate a denial of service. If your website is often bothered by denial of service, then we should be using AWS Shield or AWS WAF. And there are a couple of other tools that also does. When I say that also does, denial of service is not their primary job, but you could use them for denial of service. Route 53's purpose is to provide DNS. CloudFront is to provide caching. Elastic Load Balancer, ELB's work is to provide load balancing. VPC is to create and secure a virtual private environment. But they also support mitigating denial of service, but not to the extent you would get in AWS Shield and AWS WAF. So AWS Shield and WAF are the primary ones, but the rest can also be used to mitigate distributed denial of service. The other tricky question is this actually will test your familiarity with the region and the services available in the region. So when you're trying to provision a service in a particular region, you're not seeing the service in that region. How do we go about fixing it, or how do we go about using the service in the cloud? It's a tricky question. And if you have not gone through such situation, you can totally blow it away. You really need to have a good understanding on regions, the services available in those regions, and what if a particular service is not available, how to go about doing it. The answer is not all services are available in all regions. Anytime Amazon announces a new service, they don't immediately publish them on all regions. They start small, and as in when the traffic increases, as in when it becomes more likable to the customers, they actually move the service to different regions. So as you see in this picture, within America, North Virginia has more services compared to Ohio or compared to North California. So within North America itself, North Virginia is the preferred one. So similarly, there are preferred regions within Europe, Middle East, and Africa, and preferred regions within Asia Pacific. So anytime we don't see a service in a particular region, chances that the service is not available in that region yet, we got to check the documentation and find the nearest region that offers that service and start using the service from that region. Now you might think, well, if I'm looking for a service in Asia, let's say in Mumbai, and if it is not available, why not simply switch to North Virginia and start using it? You could, but that's going to add more latency to your application. So that's why we need to check for application, which is check for region, which is very near to the place where you want to serve your customers, and find nearest region instead of always going back to North Virginia and deploying your application in North Virginia. Again, there's a link in aws.com that you can go and look for services available in different region, and that's exactly what you're seeing here. And if your service is not available in a particular region, switch to the other region that provides your service, the nearest other region that provides that service, and start using service from there. With the coming up of cloud, a lot of companies have turned down their monitoring team. Instead, they want to go with the monitorings that cloud provides. Nobody wants to, or at least many people don't want to go through the hassle of, at least new startups and new companies that are thinking of having a monitoring environment. Now, they don't want to go with traditional NOC monitoring. Instead, they would like to leverage AWS monitorings available, because it monitors a lot of stuff, not just the availability, but it monitors a lot of stuff like failures, errors. It also triggers emails, stuff like that. So how do you actually set up a monitor to how do you set up a monitor to monitor the website metrics in real time in AWS? The simple way, anytime you have a question about monitoring, CloudWatch should strike your mind, because CloudWatch is meant for monitoring, is meant for collecting metrics, is meant for providing graphical representation of what's going on in a particular network at a particular point of time. So CloudWatch helps us to monitor applications, and using CloudWatch we can monitor the state changes, not only the state changes, the auto-scaling life cycle events. Anytime there are more services added, there is a reduction in the number of servers because of less usage, and very informative messages can be received through CloudWatch. CloudWatch can now support scheduled events. If you want to schedule anything, CloudWatch has an event that would schedule an action, right? Schedule a trigger, time-based, not incident-based. Anything happening and then you get an action happening that's incident-based. On the other hand, you can simply schedule few things on time-based. So that's possible with CloudWatch. So this CloudWatch integrates very well with a lot of other services like notifications for notifying the user or for notifying the administrator about it. And it can integrate well with Lambda. So to trigger an action, anytime you're designing an auto-healing environment, this CloudWatch can actually monitor and send an email if we are integrating it with SNS, Simple Notification Service. Or this CloudWatch can monitor and based on what's happening, it can trigger an event in Lambda, and that would in turn run a function till the environment comes back to normal. So CloudWatch integrates well with a lot of other AWS services. Alright, so CloudWatch has 3 statuses: green when everything is going good, yellow when the service is degraded, and red when the service is not available. Green is good, so we don't have to do anything about it. But anytime there's an yellow, the picture that we're looking at, it's actually calling a Lambda function to debug the application and to fix it. And anytime there's a red alert, it immediately notifies the owner of the application about, well, the service is down, and here is the report that I have. Here is the metrics that I've collected about the service, stuff like that. If the job role requires you to manage the servers as well, there are certain job roles which are on the system side. There are certain job roles which is development plus system side. Now you're responsible for the application and the server as well. So if that's the case, you might be tested with some basic questions like the different types of virtualization in AWS and what are the difference between them. Alright, the 3 major types of virtualization are HVM, which is hardware virtual machine. The other one is PV, para virtualization. And the third one is PV on HVM, para virtualization on hardware virtual module. Alright, the difference between them, or actually describing them, is actually the difference between them. HVM, it's actually a fully virtualized hardware. The whole hardware is virtualized and all virtual machines act separate from each other. And these VMs are booted by executing master boot record in the root block. And when we talk about para virtualization, Paragrub is actually the special boot loader which boots the PV AMIs. And when we talk about PV on HVM, it's actually the marriage between HVM and PV. And this para virtualization on HVM, in other words, PV on HVM, it actually helps operating system take advantage in storage and the network input output available through the host. Another good question is, name some of the services that are not region specific. Now, you've been taught that all services are within a region and some services are within an availability zone. For example, EC2 is within an availability zone, EBS is within an availability zone, S3 is region specific, DynamoDB is region specific, stuff like that. VPC is both availability and region specific, meaning subnets are availability zone specific and VPC is region specific, stuff like that. So you might have thought, you might have learned in that combination. But there could be some tricky questions that tests you how well you have understood the region, non-region, and availability, non-availability services. I should say there are services that are not region specific. That would be IAM. So we can't have IAM for every availability zone and for every region, which means users will have to use one username and password for one region, and anytime they switch to another region they will have to use another username and password. That's more work, and that's not a good design as well. Authentication has to be global. So IAM is a global service, and which means it's not region specific. On the other hand, Route 53 is again a regional specific, so we can't have Route 53 for every region. Route 53 is not a region-specific service. It's a global service. And it's one application. Users access from everywhere or from every part of the world. So we can't have one URL or one DNS name for each region if your application is a global application. And then Web Application Firewall works well with CloudFront. Then CloudFront is a region-based service. So the Web Application Firewall, it's not a region-specific service. It's a global service. And CloudFront is again a global service. Though you can cache content on a continent and country basis, it's still considered a global service, right? It's not bound to any region. So when you activate CloudFront, you're activating it away from region or availability zone. So when you're activating a Web Application Firewall, because it's not a region-specific service, you're activating it away from availability zone and regions. So a quick recap: IAM users, groups, roles, and accounts, they are global services. They can be used globally. Route 53 services are offered at edge locations and they are global as well. Web Application Firewall, a service that protects our web application from common web exploits. They are global service as well. CloudFront is Global Content Delivery Network, CDN, and they are offered at edge locations, which are a global service. In other words, non-region specific service or beyond region service. All right, this is another good question as well. In the project that you are being interviewed, if they really want to secure their environment using NAT, or if they are already securing their environment using NAT by any of these two methods like NAT gateway or NAT instances, you can expect this question. What are the difference between a NAT gateway and NAT instances? Now, they both serve the same thing, right? So they're not two different services trying to achieve two different things. They both serve the same thing, but still they do have differences in them, right? On a high level, they both achieve providing NATing for the service behind it, but the difference comes when we talk about the availability of it. NAT gateway is a managed service by Amazon, whereas NAT instance is managed by us. Now I'm talking about the third point, maintenance here. NAT gateway is managed by Amazon, NAT instance is managed by us, and availability of NAT gateway is very high and availability of NAT instance is less compared to the NAT gateway because it's managed by us. It's on an EC2 instance which could actually fail, and if it fails we'll have to relaunch it. But if it is NAT gateway, if something happens to that service, Amazon would take care of reprovisioning it. And talking about bandwidth, it can burst up to 75 gigabits. Traffic through the NAT gateway can burst up to 75 gigabits. But for NAT instance, it actually depends on the server that we launch. And if we are launching a T2 micro, it barely gets any bandwidth. So there's a difference there. And the performance, because it's highly available because of the bigger pipe, 75 gigabits, the performance of the NAT gateway is very high, but the performance of the NAT instance is going to be average. Again, it depends on the size of the NAT instance that we pick. And billing. A billing for NAT gateway is the number of gateways that we provision and the duration for which we use the NAT gateway. But billing for NAT instance is number of instance and the type of instance that we use. Of course, number of instance, duration, and the type of instance that we use. Security in NAT gateway cannot be assigned, meaning it already comes with full packed security. But in NAT instance, security is a bit customizable. I can go and change the security because it's a server managed by me or managed by us. I can always change the security. Well, allow this, don't allow this, stuff like that. Size and load of the NAT gateway is uniform, but the size and the load of the NAT instance changes as per a NAT gateway is a fixed product, but NAT instance can be small instance, can be a big instance, so the size and the load through it varies. Right. The other question you could get asked is, what are the difference between stopping and terminating an EC2 instance? Now you will be able to answer only if you have worked on environments where you have your instance stopped and where you have your instance terminated. If you have only used lab and are attending the interview, chances are that you're always lost when answering this question. It might look like both are the same. Well, stopping and terminating, both are the same. But there is a difference in it. So when you stop an instance, it actually performs a normal shutdown on the instance and it simply moves the instance to the stopped state. But when you actually terminate the instance is moved to the stop state. The EBS volumes that are attached to it are deleted and removed, and we'll never be able to recover them again. So that's a big difference between stopping and terminating an instance. If you're thinking of using the instance again along with the data in it, you should only be thinking of stopping the instance, but you should be terminating the instance only if you want to get rid of that instance forever. If you are being interviewed for an architect level position or a junior architect level position or even an cloud consultant level position or even in an engineering position, this is a very common question that get asked. What are the different types of EC2 instances based on their cost or based on how we pay them, right? They're all compute capacity. For example, the different types are on-demand instances, spot instances, and reserved instances. It kind of looks the same. They all provide the compute capacity. They all provide the same type of hardwares for us. But if you're looking at cost saving or optimizing cost in our environment, we got to be very careful about which one are we picking. Now we might think that, well, I'll go with on-demand instance because I pay on a per hour basis, which is cheap. I can use them anytime I want, and anytime I don't want, I can simply get rid of it by terminating it. You're right, but if the requirement is to use the service for 1 year, the requirement is to use the service for 3 years, then you'll be wasting a lot of money buying on-demand instances. You'll be wasting a lot of money paying on an hourly basis. Instead, we should be going for reserved instance where we can reserve the capacity for the complete 1 year or complete 3 years and save huge amount in buying reserved instances. Alright, so on-demand is cheap to start with if you're only planning to use it for a short while, but if you're planning to run it for a long while, then we should be going for reserved instance. That is what is cost efficient. So spot instance is cheaper than on-demand instance. And there are different use cases for spot instance as well. So let's look at one after the other. The on-demand instance. The on-demand instance is purchased at a fixed rate per hour. This is very short term and irregular workloads. And for testing, for development, on-demand instance is a very good use case. We should be using on-demand for production. Spot instance. Spot instance allows users to purchase EC2 at a reduced price, and anytime we have more instances, we can always go and sell it in spot instances. I'm referring to anytime we have more reserved instances, we can always sell them in spot instance catalog. And the way we buy spot instance is we actually put a budget. This is how much I'm willing to pay. All right, would you be able to give service within this cost? So anytime the price comes down and meets the cost that we have put in, we'll be assigned an instance. And anytime the price shoots up, the instance will be taken away from us. But in case of on-demand instances, we have bought that instance for that particular hour and it stays with us. But with spot instances, it varies based on the price. If you meet the price, you get the instance. If you don't meet the price, it goes away to somebody else. And the spot instance availability is actually based on supply and demand in the market. There's no guarantee that you will get spot instance at all time. Alright, so that's a caveat there you should be familiar with. That's a caveat there you should be aware when you are proposing somebody that we can go for spot instance and save money. It's not always going to be available. If you want your spot instance to be available to you, then we need to carefully watch the history of the price of the spot instance. Now, how much was it last month and how much is it this month? So how can I quote, or how much can I quote, stuff like that. So you got to look at those history before you propose somebody that, well, we're going to save money using spot instance. On the other hand, reserved instance provide cost savings for the company. We can opt for reserved instances for 1 year or 3 years. There are actually 3 types of reserved instances: light, medium, and heavy reserved instances. They are based on the amount that we would be paying. And cost benefit also depends with reserved instance. The cost benefit also depends based on, are we doing all upfront or no upfront or partial payment, then split the rest as monthly payments. So there are many purchase options available. But overall, if you're looking at using an application for the next 1 year and 3 years, you should not be going for on-demand instance. You should be going for reserved instance, and that's what gives you the cost benefit. And in an AWS interview, sometimes you might be asked, how you interact with the AWS environment. Are you using CLI? Are you using console? And depending on your answer, whether console or CLI, the panelists put a score. Okay, this person is CLI specific, this person is console specific, or this person has used AWS environment through the SDK, stuff like that. So this question tests whether you are a CLI person or a console person. And the question goes like this: how do you set up SSH agent forwarding so that you do not have to copy the key every time you log in? If you have used PuTTY, anytime if you want to log into an EC2 instance, you will have to put the IP and the port number. Along with that, you will have to map, or we will have to map the key in the PuTTY, and this has to be done every time. That's what we would have done in our lab environments, right? But in production environment, using the same key or mapping the same key again and again every time, it's actually an hassle. It's considered as a blocker. So you might want to cache it. You might want to permanently add it in your PuTTY session so you can immediately log in and start using it. So here in the place where you would actually map the private key, there's a quick button that actually fixes or that actually binds your SSH to your PuTTY instance. So we can enable SSH agent forwarding that will actually bind our key to the SSH, and next time when we try to log in, we don't have to always go through mapping the key and trying to log in. Alright, this question, what are Solaris and AX operating systems? Are they available with AWS? That question generally gets asked to test how familiar are you with the AMIs available? How familiar are you with EC2? How familiar are you with the EC2 hardwares available? That basically tests that. Now the first question or the first thought that comes to your mind is, well, everything is available with AWS. I've seen Windows, I've seen Ubuntu, I've seen Red Hat, I've seen Amazon AMIs, and if I don't see my operating system there, I can always go to Marketplace and try them. If I don't find a Marketplace, I can always go to Community and try them. So there are a lot of AMIs available, there are a lot of operating systems available. I will be able to find Solaris and AX, but that's not the case. Solaris and AX are not available with AWS. That's because Solaris uses a different, Solaris does not support the architecture, does not support public cloud currently. The same goes for AX as well. They run on Power CPU and not on Intel, and as of now, Amazon does not provide power machines. This should not be confused with HPC, which is high performance computing. Should not be confused with that. Now these are different hardwares, different CPU itself that the cloud providers they do not provide yet. Another question you could get asked in organizations that would want to automate their infrastructure using Amazon native services would be, how do you actually recover an EC2 instance or auto recover an EC2 instance when it fails? Well, we know that EC2 instances are considered as immutable, meaning irreparable. We don't spend time fixing bugs in an OS, stuff like that. Once an EC2 instance crashes, like it goes on a OS panic, or there are various reasons why it would fail. So we don't have to really worry about fixing it. We can always relaunch that instance and that would fix it. But what if it happens at 2 o'clock in the night? What if it happens during a weekend when nobody's in office looking or monitoring those instances? So you would want to automate that, not only on a weekend or during midnights, but it's general practice good to automate it. So you could face this question: how do you actually automate an EC2 instance once it fails? And the answer to that question is using CloudWatch, we can recover the instance. So as you see, there is an alarm threshold set in CloudWatch, and once the threshold is met, meaning if there is an error, if there is a failure, if the EC2 instance is not responding for a certain while, we can set an alarm. And once the alarm is met, let's say the CPU utilization stayed high for 5 minutes, right? It's not taking any new connections, or the instance is not pinging for 5 minutes, or in this case, it's 2 minutes. It's not pinging, so it's not going to respond connection. So in those cases, you would want to automatically recover that EC2 instance by rebooting the instance. All right, now look at this, the take this action section under the action. So there we have a bunch of options like recover this instance, meaning reboot the instance. So that's how we would recover. The other two options are beyond the scope of the question, but still you can go ahead and apply. just like I'm going to do it. So the other option is stop the instance. That's very useful when you want to stop instances that are having low utilizations. Nobody's using the system as of now. You don't want them to be running and wasting the cloud expenditure. So you can actually set an alarm that stops the EC2 instance that's having low utilization. So somebody was working in an instance and they left it without, or they forgot to shut down that instance, and it gets, they will only use it again the next day morning. So in between there could be like 12 hours that the system is running idle, nobody's using it, and you're paying for it. So you can identify such instances and actually stop them when the CPU utilization is low, meaning nobody is using it. The other one is to terminate. Let's say you want to give system to somebody temporarily and you don't want them to hand the system back to you, right? This is actually an idea. In other words, this is actually the scenario. So you hand over a system to somebody, and when they're done, they're done. We can actually terminate the system. So you could instruct the other person to terminate the system when they're done, and they could forget and the instance could be running forever. Or you can monitor the system after the specified time is over and you can terminate the system. Or best part, you can automate the system termination. So you assign a system to somebody and then turn on this CloudWatch action to terminate the instance when the CPU is low for like 2 hours, meaning they've already left, or CPU is low for 30 minutes, meaning they've already left, stuff like that. So that's possible. And if you're getting hired for an system side architect or even on the SysOps side, you could face this question: what are the common and different types of AMI designs? There are a lot of AMI designs. The question is the common ones and the difference between them. So the common ones are the full back AMIs, and the other one is just enough OS AMI, JEOS AMI, and the other one is hybrid type AMIs. So let's look at the difference between them. The full backed AMI, just like the name says, it's fully baked. It's ready to use AMI. This is the simplest AMI to deploy. Can be a bit expensive, it can be a bit cumbersome because you'll have to do a lot of work beforehand. You could use the AMI, so a lot of planning, a lot of thought process will go into it, and the AMI is ready to use, right? You hand over the AMI to somebody and it's ready to use, or if you want to reuse the AMI, it's already ready for you to use. So that's full baked AMI. The other one is just enough operating system AMI. Just like the name says, it has as you can also see in the diagram or in the picture, it covers a part of the OS. All bootstraps are already packed properly, and the security monitoring, logging, and the other stuff are configured at the time of deployment or at the time you would be using it. So not much thought process will go in here. The only focus is on choosing the operating system and what goes, the operating system specific agents or bootstraps that goes into the operating system. That's all we worry about. The advantage of this is it's flexible, meaning you can choose to install additional softwares at the time of deploying, but that's going to require an additional expertise on the person who will be using the AMI. So that's another overhead there. But the advantage is that it's kind of flexible. I can change the configurations during the time of deployment. The other one is a hybrid AMI. Now the hybrid AMI actually falls in between the fully baked AMI and just enough operating system options. So these AMIs have some features of the baked type and some features of the just enough OS type. So as you see, the security monitoring, logging are packed in that AMI, and the runtime environments are installed during the time of a deployment. So this is where the strict company policies would go into the AMI. Company policies like you got to log this, you got to monitor this. These are the ports that generally gets open in all the systems, stuff like that. So they strictly go into the AMI and sits in an AMI format. And during deployment, you have the flexibility of choosing the different runtime and the application that sits in an EC2 instance. Another very famous question you would face in an interview is, how can you recover login to an EC2 instance to which you lost the key? Well, we know that if the key is lost, we can't recover it. There are some organizations that integrate their EC2 instances with an AD. That's different. Right, so you can go and reset the password in the AD and you will be able to log in with the new password. But here the specific tricky question is, you are using a key to log in, and how do you recover if you have lost the key? Generally, companies would have made a backup of the key so we can pick from the backup, but here the specific question is we have lost the key, literally no backups on the key at all. So how can we log in? And we know that we can't log into the instance without the key present with us. So the steps to recover is that make the instance use another key and use that key to log in. Once the key is lost, it's lost forever. We won't be able to recover it. You can't raise a ticket with Amazon. Not possible. They're not going to help. It's beyond the scope. So make the instance use another key. It's only the key that's the problem. You still have valid data in it. You got to recover the data. It's just the key that's having the problem. So we can actually focus on the key part alone and change the key, and that will allow us to log in. So how do we do it? Step-by-step procedure. So first, verify the EC2 config service is running in that instance. If you want, you can actually beforehand install the EC2 config in that service, or you can actually make the EC2 config run through the console. Just a couple of button clicks and that'll make the EC2 config run in that EC2 instance, and then detach the root volume for that instance. Of course, it's going to require a stop and start. So detach the root volume from the instance, attach the root volume to another instance as a temporary volume, or it could be a temporary instance that you've launched only to fix this issue. And then log in to that instance and to that particular volume and modify the configuration file. Modify it to use the new key, and then move the root volume back to its original position and restart the instance. And now the instance is going to have the new key, and you also have the new key with which you can log in. So that's how we go ahead and fix it. Now let's move on to some product specific or S3 product specific questions. A general perception is S3 and EBS can be used interchangeably, and the interviewer would want to test your knowledge on S3 and EBS. Well, EBS uses S3, that's true, but they can't be interchangeably used. So you might face this question: what are some key differences between AWS S3 and EBS? Well, the differences are S3 is an object store, meaning you can't install anything in it. You can store drive files, but you can't actually install in it. It's not a file system. But EBS is a file system. You can install services, install applications in it, and that's going to run stuff like that. And talking about performance, S3 is much faster and EBS is super faster when accessing from the instance, because from the instance, if you need to access S3, you'll actually have to go out through the internet and access the S3, or S3 is an external service, a very external service. You'll have to go through, or you'll have to go outside of your VPC to access S3. S3 does not come under a VPC, but EBS comes under a VPC. It's on the same VPC, so you would be able to use it kind of locally. Compared to S3, EBS is very local, so that way it's going to be faster. And redundancy, talking about redundancy of S3 and EBS. S3 is replicated. The data in S3 is replicated across the data centers, but EBS is replicated within the data center, meaning S3 is replicated across availability zones. EBS is within an availability zone. So that way redundancy is a bit less in EBS. In other words, redundancy is higher in S3 than EBS. And talking about security of S3, S3 can be made private as well as public, meaning anybody can access S3 from anywhere in the internet. That's possible with S3. But EBS can only be accessed when attached to an EC2 instance. Right? Just one instance can access it, whereas S3 is publicly directly accessible. The other question related to S3 security is, how do you allow access to a user to a certain bucket, which means this user is not having access to S3 at all, but this user needs to be given access to a certain bucket. How do we do it? The same case applies to servers as well. In few cases, there could be an instance where a person is new to the team and you actually don't want them to access the production service. Now he is in the production group, and by default he or she is granted access to that server, but you specifically want to deny access to that production server till the time he or she is matured enough to access or understand the process, understand the do's and don'ts before they can put their hands on the production server. So how do we go about doing it? So first we would categorize our instances. Well, these are critical instances. These are normal instances. And we would actually put a tag on them. That's how we categorize. Right? So you put a tag on them. Put a tag saying, well, they are highly critical. They are medium critical and they are not critical at all, still they're in production, stuff like that. And then you would pick the users who wants to or who should be or should not be given access to a certain server, and you would actually allow the user to access or not access servers based on a specific tag. In other words, you can use actually tags. In the previous step, we put tags on the critical server, right? So you would define that this user is not going to use this tag. All right, this user is not allowed to use the resources with this tag. So that's how you would make your step forward. So you would allow or deny based on the tags that you have put. So in this case, he or she will not be allowed to servers which are tag critical servers. So that's how you allow deny access to them. And the same goes for bucket as well. Right, if an organization is excessively using S3 for their data storage because of the benefit that it provides, the cost and the durability, you might get asked this question, which is organizations would replicate the data from one region to another region for additional data durability and for having data redundancy. Not only for that, they would also do that for DR purposes, for disaster recovery. If the whole region is down, you still have the data available somewhere else and you can pick and use it. Some organizations would store data in different regions for compliance reasons, to provide low latency access to their users who are local to that region, stuff like that. So when companies do replication, how do you make sure that there is consistency in the replication? How do you make sure that the replication is not failing and the data gets transferred for sure and there are logs for that replication? This is something that the companies would use where they're excessively using S3 and they're fully relying on the replication in running their business. And the way we could do it is we can set up a replication monitor. It's actually a set of tools that we could use together to make sure that the cloud replication, region level replication is happening properly. So this is how it happens. Now on this side, on the left hand side, we have the region 1 and on the right hand side, we have region 2. And region 1 is the source bucket and region 2 is the destination bucket. Right, so object is put in the source bucket and it has to go directly to the region 2 bucket or made a copy in the region 2 bucket. And the problem is sometimes it fails and there is no consistency between them. So the way you would do it is connect these services together and create an cross-replication or cross-region replication monitor that actually monitors your environment. So there are CloudWatch that make sure that the data is moved, no data is failing. Again, there's CloudWatch on the other end, make sure that the data is moving. And then we have the logs generated through CloudTrail, and that's actually written in DynamoDB. And if there is an error, if something is failing, you get notified through an SMS or you get notified through an email using the SNS service. So that's how we could leverage these tools and set up an cross-region replication monitor that actually monitors your data replication. Some common issues that companies face in VPC is that we all know that I can use Route 53 to resolve an IP address externally from the internet, but by default the servers won't connect to the other servers using our custom DNS name. That it does not do that by default. So it's actually a problem. There are some additional things that as an administrator or as an architect or as a person who uses it, you will have to do. And that's what we're going to discuss. So the question could be, VPC is not resolving the server through the DNS. You can access it through the IP, but not through the DNS name. And what could be the issue and how do you go about fixing it? And you will be able to answer this question only if you have done it already. It's a quick and simple step. By default, VPC does not allow, that's the default feature. And we will have to enable the DNS hostname resolution before. Now this is for the custom DNS, not for the default DNS that comes along. This is for the custom DNS. So we will have to enable the DNS hostname resolution. So we'll have to enable the DNS hostname resolution so they actually resolve. Let's say I want to connect to server1.simplylearn.com. By default, it's not allowed. But if I enable this option, then I will be able to connect to server1.simplylearn.com. If a company has VPCs in different regions and they have a head office in a central place and the rest of them are branch offices and they are connecting to the head office for access or for saving data or for accessing certain files or certain data or storing data. All right, so they would actually mimic the hub and spoke topology, where you have the VPC, which is centrally in an accessible region, a centrally accessible region, and then you would have a local VPCs or branch offices in different other regions, and they get connected to the VPC in the central location. And the question is, how do you actually connect the multiple sites to a VPC and make communication happen between them? By default, it does not do that. We know that VPCs, they need to be peered between them in order to access the resources. Let's look at this picture, right? So I have like a customer network or branch offices in different parts, and they get connected to a VPC. That's fine. So what we have achieved is those different offices, the remote offices, they are connecting to the VPC and they're talking, but they can't connect or they can't talk to each other. That's what we have built. But the requirement is the traffic needs to, or they should be able to talk to each other, but they should not have a direct connection between them, which means that they will have to come and hit the VPC and then reach the other customer network, which is in Los Angeles or which is in New York. All right, that's the requirement. So that's possible with some architecting in the cloud. So that's using VPN Cloud Hub. You look at these dotted lines, which actually allows customers, or which actually allows the corporate networks to talk to each other through the VPC. Again, by default, it doesn't happen. Cloud Hub is an architecture that we should be using to make this happen. And what's the advantage of it? As a central office, or as the headquarters office, which is in the VPC, or headquarters data center, which is in the VPC, you have control, or the VPC has control on who talks to who, and what traffic can talk to, what traffic can be routed to the other head office, stuff like that. That centralized control is on the VPC. The other question you could get asked is, name and explain some security products and features available in VPC. Well, VPC itself is an security service. It provides a security service to the application, but how do you actually secure the VPC itself? That's the question. And yes, there are products that can actually secure the VPC, or the VPC delivers those products to secure the application. Access to the VPC is restricted through a network access control list. Right? So that's an security product in VPC. And a VPC has security groups that protects the instances from unwanted inbound and outbound traffic, and network access control list protects the subnets from unwanted inbound and outbound access. And there are flow logs we can capture in VPC that captures incoming and outgoing traffic through a VPC, which will be used for later analysis, as in what's the traffic pattern, what's the behavior of the traffic pattern, stuff like that. So there are some security products and features available in VPC. Now, how do you monitor VPC? VPC is a very important concept, very important service as well. Everything sits in a VPC. Most of the service sits in a VPC, except for Lambda and S3 and DynamoDB and a couple of other services. Most of them sit in a VPC for security reasons. So how do you monitor your VPC? How do you gain some visibility on your VPC? Well, we can gain visibility on your VPC using VPC flow log. That's the basic service. As you see, it actually captures what's allowed, what's not allowed, stuff like that. Which IP is allowed, which IP is not allowed, stuff like that. So we can gather it and we can use that for analysis. And the other one is CloudWatch and CloudWatch logs, the data transfers that happen. So this is who gets allowed and who does not get allowed. I mean, the flow logs is who is allowed and who's not allowed, that kind of detail. And CloudWatch gives information about the data transfer, how much data is getting transferred. We can actually pick unusual data transfers if there is a sudden hike in the graph. There's a sudden hike and something happens at 12 on a regular basis and you weren't expecting it. There's something suspicious. It could be valid backups. It could be a malicious activity as well. So that's how you know, by looking at CloudWatch logs and CloudWatch dashboard.
Now let's talk about multiple choice questions. When going for an interview, you might sometimes find yourself that the company is conducting an online test. Based on the score, they can put you to a panelist and then they would take it forward. So we thought we'll also include multiple choice questions to help you better handle such situation.
if you come across. All right, when you find yourself in such situation, the key to clear them is to understand the question properly, read between the lines. That's what they say. There can be like a big paragraph with 3 lines or 10 lines. You really got to understand what the question is about and then try to find answer for that question. So that's thumb rule number 1. And then the second rule is try to compare and contrast the services mentioned, or try to compare and contrast the answers. You can easily weed out 1 or 2 answers, and then you will be left with only 2 answers to decide from. So that also helps you with time, and that also helps you with some precision in your answer. So number 1, read between the lines. Number 2, compare and contrast the services, and you'll be able to easily weed out the wrong ones. So let's try answering this question. Suppose you are a game designer and you want to develop a game with a single digit millisecond latency. Which of the following database services would you choose? So we know that the following are database services. Good enough. All right. And it talks about millisecond latency. That's a key point. And the third thing is it's a game. Could be a mobile game. It's a game that you are trying to design, and you need millisecond latency, and it has to be a database. All right, so let's talk about the options available. RDS. RDS is a database for sure. Is it good for game design? We'll come back to that. Neptune. Neptune is a graph, a database service in Amazon. So that's kind of out of the equation. And Snowball is actually a storage. All right, it's a transport medium, I would say. So that's again out of the equation. So the tie is between RDS and DynamoDB. So if we need to talk about RDS, RDS is a platform as a service. It provides cost-efficient, resizable capacity, but it's an SQL database, meaning the tables are kind of strict. It's good for banking and other type of applications, but not really good for anything that has to do with gaming. So the only option left is DynamoDB. Again, it's the right answer. DynamoDB is actually an fast and flexible NoSQL database service, and it provides a single-digit millisecond latency at any scale. And it's a database at the same time. It's a key value store model database. So the right answer is DynamoDB. All right. Let's look at the next question. If you need to perform real-time monitoring of AWS services and get actionable insights, which service would you use? All right, let's list the services. So it talks about real-time monitoring. A firewall manager, what does it provide? Now, firewall manager is not really a monitor, just like the name says, it's a manager. It manages multiple firewalls. And AWS Guard Duty is an threat detection service. It does monitoring. It does continuously monitor our environment, but it monitors for threats. All right, only threats. Now let's talk about CloudWatch. CloudWatch is a service that helps to track metrics. It's a service that is used to monitor the environment and give us a system-wide visibility, and also it helps us to store logs. So at the moment it kind of looks like that could be the right answer. We don't know that yet, but we have one more option left. That's EBS. So what's EBS? EBS is a block storage, elastic block store. If we abbreviate EBS, it's elastic block store. So all three of them are easily out of the question. The first one is to manage. Second one is to find threats. Of course, it does monitoring. So there's, if there is one relation between CloudWatch and Guard Duty, that's monitoring. So easily we can actually find ourselves slipped towards picking Guard Duty, but know that Guard Duty is only for gaining security insight, but not about gaining AWS service insight. So CloudWatch is a service that helps us to get a system-wide or an AWS-wide or an account-wide, and it has a number of metrics we can monitor and get a very good insight of how a service is performing, be it CPU, be it RAM, be it network utilization, be it connection failures. CloudWatch is a service that helps us perform a real-time monitoring and get some actionable insights on the services. All right, let's talk about this 33rd question. As a web developer, you are developing an app especially for the mobile platform. All right, there is a mention that this is especially for the mobile platform. So a lot of services gets filtered out, mobile platform. Right? Which of the following lets you add user sign up, sign in, and access control to your web and mobile app quickly and easily? All right, so this is all about signing in to your mobile app. So if we need to read between the lines, that's how we can read sign up or sign in into a mobile platform. All right, so we have like 4 options here: Shield, AWS Massey, AWS Inspector, Amazon Cognito. So let's try to weed out services which are not relevant to it. So what's AWS Shield? AWS Shield is actually a service that provides a DDoS mitigation or a DDoS protection, denial of service protection. It's a security feature. Let's talk about the second option. AWS Massey is again a security service that uses machine learning to automatically discover and classify the data. It again talks about security, and this security is all about encrypting or saving the data. It does not come close with signing up and mobile platform. Alright, let's talk about the other one, AWS Inspector. Now, AWS Inspector has something to do with apps. It definitely has something to do with apps. So kind of looks like that's relevant as of now. So it actually helps with improving the security and compliance of the apps that we deploy in the cloud. So kind of looks like it could be because it has to do with apps. The last one, Cognito. Now, Cognito is a service that actually lets the administrator to have control access over web and mobile apps. And it's a service that helps us to sign up and sign in to an mobile and web app. So that very much looks like we found the answer. So Cognito is a service that helps web app and mobile app for sign up and signing in, and also gives the administrator to have control over access control over the web and the mobile app. Pretty much we found it. So it's Cognito. Cognito is a service that helps us to set up, sign in, and have access control over the users who would be using our mobile and web app. Alright, how about this question? You are an ML engineer or a machine learning engineer who's on the lookout for a solution that will discover sensitive information that your enterprise stores in AWS and then uses NLP to classify that data and provide business related insights. Which among the following services would you choose? So we have a bunch of services that's going to help us achieve, or one of it is going to help us achieve the above requirement. So it's a service that deals with machine learning. You're a machine learning engineer who's looking for a service that will help you to discover information at your enterprise store. So we're talking about storage, discover information in store, and then classify the data depending on severity, sensitivity, classify the data. So which service is that? So firewall manager, just like the name says, it's a manager. And AWS IAM, if we abbreviate it, it's Identity and Access Management. So it's Identity and Access Management, nothing to do with identifying sensitive data and managing it. So the first two is already out of the equation. And then the AWS Massey, we already had a quick definition description for AWS Massey, that it's actually a security service that uses machine learning. Kind of looks like it could be it. It's a security service that uses machine learning, and it discovers and classifies the sensitive information. Not only that, it does not stop there. It goes beyond and protects the sensitive data. AWS Massey kind of looks like. But we still have one more option to look at, which is Cloud HMS. Cloud HMS is also a security service. Kind of looks like that could be the answer as well. And it enables us to generate encryption keys and save the data. So kind of 50% of it. It's a security service. It encrypts, helps us protect the data, but AWS Massey is right on spot. It's a machine learning service. It helps us to classify the data and also to protect the data. So the answer for this question would be AWS Massey. So hope you kind of get it how this is going. So first we apply the thumb rule, identify the question that's being asked, read between the lines, and then try to find the service that meets your requirement. And finding the service is by first weeding out the wrong ones, recollect everything that you've learned about the service and see how well that matches with those hints that you have picked up. And if that doesn't match, weed that out, and you'll end up with just two to decide from at some point, and then it becomes easy for you to decide. Click on the question, submit it, and then move on to the other question in your interview. Alright, so how about this one? You are a system administrator in a company which is running most of its infrastructure on AWS. You are required to track your users and keep a look on how your users are being authenticated. Alright, so this is where the problem statement starts. Alright, you need to keep track of how your users are being authenticated, and you wish to create and manage AWS users and use permissions to allow and deny their access to the AWS resources. Alright, so you are to give them permission, number one, and then, if we put them in the right order, first giving them permissions and then tracking their usage. Let's see which of the service will help us achieve it. IAM is a service that helps us to, looking at the permissions, we can actually predict whether the user or the group will have service or not. So that helps us to get a track of who is able to use, who's not able to use certain service and all that stuff. So it kind of looks like, but we have other three options left. Let's look at AWS Firewall Manager. Just like the name says, it's actually a firewall manager. It helps us to manage multiple firewalls. Simple as that. And Shield is a service. It's a service that's used to protect denial of service or distributed denial of service. An API gateway is a service that makes it easy for developers to create, publish, maintain, and monitor and secure APIs. So, it's completely on the API side, very less on user and how you authenticate your user. We can get that by looking at the name itself, right? If we abbreviate it, or if you try to find a definition for the name API gateway, you would get it. It has to do with API. But if we abbreviate AWS IAM, it's Identity and Access Management, pretty much meets the requirement for the problem statement above. It's AWS Identity and Access Management. That's the right answer. Alright, let's look at this one. If you want to allocate various private and public IP address in order to make them communicate with the internet and other instances, you will use this service. Which of the following is this service? So it talks about using public and private IP address. So this service uses IP address, and then this service helps us to allow and deny connections to the internet and to the other instances. So you get the question, is it? Let's pick the service that helps us achieve it. Route 53. Route 53 is actually a DNS service, right? It's not a service that's used to allow or deny. No, it does not do that. VPC uses public and private IP address. Yes. So kind of looks like VPC helps us to allow, the security in VPC, the security group, the network access control list in a VPC, the routing table in a VPC, that actually helps us to allow or deny a connection to a particular IP address or to a particular service within the VPC or outside of the VPC. So as of now, it kind of looks like it could be, but let's look at the other services. What if we find a service that closely matches to the above requirement than the Amazon VPC? Gateway, API gateway, we know that it's a managed service that makes it easy for developers to create, publish, maintain, and monitor APIs and secure APIs. So that has completely to do with API, not with IP. CloudFront, we know about CloudFront that it's a content delivery network, and it provides global distribution of servers where our content can be cached. It could be video or bulk media or anything else. They can be cached locally, so users can easily access them and download them easily. All right, so that's CloudFront. Now at this point, after looking at all four, it looks like VPC is the right answer, and in fact VPC is the right answer. VPC has public IP address. VPC can help us with private IP address. VPC can be used to allow, deny connection based on the security group, access control list, and the routing table it has. So that's the right answer is VPC. Alright, how about this one? This platform as a service or platform as a DB service provides us with a cost-efficient and resizable capacity while automating time-consuming administrative tasks. So this question is very clear. It's a DB service we got to look for, and it's a service that can provide automating some of the time-consuming tasks. It has to be resizable at the same time. So let's talk about Amazon Relational Database. It's a database kind of matches the requirement. We can resize it as and when needed. All right. Looks like it's a fit as of now. It actually automates some of the time consuming work. Looks like it's a fit as of now. Let's move on to Elastic Cache and then try to see if that matches the definition that we've figured out above. Elastic Cache, it's actually a caching service. It's again an in-memory data store, which helps in achieving high throughput and low latency in memory data store. So it's not a full-blown database, and it does not come with any Amazon provisioned automation in it for automating any of the administration tasks. No, it does not come up with anything like that. Yeah, we can resize the capacity as and when needed, but automation, it's not there yet, and moreover it's not a database, so that's out of the equation. VPC is not a resizable one. Once we have designed VPC, it's fixed, it can't be resized. So that's out of the equation. And Amazon Glacier is a storage but not a database. Right, so that's again out of the equation. So the tie is kind of between Amazon Relational Database Service and Amazon Elastic Cache, because they both aid the database service, but Elastic Cache is not a full-blown database. It actually helps the database, but it's not a full-blown database. So it's Amazon Relational Database. So that's the one which is a platform as a service. It's the one which can be resized. It's the one which can be used to automate the time-consuming administrative tasks. Alright, let's talk about this one. Which of the following is a means for accessing human researchers or consultants to help solve a problem on a contractual or a temporary basis? Alright, let's read the question again. Which of the following is a means for accessing human researchers or consultant to help solve problems on a contractual or a temporary basis? It's like assigning tasks or hiring AWS experts for a temporary job. So let's try to find that kind of service in the 4 services that are listed. Amazon Elastic MapReduce. MapReduce is actually an framework service that makes it easy and cost effective to analyze large amount of data, but that has nothing to do with accessing human researchers. Alright, let's talk about Mechanical Turk. It's a web service that provides a human workforce. That's the definition for it. For example, automation is good, but not everything can be automated. For something to qualify for automation, it has to be a repetitive task. A one-time task can't be automated, or the time and money that you would be spending in automation is not worth it. Instead, you could have done it manually. So that does not qualify for automation. And anything that requires intelligence, right? Anything that's a special case. Right? Automation can do repetitive tasks. Automation can do precise work, but it has to be a repetitive task. The scenario, it should have been there already. Only then that can be executed. But if it's a new scenario and it requires appropriate addressing, then it requires human task. So we could hire researchers and consultants who can help solve a problem using Amazon Mechanical Turk. The other 2 are already out of the equation. Now DevPay is actually a payment system through Amazon, and multi-factor authentication, as it says, it's an authentication system. So the right answer is Amazon Mechanical Turk. Alright, this sounds interesting. Let's look at this one. This service is used to make it easy to deploy, manage, and scale containerized applications using Kubernetes on AWS. Which of the following is this AWS service? So it's a service to deploy, manage, and scale containerized applications. So it deals with containers. It also should have the ability to use Kubernetes, which is a container orchestration service. Alright, the first one, Amazon Elastic Container Service. Kind of looks like it's the one. The name itself has the word and the relation we're looking for, Elastic Container Service. So this container service is an highly scalable, high performance container orchestration service. Let's look at the other one, AWS Batch. It's a service that enables IT professionals to schedule and execute batch processing. I mean, the name itself says that that's meant for batch processing. Elastic Beanstalk, that's another service that helps us to deploy, manage, and scale, but it helps us with EC2 instances, not with containerized instances. So that's again out of the equation. Would Lightsail be a good tie for Elastic Container Service? What's Lightsail? Now, Lightsail is a service. It's called as a virtual private server without a VPC. It's called as a virtual private server. It comes with predefined compute, storage, networking capacity. It's actually a server, not a container. right? So at this point, that also becomes out of the equation. So it's Amazon Elastic Container Service. That's the one that helps us to easily deploy, manage, scale container services, and it helps us orchestrate the containers using Kubernetes. Alright, how about this one? Alright, this service lets us to run code without provisioning or managing servers. So no servers, run code. Select the correct service from the below option. Alright, so no servers, but we should be able to run code. Amazon EC2 Autoscaling. EC2 Autoscaling. EC2 is Elastic Compute Cloud, which is a server, and Autoscaling is a service that helps us to achieve scaling the server. So that's the definition for it. Could be that's out of the equation. AWS Lambda. Now Lambda is a service. It's actually an event-driven serverless computing platform, and Lambda runs code in response to the event that it receives, and it automatically manages the compute resource that's required for that code. As long as we have uploaded a code that's correct and set up events correctly to map to that code, it's going to run seamlessly. So that's about Lambda. It kind of looks like it could be the answer because Lambda runs code. We don't have to manage servers. It manages servers by itself. But we can't conclude as of now. We have other two services to talk about. AWS Batch. Alright, Batch is a service that enables IT professionals to run batch job. We know that. And about Inspector, Amazon Inspector, it's actually a service that helps us to increase and identify any security issues and align our application with compliance. Well, that's not the requirement in the question. The requirement in the question was run code without provisioning a server, and without any more space for confusion, AWS Lambda is a service, or is the service that runs code without provisioning and managing services. Right? The right one would be AWS Lambda. Alright, so by this we have come to the end of the first section.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
I'm glad that we were able to provide you a second part in AWS interview questions. Alright, let's get started. So in an environment where there is a lot of automation, infrastructure automation, you'll be posted with this question: how can you add an existing instance to a new autoscaling group? Now this is when you are taking an instance away from the autoscaling group to troubleshoot, to fix a problem, to look at logs, or if you have suspended the autoscaling, you might need to re-add that instance to the autoscaling group. Only then it's going to take part in it, right? Only then the autoscaling is going to count it as part of it. It's not a straight procedure. When you remove them, it doesn't get automatically re-added. And I've had worked with some clients when their developers were managing their own environment, they had problems adding the instance back to the autoscaling group. Irrespective of what they tried, the instance was not getting added to the autoscaling group, and whatever they fix that they were provided, or whatever fix that they have provided, were not getting encountered in the autoscaling group. So like I said, it's not a straight a click button procedure. There are ways we'll have to do it. So how can you add an existing instance to the autoscaling group? There are a few steps that we need to follow. So the first one would be to, under the EC2 instance console, right, under the instance, under actions in specific, there's an option called attach to autoscaling group, right? If you have multiple autoscaling groups in your account or in the region that you're working in, then you're going to be posted with the different autoscaling groups that you have in your account. Let's say you have 5 autoscaling groups for 5 different applications. You're going to be posted with 5 different autoscaling groups, and then you would select the appropriate autoscaling group and attach the instance to that particular autoscaling group. While adding to the autoscaling group, if you want to change the instance type, that's possible as well. Sometimes when you want to add the instance back to the autoscaling group, there would be requirement that you change the instance type to a better one, to a better family, to the better instance type. You could do that at that time. And after that, you have completely added the instance back to the autoscaling group. So it's actually a 7-step process, adding an instance back to the autoscaling group. In an environment where they're dealing with migrating the instance, or migrating an application, or migrating an instance, migrating an VM into the cloud, If the project that you're going to work with deals with a lot of migrations, you could be posted this question: what are the factors you will consider while migrating to Amazon Web Services? The first one is cost. Is it worth moving the instance to the cloud? Given the additional bells and whistles features available in the cloud, is this application going to use all of them? Is moving into the cloud beneficial to the application in the first place? Beneficial to the users who will be using the application in the first place. So that's a factor to think of. So this actually includes cost of the infrastructure and the ability to match the demand and supply transparency. Is this application in high demand? Is it going to be a big loss if the application becomes unavailable for some time? So there are a few things that needs to be considered before we move the application to the cloud. And then if the application needs to be provisioned immediately, is there an urge? Is there an urge to provision the application immediately? That's something that needs to be considered. If the application requires to go online, if the application needs to hit the market immediately, then we would need to move it to the cloud, because in on-premises, procuring or buying an infrastructure, buying the bandwidth, buying the switch port, buying an instance, buying the softwares, buying the license related to it, it's going to take time, at least like 2 weeks or so, before you can bring up an server and launch an application in it, right? So if the application cannot wait, waiting means workforce productivity loss, is it? So we would want to immediately launch instances and put application on top of it. In those cases, if your application is of that type, if there is an urge in making the application go online as soon as possible, then that's a candidate for moving to the cloud. And if the application, or if the software, or if the product that you're launching, it requires hardware, it requires an updated hardware all the time, that's not going to be possible in on-premises. We try to deal with legacy infrastructure all the time in on-premises, but in the cloud, they're constantly upgrading their hardwares. Only then they can keep themselves up going in the market. So the cloud providers are constantly updating their hardwares. And if you want to be benefited, or if your application wants to be benefited by the constant upgrading of the hardwares, making sure the hardware is as latest as possible, the software version, the licensing is as latest as possible, then that's a candidate to be moved to the cloud. And if the application does not want to go through any risk, if the application is very sensitive to failures, if the application is very much tagged to the revenue of the company, and you don't want to take a chance in seeing the application fail and seeing the revenue drop, then that's a candidate for moving to the cloud. And business agility, moving to the cloud, at least half of the responsibility is now taken care by the provider. In this case, it's Amazon. At least half of the responsibility is taken care by them. Like if the hardware fails, Amazon makes sure that they're fixing the hardware immediately. And notifications, if something happens, there are immediate notifications available that we can set it up and make ourselves aware that something has broken, and we can immediately jump in and fix it. So you see, the responsibility is now being shared between Amazon and us. So if you want to get that benefit for your application, for your organization, for the product that you're launching, then it needs to be moved to the cloud so you can get that benefit from the cloud. The other question you could get asked is, what is RTO and RPO in AWS? They are essentially disaster recovery terms. When you're planning for disaster recovery, you cannot avoid planning disaster recovery without talking about RTO and RPO. Now, what's the RTO? What's the RPO in your environment? Or how do you define RTO? How do you define RPO? Are some general questions that get asked. RTO is recovery time objective. RTO stands for the maximum time the company is willing to wait for the recovery to happen, or for the recovery to finish when a disaster strikes. So RTO is in the future, right? How much time is it going to take to fix and bring everything to normal? So that's RTO. On the other hand, RPO is recovery point objective, which is the maximum amount of data loss your company is willing to accept as measured in time. RPO always refers to the backups, the number of backups, the frequency of the backups, right? Because when an outage happens, you can always go back to the latest backup, right? And if the latest backup was before 12 hours, you have lost the in between 12 hours of data storage, right? So RPO is the acceptable amount. If the company wants less RPO is 1 hour, then you should be planning on taking backups every 1 hour. If RPO is 12 hours, then you should be planning on taking backups every 12 hours. So that's how RPO and RTO helps disaster recovery. The fourth question you could get asked is if you'd like to transfer huge amount of data, which is the best option among Snowball, Edge, and Snowmobile? Again, this is a question that gets asked if the company is dealing with a lot of data transfer into the cloud, or if the company is dealing with migrating data into the cloud. I'm talking about a huge amount of data in petabytes. Snowball and all of the Snowball series deals with the petabyte-sized data migrations. So there are three options available as of now. AWS Snowball is an data transport solution for moving high volume of data into and out of a specified AWS region. On the other hand, AWS Snowball Edge adds additional computing functions. Snowball is simple storage and movement of data, and Snowball Edge has a compute function attached to it. Snowmobile, on the other hand, is an exabyte scale migration service that allows us to transfer data up to 100 petabytes. That's like 100,000 terabytes. So depending on the size of data that we want to transfer from our data center to the cloud, we can rent any of these three services. Let's talk about some CloudFormation questions. This is a classic question. How is AWS CloudFormation different from AWS Elastic Beanstalk? From the surface, they both look like the same. You don't go through the console provisioning resources. You don't go through CLI and provision resources. Both of them provision resources through click button, right? But underneath, they are actually different services. They aid different services. So knowing that is going to help you understand this question a lot better. Let's talk about the difference between them, and this is what you will be explaining to the interviewer or the panelist. So the CloudFormation service helps you describe and provision all the infrastructure resources in the cloud environment. On the other hand, Elastic Beanstalk provides an simple environment to which we can deploy and run application. CloudFormation gives us an infrastructure, and Elastic Beanstalk gives us a small contained environment in which we can run our application. And CloudFormation supports the infrastructure needs of many different types of application, like the enterprise application, the legacy applications, and any new modern application that you want to have in the cloud. On the other hand, the Elastic Beanstalk, it's a combination of developer tools. They are tools that helps manage the lifecycle of a single application. So CloudFormation, in short, is managing the infrastructure as a whole, and Elastic Beanstalk, in short, is managing and running an application in the cloud. And if the company that you're getting hired is using CloudFormation to manage their infrastructure, or if they're using infrastructure or any of the infrastructure as a code services, then you would definitely face this question: what are the elements of an AWS CloudFormation template? So it has 4 or 5 basic elements, right? And the template is in the form of JSON or in YAML format. Right, so it has parameters, it has outputs, it has data, it has resources, and then the format or the format version or the file format version for the CloudFormation template. So parameter is nothing but it actually lets you to specify the type of EC2 instance that you want, the type of RDS that you want, right? So EC2 is an umbrella, RDS is an umbrella, and parameters within that EC2 and parameters within that RDS are the specific details of the EC2 or the specific details of the RDS service. So that's what parameters in a CloudFormation template. And then the element of the CloudFormation template is outputs. For example, if you want to output the name of an S3 bucket that was created, if you want to output the name of the EC2 instance, if you want to output the name of some resources that have been created, instead of looking into the template, instead of navigating through in the console and finding the name of the resource, we can actually have them outputted in the result section. So you can simply go and look at all the resources created through the template in the output section, and that's what output values or output does in the CloudFormation template. And then we have resources. Resources are nothing but what defines what are the cloud components or cloud resources that will be created through this CloudFormation template. Now, EC2 is a resource, RDS is a resource, and S3 bucket is a resource, Elastic Load Balancer is a resource, and NAT Gateway is a resource, VPC is a resource. So you see, all these components are the resources, and the resource section in the CloudFormation defines what are the AWS cloud resources that will be created through this CloudFormation template. And then we have version. Version actually identifies the capabilities of the template. We just need to make sure that it is of the latest version type, and the latest version is 0909 2010. That's the latest version number. You'll be able to find that on the top of the CloudFormation template, and that version number defines the capabilities of the CloudFormation template. So just need to make sure that it's the latest all the time. Still talking about CloudFormation, this is another classic question. What happens when one of the resources in a stack cannot be created successfully? Well, if the resource in a stack cannot be created, the CloudFormation automatically rolls back and terminates all the resources that was created using the CloudFormation template. So whatever resources that were created through the CloudFormation template from the beginning, let's say we have created like 10 resources and the 11th resource is now failing, CloudFormation will roll back and delete all the 10 resources that were created previously. And this is very useful when the CloudFormation cannot go forward. CloudFormation cannot create additional resources because we have reached the elastic IP limits. Elastic IP limit per region is 5, right? And if you have already used 5 IPs and your CloudFormation is trying to buy 3 more IPs, we've hit the soft limit. Till we fix that with Amazon, CloudFormation will not be able to launch additional resources and additional IPs. So it's going to cancel and roll back everything. That's true with a missing EC2 AMI as well. If an AMI is included in the template but the AMI is not actually present, then CloudFormation is going to search for the AMI, and because it's not present, it's going to roll back and delete all the resources that it created. So that's what CloudFormation does. It simply rolls back all the resources that it created. I mean, if it sees a failure, it would simply roll back all the resources that it created. And this feature actually simplifies the system administration and layered solutions built on top of AWS CloudFormation. So at any point, we know that there are no orphan resources in our environment, because something did not work, or because there was an CloudFormation executed some, there are no orphan resources in our account. At any point, we can be sure that if CloudFormation is launching a resource and if it's going to fail, and it's going to come back and delete all the resources it's created, so there are no orphan resources in our account. Now let's talk about some questions in Elastic Block Store. Again, if the environment deals with a lot of automation, you could be thrown this question: how can you automate EC2 backup using EBS? It's actually a 6-step process. To automate the EC2 backups, we'll need to write a script to automate the below steps using AWS API. And these are the steps that should be found in the scripts. First, to get the list of instances, and then the script that we are writing should be able to connect to AWS using the API and list the Amazon EBS volumes that are attached locally to the instance. And then it needs to list the snapshots of each volume, make sure the snapshots are present, and it needs to assign a retention period for the snapshot, because over time the snapshots are going to be invalid, right? Once you have some 10 latest snapshots, any snapshot that you have taken before that 10 becomes invalid because you have captured the latest, and 10 snapshot coverage is enough for you. And then the fifth point is to create a snapshot of each volume, create a new snapshot of each volume, and then delete the old snapshot. Anytime a new snapshot gets created, the oldest snapshot in the list needs to go away. So we need to include options, we need to include scripts in our script, lines in our script that make sure that it's deleting the older snapshots which are older than the retention period that we are mentioning. Another question that you could see in the interview, be it a written interview, be it online interview, or be it an telephonic or face-to-face interview, is what's the difference between EBS and instance store? Let's talk about EBS first. EBS is kind of permanent storage. The data in it can be restored at a later point. When we save data in EBS, the data lives even after the lifetime of the EC2 instance. For example, we can stop the instance and the data is still going to be present in EBS. We can move the EBS from one instance to another instance and the data is simply going to be present there. So EBS is kind of permanent storage when compared to instance. On the other hand, instance store is temporary storage, and that storage is actually physically attached to the host of the machine. EBS is an external storage, and instance store is locally attached to the instance or locally attached to the host of the machine. We cannot detach an instance store from one instance and attach it to another, but we can do that with EBS. So that's a big difference. One is permanent data and another one is EBS is permanent, instance store is volatile data, and instance store, with instance store we won't be able to detach the storage and attach it to another instance. And another feature of instance store is data in an instance store is lost if the disk fails or the instance is stopped or terminated. So instance store is only good for storing cache data. If you want to store permanent data, then we should think of using EBS and not instance store. While talking about storage on the same lines, this is another classic question. How can you take backups of EFS like EBS? And if you can take backup, how do you take that backup? The answer is yes, we can take EFS to EFS backup solution. EFS does not support snapshot. Like EBS, EFS does not support snapshot. Snapshot is not an option for EFS, Elastic File System, right? We can only take backup from one EFS to another EFS, and this backup solution is to recover from unintended changes or deletions of the EFS, and this can be automated. Right? Any data that we store in EFS can be automatically replicated to another EFS, and once this EFS goes down or gets deleted or data gets deleted, or the whole EFS is for some reason interrupted or deleted, we can recover the data from, we can use the other EFS and bring the application to consistency. And to achieve this, it's not an one-step configuration, it's a cycle. There are a series of steps that's involved before we can achieve EFS to EFS backup. The first thing is to sign in to the AWS Management Console, and under EFS, or click on EFS to EFS restore button from the services list, and from there we can use the region selector in the console navigation bar to select the actual region in which we want to work on, and from there ensure that we have selected the right template. Some of the templates would be EFS to EFS backup, granular backups, incremental backups. Right, so there are some templates, the kind of backups that you want to take. Do you want to take granular? Do you want to take increment backups? Stuff like that. And then create a name to that solution, the kind of backup that we have created. And finally review all the configurations that you have done and click on save. And from that point onwards, the data is going to be copied. And from that point onwards, any additional data that you put is going to copy it and replicate it. Now you have an EFS to EFS backup. This is another classic question in companies which deals with data management. There are easy options to create snapshots, but deleting snapshots is not always an click button or a single step configuration. So you might be facing a question like, how do you auto delete old snapshots? And the procedure is like this. Now, as best practice, we will take snapshots of EBS volume to S3. All snapshots get stored in S3. We know that now. And we can use AWS Ops Automator to automatically handle all snapshots. The Ops Automator service, it allows us to create, copy, delete EBS snapshots. So there are CloudFormation templates available for AWS Ops Automator, and this Automator template will scan the environment and it would take snapshots. It would copy the snapshot from one region to another region if you want, if you're setting up a DR environment. And not only that, based on the retention period that we create, it's going to delete the snapshots which are older than the retention period. So life or managing snapshot is made a lot easier because of this Ops Automator CloudFormation template. Moving into questions in Elastic Load Balancer, this again could be a question in the interview. What are the different types of load balancers in AWS and what's their use case? What's the difference between them? And as of now, as we speak, there are 3 types of load balancers which are available in AWS. The first one being application load balancer. Just like the name says, the application load balancer works on the application layer and deals with HTTP and HTTPS requests. And it also supports path-based routing. For example, simplilearn.com/some web page, simplilearn.com/another website. So it's going to direct the path based on the / value that you give in the URL. So that's path-based routing. So it supports that. And not only that, it can support port-based :8080, :8081, or :8090. Based on that port also, it can take a routing decision, and that's what application load balancer does. On the other hand, we have network load balancer, and the network load balancer makes routing decisions at the transport level. It's faster because it has very less thing to work on. It works on lower OSI layer. It works on a lower layer, so it has very less information to work with than compared with application layer. So comparatively, it's a lot faster and it handles millions of requests per second. And after the load balancer receives a connection, it selects a target group for the default rule using the flow hash routing algorithm. It does simple routing, right? It does not do path-based or port-based routing. It does simple routing, and because of it, it's faster. And then we have a classic load balancer, which is kind of expiring as we speak. Amazon is discouraging people using classic load balancer, but there are companies which are still using classic load balancer. They are the ones who were the first one to step into Amazon when classic load balancer was the first load balancer or the only load balancer available at that point. So it supports HTTP, HTTPS, TCP, SSL protocol, and it has a fixed relationship between a load balancer port and the container port. So initially we only had classic load balancer, and then after some point Amazon said, instead of having one load balancer address all type of traffic, we're going to have 2 load balancers called as the child from the classic, 2 load balancer, and one is going to specifically address the application requirement and one is going to specifically address the network requirement, and let's call it as application load balancer and network load balancer. So that's how now we have 2 different load balancers. Talking about load balancer, another classic question could be, what are the different uses of the various load balancer in AWS Elastic load balancing? There are 3 types of load balancer. We just spoke about it. Application load balancer is used if we need flexible application management and TLS termination, and network load balancer if we require extreme performance and the load balancing should happen based on static IPs for the application. And classic load balancer is an old load balancer which is for people who are still running their environment from EC2 classic network. Now this is an older version of VPC, or this is what was present before VPC was created. EC2 classic network is what was present before EC2 was created. So they are the 3 types and they are the use cases of it. Let's talk about some of the security related questions you would face in the interview. When talking about security and firewall in AWS, we cannot avoid discussion talking about WAF, Web Application Firewall, and you would definitely see yourself in this situation where you've been asked how can you use AWS WAF in monitoring your AWS applications. WAF or Web Application Firewall protects our web application from common web exploits, and WAF helps us control which traffic source your application should be allowed or blocked, which traffic from a certain source, which source or which traffic from a certain source should be allowed or blocked your application. With WAF, we can also create custom rules that blocks common attack patterns. If it is a banking application, it has a certain type of attacks, and if it is simple data management, data storage application, it has content management application, it has a separate type of attack. So based on the application type, we can identify a pattern and create rules that would actually block that attack based on the rule that we create. And WAF can be used for three cases. The first one is allow all requests, and then block all requests, and count all requests for a new policy. So it's also an monitoring and management service which actually counts all the policies, or counts all the requests that matches a particular policy that we create. And some of the characteristics we can mention in AWS WAF are the origin IPs and the strings that appear in the request. We can allow block based on origin IP, allow block based on strings that appear in the request. We can allow block or count based on the origin country, length of the request. We can block and count the presence of malicious scripts in an connection. We can count the request headers, or we can allow block a certain request header, and we can count the presence of a malicious SQL code in a connection that we get and that want to reach our application. Still talking about security, what are the different AWS IAM categories we can control? Using AWS IAM, we can do the following. One is create and manage IAM users. And once the user database gets bigger and bigger, we can create and manage them in groups. And in IAM, we can use it to manage the security credentials, kind of setting the complexity of the password, setting additional authentications, like MFA, and rotating the passwords, resetting the password. There are a few things we could do with IAM. And finally, we can create policies that actually grants access to AWS services and resources. Another question you will see is, what are the policies that you can set for your user's password? So some of the policies that we can set for the user password is the minimum length, or the complexity of the password by at least having one number or one special characters in the password. So that's one. And then the requirement of a specific character types, including uppercase, lowercase, number, and non-alphabetic characters. So it becomes very hard for somebody else to guess what the password would be and try to hack them. So we can set the length of the password, we can set the complexity in the password, and then we can set an automatic expiration of the password. So after a certain time, the user is forced to create a new password, so the password is not stale, old, and easy to guess in the environment. And we can also set settings like the user should contact the admin when the password is about to expire. So you can get a hold of how the user is setting their password. Is it having good complexity in it? Is it meeting company standards? Or there are a few things that we can control and set for the users when the users are setting or recreating the password. Another question that could be posted in an interview, so to understand your understanding of IAM, is what's the difference between an IAM role and an IAM user? Let's talk about IAM user. Let's start small and then go big, or let's start simple and then talk about the complex one. The IAM user has a permanent long-term credential, and it's used to interact directly with AWS services. And on the other hand, IAM role is an IAM entity that defines a set of permissions for making AWS service requests. So IAM user is an permanent credential and role are temporary credentials. And IAM user has full access to all AWS IAM functionalities. And with role, trusted entities such as IAM users, application, or AWS services assume the role. So when an IAM user is given a permission, it sticks within the IAM user. But with roles, we can give permissions to applications, we can give permissions to users in the same account, in a different account, the corporate ID. We can give permissions to EC2, S3, RDS, VPC, and lot more. Role is wide, and IAM user is not so wide. It's very constrained only for that IAM user. Let's talk about managed policies in AWS. Managed policies, there are two types, customer managed and Amazon managed. So managed policies are IAM resources that express permissions using the IAM policy language. We can create policies, edit them, manage them separately from the IAM user group and roles which they are attached to. So they are something that we can do to managed policies if it is customer managed. And we can now update policy in one place, and the permissions automatically extend to all the attached entries. So I can have like 3 services, 4 services point to a particular policy, and if I edit that particular policy, it's going to reflect on those 3 or 4 services. So anything that I allow is going to be allowed for those 4 services. Anything that I denied is going to be denied for the 4 services. Imagine what would be without the IAM managed policy. We'll have to go and specifically allow deny on those different instances 4 or 5 times depending on the number of instances that we have. So like I said, there are 2 types of managed policies. One is managed by us, which is customer managed policies, and then the other is managed by AWS, which is AWS managed policy. This question, can you give an example of an IAM policy and a policy summary? This is actually to test how well versed are you with the AWS console. The answer to that question is, look at the following policy. This policy is used to grant access to add, update, and delete objects from a specific folder. In this case, name of the folder is example folder, and it's present in a bucket called example bucket. So this is an IAM policy. On the other hand, the policy summary is a list of access level, resource, and conditions for each service defined in a policy. So IAM policy is all about one particular resource, and the policy summary is all about multiple resources. With IAM policy, it was only talking about S3 bucket and one particular S3 bucket. Here it talks about CloudFormation template, CloudWatch logs, EC2, Elastic Beanstalk services. Summary of resources and the permissions and policies attached to them. That's what policy summary is all about. Another question could be like this: what's the use case of IAM and how does IAM help your business? Now, 2 important or primary work of IAM is to help us manage IAM users and their access. It provides secure access to multiple users to their appropriate AWS resources. So that's one it does. And the second thing it does is manage access for federated users. Federated users are non-IAM users, and through IAM we can actually allow and provide secure access to resources in our AWS account to our employees without the IAM user. Now, they could be authenticated using the Active Directory, they could be authenticated using the Facebook credential, Google credential, Amazon credential, and a couple of other credentials, third-party identity management, right? So we could actually trust them and we could give them access to our account based on the trust relationship that we have built with the other identity systems. All right, so 2 things. One is manage users and their access manage IAM user and their access in our AWS environment, and second is manage access for federated users who are non-IAM users. And more importantly, IAM is a free service, and with that we'll only be charged for the use of the resources, not for the IAM username and password that we create. All right, let's now talk about some of the questions in Route 53. One classic question that could be asked in an interview is, what is the difference between latency-based routing and geo-DNS or geo-based DNS routing? Now, the geo-based DNS routing takes routing decisions on the basis of the geographic location of the request. And on the other hand, the latency-based routing utilizes latency measurements between networks and data centers. Now, latency-based routing is used where you want to give your customers the lowest latency as possible. So that's when we would use latency based routing. And on the other hand, geo based routing is when we want to direct customers to different websites based on the country they are browsing from. You could have 2 different or 3 different websites for the same URL. Take Amazon, the shopping website, for example. When we go to Amazon.com from in the US, it directs us to the US web page where the products are different, the currency is different, right, and the flag and a couple of other advertisements that shows up are different. And when we go to Amazon.com from India, it gets directed to the Amazon.com Indian site, where again the currency, the product, and the advertisements, they're all different, right? So depending on the country they're trying to browse, if you want to direct customers to 2 or 3 different websites, we would use geo-based routing. Another use case of geo-based routing is if you have a compliance that you should handle all the DNS requests, or if you should handle all the requests from a country within the country, then you would do geo-based routing. Now, you wouldn't direct the customer to a server which is in another country, right? You would direct the customer to a server which is very local to them. That's another use case of geo-based routing. And like I said, for latency-based routing, the whole goal or aim is to achieve minimum end-user latency. If you are hired for the architect role and if that requires working a lot on the DNS, then you could be posted with this question: what is the difference between domain and a hosted zone? A domain is actually a collection of data describing a self-contained administrative and technical unit on the internet, right? So for example, Simplilearn.com is actually a domain. On the other hand, hosted zone is actually an container that holds information about how you want to route traffic on the internet to a specific domain. For example, lms.simplilearn.com is an hosted zone, whereas simplilearn.com is an domain. So in other words, in hosted zone, you would see the domain name plus a prefix to it. LMS is a prefix here. FTP is a prefix. Mail.simplilearn.com is a prefix. So that's how you would see a prefix in hosted zones. Another classic question from Route 53 would be: how does Amazon Route 53 provide high availability and low latency? The way Amazon Route 53 provides high availability and low latency is by globally distributed DNS servers. Amazon is a global service and they have DNS services globally. Any customer doing a query from different parts of the world, they get to reach an DNS server which is very local to them, and that's how it provides low latency. Now, this is not true with all the DNS providers. There are DNS providers who are very local to a country, who are very local to a continent. So they generally don't provide low latency service, right? It's always high latency. It's low latency for local users, but anybody browsing from a different country or a different continent, it's going to be high latency for them. But that's not again true with Amazon. Amazon is a globally distributed DNS provider. It has DNS servers global wide, and like I said, it has optimal locations. It has got global servers, or in other words, it has got servers around the globe, different parts in the globe, and that's how they are able to provide high availability. And because it's not running on just one server but on many servers, they provide high availability and low latency. If the environment that you're going to work on is going to take a lot of configuration backups, environmental backups, then you can expect questions in AWS config. A classic question would be: how does AWS config work along with AWS CloudTrail? AWS CloudTrail actually records user API activity on the account, and any HTTPS access or any sort of access that's made to the cloud environment, that's recorded in the CloudTrail. In other words, any API calls, the time is recorded, the type of call is recorded, and what was the response given. Was it a failure? Was it successful? They also get recorded in CloudTrail. It's actually a log. It actually records the activity in your cloud environment. On the other hand, config is a point-in-time configuration details of your resources. For example, at a given point, what are all the resources that were present in my environment? What are all the resources, or what are the configuration in those resources at a given point? They get captured in AWS config. Right. So with that information, you can always answer the question, what did my AWS resource look like at a given point in time? That question gets answered when we use AWS config. On the other hand, with CloudTrail, you can answer the question, by looking at the CloudTrail, or with the help of CloudTrail, you can easily answer the question, who made an API call to modify this resource? That's answered by CloudTrail. And with CloudTrail, we can detect if a security group was incorrectly configured and who did that configuration. Let's say there happened to be a downtime and you want to identify Let's say there happened to be a downtime and you want to identify who made that change in the environment. You can simply look at CloudTrail and find out who made the change. And if you want to look at how the environment looked like before the change, you can always look at AWS config. Can AWS configure or AWS config aggregate data across different AWS accounts? Yes, it can. Now this question is actually to test whether you have used AWS config or not. I know some of the services are very local, is it? Some of these services are availability zone specific, some of them are regional specific, and some of them are global services in Amazon. And though some of the services are region services, you still can do some changes, add some configuration to it and collect regional data in it. For example, S3 is a regional service, but still you can collect logs from all of the regions into an S3 bucket in one particular region. That's possible. And CloudTrail is CloudWatch is an regional service, but still you can, with some changes to it, with some adding permissions to it, you can always monitor the CloudWatch that belongs to CloudWatch logs that belongs to other regions. They're not global by default, but you can do some changes and make it global. Similarly, AWS config is a service that's a region-based service, but still you can make it act globally. We can aggregate data across a different region and different accounts in an AWS config and deliver the updates from different accounts to one S3 bucket and can access it from there. AWS config also works or integrates seamlessly with SNS topic. So, anytime there is a change, anytime a new data gets collected, you can always notify yourself or notify a group of people about the new log or the new config or new edit that happened in the environment. Let's look at some of the database questions. Database should be running on reserved instances. So whether you know that fact or not, the interviewer wants to understand how well you know that fact by asking this question. How are reserved instances different from on-demand DB instances? Reserved instances and on-demand instances are exactly the same when it comes to their function, but they only differ based on how they are built. Reserved instances are purchased for 1 year or 3 year reservation, and in return we get a very low per hour pricing because we're paying upfront. It's generally said that reserved instance is 75% cheaper than on-demand instance, and Amazon gives you that benefit because you're committing for 1 year and sometimes you're paying in advance for the whole year. On the other hand, on-demand instances are built on an hourly price. Talking about autoscaling, how will you understand the different types of autoscaling? The interviewer might ask this question: which type of scaling would you recommend for RDS and why? There are two types of scaling, as you would know now, vertical and horizontal. And in vertical scaling, we can vertically scale up the master database with a couple of clicks. Right, so that's vertical scaling. Vertical scaling is keeping the same node and making it bigger and bigger. If previously it was running on T2 micro, now we would like to run it on M3, 2 times large instance. Previously it had 1 virtual CPU, 1 gigabit. Now it's going to have 8 virtual CPU and 30 gigabit of RAM. So that's vertical scaling. On the other hand, horizontal scaling is adding more nodes to it. Previously it was running on 1 VM. Now it's going to run on 2, 3, 10 VMs. Right? That's horizontal scaling. So database can only be scaled vertically, and there are 18 different types of instances we can resize our RDS to. Right, so this is true for RDS MySQL, Postgres SQL, MariaDB, Oracle, Microsoft SQL servers. There are 18 type of instances we can vertically scale up to. On the other hand, horizontal scaling are good for replicas. So they are read-only replicas. We're not going to touch the master database. We're not going to touch the primary database, but I can do horizontal scaling only with Amazon Aurora. And I can add additional read replicas. I can add up to 15 read replicas for Amazon Aurora and up to 5 read replicas for RDS MySQL, Postgres SQL, and MariaDB RDS instances. And when we add replica, we are horizontally scaling, adding more nodes, right? Read-only nodes. So that's horizontal scaling. So how do you really decide between vertical and horizontal scaling? If you're looking to increase the storage and the processing capacity, we'll have to do a vertical scaling. If you're looking at increasing the performance or of the read-heavy database, we need to be looking for horizontal scaling, or we need to be implementing horizontal scaling in our environment. Still talking about database, this is another good question you can expect in the interview. What is the maintenance window in Amazon RDS? Will your DB instance be available during the maintenance event? Right, so this is really to test how well you have understood the SLA, how well you have understood the Amazon RDS, the failover mechanism of Amazon RDS, stuff like that. So RDS maintenance window, it lets you decide when a DB instance modification, a database engine upgrades, or software patching has to occur. And you actually get to decide, should it happen at 12 in the night, or should it happen at afternoon? Should it happen early in the morning? Should it happen in the evening? You actually get to decide. And automatic scheduling by Amazon is done only for patches that are security and durability related. Sometimes Amazon takes down and does automatic scheduling if there is a need for a patch update that deals with security and durability. And by default, the maintenance window is for 30 minutes. And the important point is the DB instance will be available during that event, because you're going to have primary and secondary, right? So when that upgrade happens, Amazon would shift the connection to the secondary, do the upgrade, and then switch back to the primary. Another classic question would be, what are the consistency models in DynamoDB? In DynamoDB, there is eventual consistency read. This eventual consistency model, it actually maximizes your read throughput. And the best part with eventual consistency is all copies of data reach consistency within a second. And sometimes when you write and when you're trying to read immediately, chances that you would still be reading the old data. That's eventual consistency. On the other hand, there is another consistency model called the strong consistency, or strongly consistent read, where there is going to be a delay in writing the data, making sure the data is written in all places, but it guarantees one thing, that is, once you have done a write and then you're trying to do a read, it's going to make sure that it's going to show you the updated data, not the old data. You can be guaranteed of it that it is going to show the updated data and not the old data. That's strongly consistent. Still talking about database, talking about NoSQL, DynamoDB or NoSQL database, which is DynamoDB in Amazon. You could be asked this question: what kind of query functionality does DynamoDB support? DynamoDB supports get and put operation. DynamoDB supports, or DynamoDB provides flexible querying by letting you query on non-primary key attributes using global secondary index and local secondary indexes. A primary key can be either a single attribute partition key or a composite partition sort key. In other words, a DynamoDB indexes a composite partition sort key as a partition key element and a sort key element. And by holding the partition key, when doing a search or when doing a query, by holding the partition key element constant, we can search across the sort key element to retrieve the other items in that table. And the composite partition sort key should be a combination of a user ID partition and a timestamp. So that's what the composite partition sort key is made of. Let's look at some of the multiple choice questions. Sometimes some companies would have a written test or an MCQ type online test before they call you for the first level or before they call you for the second level. So these are some classical questions that companies ask in their multiple choice online questions. Let's look at this question. As a developer, using this pay-per-use service, you can send, store, and receive messages between software components. Which of the following is being referred here? Let's look at it. Right, we have AWS Step Functions, Amazon MQ, Amazon Simple Queue Service, Amazon Simple Notification Service. Let's read the question again. As a developer, using this pay-per-use service, so the service that we are looking for is a pay-per-use service, you can send, store, and retrieve messages between two software components, kind of like a queue there. So what would be the right answer? It would be Amazon Simple Queue Service. Now, Amazon Simple Queue Service is the one that's used to decouple the environment. It breaks the tight coupling and then it introduces decoupling in that environment by providing a queue or by inserting a queue between two software components. Let's look at this other question. If you would like to host a real-time audio and video conferencing application on AWS, right? It's an audio and video conferencing application on AWS. This service provides you with a secure and easy to use application. What is this service? Let's look at the options. They are Amazon Chime, Amazon Workspace, Amazon MQ, Amazon AppStream. You might tend to look at Amazon AppStream because it's real-time and a video conference, but it's actually for a different purpose. It's actually Amazon Chime that lets you create chat and create a chat board and then collaborate with the security of the AWS services. So it lets you do the audio, it lets you do the video conference, all supported by AWS security features. It's actually Amazon Chime. Let's look at this question. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. Which of the following service best serves your requirement? AWS EC2 Autoscaling, AWS Snowball, AWS Fargate, AWS Batch. Let's read the question again. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. It looks like it's batch service. Let's look at the other options as well. AWS Snowball is actually an storage transport service. EC2 Autoscaling is introducing scalability and elasticity in the environment, and AWS Fargate is container services. AWS Batch is the one is being referred here that actually runs thousands of individual jobs which are similar. AWS Batch is the right answer. Right, let's look at the other one. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are we referring to? So we have Amazon SageMaker, AWS Deep Lens, Amazon Comprehend, AWS Device Farm. Let's read the question again. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are referred here? The answer is SageMaker. It provides every developer and data scientist with the ability to build, train, and deploy machine learning models quickly. That's what SageMaker does. Now, for you to be familiar with the products, I would recommend you to simply go through the product description. There's one page available on Amazon that explains all the products, quick, neat, and simple. That really helps you to be very familiar with what the product is all about and what it is capable of. Is it a DB service? Is it a machine learning service? Or is it a monitoring service? Is it a developer service? Stuff like that. So get that information, get that details before you attend an interview, and that should really help to answer or face such questions with great confidence. So the answer is Amazon SageMaker, because that's the one that provides developers and data scientists the ability to build, train, and deploy machine learning models quickly as possible. All right, let's look at this one. Let's say that you are working for your company's ID team and you are designated to adjust the capacity of the AWS resource based on the incoming application and network traffic. How do you do it? So what's the service that actually helps us to adjust the capacity of the AWS resource based on the incoming application? Let's look at it. Amazon VPC, Amazon IAM, Amazon Inspector, Amazon Elastic Load Balancing. Amazon VPC is a networking service. Amazon IAM is an username password authentication. Amazon Inspector is a service that actually does a security audit in our environment, and Amazon Elastic Load Balancer is a service that helps in scalability. That's in one way, indirectly that helps in increasing the availability of the application, right? And monitoring how much requests are coming in through the Elastic Load Balancer. We can actually adjust the environment that's running behind it. So the answer is going to be Amazon Elastic Load Balancer. All right, let's look at this question. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon's servers. So we have Amazon GameLift, Amazon Greengrass, Amazon Lumberyard, Amazon Sumerian. Let's read the question again. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon servers. The answer is Amazon Lumberyard. This Lumberyard is an free AAA gaming engine deeply integrated with AWS and Twitch with full source. This Lumberyard provides a growing set of tools that helps you create an highest game quality applications, and they connect to a lot of games and vast compute and storage in the cloud. So it's that service they are referring to. Let's look at this question. You are the project manager of your company's cloud architect team. You are required to visualize, understand, and manage your AWS cost and usage over time. Which of the following service will be the best fit for this? We have AWS Budgets, we have AWS Cost Explorer, we have Amazon Workmail, we have Amazon Connect, and the answer is going to be Cost Explorer. Now, Cost Explorer is an option in the Amazon console that helps you to visualize and understand and even manage the AWS cost over time. Who's spending more? Who's spending less? And what is the trend? What is the projected cost for the coming month? All these can be visualized in AWS Cost Explorer. Let's look at this question. You are a chief cloud architect at your company, and how can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? So we have CloudFormation as a service, we have AWS Aurora as a solution, we have AWS Autoscaling, and Amazon API Gateway. Let's read the question again. You're the chief cloud architect at your company. How can you automatically monitor and adjust computer resources? How can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? This is an easy question to answer. The answer is Autoscaling. Right? That's a basic service and solution architect course, is it? Autoscaling is the service that helps us to easily adjust, monitor, and ensure the maximum performance and efficiency of all scalable resources. It does that by automatically scaling the environment to handle the inputs. Let's look at this question. As a database administrator, you will use a service that is used to set up and manage databases such as MySQL, MariaDB, and Postgres SQL. Which service are we referring to? Amazon Aurora, Amazon Elasticache, AWS RDS, AWS Database Migration Service. Amazon Aurora is Amazon's flavor of the RDS service, and Elasticache is the caching service provided by Amazon. They are not full-fledged database. And database migration service, just like the name says, it helps to migrate the database from on-premises to the cloud and from one database flavor to another database flavor. Amazon RDS is the service, is the console, is the service, is the umbrella service that helps us to set up, manage databases like MySQL, MariaDB, and Postgres SQL. It's Amazon RDS. Let's look at this last question. A part of your marketing work requires you to push messages onto Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. So the options are AWS CloudTrail, AWS Config, Amazon Chime, AWS Simple Notification Service. All right, it says a part of your marketing work requires you to push messages. It's dealing with pushing messages to Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. It's Simple Notification Service. Simple Notification Service is a message pushing service. Right? SQS is pulling. Similarly, SNS is pushing. Right? Here it talks about a pushing system that pushes messages to Google, Facebook, Windows, and Apple through API, and it's going to be a simple notification system or a simple notification service.
And with that, we have reached the end of this session on Amazon AWS full course for beginners. Should you need any assistance or any other resources used in these sessions like PPTs, project documentation, GitHub links, doubt clarifications, and others, then please let us know in the comment section below, and a team of experts will get back to you as soon as possible. Until next time, thank you and keep learning with Simplilearn. Stay tuned for more from Simplilearn.